Normal camera showing that the Earth is completely flat over distances with no curvature obscuring anything. People do it all the time. They also use telescoping lenses to reacquire things that have visually disappeared from the bottom up. I didn't like clip one of those.
That's okay.
For the video.
And you know what? Maybe we don't have to. I just want to give you the opportunity. I was just thinking this would be a good experiment that we could do in real reality together.
Can I address that?
We could verify, because we're just talking. I want to see it with my own eyes, because isn't that what this is?
Please,
observing
please,
yourself,
I beg of you. Can I address that? So a couple of things. The red rhetoric thing. So in Earth curve maths, which is where the assertion comes from that the horizon's blocking the view of the buildings, there's no account for angular descriptions in that maths. So
I'd be curious what he would say to you on that.
Again?
I said I would be curious to see what Red would say to you on that.
Okay.
Go ahead and continue.
It's not really about Red's opinion. It's more about the way it works. I mean, if again,
it's just
two things I want to address. There's just a couple of things I want to address. So the first is the Red rhetoric thing, but then I do want to cover this experiment idea. Great idea, but I do want to get to that more importantly. But the Red rhetoric thing, if you're looking at the building from the base of the building, you appreciate that you've got a very wide angle to the building. You'd have to literally arc the camera up. And as you back away from the building, you'll arc your camera down again. In other words, there's an angular relationship that's going on here. But in the assertions that the horizon's blocking the bottom of the building, it's not accounting for angles. It's not accounting for angular size. It's not accounting for
perspective. But those experiments do account for those angles. That's the thing. In those videos, and they show you exactly how it's done, they absolutely do account for those angles.
Can you show me that in Walter Bislin's maths, please?
I'm not talking about Walter Bisling. I'm talking about Red's rhetoric and his videos and his experiments.
I've had plenty of interactions.
He takes the P900.
I've had plenty of interactions with Red rhetoric as well.
I know, I've heard them.
Red rhetoric's maths is the same as Walter Bislin's. It's, as I said earlier, the globe Earth maths. There's not more than one. That's it. They're all using the same maths. Okay. So there is no account for angular anything in globe Earth maths. None. Okay? It's a 10-foot wall at any distance.
I don't think that Red would agree with you on that, and it's his experiment, so I'd be curious. And that's why I want us to do it. If we do it, instead of talking about other people's experiments.
That was the first thing. Okay, we can just defer to Red. Okay, there was two things, though. That was the first. So Red,
get to the second, then.
Yeah, the second was knowing what science is. So you're under the misapprehension. Please don't get triggered in the middle of what I'm telling you. That this is an experiment, but it isn't. Now, the way we've been hoodwinked into believing that we're on a sphere is by people telling you that they've got experiments or science or theories. I beg your indulgence to just let me say this. Thank you. So that magic trick has been planted into you from a very early age, about 5th grade, where they taught you what the scientific method actually was and how the method offers empiricism through the method described to you in the, whatever you want to call it, the pre-show, i.e. if A then B, or if A not B, alternative and null hypothesis validated by experiment to give you an empirical outcome. Only one can be true. So therefore science, and in this case experiment, offers an empirical outcome. So when you hear the word experiment, in this case referenced incorrectly to a blink test, the audience will hear empirical, because that's what they've been trained from a very early age. However, an experiment is to establish the cause of a naturally occurring phenomena through systematic experimentation based on a valid hypothesis. Now, this doesn't have that. There is no naturally occurring phenomena here to study. Nothing's occurring in nature. You're talking about a comparison with a varying angle from two different lens positions. That's not a naturally occurring phenomena to science. This is outside the purview of science. But understanding what science actually is the key to understanding how you've been deceived into believing that you're on a model called a sphere that was derived from flat Earth elevation angle measurements to Polaris to give you latitude. Understanding science. So I shouldn't
trust my own eyes, Nathan. Are you telling me this?
Sorry?
Should I not trust my own eyes?
What do you mean, trust your own eyes?
Should I trust my eyes?
I don't know what you mean.
It's a simple question.
Yes, you should trust your own eyes, which show you obviously that you can see further than you'd be able to see on a sphere.
But I disagree, because that's not what I'm seeing.
What are you seeing? We're looking for evidence. We're looking for evidence.
I'm telling you, I'm seeing things disappear bottom up. And I'm seeing
And-
that there's an issue with the understanding of how that visual effect works with the
Gotcha.
human eye related to reality,
Okay.
right? So I'm just, the reason I'm asking this question is because this is a sticking point in the flat earth debate is, can we trust our eyes and our senses? And is it okay to employ different tools that can see farther, that can, measure farther? Or should we only rely on our eyes and our senses only?
They're
I don't
both the
really
same
understand
thing.
the question 100%, but I'd like to address one thing that you mentioned, and I've said it already, and I apologize for saying it again. But the fact is that when you look at an object disappearing to your eye from the bottom up, and then are able to use instrumentation to reacquire it entirely, that
So we can use,
falsifies-
okay, that's the answer.
Yes,
That's the answer. We can use instrumentation. Great.
May I?
Yeah, go
Please.
ahead.
When you reacquire it using instrumentation, it is important to acknowledge that you have falsified the notion that it was disappearing over the curve of a presupposed spherical Earth. I'd like you to just agree to that, because that's the kind of thing that we're going to be testing.
So you're saying that if we go and we find the right thing to
Instruments.
view, right?
Telescope is
Then
fine.
if we do a telescope or
Or
a
a-
P900 or whatever your favorite camera would be, right?
Mhm.
If we see something going over the horizon and then you can bring it back by zooming in, you're saying that's the proof, right? That would be
I'm
the
saying-
experiment we're testing?
I'm going to repeat what I said, and then you'll tell me because that's not what I said. I said that falsifies the supposition that it was disappearing bottom up due to going over a presupposed spherical Earth.
Right. Okay. Yeah, no, that's what I meant. Yeah, exactly.
Okay.
Okay. So that would be the experiment we could do. That could be one of the experiments we do.
It's
And we
not an
could get one of
experiment.
these bad
It'd
boys.
be more appropriate to call it a demonstration.
Sure. Demonstration, whatever word you want, right? This is the baby
Words-
that I'm
words are
going to be picking up.
Experiment is very, very
Celestron.
specific.
Okay. Yeah. Celestron Next Gen 6SE telescope. I'm getting it because it's one of the cheaper ones, actually. And I'm going to be planning on making observations of celestial objects, but you can also use this along with multiple cameras, and you can get different kinds of cameras just to sort of like include every possible viewing angle that we could imagine. And then we could try to make observations like that, right?
Absolutely. Hell yeah.
Okay,
Absolutely. That would be great fun. Another thing, and so that's the curvature stuff, and that's the only claim we got to today. The heliocentric
Let's-
model makes a bunch more claims that are evidence-free.
Can I run
Sure.
one by you real quick, Patrick? And
Yeah, sure.
Nathan, feel free to jump in as you're going to do anyways, which is fine. Another experiment we could do is by bringing in the sun. Okay. So this is a personal observation that I've made many times. And my question would be, if the earth is flat, how could we have complete darkness on one half of the planet and light on the other half of the planet if the sun would be required to move away from us as opposed to circumnavigating us or going around us, right? On the
We
so I just
never
want
have
to ask,
complete darkness on
this
the Earth.
is the question, and then go ahead. Does the angular size of the sun change throughout the day?
Okay. Now, it's very important to note that I'm not claiming any of these. I'm not making claims about this. But one can observe on a very, very clear day the sun getting smaller and smaller in deserts. Now, in
We lose Patrick?
in
So-
moisture-rich,
Oh, there
we
you
have.
go.
We've
You're
managed to lose Patrick somehow. But your question is, why does the angular
Patrick, you're
size of
back.
the
Oh,
sun
sorry.
not...
Hold on, Nathan. I just want to make sure he's back, and then feel free. Okay, Patrick, are you back? Can you hear me? I just noticed his connection
Looks like he's
dropped. a little
frozen.
bit.
Yeah, it looks like he's frozen.
Okay, let's let him fix that. Nathan, take it away.
So you're saying, why does the apparent size of the sun not change throughout the day? Correct?
No, I was actually asking the question: does the sun change in angular size throughout the day? That was my question. And Patrick's back, so maybe Patrick finish, and then Nathan, go ahead.
let me just finish real quick. But the statement, how is it that half the Earth has total darkness? That's not actually true. There are times when the Earth has way more visibility of the sun than the globe model would ever allow. But so the notion that it has to be a ball because there's exactly half of the Earth that doesn't have any sun, at all given times, it's just falsifiable. It's not true. In fact, there are some days when they say that the Earth is seeing 99% of all human beings are seeing the sun all at the same time. You can look that stuff up. It's very interesting. But no, the globe model does not explain the percentage of the Earth that is looking at the sun.
Okay, so then the next question is, does the angular size of the sun in the flat Earth model have to change throughout the day?
What
Because
flat
it's
Earth model would that
moving
be?
away from us and towards us, right? It's moving
Let
on
Nathan
the
take that.
record player, right?
What flat Earth model would that be? I haven't claimed any flat Earth model. That's the first thing. And secondly,
Well, there is no flat Earth model, first of all, but I'm just curious what you think about the sun. How do we resolve the issue with the sun?
well, when you say there is no flat Earth model, that's not true. They're all flat Earth models.
Can
All
we
of the
make
maps-
predictions on it? Do we
bad.
have an actual scientific model where you can make predictions and you
What's-
can do those equations and have repeatable experiments? Do you have that model in place? Do you have, any footage of the edge of the Earth? Like this is what I mean. Like, we don't have an actual model. This is admitted by Jeranism and all the many of the flat earthers. They say, yeah, we don't have a model. We just have our counter evidence to your evidence. Do you agree
I
with
was in
that,
the
or do
middle
you
of
have a
saying something
model
opposite to
present?
that, but I got stepped all over. I'll try again to contradict what you've just said. Other people say that aren't me. All of them are flat
No, I'm
Earth
asking you.
models. That's the second attempt. I'll count them off. All of the models, including your globe model, are flat Earth models. All of them are using the latitude lines that are derived by way of a measurement. That's an, in reality, measurement of Polaris on a flat plane. Those angle measurements to Polaris and the degree that it drops towards the horizon as you move away from it give you the latitude lines. That's flat Earth elevation angle measurements to derive the concept that is used to give you your globe model. Now, models aren't science. Science deals exclusively with phenomenon. That's things happening. Flat Earth, or globe Earth for that matter, that's a concrete noun outside the purview of science. You keep appealing to this like it's science. It is not. Meanwhile, we've debunked the mathematical assertion that the horizon is at a geometric limitation to boats and buildings by showing that it isn't. Debunking the geometry. You don't need to trust anything. The maths is
If I
laid
don't
down,
trust
set
it,
in
that's why we're going
stone.
to do the experiments. You didn't really debunk it. You had an answer. There's answers to your answers. We can go on forever. Let's do the experiment together and just prove it once and for all.
What's
I'm
the
asking about
experiment?
the sun,
So-
Nathan.
What's an
So
Does the
experiment?
sun change
Okay, what's
in
an
angular
experiment?
size throughout the day on a flat Earth or not?
The not actual size of the sun. You're asking me why does the not actual size of the sun, that's angular size,
Does the
not
sun
change?
get bigger and smaller throughout the day based on where it's located and where you're viewing it?
And that's angular size, not actual size.
That's what I said, the angular size. Yeah. Does that change?
The not actual size change?
Does the sun change in size?
In not actual size, angular size.
Does the sun
What do you mean
appear
by
to
that?
get smaller?
Or angular, not actual size. It's the third time I've said it.
Right, because of it's not like we're saying the sun is growing and shrinking like as an actual object. I'm not saying that. Let me rephrase it. From my perspective, viewing the sun, if I were to track it throughout the day, and obviously I would never stare directly at the sun, never do that. Let's say I got a really nice camera with a decent zoom on it, and I put a solar filter on front of that camera, and I literally just mount it on an equatorial mount that would actually track the sun throughout the day, and I let it run for, say, a few days in a row. Will I see the actual size of that sun change based on perspective? Because it would have to be moving forwards and backwards, because what's a sunset otherwise, right? This is the argument that you guys will bring if I say, I've watched the sun go below the horizon. I see it multiple times, and I've seen it come up from the horizon until it's a full sphere in the sky. So in the flat Earth explanation, it would have to go away from you, right? Similar to the boats on the horizon. That's the only way it would work on a flat surface. So if that's true, then we would see an observable difference in the angular size of the sun relative to the observer.
The not
Okay, I'd
actual
like to-
size.
Nathan, I'd like to answer this.
Well, he's put it to me. No, that is what the sun does as it goes away from you. Do you know how I know?
So it gets smaller.
my
to
bad,
me.
only
To
one
me, it gets
sentence.
smaller.
Only about 2 or 3 minutes from you. One sentence from me. Maybe you call me a dick. I'll try again. In celestial
We are,
navigation,
Dick, but that's
you measure
separate.
your position to the horizon. Now, if the sun is above the horizon, its GP location, that's the point below the sun on the ground, i.e. if the sun was above you at your zenith, can be, and often is, beyond the horizon. So when you measure your angle to the horizon and the GP location of the star, it's beyond the limitation of your view at the horizon. So when you say it's going over the horizon, you mean over the physical geometric limitation to your view at 1.22 times the square root of the observer's height in feet, aka Earth curve hill getting in the way, that we debunked? Definitely not. Meanwhile, in celestial navigation, you can measure its position beyond the horizon after you establish the ground as level to get an angle to the sun to find out where your location is. That's called celestial navigation. It only works on a flat plane. It only works with angle measurements from Polaris, that's your latitude lines, that were measured from a flat plane. That's why all the maps are flat. So, no,
I
the
don't-
sun doesn't go beyond the horizon.
So Nathan, give me a straight answer. Does the size of the sun on my perspective change? And why do I see, as the sun is going over the horizon, I don't see the whole sun disappear. I see it like a quarter of a sun, then half a sun, then three, like it's dipping down. I'm seeing it disappear downwards. And then I'm watching the same phenomenon in the morning, right from my deck. And it's coming up and you see the top and then a little bit more and then a little bit more and then a little bit more. Then it's in the sky, right? That's what I'm witnessing. And so if you're saying that the sun, the reason the sun is setting and rising is because it's vanishing from my
didn't make
field
a
of
claim.
vision,
I didn't make this claim.
then I would see the whole thing shrink into the smallest little dot to like a pinhead.
Would you?
And then I couldn't see it anymore. I would not see the shape obscured by the horizon. I wouldn't see that.
Like a brick that disappears at 4 miles.
We're not talking about bricks. I'm talking about the sun.
Well, no, we're talking about things that you said get blocked by the horizon. There's a physical geometric limitation at 1.22 times the square root of the observer's height in feet. That's an Earth curve hill getting in the way that the sun's going behind in this
Circular
description.
argument, no joke.
My bad, I'm just summarising his position. Haven't actually refuted it yet. Of course, that's the first time.
Refute it. Why do I see that? Explain it.
I
And
was
does
in the middle
size
of
change?
I was in the middle of summarising your position to refute it, but then somebody's talked, and now you're asking me to do it again. Just another interruption. Yeah, if the horizon was Earth curve, it would be at 1.22 times the square root of the observer's height in feet. A hill, geometric in limitations, to get in the way of the sun. We've debunked that. The horizon's not Earth curve. We can show it beyond
You
the
didn't debunk
geometric
it, you just said
limitations.
words. We have to do
And there's
that
the third
experiment
interruption.
together.
We can show it beyond the geometric limitations, and further to that, you can measure the GP position of the sun beyond the horizon, where you see it, when you navigate with it. It could be up to 2,000 or 3,000 miles away from you if it's low to the horizon, based on the angular measurement off a flat plane, minus from 90 and times by 60 to give you the distance to the GP to navigate with it. Well, that distance is along a flat baseline. It's a triangle. Well, that's the sun already beyond the horizon in navigational terms. So when you say it goes beyond a hill, no, it's long beyond the hill when you measure its GP position on a flat plane. That's the second time I've refuted your position.
That's not a refutation. So my eyes are deceiving me?
No,
Patrick, give it a
navigation.
shot.
No, navigation
Let me-
is showing you that it's
let me take a-
already beyond the horizon when it's several thousand miles away from you and you're using it with an angle measurement to it. Third time.
All right, so let me take a crack at this. So what I don't really understand here is we started by saying there is no evidence that the curve of the Earth is of a presupposed spherical Earth is the reason why we have a horizon. And we ended up kind of battling to a standstill with us saying, do you have evidence of such? To which you responded, okay, we're going to do an experiment to get evidence of such. And then you say to me,
Because you didn't like the experiment I showed you. And so I said, let's do it ourselves then.
Right.
Can you define experiment
mind?
for us?
I just,
You
I
haven't
was-
shown anything.
I was 10 seconds into my answer. Dave.
Go ahead, Patrick. Go ahead, Patrick.
I mean, Nathan gets mad for a reason. Okay, so I'm gonna try again. All right. So the fact is that we said repeatedly that we can show that the Earth is not a ball because the horizon can be shown not to be Earth curve, because we're able to reacquire objects that were previously thought to be beyond the horizon, blocked by a physical barrier, not simply too small to see because of perspective, blocked by the physical curvature of the Earth. This is the claim of the Globers, okay? Now, you then come back to me and say, well, we're going to find some other experiment. That's fine, whatever. But the fact is that I have already shown you why it is possible to show that the curvature of the Earth is not the reason for the horizon and that such curvature cannot be shown to exist. And then in response, you've come to me and you've said, okay, so we're going to go over to your model that I don't claim, and we're going to say, I want you to explain to me why the sun does this. And you can come up with a laundry list of observable phenomena that you think are explained by the globe model, which we have effectively just debunked. But just because it makes predictions in your mind does not mean that it is true, that it is the reality that we are standing on. That is called an affirming the consequent fallacy. If the Earth is a globe, then we would see the sun go down under the horizon. The sun seems to go down under the horizon, therefore the Earth is a globe. Affirming the consequent fallacy. If A, then B, B, therefore A. It's a fallacy. You can get ChatGPT to admit to it over and over again. So when you ask me to explain to you why the sun appears to do what it does, it's just not part of my burden. We've already shown that the horizon is not Earth curve. Therefore, the Earth is not a ball of 3959 miles in radius. I'm done.
Okay, can I respond real quick? And then Josh, I'd like you to chime in on this.
No problem. Just been listening.
So if I'm looking at your model, there has to be certain things that happen if that model is to be true. And the whole point of looking at it is to say, I see a contradiction with what you're saying over here. So we got most of this debate was taken up with the curvature thing, which is great. I'm glad. And everybody can figure it out. And we should do those experiments without watching videos. I agree, right? But if I say, all right, how do you answer this contradiction? I want to know, because if that is if the phenomena of the sun isn't explained, then that's a problem for flat Earth. And I want to know, how do you get around that? And what's the evidence that you have to refute that?
So what claim have we made about the sun exactly for us to be defending?
I made the claim. I asked the question. I said, okay, because actually, this is a really good, we didn't actually get your claim. How close is the sun and how does it operate on a flat Earth?
Okay, so you can't acquire that information because if you're using the sun to navigate with, as it moves towards the horizon, you're measuring an angle and then calculating the distance to the GP beyond the horizon that isn't Earth curve that we've debunked, then that would infer, if you're using the triangle to get the height, that it's moving lower to the ground as it reaches the horizon. Well, obviously that's not the case. The sun isn't getting closer to the ground. You can derive its GP position to navigate with it, but it's not getting closer to the ground. So we don't have a height claim. I don't make a height claim. Meanwhile, Kepler's third law of interplanetary motion would suggest that you have orbits, and those orbits can be used to give you scaling values for a sphere Earth in a sky vacuum with gas not expanding into it, and the sun being at a 93 million mile distance because a guy called Christian Huygens superimposed the R value we debunked, measured by Al-Biruni at a geometric limitation at 1.2 times the square root of the observer's height in feet, onto Venus. So Christian Huygens assumes that Venus has the same R value because obviously it's a rock in a sky vacuum in an orbital motion that Kepler assumed. And therefore you can give your scaling values to your R assumptions to give you your distance and size of the sun, all of which we can debunk. So we don't have a size and distance claim for the sun. You do. This is a burden of proof reversal fallacy. You're the one with the positive claim of size and distance for the sun, and asking me why it does a not actual size change as it moves through its not actual position in a refracted non-geometric Earth curve world is irrelevant because I don't have a claim about it. You have one about a distance and size to your sun in a heliocentric model. And given that I've just told you about all the assumptions of an R value imposed by Christian Huygens on Venus with an application of Kepler's third law, how do you justify your distance to your sun?
I'm just talking about observation, man. That's what I want to know. How does it work on a flat Earth? If the Earth is flat, and I disagree with Patrick's assumption that there's somehow not the phenomena of half the earth being lit and half the earth not. I've got friends that live in Australia. We can experiment all the time and go put cameras out our windows and observe how pitch black that it gets in one area without any kind of faint light going on that you would expect if the sun is going away. You have pitch black and you have full daylight on the other side on it, right? So if the flat earth model is to actually work, the
What model?
contradiction I'm pointing out
What model?
is that the sun would have to change angular size throughout the day. And what we observe, what I have observed, it doesn't change angular size, not even one little bit. And anytime we see change in the size, we can ascribe that to glare and the way light operates with the human eye and everything else. But if you
Okay.
take those solar filtered camera lenses
I got all
and
this.
you track it, and
got
you
it.
track
It's the
it for
second time.
days
I got it the
days,
first time.
it won't. Oh,
I
you're
got it. I got it the first time.
I'm just about,
I'm not
just about
deaf.
finished.
Two,
I'm just about finished. I'm just about
three,
finished.
Let him finish
Just
what
finish.
repeating it. I heard it the first time.
5. That's 6 times you
It
interrupted.
doesn't matter what I'm
Dave,
saying.
Dave, go ahead and finish.
Shut up.
Second time I've
I'll
heard
finish,
it.
and then
I
you
heard it
can
the
go.
first time.
So I'm going to mute him.
Right, but we are talking to an audience as well.
Yeah, we're not.
So
exactly.
we're
I'm
trying.
going to get muted because I've already addressed it, and he's rinsed and repeated and gone through the motions of saying the exact same thing again. And because he doesn't like me giving the same objection to the same repetition of the same thing, I get muted. So when I'm asked why I have my own show, for my own audience that can hear me speaking because I'm not in control of my own show, yeah, I can still talk to you as an audience and say, what a wanker. You don't like me objecting to you repeating the same thing I've already overcome? You haven't acknowledged my refutation of it? Just going to be completely ignored? Yeah, that's all right. Stick me on mute. That's why I've got my own show. So that I don't get muted by a host when I object to hearing the same thing repeated without a single acknowledgement of my refutation of it.
would change angular size throughout the day to the observer if it was a close sun going over a flat earth. It would, if it doesn't, that's a problem. And I want to know why.
So when it does change angular size, you've already said that it's because of other factors, right? So it's an automatically falsified observation if you do observe a
Nope.
change in angular size.
That's not what I said. Can I correct that? I'm asking
Yes.
you, that is if we're looking at the naked eye, which you should actually not do, but because of the effect of the sun on the eyeball. But I'm talking about looking at it through a camera, zoomed in for 3 days in a row, tracking it with an equatorial mount, which we're going to get to, which is a major problem for flat
Solar
Earth.
filters.
Solar filters, keeping it zoomed, following it and tracking it doesn't change a bit. So we can eliminate the issue with glare and perspective and human eye limitations and all of that because we have a device that can actually show that it does not change in angular size. And that is a major problem for the flat Earth model.
So just address this multiple times. Yeah? Not actual size. Who gives a crap? Meanwhile, his audience can't hear a single word I'm saying.
Have all the answers.
You're not
The
my
fact
guru,
is,
Patrick. I love you, man, but you're not a
All right.
guru.
all right, but just think about what you're requiring right now, okay? We have already gotten to the point where you are completely stymied when it comes to showing that there's curvature of any kind. As
Stymied.
visually,
Well, I think we disagree
No,
with
no,
that.
we
I think
gotta
it
get
was
those
a disagree
experiments
to
together.
disagree.
Yeah,
Fine.
that's going.
Disagree to disagree when it's 2-on-1 and the other guests can't be heard and interject in any way.
It's
I mean,
debunked.
my God, have the tests been done? They've
Have
been
you done the test,
for
Patrick?
years.
By
Patrick,
people
have
that
you done the
don't know
test?
what they're doing, Patrick. By people
Patrick,
that
have you
Meanwhile, we're going to filibuster and talk through everything Patrick says with the other guest on mute.
Not done the test myself.
Okay, so how about this? Is
We're watching
information
YouTube then.
warfare a thing that's happening these days?
Yes.
So how do we
Okay.
know that what you're
we'll do
seeing
the
and what
test
you're seeing on the videos?
Fine.
That,
See, I want a
that's all
concession
we're
though
saying.
that when we do show, because I'm gonna have to demonstrate the actual math to you, because when we came
And I would
into this,
love that, by the
You
way.
got 4.5
All right, very
seconds
well.
before I got interrupted.
But here's the other thing. When you do see angular size change in the sun, which you can observe under a bunch of instances where the sky is where the air is very, very dry, will you agree that it is much more consistent with a moving, more local sun than with a stationary, ultra giant, very distant sun? Would you agree? Would you agree that a change in angular size of the sun under the right air conditions, because moisture in the air will cause lensing, will cause magnification, but a dry air example of the sun plainly getting smaller as it moves out of sight, wouldn't you agree that's much more consistent with a small and local sun?
Okay, thank you for. So that's that's being postulated by flat Earth, right? That's
Nope.
the theory.
I asked you a question.
Yes. Okay. Yes. Yes. If you can show me that it changes angular size, then that's a point for your side, because
Would it not falsify the notion that it's 93 million miles away and stationary?
well, yeah, because if it's actually changing in size, then I mean, there's probably more questions that have.
There it goes again. Actually changing in size when we're talking about angular size. Meanwhile, I'm muted, can't object, not allowed to interject into this conversation anymore. Talking about actual size changes when it's not actual size, angular.
The sun does not change in angular size. That's what, so that's another experiment that we could do at the Badlands Media Conference. Okay, Nathan.
So not actual size change. Fourth time.
Change in angular size, change in
Not
apparent
actual.
size,
Not actual size.
not actual.
Right.
Perspective.
Yeah, exactly. I'm not saying the sun itself shrinks and expands and changes and turns into gummy bears. I'm saying, from my perspective, I should see the sun vanishing and moving in and becoming big. It would be the same with the moon. It would be the same with a lot of things, right? So we got to test that. And one way to test it is to get a high quality zoom camera with a solar filter mounted on an equatorial mount. And then that way we can track it over a period of days and then see if the sun itself actually changes in angular size.
Actually changes in not actual size. My God.
Sorry,
Okay,
sorry.
no worries. Let's
Not
just move on. It
actual.
doesn't matter. Five
do you
times
know
is
what I
enough.
mean? Does the people
I'll
in
just
the
get
chat know
muted
what
again
I
if I
mean?
try and refute this, or
Josh, do you know
my
what I
second attempt to
mean?
refute it's
I
now
know
getting
exactly
currently
what you mean.
talked
It's not a
through.
problem.
Even though
and
I've
I-
pointed out
speaking
not
Greek
actual
here,
size is an
This is a
actual
very
size
simple
change.
observation that we could
Obviously,
make.
I'm going to get completely rumpus and talk through.
Yes,
Takes.
you are. Yes, you are.
Yeah, every time I've talked, I have. So why would I expect anything different?
Oh, yeah.
This is me angry.
But
This is me getting angry,
Okay.
right?
No. You're just annoying, and that's just the fact.
Winning.
So
Yeah, it's annoying for people who think
winning-
they're really
winning at
competent
life,
about Earth
Nathan.
being a globe.
Keep telling yourself that, buddy. Josh,
So-
how about you give a shot on this? What do you think about this?
I'm not allowed to
Well-
give it a shot? Oh, right, I was just on mute for 5 minutes.
Well,
Okay,
actually,
Josh.
I just wanted to say, I'll go ahead and concede to Nathan if he wants to go ahead and give
Okay,
it.
excellent.
I thought Nathan had
Excellent.
already answered it 5 times, as he
Excellent.
said.
So the equatorial mount, where does the concept of the equator come from? Do you know?
Go ahead and tell us.
It's your claim. You were talking about how wonderful the equatorial mount is for a flat
No, I'm
Earth. It's
talking about
terrible.
how the equatorial mount has a problem because it would have to rotate on 2 different axes in order for it to work, but it doesn't do that. And we're going to get to it, and I'll put the argument up for people to look for themselves. I want you to answer about the sun. Let's go with the sun. What do you say to that?
Well, I thought we covered it. Why does the not actual size of the sun not change in not actual size as it moves from its not actual position
I didn't
throughout the
say
day?
actual size.
Oh, my bad. I
That's
was in
not
the
what I
middle of
meant. I
summarizing your
didn't mean
position.
actual size.
Obviously, this is me being
Observer.
angry, right? Me being angry, interrupting you. So why does the not actual size of the sun not change in not actual size as it moves from its not actual position? I'm not going to answer that, but I will carry on with asking
Okay.
you if you know where the equator or the equatorial plane has come from for a second time.
Well, it's based on the concept that Earth is a sphere. So there's an equator.
Wrong.
And
How is it derived then from a sphere? Tell me.
I don't know. Tell me.
Why
It
did
would
you
be
make
the
that claim
parallel
then?
side-
Hold
it would-
on.
it would-
I'm replying to him.
You just asked us to answer it.
He didn't know. I heard his answer. He said he
I don't
didn't know.
I'm not a mathematician. I'm
But
not
you
a
made a
physicist. I'm just
claim. My bad. I'm responding to you. You don't know. Now I'm responding to you because I do. You're not going to yield even though he doesn't know.
The equator is aligned.
No, I'm
perpendicular to the
telling you
axis
that
of
I'm going to
rotation,
show
okay?
you the argument. Okay, it's not. I'm just posing
But-
arguments here because I want to know how you guys respond to this stuff. Okay, this was an argument. This was a challenge that was posed by Red's Rhetoric. Once again, he even put a Mavic
Do you want to get him on?
Pro
Get him on.
as a. Oh, I'd love to.
But you don't
but
know what you're talking
I'm
about.
just-
This is your
I'm just
claim.
I just want to put the
Stop
argument.
telling people
okay?
You don't know the
I just
argument.
wanna
I'm trying to
know.
address it.
Let's have a
I've already
discussion.
tried to
Yeah,
address it, and every
exactly.
time I try and talk, somebody's talking through me. You
Because
don't know
all
where
you're
the
doing is just
equator.
saying the same thing.
Same
over
thing
and over
again,
and
here
then
we go.
trying to
My
strong-arm
God,
people
what is
through
your
level of the
problem?
Conversation. You're not even answering the freaking questions that David has been asking you.
What about the
I mean,
equator? I asked him where the equatorial
see
plane came
that?
from, and
See
he
how the
didn't
telescope's
know. And now
moving?
I'm getting talked through again.
Yeah.
You don't know where
Okay.
the equatorial plane came from, or what the equator's. My bad. I'm never going to get this statement out. Never going to get the statement out.
And as you can see, in order to take that picture, notice how the telescope is only moving one axis. It's not pivoting here at all. It's pivoting down here at its base. See that?
Yep.
It's only moving one axis of rotation. Now, let's go ahead and go to an actual model. So what we're going to do is we are going to have a flat Earth model with an object rotating overhead. What does the telescope have to do in order to follow that object? Well, I'm seeing that that telescope on the flat Earth has to rotate two axes of rotation. Here's declination, and here's right ascension. So on the flat Earth model, it has to rotate two axes in order to follow a celestial object. Now, what about the globe? Let's go ahead and check out the globe right here. So on a globe, let's go ahead and fast forward here. Oh, there it is. So there's the globe model that we're going to use. The observers in Florida, as it was when Astronomy Live was doing his observation. And as you can see, there's declination, not moving whatsoever. And there's right ascension, moving as it should. So in reality, we only have to move one axis of rotation in order to follow a celestial object. The model needed in order for that to be the case is the round Earth model. And when we apply that to a flat Earth model, we then have to rotate two axes in order for it to follow a celestial object, i.e., there is a contradiction within the flat Earth model. So, given that equatorial telescope mounts work, do you have an answer for the geometric impossibility of an equatorial telescope mount working on a flat Earth?
I mean, that's a ridiculous claim. So first thing that they do is they attribute a model to Nathan and me. We have claimed no model. He picked a model that had in order to watch the star, you have to have two axes of rotation. And then he said on his globe model, the axis is only one axis of rotation is required. So first of all, I claim no model. Second of all, that is called an affirming the consequent fallacy. It says, okay, we're going to sit here and imagine that we are on a ball rotating. And note that my telescope only has to rotate on one axis. The answer to that is, so what? If you did live on a ball, you would be able to measure the curvature of that ball. If you did rotate at 1,037 miles per hour at the equator, there would be a million different ways that you could verify that. You'd notice. You'd be able to get up in a hot air balloon and then just wait for the Earth to move under you and go there. You have flight times completely different from going east to west and west to east. This affirming the consequent fallacy that you just played for me it's literally proof of nothing. All right, Josh.
Yeah, no, Patrick, you said there's 1,000 different ways to prove if we were on a curved Earth, there's 1,000 different ways to prove it. Give us some of those, and let's have us and the audience and all of us go test that. Because if that's false, right? If the Earth is not curved, and you said there's 1,000 different ways to test that if we were on a flat Earth, then we will be able to find out for ourselves by doing those tests. I mean, does that make sense?
Okay, I've already said the tests, so just to see if I got through.
Okay, good.
Why don't you tell me what such a test would look like? Because I've already explained how one would test such.
Well, maybe I missed that part. Maybe I was going to.
It's literally the entire 2 hours we've been talking about it.
Are you referring to curvature, right?
I am.
Start off with that.
Okay. Okay. Well, why don't we just say this? Let's propose certain tests to each other, right? I don't think that we're ever going to come to any agreement on this conversation discussion. I think we can all understand that, right? And look, I'm open to new ideas and concepts. I'm here to learn on this planet, right? I'm here to expand in knowledge. And so what I would like is, if the Earth is flat, great, prove it to me. And the same thing with you. If the Earth is curved, great, prove it to you, right? I mean, this is kind of where we're at. And so let's propose You guys come to us and say, okay, we'll test this. I don't want to test that the Earth is curved. I want to test that the Earth is flat. How would I do that?
Celestial
Give me those
navigation.
experiments.
With
What's that,
celestial
Nathan?
navigation.
With celestial, as you explained before, taking the sextant to the horizon. But I'd already said this, but we're talking about 69 miles, 75 miles that we have 1 degree of curve. So curve is negligent at shorter distances. So it's going to appear horizontal. That was my argument. Whether we agree or disagree with that, okay, I'm saying is how else can we determine this? What other ways can we determine whether these theories or these different thoughts of flat or round Earth are true or false? I mean, let's truly utilize our resources, utilize our brain power, and get to the truth. And I'm okay with that.
Yes.
I'm okay with doing experiments is that you guys say, hey, Josh, you know what? Let's go out there and let's test this or test this. Or David, how about this at noon every day? Go out there and, at noon my time and with the same corresponding time as David's time zone, we'll measure the angle of the sun in the sky and we'll come up with we'll see what we can do, right? These are things that we can do instead of going back and forth. I mean, Patrick, you said there's no model for flat Earth, or that you claim no model for flat Earth. The same thing with you, Nathan. And I completely understand that. I don't want to sit here and try to break down a flat Earth model when you guys don't have a model. But my question is that if we're going to claim that the Earth is flat, how do I know this? And it can't come about through debunking curved Earth. Does that make sense?
Because all of the maps and models that you use, including a globe, were made using flat Earth elevation angle measurements to Polaris. Without exception, your globe model included, they're all flat. They're all derived from flat measurements, the same flat measurements that you use to navigate. That's an elevation angle measurement off a flat baseline. When you describe the 1 degree for every 60 nautical miles, that's 1 degree of declination of the star in your sextant, not 1 degree of a curved Earth. You're measuring.
Well, I'm actually, Patrick.
My bad.
Nathan. I'm
my
actually
bad.
getting that
My
number
bad. I'm
through the
just answering your
circumference
question
divided by
after a
360.
long, prolonged request for us to prove the flat Earth to you. I'm just answering that. Not lots of waffle
Well, you
and
just made an
prefacing.
incorrect
Just
assumption
answering
on
you.
what I said, so I wanted to correct that. If that's okay, is that okay to do that? If you made an incorrect assumption on what I said, I took the circumference of the Earth, divide by 360, you get 69 miles. I was given an approximation of about 75 miles. And this equates to 1 degree. If a circle's 360 degrees, I think we can all agree on that. If we divide 360 by the circumference of the Earth, as in the sense of the globe Earth model, we should get 1 degree of arc length. Can we all agree on that? That makes sense.
I can agree that if you beg the
Okay,
question
thank you.
that the surface is a spherical one, that you can get 1 degree of 360. However, in
Perfect, thank you.
practical application, when navigating the surface of the Earth and referencing elevations to sea level, you can measure the declination of stars in the sky based on a flat Earth angle. Yes, I appreciate you can beg the question that means the surface is curving, but you can't get elevation angle measurements from a curved surface.
But see, and so for everybody out there, and so kind of what me and Nathan are saying is I'm not disagreeing with him on the sense of how a sextant works. And I did say that before. Am I correct on that?
That proves Earth's flat then.
No, it does not.
Yes, it does.
What it shows you is that the sextant being used as a local instrument to the horizon is predominantly a flat horizontal plane.
It's incorrect.
That's why that works.
No, you're measuring the GP position of the star, and the angle you have to it beyond the horizon could be several thousand miles.
But that
I'm just
measurement's based
correcting
upon
you.
what?
Is it okay if I correct you?
To the horizon.
No, to the GP of the star. I know you don't like being wrong, but when you measure the flat plane, that's the flat Earth baseline, the elevation angle to the star is beyond the horizon, flat for many thousands of miles, and described in navigation as an area of equal elevation. That's a flat plane beyond the horizon.
So Nathan, can you show me in the sense if we're talking here? So I don't know if everybody in the audience knows what a sextant is. Okay. Right. Can you show us how this would work? If I had a sextant, how am I measuring this?
You're measuring a flat baseline.
Is there different parts of the sextant? We got an audience here as well, man. Right. So I'm just trying to extrapolate as much information for everybody as possible. Right.
Sextant
Me
is
and you
an-
keep on
audience-
going back and forth with this.
Maybe the audience knows what a protractor is, and then we can
Correct.
kind of give them an idea. That you're measuring an angle using two straight lines.
one of which is
Right, and-
acquired by pointing the sextant at the horizon and leveling the tool. If you're on a ship, obviously rocking back and forth,
Correct.
you rock the sextant to get it lined up with
Mm-hmm.
the horizon. That is what you do to establish the baseline. That's a flat line
Yes.
to measure an angle. You'll be measuring that baseline, and once you've got it, you can measure the angle to the star. Now, that angle will be minused from 90 and times by 60 to give you the distance to the GP. That's the ground position of the star. That would be, or sun, or moon, or whatever else you're measuring in the sky. That ground position is the position where the sun or star is directly above at that time. Now, your horizon, if you're very low to the ground, might only be a couple of miles away. But you're establishing a horizontal baseline with a ground position below that star. That's a flat Earth. It can only be measured flat. That's what an angle is. There's my flat Earth proof. Not agree to disagree.
Okay.
It's not a claim either. It just is celestial navigation. My claim
So Nathan,
with
let me ask you this.
my claim with celestial navigation is that you cannot acquire an elevation angle measurement for celestial navigation if the Earth has a curved surface. It can only be done, it's a prerequisite that Earth must be flat to perform celestial navigation. I'm not,
Is there a required distance for that horizon to be for this to work? Yes or no?
no.
Oh, so I could do it in my. So if I was, let's just say I'm outside and I have a table on a ship, I could use the edge of that table to determine the flat baseline.
No.
Why not?
Because
Not
the
the horizon.
table's on a ship moving around on the sea. That's why you use the
if there,
horizon.
but there is no distance requirement to use this. We only have to have a required horizontal base, correct?
Yeah, you look in the horizon mirror, not the table mirror.
So, like you said, though, is the horizon can be very far away or it can be closer. So there's no.
We are clear that
distance.
the horizon's not a
determine-
table. I just
Right,
so I'm
GP.
clear. I just want to make sure you understand. You understand the horizon isn't a table,
I understand, but the table is a flat plane.
but it's not a horizon, which is what you look at in the sextant in the horizon mirror.
Correct. And that's kind of where I was saying is I agree with you on how the sextant works. But
With a
that
flat
does
plane.
not equate to the Earth being flat.
It can't not
Because-
be. It can't measure an angle. If one of the lines is curved, then it wouldn't be an angle, would it?
Well, it's not a precise instrument. It's not
It is.
100,000%.
It's an angle
accurate.
measuring
It's an
device. That's
approximate
pretty precise.
instrument.
Yes, it is. You're wrong.
It's pretty precise. It's
Very.
an approximation.
Yeah, very. It's an
Pretty
angle. It just
precise.
measures angles.
Right. And that's because the distance from a person to the horizon is predominantly flat because the curvature is insignificant at that level.
No, you're using the horizon to establish a flat baseline that could extend thousands of miles beyond the horizon
And I-
in order to get the GP position of the star so that you can navigate by finding your position with that GP across a circle
give
of
me an
equal. My
example
bad, still
of
in
the
the middle of
horizon
explaining how
extending
Earth's flat
thousands
to
of
you. My
miles
bad,
to
just
measure-
proving Earth's flat to you. My bad.
Don't
A
get
circle.
triggered. I'm
I'll try
asking
again
you
for a third
question through
time.
your own
A
words.
circle of equal elevation. That's a flat circle. No elevation change. Flat.
Anyways. Thank you,
Seriously,
Nathan. I
Josh-
appreciate that.
Josh, we
Okay.
have been here. We have been here. We have been here for 2.5 hours, Josh. We have spent most of this time talking about why the curvature is undetectable, how we would go about detecting that curvature. This is just a listening kind of question. How would we design that demonstration to measure the curvature of the Earth?
Well, you can take two people in different parts of the country or relatively far away, right? And we can measure the sun at equal times of the day. Now, if the Earth is flat, we can make approximations of what those angles would look like. And the Earth is curved, we can make approximations of what the
angle?
curvature would look like. Am I
You'll
correct?
need
on
flat
that?
Earth for those
I mean,
angles.
first of all, no, it has nothing to do with curvature. But you did hear me when I said that the curvature would be 8 inches times the square of the miles.
Right, but that's an approximation, and that breaks down
Nope,
after
nope,
about 100 miles.
It is
Absolutely,
incredibly
it breaks
accurate.
down.
It is incredibly.
It's incredibly accurate for short distances.
Yes,
You know this, Patrick. It's
I
incredibly
do. Yes,
accurate for short distances.
I'm literally a mathematician. I know how to
Great.
study circles.
Great. And so it's incredibly accurate for short distances because the curvature of the Earth at short distances is insignificant. But as you get further towards 100 miles, like 69, 70 miles, that equation starts to break down and no longer works because
No, it doesn't.
curvature. Yes, it does.
You
And
just,
Okay,
the
so this is
Globers-
where,
the Globers
can I
people
just
will
jump
tell
in
you
real
this.
quick here? Can I just jump in real quick?
that is
This-
a blatant falsehood.
Okay, well, then here's what we do. We
reasonable.
test it to us.
Yeah,
us
let's
physically
test it.
test it in reality. That would be the proper, because obviously we're not going to convince each other, but this is for the sake
Okay.
of the audience.
Fair
We want
enough.
to see the no. We want to see the different arguments for and against the flat Earth, right? We want to see where's the contradictions, where's the flaws. I think the sun is a really good experiment that we can do. There's other experiments
There's no
that we can do.
experiment happening
And so-
here. Okay.
no,
What do you
I'm-
mean by the sun is an experiment? What does that even mean?
How,
Not the
how do
sun is an
we change
experiment. We
out
do an
experiment with
experiment.
test?
With a test.
Is that
Okay,
better?
a
Is
test.
that
Let
better
David
word?
finish. I want to
A
hear what
test.
he's going
I
to say.
still don't
It's
know
the
what
best
the test
word
is. The sun
to
test.
do some of these things to try to find
We've
out
spent
if
this whole time
claims
talking
made.
about the curvature
Oh,
of the
Patrick,
Earth.
Patrick,
And
hold
the
on,
claims
hold on.
about
Patrick,
the
Patrick,
curvature of the Earth by
Patrick.
measuring an angle to the
Okay,
sun.
wait a
That
sec.
makes
Let me
literally
just-
no
Let me
sense.
just
Patrick,
finish this
please,
sentence.
please,
Let me just
Patrick.
finish. Nathan, hey, yeah. Okay.
I want to hear what you're saying,
So-
David. Go ahead, David.
Well, we gotta wrap this up. No offense, but I do have to go because we are coming up on a very long time of this show, which is okay.
Okay.
It's great.
Here's
but I
another
do have
experiment
to
we
go
can do
here
really
soon.
quickly. I'm going to take it through. You guys know about the midnight sun. Speaking of the sun, so first experiment would be tracking the sun for days on end to see if there's an angular change in our perspective of the size of the sun. Okay, I'm not talking about the actual size of the sun. That's one thing. Another thing, we could look at this Kiruna, Sweden, right? And just really quickly, this was something that one of my followers on Telegram had sent in. I just want to propose it. Okay. In Kiruna, Sweden, the sun stays up continually, never setting for 2 months in June and July. Yet 8,400 miles away in Australia, it still comes up every day. The total straight line flight distance from Kiruna, Sweden to Perth, Australia is just over 8,000 miles, right? Now, given that we have the sun up over 2 points on the Earth that are 8,400 miles apart, given that the flat Earth sun visibility of 9,000 to 10,000 miles, those who live in America should see the sun at the same time as Kiruna and Australia sees it, as we are only 4,400 miles from Kiruna and only 8,100 miles from Australia. And I got the exact distances there from Atlanta to Sweden. So we could just get some people in Sweden, get some people in Atlanta. We know the mile distance, and then we can start looking at the sun. On a flat Earth, we should, but we get nothing but total blackness. We get total blackness because of the curvature of the Earth as the sun is on the other side. Even in a plane at 36,000 feet high and the flat Earth model of the sun being only 3,000 miles high, we can't see the sun in the USA while it's up over Kiruna and Australia. So why can't we see the sun in America during the time that Kiruna and Australia see it, given the flat Earth model or proposition about the sun?
What
So
model?
that's
What is
the
the-
argument that's posed.
What is the assumption? What is the begging the question assumption that took place in this argument? Just think of this as like a little pop quiz on the nature of the flaw in this logic.
Mhm.
What is assumed by these
That the
people?
Earth is curved.
Yep.
So that means
Okay.
I'm telling you, this is the experiment. This is another experiment we could do.
It's an
Okay,
affirming, the, it's
demonstration
another
of
affirming the
false.
consequent formal logical fallacy. If P, then Q.
Okay.
Q, therefore P.
So this experiment is a logical fallacy, Nathan? Is that what you're saying?
Yes.
Because it's already assuming that the Earth is curved. And I
that-
understand what
and
you're
it's
saying.
No,
also
no, it's
assumes-
showing you that if this phenomena is happening, there's a contradiction that shows itself for the flat concept of the Earth.
It
Based on the
assumes a
model
stationary
straw man.
sun.
That we haven't claimed.
Yeah, that's
It assumes a stationary sun.
It's
How
called a
so?
false dichotomy and a straw man. So I haven't claimed this model, and you're burning it in false dichotomy.
So no, it's because it begs the question about why in Kiruna, Sweden, you got 24-hour sunlight for a period of the year, yet in not that far away, you have people that are seeing the sun rise and set.
Therefore,
So
the
they're
Earth's a sphere.
saying there's an issue here that would
Not
not
that
work
far.
out
Therefore,
if
the
it
Earth's
was
a
a
sphere.
flat
You
surface and the
literally,
sun was acting in the way that it would have to on a flat Earth.
you just formalized. You literally went through the affirming the consequent. You verbalized it in the perfect form. That's an affirming the
Okay, so-
consequent formal logical fallacy.
So this is not a good experiment to do.
It's not an experiment
Even
at
you
all
wouldn't
because
expect-
there's
or a
what's the
test.
fun.
It
Okay,
wouldn't be a it wouldn't be a good
okay.
test
Stop. What's the first step in the scientific method, please, David?
to make an observation.
No, incorrect. Observation of a phenomenon. That's something occurring that you want to know the cause of.
That's an observation.
That's
No.
not
That's an incomplete statement because there's nothing
Okay,
to
fine.
explain
Pick
the
it apart.
cause of
It's the
if
same
nothing.
shit.
My bad.
know what I
My
mean.
bad. I'm just correcting you. I know it's painful.
Okay,
There's nothing
buddy.
to study the cause
You
of
get
if
picked on
nothing
a lot?
happened.
Like, what's up with the
Third
hackles
attempt. I
being
know
up
it's
the whole
painful
time?
when you're wrong. It's not
I
observation
wasn't wrong. I said to make an observation.
no-
of a naturally
Sorry,
occurring
what are you talking about?
phenomenon.
It's not
I
changing
realise
the
that now
result, and I
4
see
people
one
are
over
talking
horizon.
while
There's
I'm
an
trying to make the
observation.
correction. I know you don't like being corrected. It's not me being angry. It's just the 4th attempt for me to say you're wrong. That's an incorrect assertion because an
He has the
observation.
question.
Get anywhere with
5th
this
attempt.
shit. We
5th
can't get
attempt to show
anywhere.
why he's wrong. 5th attempt.
Yeah.
Can't get anywhere.
Listen,
All
It's
right,
only the
guys,
5th
we
attempt to
can't get
finish
anywhere.
this
Nathan,
statement.
Fifth attempt, because I honestly,
Fifth
like,
attempt.
honestly, man,
I'm not
Here's
allowed
what's
to
gonna
correct him then. He's just not
he
allowed
asked
to be
a
wrong.
question.
Not
No,
allowed
no,
to be
no,
wrong.
no,
He
this
wasn't
is just-
wrong. He
Yeah, he
asked
was.
you a
Now got
question.
muted.
don't
I
understand
love
how
it.
that's-
So for my audience's benefit, I can mute them too on my recording and say that this fuckwit doesn't know what science is. Science involves observation of a naturally occurring phenomena. That's step 1 in the scientific method. It's an incomplete statement to say observation is first step. So he mutes me. After he rinses and repeats 4 times and I say, no, you're going to have my correction. No, I'll be muted by the host. Yeah, neutral platform, this one. Yeah, I'm not allowed to be correcting anybody on the panel when they're wrong about what science is.
$10. I now believe the Earth is flat. Thanks a lot, fellas. Like I didn't have enough things going on. LOL. The round Earth guys are just talking over and have no arguments. They are looking foolish to me. All right.
Yeah, even the audience knows. Not only am I being talked over, I'm being muted whenever I correct him, and he doesn't like being corrected. So you can see on screen now, host has muted you.
We're disappointing. We couldn't
David, if you're the host, you're a scumbag. You've muted your guests just because you're wrong and don't know what science is. My audience will hear how wrong you are while you've got me on mute with this little label saying the host muted your mic. How epic. How unbelievably rude. You invite me on your show, I come here for free, and all you can do is mute me. The audience knows how scummy you've been, talking through every last word we've said, but you feel the need to mute me as I tell you how you don't know how science works. Epic.
as E. E. That is the statement. Just want to make sure we got through all of that. Okay. All right. So those are our Rumbles days. Thank you so much for that. Thanks for tuning in. And let me just do this. Let's do, because I know everybody's got to run, like a 60-second closing statement to wrap it up. And let's start with Patrick.
We just spent 2 hours and 45 minutes seeing the same fallacy over and over again. We talked about the curve. And every single time we had one of 2 things. One, it was argued that you can't see the curvature because it's insignificant, which is untrue. Or that I have pictures that look like there's curvature. And then we had a situation where nobody wants to just take a telescope and say, if we can see at this great distance, then there is no curvature. It's that simple. And there are 2 other major arguments that we didn't even get a chance to get to. 1, there is no evidence of axial rotation. And 2, there is no evidence that the sky is a vacuum, because then the air we breathe would fill the space and we would all be dead. Thank you.
I think you're muted, Josh. I can't hear you.
Josh, I can't hear you, Josh.
So I said over to Nathan. Nathan, it's you, man. Go.
Oh, my bad.
Nathan.
Right. Okay. Sorry. Yeah. The main way we've been poisoned into belief of a sphere is by misapprehensions about what the scientific method is. And it was very appropriate that I just got muted by the host when trying to correct him on observation being the first step in the scientific method. That's wrong. It's observation of something occurring, so you can establish the cause of the effect. Do systematic experimentation based on a valid hypothesis. That is science. It's empirical, and the illusion of science has been used to deceive you into believing that things like blink tests have empiricism behind them when they don't. So if you want to find out more about how you've been deceived into believing you're on a sphere by way of pseudoscience, that's defined as a claim of science when there has not been an application of the scientific method, then come and watch Flat Earth Debate on Nathan Oakley 1980. You can even join. There's a link published to the public every single day that you can join the debate and express your views on the nature of Earth. Thank you very much indeed to Josh and David for having me. You've been extremely tolerant, and although it's difficult to hear us proving you wrong, and I've been muted many times in the past, I still thank you for having me. I really appreciate it, and thank you, Patrick, for inviting me along.
Josh.
Muted, so I was talking there, thanking Patrick and Nathan. But no, listen, Nathan, thank you so much. I appreciate it. Seriously, I do. Because if this is really about the truth, then let's find the truth. Am I right on that? If this is really about the truth, let's find the truth. But I would say that let's do this again. We can come back and touch on the other issues that Patrick was talking about that we didn't get to, right? But also, and I know that you said there's no flat Earth model that you guys absorbed. That's great. But let's just have the assumption that we don't know whether the Earth is flat or round. And let's figure out some tests that we can do to determine whether it is either or. And I don't think that that's a horrible thing. And I know, Nathan, you want to say some stuff on this, but I'm just saying is I think that everybody can understand it. There we are. That if there is tests that we can do, let's do them. And if there is tests that we can't do because either one's not going to prove either of that, then we're all wrong. Nobody does know. And so I think that we can use this. And by the way, observation, I understand what you were saying in the sense of observation of phenomena, but observation is the kind of like the taking of your senses of the change of the external environment. So that is a phenomena. So observation kind of does define actually what observation is. So, but either way is we can use the observational evidence, the optional things that come into a self-evident truth that we see within ourselves. And we can develop various different models, whether it's curved Earth or flat Earth. And we can come back and we can say, hey, look, the Earth is flat because, or the Earth is curved because. And I think that would be a very healthy thing to do for this group of men here who have really good levels of intelligence and understandings on these topics, that we all come together and say, hey, look, let's figure out some tests that we can all do and determine this. And the next time we come in, we present the evidence for those tests and we look at the results of those tests and we compare that and we see what makes the most sense. You know what? Honestly, if the Earth's flat, great. I want to be proven it, right? And that doesn't come about by yelling at each other and arguing. And the same thing goes to you guys. If the Earth's curved and you wanted it proved to you, it doesn't come about through argumentation. I think we all understand that. And I think that we all can have a great discussion about this. But let's try to develop a format for this. Testing it. David and I can run some tests. Nathan and Patrick can run some tests. And we can come back and say, hey, look, this is what we found. This is what the data says. And let the audience and ourselves all decide from that. Does that sound like a good idea?
Sounds like a good idea.
Yeah.
Anything else, Josh?
No, I appreciate okay. Nathan and Patrick. I mean, I think that I go by Romans 12:2. Do not conform to the pattern of this world, but be transformed by the renewing of your mind. And that's taking in new information so you don't just fall into the same continuous aspect that your environment is giving you or the information warfare that's going on is giving you. We don't want to react to our environment. We want to be completely consciously active within it. And I think it's important to hear different perspectives and different points of mathematics and how this actually works, right? Because science is not set in stone. You know, in the late 19th century, oh, absolutely. In the late 19th century, they thought they had everything they thought they knew about physics because of Newtonian physics. Obviously, Einstein came along, and I honestly, by the way, Nathan, I disagree with the majority of Einstein. And then maybe that'd be a great discussion to talk about that someday, right? But here's the thing, is science is not set in stone. Science is a dynamic system. that's continuously changing. And I think you understand that as well, in the sense that if we're going to look at the Earth, that we're evolving our information on it. That's a dynamic system. It's continuously changing as more information comes into the system. That's systems theory. Yes, that is very true. As more information comes in, you have more understanding of that system if you can extrapolate that data in a meaningful form. Anyways, I just say that next time we go about it, let's come and have a format. Let's have maybe Nathan and Patrick come back and say, Josh and David, this is this. We come up with some tests, and Josh and David go back to Nathan and Patrick and say, hey, if the Earth is flat, this is what we're looking at. This is what we would expect. Can you show us? And I think we go into like that, because I think that would bring about a good basis for the audience to make a determination, as well as our own selves.
Yes, exactly. And just so you know, guys, still love you, Nathan. We had a good sparring match. I was told by John that this had to get heated so we could get more viewers, and I think we hit over like 4,000 viewers. So well done, mate. No hard feelings. Patrick, thank you so much. We don't have to agree on everything, and everybody watching, we don't have to agree on everything. We're all investigating truth together. My focus personally is what's happening on the Earth, regardless of the shape. I'm not saying that this discussion isn't important, but I think we can all agree that we are living in the age of tyranny, lies, and deception. And it's up to each and every one of us to utilize our minds and every part of ourselves to try to find out what is the truth. And in doing that, it's important to look at the opposite opinion of what you currently hold and test yourself constantly against it. The last thing I'm going to drop here is just an address to people in the chat and other people that have sent me that look at this from a more religious perspective. That wasn't the topic of today's debate. I'm not going to bring it up any more than this. Just to give you someone that I agree with on his position. His name's Giordano Bruno, and he was actually burnt at the stake by the Vatican in the year 1600 for going against the dogma of the church. And this is what he had to say. He says, God is infinite, so his universe must be too. Thus is the excellence of God magnified and the greatness of his kingdom made manifest. He is glorified not in one, but in countless suns, not in a single earth, a single world, but in 1,000,000, I say, an infinity of worlds. And whether you agree with that or not, it's just a philosophical thought that for those of you who think that looking at the world as a sphere, or that there is the reality of an infinite universe or a vast universe, that somehow contradicts creation, contradicts a God, or contradicts Christianity or your cherished belief systems. I have a channel on Telegram that you can go. I'm a collector of refutations to this argument. And love me or hate me for that, at least you have the challenges to all the points that have been brought up. You can find it on Telegram. It's called Flat Earth Refuted. And I'm also posting a link from a friend of mine who's a theologian and biblical scholar who disagrees that the Bible actually says there's a flat earth. And he's got all of his arguments there. He's got a free PDF book. So I just wanted to address that. That could be a topic for a different debate, a different time. But I want to thank everybody for being here. Thanks to Badlands Media for allowing us to be here to host this. I don't personally want to turn my entire career into debating flat earth, but if we want to do some stuff in the future, I'm more than open, and I'd love to do those experiments. So thank you, gentlemen. Thanks to our audience. Much love. The truth is going to win, and I wish you all well. Cheers, everybody.
Night, guys.
All right, we're off the air,
Oh,
gents.
God, I got to go to the bathroom so bad.
Yeah, so do I.
I've got another show coming up. Nathan, thank you so
Me
much
too.
for joining me.
Thank you,
Really
Nathan. I appreciate
it.
it, man.
Pleasure.
It's
My
bedtime
pleasure.
for you, I suspect. And I'll talk to you on Skype, my friend. Thank you so much, and I will see you on the next Flat Earth debate.
You're a great host. Thank you,
Great.
Josh. Thank you, David. You both had a lot of spirit. Brilliant stuff. Thank you very much.
Thanks,
Cheers,
Nathan.
guys.
You take care, man, and much appreciated for you. You well.
How do I leave?
Thanks, Patrick.
How do I get out?
Thanks, Josh.
Close the
We'll catch
window.
up soon.
Just close
All
the
right,
window.
guys. Take
Okay,
care.
see you
Have a
later.
good
Thank
one.
you.
Bye.
Welcome to 24/7 Flat Earth Discord channel. Be sure to go to VC Check and 1 to get your VC verification tags to get involved in the conversation about our Earth. Be sure to bring your verifiable Earth curvature evidence, though.
Enemy spotted.
Deck. Can you receive because there could be some kind of variance or interference that you're not aware of, right?
No, I mean, in this world where we live, the physical world, that we can kind of more solidly verify because there's way more variables that we can kind of confirm. It's like way more solid. We can experiment. We can vary the variables, right? We can have an independent variable. We can actually manipulate.
Yeah, but where does that stop? Like you go a little bit higher on a mountain, suddenly there's less air density, so now there's slightly less variance. You go a little bit higher, now there's no air at all.
I wouldn't count that as an independent variable.
Why not?
Because it's not really something you physically manipulate yourself. It's just
an independent variable is just something that you are changing within your experiment to figure out what changes when you change that, right? And you can change it by either moving your location so that the ambient
natural phenomenon. So like you're trying to actually see something that's in the real world, and you can confirm that it's independent, right? And then you do that. Then you can manipulate it. But before that, it's anybody's guess.
Independent variable. From my understanding, if you're conducting an experiment, the independent variable is just something that you can change whilst keeping the rest the same to see.
Yes, but you have to be confident in its ability to be independent, right? That it's changeable.
Yeah. So if you have a tool that can measure that specific variable, and you go to a place that
you can't do that in the sky because you can't verify for sure that things are you can actually adjust those things.
You physically have the ability to adjust it using some means. You don't have to do that. You can just make sure that variable is different when you conduct the experiment, right?
The difference is that in the world that we do live in, we can measure the air that we breathe in.
We can
measure the oxygen and all this, but we can't measure it in the sky that far up.
Yeah, we can. We can go up there and check. People do it all the time. Weather balloons or manned missions up a mountain.
Sure, that high up, yes, but even higher, where the assumed space is.
Sure. I mean, you take a balloon and you go as high as you possibly can with the density of the gas you've got in the balloon, and that gets pretty fucking high up. And then if you want to go higher than that,
you won't go to Jupiter with your balloon.
You won't go to Jupiter. That's true. That's
what we're trying to.
You need some other technology, such as some kind of solid-fueled, liquid-fueled rocket to blast your way out. Fair enough.
And you're assuming that it's a place you can go to in the first place. You're assuming it's a place you can actually land on.
You are making that assumption, and some would argue that people have made that assumption and then checked, and that assumption turned out to be true because their data came back.
Yes.
But you choose not to trust that. That's fair.
Yeah, that's what I say. I try not to base my things on trust, but
yeah, and that's up to you how much you decide is worth trusting, etc. I just it feels like there's a lot of like how do you say trust the fact that this Discord app is working without the back end of knowledge and technical development and this, that, and half the technology comes from, NASA's space agencies and blah, that's forwarded civilian tech, blah, blah, blah. All that is documented, recorded, historical and scientific knowledge that you can trace back and see, well, this developed from that, and then that developed from this, and this developed from that, et cetera, et cetera, et cetera. If you can trace that back, I don't see where.
Nobody's arguing you can't develop things on the Earth. You can still have technology on the Earth, so it doesn't mean you have
it
to go
stops working once it leaves the Earth. I don't get it.
Okay, but first you have to say that something left the Earth. I mean, but that's actually a claim, so you have to prove it.
Sure. But like, if we have a rocket and that rocket goes up well within the bounds of the Earth and the sky, do we assume that it stops going up once it crosses that boundary?
I mean,
And
I
if we
would
can
like
maintain
not-
radio, if we can maintain radio communication with that rocket and see it and bounce radar off it the whole way up, and then we can continue doing that past where we can see, we can assume, okay, we can't see it anymore, but the radar's still working. There's no reason it would suddenly stop working, or it's now imaginary or something. We can continue to do
I
that
would
until it goes
prefer
past
not
our vision.
I would
Pardon?
prefer not to assume those things. I would prefer just to know that. So that doesn't mean that technology can still exist on the Earth that we have. So just because
Yeah,
there's
but where is the bound between know and assume? Like, if you use any kind of technology, you're assuming it works, right?
I'm not assuming it works. I know it works. I have a phone. I'm using it right now. I know this shit works.
Exactly.
Like,
So if I have a radar
It
that I
doesn't mean
know
it doesn't mean
works,
you can go with
and then it keeps
rockets.
working for higher and higher up, it's the same thing. Then nothing's changed.
This is like this such a like a jump in conclusion, going from phones work, therefore you can go to space. It's like-
This is not the argument I'm making. You're
Yeah.
deliberately misrepresenting it. What I'm saying is, if you have a radar device that works on Earth, you can point it at something and it says 30 meters, 50 meters, or it makes a scan of that thing, which we definitely can do with sonar or radar or whatever you want to do.
Okay, but
then you
you
point
have
it
no
up,
idea what you're
and you
measuring. You have no idea which thing you measure to build upon it, right?
No, you do.
Yeah.
You can have an idea for sure. You can point it at something, and then like you
You don't
stand
know
in
if
front
you
of it.
measured
Suddenly, the number changes to the distance that you are away from it. And you go, "Oh, this is measuring the distance."
You don't know
no?
the distance, though. You don't know the distance, how far it is. So you don't know if you measured the thing in between or the thing that's actually there. You don't know. You're just making up.
You do know. I feel
You
like
know how far
you're
it is.
deliberately
You know how far
like limiting your amount of RAM or memory to be able to keep multiple
Sorry,
things in your
what are you-
mind. But the point is
What
that
are you measuring? What are you
what are
measuring?
you measuring?
He's measuring things in the sky. He doesn't know how far they are.
You're measuring the
assume
time it
measuring these
takes
things.
for a sound wave or a electromagnetic wave to extend out and then bounce from a physical
You don't-
object that it can bounce off of and come back. And if you
How are
time
you
that
doing
and you
this?
know the speed of that thing, then you can measure
You
the
don't
How
time
are
it
you doing
takes.
this? How are you doing
You don't
this?
know the medium. You don't know the medium which through it travels
Bro,
through. So you don't
we
know how
do.
it alters
We
those
breathe
things.
the medium, and we know that the rate at which that medium changes
Yeah,
by
but you
height.
don't know what medium is in the space part. You don't know what medium is there. So you don't know if it's
Sure,
going to
sure.
travel.
And
But
who's doing this?
It's the
Who, can you explain
What do you mean?
how you're doing it and who's doing it? Where's the
this is a
information
hypothetical
come from?
situation. I haven't done this, so
Why are you
just
using
to
a
be clear.
hypothetical?
He's
Just a
using
bunch
Because
of,
hypotheticals are very useful ways to construct
But what do they
scenarios in
prove?
which you can explore
What do
ideas.
hypotheticals prove? What do hypotheticals prove?
They can prove anything depending on what the hypothetical is, for sure.
Because you're using a hypothetical.
They work with ideas, for sure.
It's not a real life situation, is it?
What do you think a hypothesis is? I mean, obviously that doesn't prove anything,
It's
but it
not a
outlines it. Yes,
Hypothesis
of
is
course
not
it
a
is. It's in, bro. It's in the name. Hypothesis. It
Ooh.
means something that isn't tested or verified yet, but is an.
Means you're just making it up. Hypothesis is something you've observed and you're trying to work out.
But there's a reason they both start with hypo. Hypothetical means involving or being based
Okay,
on a
what's
suggested
go
idea
definition
or
of hypo?
theory.
A definition of hypo.
Bro, I've googled hypothetical, and the definition that's come up from Merriam-Webster Dictionary says involving or being based on a suggested idea or theory, being or involving a hypothesis. That is its definition.
What's
So
the
that's what it is.
hypothesis? What's the hypothesis for rockets flying into space?
So the hypothesis is that the Earth has a force that acts downwards on all things. In order to overcome that, so you don't come back down, you need to eject and generate enough force to have enough velocity to escape that without being pulled down. And it takes a lot of fucking
That's not
juice
a
to do that.
hypothesis, don't you?
Oh,
You know
it
that's
takes
not
a lot of
hypothesis,
juice to
do
do
you?
that. Have you tried jumping in the air?
I have tried jumping in the air. I haven't tried jumping out of orbit though.
Oh, okay. So You're
Hey,
talking about
dude.
hypotheticals, right, bro?
We were
Hypotheticals.
talking
exactly.
briefly about hypotheticals and their relationship to hypothesis and how they're basically the same fucking word, but yeah.
Okay. So
Okay, do you know what a hypothesis is then?
Yes, I do.
What's a scientific hypothesis?
A hypothesis is a supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation.
So how is
limited
that
evidence.
how is that basically the same word as a hypothetical?
Because a hypothetical, by definition, is a something that is being or involved in a hypothesis. That is what that word means. You can look this up for
Nope.
yourself. Yeah, dude. I'm looking at it.
Hypothetical is not the
I'm
same
not
as
engaging in this. If
hypothesis.
you can't be bothered Googling the definition of a word, then
I need to Google
whatever.
it, mate.
Obviously, I
No
just
need to.
joined.
No, you're right all the time. Except I'm
But it's not
looking
the
at it
same
right
word.
now,
You said
dude.
it's basically
Hey.
the same word.
Well,
You said it's basically the same word. It's not the same
I
word.
did say that, and it is basically the same word. One's
you-
like
are
an
you
adjective,
claiming that we're
one
on a
is
ball?
a noun, but
are you
am
claiming
I
that?
claiming we're on a ball?
Yes.
Not right now. I could make that claim, but I think that's probably not a good idea,
Well,
given the
Why?
current
for
brilliance.
rockets to go to
Definitely not a
space,
good idea.
you'd need for your rockets to go to space, you'd need a radius, which your ball needs a radius, wouldn't it?
All balls have a radius, that's correct.
Okay, so you are claiming a ball then.
Okay.
No, I mean, if it was flat, you'd still probably need a rocket to get off of it to overcome the anomalous acceleration that we all experience.
You
You'd
live
have
on
to generate
you
enough.
live on a globe, don't you? Not a flat surface.
It doesn't matter if I live on a flat or a globe because if there's
Yes,
still
it
an
does.
accelerating force acting on me downwards, right? Which I assume there is in both circumstances because in a flat Earth or a globe Earth, I still jump up and come back down, right? So
Yeah.
there is some kind of
Up is
force
up,
coming
is
down.
You
Yeah,
only need
whatever,
You only
sure.
need- Yep. So
Are
They
you,
mean different things
do
with a
you
globe
live on a
and a
ball or
flat,
not?
but the point is that even if
Do you live
it
on a
doesn't matter
ball
if you're on
or
a
not. You live on a ball.
what question are you asking?
my question
live
is:
on a ball
are you
or
on the
not?
fence? Are you on the fence about this?
Do you live on a ball or not?
In some ways, maybe, in the sense of like, if I truly believe the Earth was flat, maybe my experience
dude.
of reality would be totally different, but I don't believe
Dude,
it,
Do you
unfortunately.
live on a ball or not?
Yeah. Well, that's
I
the question.
believe I live on a ball.
Okay. Why?
Okay, there you go. So, what's the radius of your ball?
Off memory, something in the mid 8,000 kilometers, but I can Google it.
More like 6,000 kilometers, but who measured that?
That's true, sorry. 6,378.
Who
Who
measured,
measured that? People have taken various measurements throughout history, but I think our latest
Measurements,
ones
not
probably used.
Measurement?
It's 3959 in kilometers.
Sure.
It's what?
Obviously, measurements involve calculations of that's inherent to the mathematics of a measurement. I would hope
Right.
you would agree.
So, can you name someone who's measured it?
No, I can't. I'd have to Google that.
So you've got a belief.
Yes, I
Do you
said
know
that
how
already. I
they got
believe
the
the
R
Earth is a globe.
value?
That's true.
Is that
Do
a
you know how they
religious
got the
belief?
R value of the radius of the Earth? And that would be the transit of
Uh,
Venus over the sun.
Maybe is that one of the methods they can use? I'm sure there's multiple different methods to measure the
No,
radius.
that's incorrect, though, isn't it? That's how they got the sun. That's
That
how they
would
got
make
the
a lot more
distance to the
sense.
sun. Yeah. Do you know?
But
how
yeah,
they got
I mean,
the
you
R
can.
value of your ball?
Sorry, are you asking me?
Do you know how you got the R value of your ball that you live on?
I googled it. That's how I got the value. How the people
So how did they get the value?
Google probably got it off scanning a website. That website probably got it from citing some scientific
Do you know who measured
report.
the radius of the Earth?
No, I don't know their names. I've already said that.
Do you know how they measured it?
No, but I know there's multiple different measurements. You could
You
use
believe
whichever one
live
you
on a
like.
spinning ball in the vacuum of space, and
He
you don't know
assumed
how
the
they
size
came up.
of Venus during its transit over the sun. That's how they
assumed the
got the
size
R
of-
value of
They
our
assumed the
round
size of-
Earth.
They assumed
They've
the size
used
of
many
Venus
different
was the
methods to
same
get the
size
radius.
as the- Oh my god! They assumed that Venus was the same size as the Earth. That's how they got the distance to the sun. You're wrong, mate.
You talking to me or this other guy?
No, I'm talking to Spring Corps.
Go for it. Prove me wrong. You're just Googling things and then saying, like,
Okay, back to it. So, do you know how they got it?
You asked me the
Know
same
anyone?
question a million times, dude.
Okay, so you live in a belief that you live on a spinning ball in the vacuum of outer
Yes,
space. Tell me
that's
why
true.
it's not a belief.
I've told you already. I believe that, and there's no claim otherwise. I
Okay.
believe we live on a globe.
How
There's
have you
no.
confirmed?
So it's
How
like a
have you
religious
confirmed that you live on a spinning ball in the vacuum of space?
I haven't done the necessary science myself, but for better or worse, I trust my scientific
Hey.
institutions with certain facts
Oh,
that I
great.
live
The
off of.
priests.
I-
So you're in a religion.
Yeah.
If you want to call it that, sure, yeah.
It is. That's what
Hey,
it
that's-
is. Do you know what the definition of religion is?
Hit me.
Well, it's having a blind faith belief in something that has no proof.
That doesn't sound dictionary based, but the belief in and worship of a
Does it need to be
superhuman
based
power or powers, especially a god or gods. I don't know if that's probably not quite right, but maybe a particular system of faith and worship that might fit it a bit better.
Yeah, there you go. Faith and worship.
Right.
You worship the ball. Your
I
gods
wouldn't say I
are.
worship
your-
it. I mean, depends what you mean by
your
worship. I
gods
don't
are-
go
your
around,
gods are giants,
bowing or
And
anything.
you have a faith-based belief in a ball. Isn't that
You're
amazing?
Okay.
defending the thing that you believe in, so you're worshiping it because you're defending it. You don't even know what it is. You're just defending it. Why?
If defense is worship, fair enough.
And blind belief at the same time.
Well, yeah, defense is
Yeah.
worship when you're believing something without having evidence of why you believe that. Like there's no
I have evidence. I understand that you guys, your like burden of proof for that evidence is a different level of mine or has different things. That's fair enough, but I still personally consider it evidence. That's
Well, here's the thing, we
fine
know
for me.
it-
No,
flat.
it's not evidence. It's belief, bro.
Yeah, we
It's not
know it's
evidence,
flat.
It's belief. Yeah, go.
So how do you separate knowledge and belief in your mind?
Listen. Go outside. Like, go outside. Look, we are not moving.
Can
we
you
are
answer my question?
motionless,
How do
okay?
you separate
you
knowledge and
believe-
belief in your mind?
You believe that we are on a spinning ball, tilting, wobbling in the fucking vacuum of space. But when you go outside, we are not moving, bro. Motionless. And water, bro. Water. Listen. Okay. If you put water in a cup, I say this so many times. If you put water in a cup, right, the cup become the container, and water is flat, is level when it at rest. You move the same water into a swimming pool. Guess what? The shore around it is the container, and water is flat and level. Now we put the
You're
same
dead right
water
so far.
no, listen. When we put the same water in a lake, right? The shore around it, it's the container, and water is flat, is level when it's at rest, right? Now you put the same
Yep.
fucking water in the ocean. What's gonna happen? It turn into a ball?
No. If you take a similar size measurement, if you take a cup size like circumference of the ocean, it will definitely appear as flat as the cup does. No disagreements there.
so
But when you start
So
zooming
where
out
did
to
you get the
like
ball from?
thousands and thousands of kilometers, a curvature starts to appear because it's a matter of scale. But
there's
Yeah.
bumps in the ocean, water bumps.
there
what
was
you're
actually,
saying?
they're called tides. But
Yeah?
yeah,
Okay. Could you?
yeah,
show
that's what a
us
tide
water
is.
bumps?
It's just a bump. Yeah, dude, like watch the water rise up and down. It's a bump. That's how that works.
I don't
It's
know about
very
you, but
fascinating.
When I
actually.
look at the beach, I see waves that are crashing on the shore of the container, right?
Yeah.
Because
But you'll also notice over like an 8-hour period that flat level will rise and fall. And if you zoom out enough, you can see the actual gradient of that rising and fall. And you'll notice that coincides with the moon. And then you realize, oh, they're tides and the gravity is being shifted
Hold on.
and they're actually little balls. It's very interesting how water moves.
well, keep it simple, right? Does water always find level?
As best it can with the forces it's being subjected to, yeah.
It's always going to try and find level, right? No matter what container it's in, water always tries to find the equilibrium, right?
Yeah, a balance of forces and equilibrium for sure.
Okay. So one fact that we have to both agree on is that the Earth is 72% covered in water, right?
Yes, by surface, by just that doesn't account for volume, but yeah, sure.
Let's just
I'll
say
go with 72.
yeah, 72%, right? So if water
Surface
always
area,
finds
to be
level,
specific.
yeah,
not
if
volume.
water,
Yeah.
if
Yeah,
water
yeah, yeah.
always finds level, and 72% of the Earth is covered in water, right?
Mm-hmm.
Then how are we on any type of spheroid or sphere? Doesn't make sense.
It does make sense. I mean,
So
It's
water can stick
not-
to a ball.
yeah, in
Water-
the same way a raindrop is a sphere. It's like it's a
raindrop?
distribution of
How about
forces. Yeah.
the convexity of water. Is that what you're talking about?
I'm talking about the tendency for water to form an equilibrium with the forces it's being subjected to. In a raindrop, there's like van der Waals forces on the outside and hydrogen bonds and all this shit that contain the water in a sphere. And in the same manner, and that's the most balanced force. Obviously, when it's falling, it starts to elongate as there's different accelerations and blah, blah, blah. In the same way, on the Earth's surface, the water will take the shape of a container. If it was flat, it would be flat, sure. If it was a
it's
sphere, it would be spherical. But
What do they
depends
call...
on the shape of the container. Again, this is begging the question.
Well, what do they call it? They call it sea level, don't they?
They do. There is a name for it, sea level, and that
Yeah,
is
it's not
the
sea curve.
relative.
Because it's flat.
Yeah, you can use like the terminology to prove your point, but it doesn't really
No, but it's true
mean
though,
anything.
because it's sea level.
That is true. It is called
70
sea level.
Why?
It is the level, the height. Why? Because it's a very useful measurement when talking about ships and distance to the bottom of the
Because
sea
the
and the
ocean
distance.
is flat over a stretch of like a span. Like when you have water in a container, right? Like what would contain the oceans? Why are the oceans
The sides of it.
right? The shores or
Sure, the long sloping continental shelves or whatever you want
right.
to say. Yeah.
It's being contained, right? That's why waves are crashing because it's like water in a bathtub sloshing around. If you think about it like that.
Somewhat. Waves are kind of there's wind and shit, but yeah, fair enough.
Right. So 72% of the Earth is covered in water.
Mm-hmm.
Flat, sea level, water.
Yeah, I mean you're throwing in flat as in implying that that's the container, but if you want to say that, sure.
Yeah,
It
because
looks flat. Yeah.
if it's 72% of the Earth's surface is covered in water, that means 72% at least is flat, right? So how can you shape that into a ball? That doesn't
In
make
the same way, a raindrop is shaped into a ball. Just because, listen, what you're saying is the same thing as saying a raindrop surface is 100% water. So why isn't a raindrop flat? It's because there's other shit happening. That's why.
Well, okay, so you're talking about raindrop, right? So what would happen when the raindrop drop on the ground or drop in whatever? What do you think is gonna happen, right? Let's say 1,000 raindrop drop in the same spot. What do you think is gonna happen? It's gonna rush to every direction to find its level.
Well, it's gonna hit the ground, and then all the momentum from each of those raindrops are gonna splatter. What do you think happens if a hypothetical spherical Earth hits a big fat wall? It's gonna do the exact same thing. It's gonna splatter like a raindrop.
Yeah, well, because you think that we're living on a ball. That's why.
Yeah.
Yeah,
That's exactly why. You got me.
Well, the only the only ball really exists in your imagination and where you see from NASA picture, photo, whatever you want to call videos. But in actuality, bro, you go outside, water is fucking flat. Water is flat with the same
dude,
dimension
I understand. I understand that.
3959. There's no curvature. Drop over distance, my friend. You live in fantasy. Hello.
Okay, man. Yeah, like you can insult and say I'm fanning whatever,
No, I'm not
but it's not
insulting.
going to
I'm
change my
telling you-
mind.
I'm telling you real shit. Well,
You're telling me what you believe, and
so
I
what are you
appreciate
here
that,
for?
but it's
You
not
here to
changing
challenge
anything.
Deck.
I'm just here to chat. Yeah, but I'm here to understand your positions, why you believe it, and I'm hoping that you would take the same position for me as well.
It's not a belief, bro. We know fucking water does
We
does
know
not
it's
curve
flat.
into a ball,
That's the
bro.
difference.
You believe, bro. You just admitted earlier that your whole fucking shit is based on belief, and you want to point at us that we believe. No, fool, you believe in that shit, bro.
Yeah, we
No
know
one's
it's
actually
flat.
like told me what the difference in their personal definitions between belief and knowledge is. How you separate those two things? I would like to hear that.
Timbo said it pretty well earlier, right, Timbo?
Kembo,
Hey, but-
he just said go outside. It's flat. That's all I heard. I'm not sure really.
Okay. I'll reiterate what he said as best I can. But belief in something, the difference between knowing something and believing something is belief is having faith in a subject without having any evidence to back up that belief. That's why it's called a belief. That's why it's religious. Because you're not using evidence to back up your belief. You're using a feeling. You're using subjective
Well,
evidence.
listen, on
that
the
you
on the
have.
dictionary, what belief is saying is an acceptance that something exists or is true, and then it says especially one without proof. So it means that
So you have no
yes, a
proof.
belief without no, but listen, a belief, right, can be without proof, but it can also be with proof. The core crux of it is that it's something that you accept as true or existing, right? That's the core of it. Whether there's evidence or not, the point is that you believe it or that you accept it to be true and that it exists. That's the definition of belief, or the one that I use at least.
Well, let me ask him a question.
Hold on, let me clear that up, Kel. One sec. You
Sure.
can't believe something and know it. Yeah, you either know something or you believe it, but you can't believe
You can.
something.
Why
and
not?
subsequently
They're not.
know it.
They're not antonyms. No. So no. The verb in the dictionary says be aware of through observation, inquiry, or information. Okay, and then a belief is an acceptance that something exists or is true. So I don't see any reason why you can't both believe and know something to be true. They're very similar words in definition.
No, forget. It's a contradiction. If you know something to be true, no, let me finish. If you know something to be true, yeah, I don't believe I'm speaking to you now. I know I'm speaking to you now 100%, okay? There's no belief here. I know what I'm
What are
doing.
you defining as belief?
So belief is, well, as explained to you several times, is a faith, okay? It's a faith. I
No,
don't have faith.
that's what your definition of belief is. Okay,
No,
sure,
no,
we can use that one. But the one in the
everybody-
dictionary is different.
Everybody has the same understanding here.
No, that is
To
wrong.
know something is to have some sort of direct experience, okay, where you know 100%, right? I know 100% I'm talking to you now, Dec, and I can't believe it because I know it. You can't hold both positions at the same time.
You can. I don't know why you think you can't, but if you look at the definitions of the exact words and their meanings, they're not contradictory in nature. They just aren't. You can look at the words and see for yourself, they're not contradictory. If you want to make your own definition, then they might very well be contradictory. But in my mind and in the English dictionary's mind, that I can both believe and know something. Right?
No, you're even quoting the dictionary wrong. To have a knowing is not the same as a belief, and if you think that it is, then you need to scratch up a little bit. You need to, tighten up a little bit with your definitions.
I'm reading them to you right now. How much more scratched up can I be? Okay. I mean,
You're
what do
holding
you
you're
want?
holding you're holding a contradictory position, okay? To have a belief is a faith. To have a faith, yeah, is not to know something, it is to believe, okay? But to know something includes direct experience of some sort. Hence why we do not like to believe that the stars are anything more than what we can see they are as lights in the sky. You believe that they are something else, but we know, we don't believe, we know you can't prove that. So there is a difference, and science is a good marker for this, because when you've got a method like the scientific method, that can take you from belief, i.e. a hypothesis, to knowing. And this is the main difference between you and us here. We understand you can know something, and science does prove things. You seem to think it's every opinion for themselves, and that's not how we work here.
That's not what I'm saying, and that's fine if we can hold different beliefs. That's not a reason to arc up, all right? That's cool. If that's the way you do things here, fair enough. and I'm happy to adopt your personal definition of belief and know. Then, in that case,
Not a
in my
personal
eyes,
definition. It's not a personal
It's-
definition.
if it's not, if it's not
personal
in,
definition.
bro, the actual dictionary, the Oxford Dictionary, is different to
Yes,
what you're
makes
saying
a
the word
distinction.
means.
Yes,
Therefore,
the Oxford
it's a different
Dictionary makes a
definition.
distinction between the word belief and the word knowledge. Otherwise, we wouldn't have two separate words to detail the difference.
It makes a distinction between grab and hold. It doesn't mean that they mean different things necessarily. They're
Right,
just two
then-
different
then
words.
not-
that
so are they synonymous? Are they synonymous?
they can be depending on how you use it. Personally,
okay,
I've
so
been
it's the
using it
context.
quite synonymously.
So we're
It is
talking about
contextual for
context?
sure. Yeah, it is contextual for sure. So, but obviously, in this context, we are separating belief in terms of like something without evidence. So that's
right.
If that's what we want to accept as the definition of belief, then I'll say I don't actually believe
So
the
that's
Earth is round. Then I know.
So that can.
in that
so,
case.
so it's not
so
a
you know
personal
it.
definition. So it's not our personal definition, correct? It's in that context that it's being used, right?
Well, yeah,
Because
it's
it can
the
be.
contextual
right?
definition
it's built to be
of
used
this.
in that context. It's built to be used in that context.
No,
Just the most important thing is that we
it's
can
not
come
built to be used in any context. It just is. But what did you say? Sorry, Flying?
As long as we can come to an agreement how he sees the word, that's all that matters. If we can say
Yeah,
that,
exactly.
you
So
know,
I'm happy to accept that. I'll use belief now to mean without evidence. Okay, so in that case, or at least believe. I mean, for me personally, when I say I believe something, what I mean is that like when I talk honestly and what I truly think is reality, that's what I mean by believe. So like when I say I believe my hair is blonde, what I mean is my true actual, my best to my knowledge ability to describe the world, I believe it's blonde. And in the same way, I believe the Earth is
Well, that would be something that's based
sphere.
on experience,
But-
right?
but
And
it
something
sounds like
you
you would-
can verify. That's something that's verifiable.
No, he's still using.
Listen. I'm just talking about definitions right now. We don't have to go into verification all that. But point being is that what I use belief meaning as in I know it and feel it and accept it to be true in my mind. I act as if this fact is true. That's what I mean by belief. So when I say that, I mean I believe the Earth is round. But if we're talking about know in terms of having
Okay, so
evidence
where's
that
the
you
evidence?
personally feel is
Where's
enough
the evidence which supports your belief of having knowledge that the Earth
Yeah,
is
why
round?
why do you believe the Earth is round?
many reasons, right?
Okay,
I mean,
let's
the
name-
fact
let's name
that
one.
Fallacies
name
is the
a
reason.
single one. I'm sure you can pick to holes any single one I use, right? Using your own
Yeah, we can.
methodology. But if I can just throw out like a number of them, right? So like, obviously we have pictures and satellite observations. They get pretty iffy and, you know, could all be graphical, whatever. We have like mathematical observations. We have observations of different planetary objects using telescopes that are purely mechanical.
What is
There's no
something that we
electronic
can do for
involved.
ourselves? What is that? We're looking for something that we can do ourselves to verify it for ourselves.
Okay. I mean, to me, and your burden of proof may be different for better or worse, but to me, if I can go out, buy a telescope that's purely mechanical, doesn't have any electronic things that could maybe affect the image and generate things, right, that aren't there, whatever. If I can buy a telescope, point it at a different planet, and see that it acts as if
We're
it's a
talking about
sphere, it
what we're standing
spins,
on.
its
Why
face
are we looking at the
changes.
sky? Whoa, slow down. Why are we looking at the sky? We're trying to determine the surface quality of what we're living on.
Yeah. So a good way to determine things that aren't directly observable, right, in terms of scale and things like this, is to look at similar objects and then extrapolate that information. Obviously, you don't.
So
maybe you
it
don't want
looks
to do
like
it.
looks like a good enough standard for you.
Not usually, but looks like flat seems to be a good enough standard for you guys. So I'm using that one. But if that's
Beck,
give me a
let's just
different
clear this up. Let's just clear this up before we go any further, okay? You seem to think that we have our own personal definitions for stuff, okay? We have scientific
Everyone
method,
does.
okay? No, listen, no, this is where you're wrong, right? We have something called the scientific method, okay?
We
And the
do.
Yeah. Now that differentiates. That will help you to find the cause to phenomena, okay? So we don't have to believe things, yeah? if it is if it happens in nature, if it's an observable phenomena, then we can use science. So we don't have to pre-assume, we don't have to we don't have to make assumptions or have beliefs. Yeah, we can take
assumptions happen in science all the time. But sure.
No, if there are assumptions, right? If your conclusion is if you're making assumptions, what you're doing is pseudoscience, which is fine.
No,
but what I'm telling
if your
you
assumptions are too big for the conclusion, then yeah, fair enough. But like normal science makes assumptions all the time for the purpose of the experiment, for sure. Like you assume ideal conditions, you assume this.
You can't pre-assume a globe when the question is a globe. You can't pre-assume the planets are spheres.
That's fair enough. Yeah,
when what is in question is the actual sphericity of the lights in the sky. So what I'm saying is you are jumping into these mistakes and you are scattergunning all over the place because you're not keeping it to the scientific standards. It is not our standards, but it needs to be observable and repeatable within nature. We can call it science, and then it goes,
100%.
It leaves belief and enters the realm of knowing. And that's the difference.
Sure. So let's say that, well, like, let's create a hypothetical experiment in which we're using the scientific method to determine the shape of a light in the sky, and one that happens to cross very regularly and in the same way across our sky for hundreds of years.
You've made a mistake. How the hell are you going to be able to manipulate any independent variables in the sky? Listen, you can't do space. You can't do science on lights in the sky, which is why we will tell you again and again: the lights in the sky are no way to prove the ground that you're walking on.
Right.
Because there is no science involved here. This is all pseudoscience based on your assumptions, on your assumptions of what the lights in the sky are. The lights in the sky are not, you cannot do any science here. So just recognize that.
I will not recognize that because I completely disagree.
To the surface quality of what you're living on.
We haven't even drawn any conclusions to what we're living on at all. I'm just talking about...
You're pre-assuming the lights are planets. You're pre-assuming the lights are planets, and then you're comparing
I'm just
to the
saying they're lights. Right. So far, I'm just saying I see some lights up in the sky. I want to know what they are. Are we good so far?
That's great and dandy, but that wasn't the question, man. The question was...
I'm getting there. I'll get there. Right?
Why do you believe that you were on a globe? That's the simple question. Why do you believe? What would you do? Your top three reasons why you believe you're on a globe. Keep it simple.
Because of, well, listen, everything I say, you're going to say it's not scientific, even though I believe it's scientific. And then you're going to ask, well, why do you believe it's scientific?
Well, hold on.
Say, well, I believe it's scientific as well.
You're assuming what we're going to do. We're giving
I'm
you the
making
spotlight.
a very valid assumption because every time I've tried to do it thus far, you've done this. I doubt you're not going to do it this time. But
okay,
sure, I'll try.
I'll mute myself. I'll ask the question one more time, and I'm going to mute myself.
Okay,
Why do you believe that you were on a globe? Your top three reasons.
So here's a big one, right? And I'm going to go on the planet thing, and if you'll let me finish, just so you can see my whole point in entirety, and then you can say where it falls down or where the fundamentals are wrong or whatever. But I believe that you can conduct scientific inquiry and observations on basically anything, right? You don't, like, I think your understanding of independent variable is a little confused, but my understanding is that there can be things in nature that as long as you measure a certain variable to be different at different times or whatever, then you can count that as an experiment where the independent variable is the thing that has changed, whether it be the sea level or the level of light or the angle of the sun in the sky or the wind speed, whatever the variable might be, right? As long as that variable that you're measuring is changing, then you can say, okay, that's my independent variable. And obviously this is going to have different things because depending on the environment, your controlled variables are going to be difficult to control, etc. But whatever, I digress. So let's say we can conduct scientific inquiry.
Yeah. Let's start with number one. Go ahead.
So scientific inquiry, I see a light in the sky, and I notice that it moves in the exact same way relative to all the other lights. They seem to stay the exact same position. This one moves. I go, what the hell? Moves in the same way. So then I build a device that can take in light and then magnify that image so I can look further. and I point it there and I go, oh shit, it's not just like a little tiny light generation. It's actually like what looks to be a circle in the sky that has colors and it has a shape and whatever. And then I build a better one, and then suddenly it's a lot more clearer. I can see detailed colors. I can see other circles cross in front of that, etc.
Can I?
And I can now,
real quick,
if I can finish, and then you can ask at the end. And then after I do that, and I make lots of observations, detailed with my very detailed light magnifying device, I can then track the positions and see where they go relative to me all the time. And I plot these things out, and I notice they repeat every single year. Interesting. So then I look at these different things, understand how these movements can rectify against each other, and realize, oh, well, if they move relative to each other and we, again, assume some forces, which we're obviously going to assume, we can not assume anything, but we don't get very far in science if we don't assume anything at all. But if we assume that the forces acting on all these things are the same, and there's not just random things acting on random other things, which wouldn't make sense because there's patterns that we can clearly see, which usually indicates some kind of underlying common variable across them all, we develop some laws that these things tend to follow, etc.
Is what does anything in the sky have to do with the measurable, observable Earth that we're living on? What does anything have to do with? Like, it has nothing to do with Earth, man. We're trying to
so
we can make Earth is flat. How do you know it's round?
So we can make two assumptions. We can either make the assumption that the Earth is separate from the sky and the lights in the sky and everything. We can assume that they're separate, or we can make the assumption that they're a continuous kind of continuum and there's nothing really separating it, right? Those are both assumptions we can make, and those will lead us on two different paths.
We're not making assumptions here, my dude.
You always have to make an assumption. You always do. Yeah, it's inescapable.
You know what an assumption is? It's a hypothesis.
No, it's a fact taken to be true.
That's not a fact. When you assume something to be true, you're assuming without evidence. You know what that's called? That's called a hypothesis until you prove it with evidence.
That's not called a hypothesis. Is different from a belief. A hypothesis is an outline of what you think is going to happen that you haven't verified yet, right? So that's
you haven't verified that.
An
assumption
is something that you accept as true without question or proof. You have to do that as humans. You can't operate having 100% scientific inquiry and method over every single fact in your brain. It's not a thing that happens.
Let's simplify the conversation, please. Like, seriously.
Can you not follow or what?
Oh, I can follow pretty easily.
Then why do we need to simplify it?
Because that's not you're beating around the bush to the question that I asked, which was give us a reason or some type of measurable experiment or some type of anything, any reason that you believe that you're on a ball. Like, why do you believe you're on a ball? Give me the number 1, number 2, and number 3 reasons. It's very simple. There's got to be something there, right? There's so many things you can point to, but you're not pointing to one of them.
I've pointed to several, but I was currently pointing to the planet thing. Yeah. So the point is, you can make the assumption that either the Earth is separated from the sky and the heavens and the lights, or you can assume they're continuous. If you make the assumption that they're continuous, which I'm going to do, then we assume that the Earth is probably very similar to other things that we see outside. It makes no sense to assume that the Earth has a completely separate set of laws and rules. And
why?
Listen, I'll tell you why, instead of just repeating it. When we talk about rules and like laws of nature in science, the point of them is that they are continuous, they act on everything without discrimination. So the idea that the Earth would somehow be different and above or separate from all the rest of the laws that govern everything else we observe,
but that's what you observe.
To me, doesn't make any sense.
But that's what you observe. That's what you experience.
It isn't what I observe, not at all.
Yeah, it is. It is what you observe and experience. You do not see a similarity.
The observance of it being flat?
Yeah, you don't see any observable similarities.
Sure, I do.
It's it's illogical.
Show me a tree on Mars.
Okay, there's no trees on Mars. Good one. You got me.
Okay, well, what's
They have rocks. They have forces that
You don't see that. You do not. No, you don't. You don't observe that. You don't observe that.
Yeah, I can look with my telescope, see moons
And not
rotating
see
around
rocks.
the,
Hey, you
around,
do
around
not
Mars.
see rocks. You do not see rocks.
You do not see rotation.
Hey, dude, when
you can see
look
the
in your-
movement of
Hang
objects on there.
When you look,
Okay.
when you look in your telescope at Mars, what do you see?
Huge
I've got
red
one.
planet.
Don't lie to me.
A red planet. Okay.
Red planet. So, do you see rocks?
My telescope isn't quite that good.
So you just said you see rocks when you look at Mars. T-Dub said,
Rock.
"What do you observe?" And you said rocks.
Okay,
Where
well,
are the rocks?
let me be more specific. I don't observe any rocks with my telescope. You're right.
See
I
a red
observe
light in the sky. Yeah.
observe
Be
a
honest,
circle.
I've got one. I've got a telescope.
Okay, our telescopes might be
telescope
different.
too. What
Sure,
do you see in the
cool,
sky?
man.
A red light. Correct.
Red object. It's definitely very objective in my telescope.
Okay. So is that object spherical?
It sure looks like a circle.
It looks like a circle.
Circle.
Great.
Right.
But sure, but I don't really encounter many. I don't encounter many objects in my day to day that is a 2D plane. Doesn't happen very often unless it's like
2D
paper
doesn't
or
exist,
something like
mate. Get
this.
into reality. 2D does not exist. All right?
Yeah, 100% agree. Yeah, I agree.
Great. So why are you bringing up 2D?
Well, it was more colloquial. I was saying it like it's more flat than it is deep, but we can.
Okay.
Sure,
so
it's
you look
3D,
up in
but
the sky,
its depth dimension
in
is
the
much,
sky,
much,
you
much,
see
much
a
smaller than its length and width.
see a red
Is what I
light.
meant.
You look up in the sky, you see a red light, and it looks like a circle.
And
A red circular object, 3D object.
How do you know it's 3D? You're looking through a uni lens.
right.
You just have a fucking rage that everything is 3D and there's no such thing as 2D.
No. He asked,
Yeah,
how do you
but
know it's
2D
3D? Yeah.
Yeah, so if I'm looking at something, right, then
Telescope,
I know
right.
it exists in three dimensional.
But
Three
you don't know
dimensions.
it's physical, do you?
I'm looking at it.
Yep. How do you know that's something you can land on?
I don't yet.
Okay.
Okay. So why are you saying it's got rocks on it?
Progress. This is great progress.
Okay, I will rescind the rock comment. We don't know enough about
Okay.
Mars with our
So-
telescope yet to understand the rocks. Sure.
Everything-
or lack thereof.
Okay.
Everything that you see in space is from a third-hand party that you cannot get any evidence by yourself to confirm.
Are you
that
you're
any of
assuming
these
stuff?
things
I've got my
exist.
telescope and I can see it. Right, I know
You
it's
see
there.
a red light. That's what you see. A red.
Exactly. You just
light.
admitted it.
Red, not a light. It's not a light anymore. If it's a light with my naked eye, it's a point, right? With a telescope, it
Well, it
is
does
a
look like a
thing
light.
that has dimensions
Bro.
and is circular. It does have light
can't
reflecting
see
off of it,
dimen-
obviously.
Are you talking about three
Of
dimensions?
course, you can
can't-
see.
You can't see
I can see-
dimensions with a telescope.
Right.
Yes, you can. You can see two of them.
One lens.
It's one lens. Yeah.
What, you're seeing one dimension with a telescope?
So check it out.
Close
When you
your
wear-
eye. Close
when you
your
wear-
eye. Close one eye.
Yeah,
Do you
close
see
one
three
eye.
dimensions with one eye.
No, I see two dimensions. Is what I'm saying. I see two dimensions in a telescope.
That's not what you said.
That is exactly what I said. If you listened
No, it's
instead
not
of
what you
just
said.
raging over. Me, you would have heard that I said I can see
I'm not
dimensions
stupid,
in a
man.
telescope.
Otherwise,
I can
wouldn't
see
be
two of them.
arguing that
I'm not
you
calling
said
you stupid.
three
I'm saying you misheard me
I
because
said
you were talking
I'm
over
not
me.
Stupid. I said I'm not stupid.
Sure, and you only said I'm not stupid because you assumed that I'm assuming you're stupid. I'm not, right?
Okay. Let's
No,
back
this-
up a
that's
second.
fucking
Yes, let's
childish.
please back up because he's very aggressive. I don't know why.
Yeah, I am.
I mean-
because you're a fucking moron the whole time.
Oh, you're assuming I'm
whole-
stupid now.
the whole
Listen,
time.
dude, just chill out.
All right, Deck. All right.
Yeah,
let's go back.
Beastocles.
Hold on.
Beastocles or Beastocles?
Well, whatever you prefer, man. It's okay.
Beastocles is a traditional Greek pronunciation, and it sounds
Sure.
cooler. I'll go with that.
Thanks. Let's get back to the conversation at hand real quick, man. And it's still the
Deck, I've
conversation.
just muted you, right? So I'm just going to give you a warning. The whole time I've been listening, making dinner, and all as you've done is begged the question and brought up fallacies. All right? You've got no proof of anything, and you can't prove anything that you're saying. So who's the moron?
Well,
there you go.
Yeah.
The moron is the person that forcefully mutes people that they disagree with, I would say, but that's just me.
But did you listen to what I actually said, though?
I
Are
did.
you going to
I
bring
did.
any evidence to the table or not?
I mean,
I've been
he's not
trying
wrong,
to. You
Deck.
just keep getting angry. I'm
Go.
trying my
Where's
best.
the evidence that you can confirm that you live on a ball?
That's all we're asking from you, brother. Where's
Yeah, I know.
the
I'm
evidence?
trying. I know you're trying to
Where's
stick on
the
his side, Beastocles, but I think you should probably distance yourself from this
what I know
behavior
to be
over here.
true?
No. From old mate over here. Just because you believe the
Okay,
same thing
am
doesn't
I-
mean you have to
am
be
I wrong?
buddies. But yeah, sure.
Am I wrong, though?
He's not wrong. He may have a curt way of saying it, but he's
I
not
have
wrong.
I have no doubt that you think I'm wrong.
No. That's not what the question was. Was he wrong about the statement that he said when he had you muted, where he said you brought?
I've come in
no
here, I've brought in conjecture, no proof. Yeah, I understand that he sees none of that as proof. I see it as proof. Two different things.
no
That's
proof.
fine.
There isn't
What
any
proof,
proof.
bro.
No,
You
Deck,
admitted earlier that it was all belief, and what proof are
Yes.
you talking about, bro?
Right.
We've got you on
Are slow or
recorded.
something, man?
Yeah. And listen, Deck, we're just trying to demonstrate to you that everything that you're saying is a belief, right? And that there is
I've agreed to that.
But listen, the logical position is to understand that there is no motion, there is no curvature, right? That is that is the logical position. So the burden of
I
proof
would disagree.
be, no, it is, because all of your senses will tell you we are not.
And I would
moving,
disagree.
we are
That's
not-
okay.
No.
Let him finish,
You're,
let him finish.
you're wrong.
What are you
You're wrong.
disagreeing about, though? What are you disagreeing about?
I'm disagreeing that it's the logical position to assume there is no curvature and no movement. That's what I'm disagreeing
Okay, so
with.
go. Where is it? Where is it then?
So I think the most logical position, right, is that the Earth is not any different to anything else that we can look at. That's my
illogical.
position.
That's
I don't think that's illogical.
It is
Your
illogical.
pre-assumption-
I think I feel
your
like it's more
pre-assumption of
logical. It's so listen. You have to
Okay, so
assume either the Earth is different to everything else, or the Earth is the same
What do you mean
as everything else.
else? You don't even know that those things up there are physical. All right, so you do this. You walk outside, right? You walk to the beach, right? You look out. It looks flat.
It looks flat.
And it
Right.
feels
Yeah, it does.
stationary.
right.
Yeah. So you.
I'm going to
think that
quote you
it's
from earlier. Is it now the scientific method that when things look the way that's sufficient?
No. Well, that doesn't matter. I can give you laser tests if you want, but like
Yeah,
what,
we have.
what I'm
in a good
saying
way,
is,
Timbo.
okay.
If you,
What's that, mate?
I can put this in a different way that he might understand. Would be that when you're a child, if you were never taught that you were living on a spinning space ball, when you walked outside, you would never have made that assumption on your own.
Right.
You
That's
only
fair.
make that
Yeah, that's
assumption
true.
because you're told.
Right.
That's why it's
Yeah.
the logical position.
Yeah, that's why it's logical. Yeah. So you'd need some really good evidence.
To be fully clear, every position you come to is logical and says you're going to have a reason for believing everything you do. But,
Hey, mate.
yeah.
So him saying that, how do you come to the conclusion that you live on a ball?
Right.
Because everything outside tells you that it's flat and stationary.
Okay, so I don't think that like saying, well,
Man, just
I'm
answer.
answering your question, dude. If you give me a bit, all right?
He asked you 20 minutes ago to give you 3 best reasons, and you went off into space.
You keep monologuing, dude. So hold on.
I'll
He just
monologue
asked me.
No.
So he's put it in a different way, and he said that how come, as a child, you would never have thought that the Earth is a sphere when you would take your own observations in and go, oh, it's flat. I've got no reason to believe otherwise, right? He just asked me that.
That's a great, yeah.
Sure. In the same way, a child will look at a phone and assume it's magic. A child will look at a TV, assume that screens just play stuff. But the point is that a child does not have the capacity with their senses that they're naturally born with to understand a lot of what goes on around them. You need to have a base of knowledge that people can build up over time and learn so that... Yeah, I'm answering the question.
Wait, hang on, but the point is, the point is that when you grew up from a child and you were an adult, you would still be looking out over the flat earth and not assuming that you're on a spinning ball. The only reason you've got that assumption is because you've been told that. So you're believing what the authorities tell us to be true.
Yeah, sure. You can look at it that way.
Okay, I
an
have
alternative
a question now. Wait,
but listen, what you're saying about that is true for any kind of knowledge that is like multi-generational, right? Like if I was a child and no one taught me how to make fire, I would grow to an adult and assume fire just comes from lightning, right? But the thing is, I need to be taught that from someone that's figured it.
No,
and then you extrapolate that for 2,000 years, and suddenly you can't only make fire, you can also make phones, you can make laptops, and you can make rockets, and you can look into space.
Deck, let me throw you a bone.
Flat
real quick,
is
man.
an observation, man.
Burn me, man,
It's an
burn me.
observation.
I'm gonna throw you a bone because you're almost there. And what I mean by almost there, I'm saying like
nowhere near
it. Well, the thing is,
I won't be offended by the deliberate talking down, but sure, I'm almost there. Help me along.
What you said earlier, right?
Yeah.
Or what AJ said earlier about if you were a child, or all the way up to an adult, if you've never been told you were on a spinning ball, right? Then you would trust your senses. Your natural senses tell you that it's flat, there is no curvature. So that means that your only reason for believing that the earth is round is from authoritative sources. Now, having that in mind, do you agree with that, right? It comes from authoritative sources. Okay.
Authoritative in the sense of like the institutional, a lot of people.
Someone that has
not in the sense of the enforcing the belief, like
not
at threat of violence or something.
Now, my question
not
for
scientific, so
yeah, but
Kimbo, just like let Beasticles go for it this time.
I'm just reiterating that shape is not scientific.
So my question for you, Deck, is have you ever felt that authority figures, such scientists, anybody with credentials, has ever lied to you personally? Have you felt like someone was lying? Politician, president, anybody?
Yes, and also mistakenly told me something that they believed to be true but is actually wrong. Both of those things have happened from authority figures, 100%.
Okay. Now, knowing that, and knowing that humans have the capacity to lie and deceive for their own ends, right?
Yes. Man is evil.
Why do you trust these authoritative figures, right, so wholeheartedly as like a religious belief that you're willing to deny the science about observable, measurable phenomenon and go with the authoritative narrative? When you know that they lied to you, you've seen it. Have you ever thought about that? Like, what if they are actually lying to you?
Of course I have, and I'm sure they lie about a bunch of shit. There's probably aliens, there's probably fucking this and that. God knows what else, yeah.
So my next question is why would they tell you the truth about you being on a spinning ball? Like, why would that be true? Like, why do you believe that's true? If you know that the source of information you're getting is capable of lying and probably has reason to lie because they don't want what's best for you. They want what's best for them.
Yeah,
Well,
okay,
the fact
but
is
like
that
what
they do
reason?
lie, because I think that everyone would agree that they tell you that the theory of gravity is science and that there's science behind this gravity. Would you agree with that?
There is a lot of science behind the idea of gravity for sure.
No, there's not.
Actually,
well, there's a lot of scientific papers behind it. If you count that as science, then yeah, but sure.
Then let's go through that. Let's go through that.
Yeah, let's go through that for real.
We can show 100%. that it's not science. So can you define science? What is the definition of science?
All right, let me get a proper one up.
He's going to Google
science.
real quick.
We're looking at natural science because we're looking at the world.
So science definition: the systematic study of the structure and behavior of the physical and natural world through observation, experimentation, and the testing of theories against the evidence obtained. Are we happy with that?
Beautiful.
Well done.
The dictionary does very well. Yeah.
Let's have a look.
It's actually not correct from someone. Okay, dude. Anyway, AJ, go.
Can everyone let AJ take this? Can you let AJ
Wait a
take
second,
this?
though. Can we just wait? I just want to clarify one thing, that the last statement in that definition is incorrect.
And the testing of
Okay,
theories against the
elaborate.
evidence obtained, you're saying that's wrong?
Yeah, it stops at observation and experiment. That's where it stops.
No,
Well, it doesn't. Not according to the Oxford Dictionary. I don't know if you're a
Yeah,
much
the Oxford
better
Dictionary
source
is
than
wrong.
that.
A theory
T-Dub has
scientific theory
fucking made his
developed-
decision.
A scientific theory is developed after experimentation.
Yeah, but a scientific theory is inclusive of science as a whole, and scientific theories need to be tested against evidence. No?
No such thing as science as a whole.
Okay, we're going off track
Okay,
anyway.
sure.
Let's
Yeah,
do
we're
the
going off
science
track.
method.
Anyway, we agree on the science. Most of us do, at least, on the definition of science. Sure.
Go ahead, AJ.
So then, what's the scientific method, and what are the dependent and independent variables?
Okay, going back to year 8 science. Let's get it.
Yep.
So the process in the scientific method, this is from Wikipedia at least, involves making conjectures or hypotheses, hypothetical explanations around your observations and what you observe in nature, getting predictions from that hypotheses, and then testing them against evidence and empirical measurements that you can make.
Sure. And then we also have to have the dependent and independent variables as well.
Sure, that's inclusive
And
within the
control.
experimentation, for sure.
Control variables and a null
so
hypothesis.
the first issue that I would have is that with the dependent and independent variables, you have to manipulate gravity itself. You have to manipulate the cause, not the effect. So can you show anywhere where someone has actually manipulated the cause, gravity, and not the effect?
So there's no stipulation that you have to change. Well, I mean, sorry. So you're saying that you have to manipulate gravity itself in order to test gravity.
Right.
That's how you would establish that it is
Correct.
the cause of an effect that you've observed in nature.
Right.
So that's the first
Right,
point.
okay.
And then the second
Right.
point, it's the study of the physical and naturally occurring world. So when we have a look at gravity, gravity was proposed in Einstein's relativity in 1905. And then we have, I forget the guy's name, but something Fritz came in about 1930 and showed that what Einstein had proposed
I
was
don't think
99%
Einstein wasn't it Newton that invented gravity? His whole apple on the head?
No, it's not actually Newton today. It's actually Einsteinian gravity that's actually accepted, which is the bending and walking.
And, oh, yes. I mean, obviously, Einsteinian gravity is slightly different to Newtonian gravity, but
So,
Newton came up
what
with the
I'm
idea of
saying
gravity
is-
in the first place.
Okay, so
Do you know the
Einstein,
difference?
when he came up with his theory
Yeah, I
of
do.
relativity,
What's the
when
difference?
Einstein came up with the
One is to do with space-time continuum, etc., but
Tell me
the
what-
other one is just to do with methods and stuff. Everyone can tell everyone what to do. Don't get offended. Grow up. AJ, keep going.
Okay, so I just lost my train of thought then.
Yeah.
Okay, so we're studying the physical and natural world. So Einstein's relativity was about 1905, and I think it was a dude named Fritz in 1930 that actually showed that Einstein was about 99% incorrect, that the gravity or the whatever he had proposed could not actually hold that universe in place for what it was doing. So this is where they then proposed, instead of throwing that theory out, they've proposed dark matter and dark energy, which now make up 95% of our universe. Now, dark energy and dark matter cannot be seen, cannot be detected. They admit they know very little about it. So how, again, is gravity scientific when, one, there is no independent and dependent variables, but two, there's nothing physical to actually study. You're studying a belief to make gravity work, right? And then thirdly to that, there's another part to that as well, but is that it's the bending and warping of space-time. And again, science is the physical. The space and time is a concept. Time is not physical. So you can't bend a concept.
Time is physical. It's the fourth physical dimension.
No, it's not.
Not
It's
physical.
a concept. It's not
Physical
tangible,
means
not-
physics, means
not
to do with
malleable.
physics. Time is definitely within the realm of
Well,
physics.
regardless of whether you believe that or not, we have no dependent and independent variables, and we have dark matter making up 95% of the universe that cannot be seen, cannot be detected, doesn't interact with anything, and we know that science, the definition of science, is observing the physical, manifested, and natural. So therefore, there is no possible way that there is science behind gravity. You have an agreed upon average of the rate that things fall, and then it's begged the question of what causes it.
And affirm the
I see. I mean, well, if I can respond to that, I understand that you've recognized the fact that throughout scientific history, if you want to call it that there have been multiple revisions and changes and additions to the understanding of how natural laws work. And so when Newton first came up with gravity, of course, he got some shit wrong because he was the first guy to even think about the fact that maybe objects that have mass attract other things with mass, right? It's pretty, novel idea, sure. So then he got... Pardon me?
Now you're just making shit up.
That's
Can you answer what he
no, I'm
actually
not.
addressed?
Just, dude, listen, just because you can't
answer what he
understand
addressed?
what I'm saying doesn't mean I'm not making sense.
Answer what he addressed.
Dude, he spoke for like 10 minutes.
Is it science according to science? Or
AJ,
is
you
it
don't
not
have to get
science?
angry with dickhead over here.
I'm not getting angry. I'm just asking the
Okay,
question. Is
good.
it science or is it pseudoscience? Because according to the definition of science and the scientific method, it has nothing to do with science.
I don't think that's quite true. So listen, obviously science is built to revise itself. People will get things wrong, and the point is that using the scientific
Give a
method...
viable, just give a valid hypothesis for gravity.
Oh, just give it like I'm a fucking physicist that's like
But you're
experimental and
arguing for it.
theoretical.
So, should know it.
Your belief.
Dude, I can trust someone that has more expertise than myself that they have something right.
Why?
But you were just explaining. and then
Right?
T-Dub
Because
asked the
I
question
can't-
and you can't do it.
Unless I want to live and forage and build everything myself, build my own phone, build my everything, I have to be able to trust other people with different jobs and roles that I don't
What
have
are you
the time.
trusting? What are you
That's not
trusting?
science, it's
What are
engineering.
you trusting?
Yeah.
What are you trusting? What is it you're trusting?
I'm
exactly?
trusting individual people's ability to understand things that I don't, and then
So what is it that they did? What is it that they did that you are trusting?
various scientific experiments.
Various.
Like what?
Dude, like thousands and thousands of scientific papers, not only by just
You don't even
Einstein.
know.
Like
you don't
what?
even know what you're trusting in. You just have a blind
Dude.
faith.
Like Einstein's general theory of relativity and special
What's
theory
that?
of relativity. That's
What's that?
two names of
Define that.
papers.
Define it.
Define it. Define a scientific paper.
Yeah, define the theory of relativity.
The theory of general relativity is like a multiple 100-page document about the science. Like it's very
But you don't
complicated.
know it.
That's
You
the
don't
point
know
of it.
Right. Yeah, you
I'm
don't
not saying I know the entire paper word for word off by heart. Of course I don't know it, and it's ridiculous that you would think that I would, right? But there are scientists in the field of physics who have studied this for decades.
Believe this shit.
Okay.
Who have said, "Oh,
You think
trust us. We've read it. We understand it. You don't. That's okay.
Yeah.
Just believe us."
Yeah, just
Okay,
believe
and
it.
you don't believe them, and I do. That's we
You
can
think it's ever
be
been
different.
proven?
You don't have to get angry about it.
It's
You
not
think it's ever been
What I'd
proven?
like to do is just rewind a little bit because you've
Sure.
said that you don't agree that
Yeah, go,
it's
AJ.
not
Sorry, mate.
science, but we have just
Yeah, I
gone
keep
over
getting
the
distracted
science.
from these guys jumping in. Sorry, it wasn't meant to be between you and I.
No, but we have just gone over the definition of science and the scientific method, and then we can
Yeah,
clearly
yeah.
see that it's not manifest. So in that case, and we can't use
Well,
the
no.
independent.
So let me
variables. So how
let
do
me
you
respond what I
believe-
was
Hang on.
trying to respond.
How do you
Okay.
believe that is science?
Sure. So let me try and respond what I was saying before. So yeah, you outlined Newton and then this other guy, Fritz. I think Einstein's middle name is Fritz, but I don't know if it's a different guy. Newton, Einstein, fucking Kepler, Hubble, whatever, dark energy, etc. But this is a building over multiple decades of understanding. But what you miss is that from Newton, when he first thought about this idea of gravity and mass and stuff, and came up with his not calculations, formulas for calculating different accelerations and movement of different stuff. That worked to a large degree. And people would go, oh my God, these calculations actually predict things and they can, they work. So then they use them for a while and they build a bunch of machinery and technology and stuff that work until they go, hold on, this one's not working anymore. This should work, but it's not. And so then someone has to go, well, listen, it's worked up until this point. Why isn't it fully explaining it? And so then they change it a bit and they come up with different ideas to explain more and more things.
Theory of relativity to them making shit.
We need to go right back to where you began because, again, you said, this science is continuing on. It's growing. They're growing in knowledge. It's progressive, yeah? But the problem is from the beginning, from the scientific definition and from the scientific method, we can clear that it's not even science to begin with. So whatever they're assuming or whatever they're doing still has nothing to do with science, regardless of what they're progressing with. It's not physical. Yeah, it can't be seen. Therefore, it's not science. There is no dependent and independent variables. So therefore, it does not meet the definition of science. So from the beginning.
What do you mean? What exactly doesn't have a dependent and independent variable? Because if you haven't read the actual Principia Mathematica and the actual scientific papers, you're not going to be able to see any experiments and see which ones have variables and not.
Manipulated gravity. Read
it and tell me. But if you're just arguing from ignorance, it doesn't really.
Hold on, Jack. Hold on. Time out. Read it and answer it for me. Right? That's what you just said to AJ? We know this shit, dude. We know.
You don't, clearly, or you wouldn't ask me.
No, it's true. No, man. Listen, you're the one that's coming in here with your belief about the globe, about you living on a ball. That's your belief, not ours.
Sure, we're talking about gravity right now, right?
Yes, but do you understand how you're proceeding with this conversation?
Listen, my point being is that you're asking me, there's no independent variable, there's no dependent variable. I'm telling you, if you look in the scientific paper, you will find the experiment and you will see all these things
find no
listed,
hypothesis.
right?
There's no
hypothesis. You'll find no hypothesis.
Yeah.
Of course you will. Of course you will.
Why do you say that?
Because you need it for some. Science. People wouldn't accept it as a valid paper if there is no hypothesis, if there is no independent variable, there's no dependent variable. You can laugh. That's how. Okay.
Have you ever been in a
So
situation?
who has manipulated? None of these papers show us that. None of these papers show us that they have manipulated the cause. No one has.
None of them are claiming that they manipulated the cause. You're dead right.
That's right. So therefore, if they can't manipulate the cause, there's no independent variable.
You
Therefore,
don't
it is
understand
not-
independent variables, unfortunately.
You don't understand it.
Unfortunately, you don't understand it, and you making that claim means absolutely nothing. Jump on the internet, go and have a Google, and find out whether it's the cause or effect that you have to manipulate.
Okay, I'll do it.
Good. Man, eighth
Well,
grade.
an independent variable is a variable you manipulate, control, or vary in an experimental study to explore its effects. Yeah?
And are you varying or manipulating the cause or the effect?
So, listen, the effect is gravity. The
No,
cause,
the effect is things go down. That's it.
that's a different experiment. Our experiment
No,
is what
the
causes
effect
gravity.
is things go down.
Listen,
The cause
just
is
hear me out. Hear me out here. If you want to experiment on this mysterious force that makes things go down, right?
You're making it up.
You can hypothesize in your hypothesis that what causes this force is the mass of the objects. Yeah?
Wait, what force?
No,
what
you
force?
can't.
What
What's the
force?
observed phenomenon?
Gravity is a force.
The observed phenomenon is there is a force that is making things fall down. Yes or no?
Where?
So
What force?
you're saying the observed
No.
phenomenon is things go down. That's it.
The observed phenomenon
Things-
is I dropped a pen and I observed the pen go down and fall to the ground. Now,
Without
what has
any
caused that
external
to
object
occur?
acting on it is important. So it seems like it's just done it on its own, right?
Oh, you've
But
dropped it.
you're already causing that. You're already calling this gravity, but you're trying to prove gravity.
Yeah, you're already assuming there's a force behind it.
No, so listen, we understood that forces exist before we even thought
Gravity's
about
not a
gravity,
force.
right?
No, Deck.
We don't have to say it is, but what we're saying is that forces exist that make things move. And we understand that
But now you're
if something
conflating
is...
two separate issues. Hang on. Now you're conflating two separate issues because gravity today is not a force. It's the bending and warping of space-time. So if we're discussing gravity, then we're not discussing a force. So there's no point in bringing up.
We're discussing
force.
what Newton thought gravity was, are we not?
Newtonian, but we're in Einstein.
We're talking about Einsteinian.
Yeah.
I thought we hadn't
Which
even
is
got
an
to Einstein
actual
yet. We're
fact.
still talking about Newtonian. You said go back to the very start. I thought that's where we were starting from.
I said go
Newtonian
back to the start
gravity
of what
was
you were
thrown
saying.
out the window.
Okay, well, listen, the cause of whatever we want to call gravity, whether it's a force, whether it's a bending of space-time itself, whatever you want to say, the cause of that phenomenon.
We haven't established that to exist.
Can we establish... Okay, well, listen, so let me get it straight. What you're
Okay,
saying
so
is
let's make
the
it real
initial...
simple. Let's make it real
Can
simple.
I try and make
If I
it
drop
more
my
simple
pen-
so that you can say yes or no if I'm right?
Whoa, Deck, let him talk.
Okay, go for it.
No,
Pen.
we'll make it real simple. I'm holding my pen. I drop it. It goes to the floor.
Then go down.
You've now observed something. So from that point now, what do?
We investigate how other things move when they're dropped. I would say is a good starting point.
They all go down. Great.
Hold on. I see what AJ is trying to say.
Yep,
AJ is
they all
saying
go down.
we observe and see the effect, and what we're trying to figure out is the cause. That's what gravity is. It's a hypothesis, a theory about the cause that's never been proven.
Okay, sure. So we're trying to find the cause of why things go down.
Correct.
Yep, not all
Okay,
things
cool.
go down though.
So here's what happens. You drop it and you go, oh, it goes down. So then you go, I'm going to drop it from slightly higher up. And then you notice, oh, as it falls, the longer it falls for, it goes faster, right?
Okay, I dropped a
Interesting.
helium balloon.
Velocity.
I dropped a helium balloon.
Yeah, it goes up.
Okay, sure. So it goes faster up until a point. It goes faster up until a point. And it rises quite linearly, and then it kind of plateaus. And you're like, okay, interesting. That's a weird phenomenon. So then you test other things. You test different shapes of objects, and you go, okay, things with a wider surface area
air
fall
resistance.
slower,
Air
and they. Yeah, we're fucking getting there. Just chill out. So then you go, okay, obviously air is like getting in the way of this thing. So now we'll do it in a vacuum chamber. We'll suck all the air out, and now we'll drop stuff there. We'll get air out of the equation. And now we notice
And what
without
happened
air,
there?
things just speed up
Drop some gas
indefinitely.
in a vacuum chamber.
We've just missed a shit ton of steps here. We're starting here at the beginning. So we've witnessed the occurrence
So, what is the next step after we witness the occurrence according to the scientific method?
Oh, we can write it down. I mean, we are skipping a few things, but you tell me what you would do then. Sure.
Check the live stream chat real quick. Just check it. Look at what Donato just put. What's the first part?
The picture, the scientific evidence of gravity thing.
Mm-hmm. What's A?
A sunset, apparently.
The naturally observed phenomenon. What we observe. What's B?
Yeah, he's observing a sunset. Aren't we?
No, don't
What's
worry
this got
about.
to do with the pen?
No, don't worry about what's in yellow. Just look at the scientific method right there. A. What do? We observe.
Oh, okay, sure. So, observe phenomenon, hypothesis, independent variable, dependent variable, physical test, results. Okay.
Slow down. We're going step by step here. We observe
I was
something.
just reading it all out. Okay.
We observe something, right? What's the next step?
We hypothesize about why it happened.
Right. Then what's the next step?
Independent variable, we change something about what happened and see what that changes.
Right.
And then the dependent variable is what we're measuring to see.
The control.
No.
The
control is different.
Dependent variable is the thing you observed. The
Yeah, the
effect.
controlled is separate, is the things
The
you're maintaining
occurrence
the same so that you
in
can just
nature.
change the independent variable so that you can observe the dependent variable.
Okay.
Yeah.
So, when has gravity been tested?
Okay,
What was the
let's use the
physical
pen
test?
example, right? So natural observed phenomenon, pen drops.
Yeah, that's a man-made object. Let's try an apple from a tree. or a
Okay,
rock falling,
apple,
dislodging
rock,
from a
sure.
tree. Right. something
You
falling,
understand naturally
solid
just
object.
means things in nature. We're a part of nature. Everything we make is kind of natural.
Yeah, it means not
in that
man-made.
sense, but-
It means not man-made.
No, it doesn't. That's not what it means. But
Yes, it does. It means
Not in
not
science.
man-made. Yeah,
No.
look up the definition. It means not man-made.
it can. You're thinking about like synthetic versus natural. That's fair,
science,
but
hang on. Natural science is the naturally occurring world. However, there are other divisions of science, but we're not looking at those. We're looking at the naturally occurring world.
yeah. So when you drop a man-made object and then something happens to that within the natural world, then the natural laws are underlying. Whatever, semantics. So naturally observed phenomenon: a rock falls when it's dropped. The hypothesis: the heavier it feels in my hand, the faster it drops. Do we like that?
Yep.
Oh, I love it. Oof.
Cool. All right. The thing that we want to change, the heaviness of the
Wait,
object
your
I'm dropping.
hypothesis. No, sorry, I've got to stop you there. Your hypothesis must include your supposition of what's causing the thing to fall.
No, it doesn't. Absolutely not. It doesn't.
Yes, it does.
No.
Well, you don't have to, but I'd like to see how you then equate that to gravity at the end of this.
How could you possibly just come up with a cause for something you've only just observed? That comes way later. You have to do a bunch of experiments to figure out what you're actually observing first.
No, your hypothesis is the supposition of what's causing the effect.
No, you're wrong.
No, I'm right. That's why you have a dependent and independent variable.
No, it's not. The independent variable is to see how things change or how the results change when you change
the
things.
independent variable, when varied, is going to cause.
You don't need to know the cause. The assumption is that we can't know the cause until we get more info.
Guess the cause. You're trying to guess what the cause is.
That's
you're
what a
wrong.
hypothesis is. That's what a hypothesis is.
No,
Trying
a hypothesis is just. Listen, we can get the definition of hypothesis again, but a hypothesis is just a prediction. It's a supposition or proposed.
The
hold
cause
on.
and effect relation.
I am wrong here. Apologies. Explanation made. I'm thinking prediction. I've gone into year 8 science mode. That's my bad. I'm sorry. A supposition or proposed explanation made on the basis of limited evidence as a starting point for further investigation. Okay, fair enough. So without hypothesis of this, we could say, So our prediction, usually there's a prediction in here or somewhere as well, but
the pen is falling. I'm going to assume, my hypothesis is that the pen is going to fall out of my hand because the pen is heavier than air. That's going to be my hypothesis.
Okay, cool. So a density argument.
Right. Density and buoyancy. You don't need gravity to explain that. That's why things go up and why things go down. because of differences in density and buoyancy. It's that simple. Where does gravity come into play with that?
Well, I mean, you can't really separate buoyancy from downward forces. If there were no, if things didn't fall to the ground, then things wouldn't be buoyant.
If I drop a
or differently
anvil,
buoyant.
Made of iron, if I drop an anvil made of iron in a vat of mercury, is it going to float or is it going to sink?
A good question. Is mercury denser than iron or no?
It will float. That's right.
Okay, it will float. Okay, cool.
Right.
But that is presupposing the idea that it will fall. And in this experiment, we don't want to do that, right?
Because of whatever object that you're testing, right? And whatever medium you're using to test that, basically, this is the hypothesis.
But this is circular. Do you understand? Because if we're talking about buoyancy in terms of, well, buoyancy happens because things fall, and the heavier the thing will fall more than the lighter thing. Sure, but that's presupposing the falling. If we're talking about why things fall, you can't bring buoyancy into it because buoyancy presupposes the
why do
fall.
air bubbles float up? Why is it going against so-called gravity? Why do balloons...
It's a great question.
It is.
I would say buoyancy difference in density. But again, that doesn't address the underlying problem with this, is that we can't use buoyancy to explain something falling because buoyancy itself inherently has things falling built into it.
So then let's continue on with this scientific method and show us where gravity then comes into play.
That's
okay.
The proof right there.
Sure. So, scientific hypothesis. There is a force that acts on the pen and its direction is down. Do we accept that or no? That could be a hypothesis, right?
Well, if that's your hypothesis, yeah, I suppose.
Cool. Okay. So let's make that my hypothesis. There is a force acting on the pen, makes it go down. And let's build into that hypothesis as well that the heavier the thing is, the more the force affects it, and the more it falls, right? We're cool with that?
So
okay.
Weight is the cause? Is your proposed cause?
No, I'm just saying, so the hypothesis is that there is a force acting on the object, and that weight plays into the effect of that force, obviously. Like F equals ma type thing, force equals...
to have identified, so your independent variable is a force?
No, we haven't identified any variables yet. We're just doing the hypothesis.
You're supposed to be proposing the presumed cause, the supposed cause in your hypothesis.
Yeah, so the explanation is there is a force acting on the pen downwards.
Independent variable. So independent variable is force?
No, because we're not changing it.
But you have to, because you're proposing that's what's the cause of the effect that you've just witnessed. So now you need to manipulate that cause to see whether it is that.
Again, independent variable doesn't mean that you don't need to change the cause. You just need it's just a variable.
Correct. You're 100% incorrect, and everybody here listening knows you're 100% incorrect. You have to manipulate the cause, not the effect.
No. So listen, the point is that we don't know the... Listen. We don't know the cause, right, yet? In our process of A, B, C, D, we don't know the cause. We're hypothesizing the cause is a force that the pen is falling. Now, if we're just hypothesizing right now, we don't even know how to control the force. We don't even know if it necessarily exists. The point of the test is to test our
then
hypothesis.
You don't have a viable hypothesis.
No. Just because we can't change the cause. No. Just because you can't change the cause in an experiment.
Well, what are you going to do?
Doesn't mean you can't change other things to explore whether or not that cause is still happening in the same way.
So you're going to affirm the consequent.
What does that mean, sorry? Affirm the consequent?
So you're going to do something else and then assert that there was an unknown, unvariable force behind it.
Like dark matter.
Well, that's our hypothesis, no?
No, but you can't declare something to be true based on an observation. You must test.
That's the point of a hypothesis.
Hold on, wait, Deck.
No,
Look
it's
at
not.
the chat real quick. Donato's giving you some good stuff there. Just read that real quick, man. Just
The hypothesis should also contain a prediction about its verifiability. For example, if hypothesis is true, then 1 should happen when 2 is manipulated. Totally. First blank 1 is the dependent variable. First blank 1 should happen when. So the dependent variable, what you're measuring, depends on what you're doing in the second blank. And the second blank 2 is manipulated, is the independent variable. Totally. You manipulate it to get a reaction, 100%. Yeah, so nowhere in there does it say it has to be the cause. Nowhere in there does it say it has to be the cause.
Wait. How are you going to manipulate this so-called downward force that you're saying
You don't have
gravity
to.
is a downward? Oh, so then you don't have an experiment. You're not.
No,
doing
you're misreading what he's just linked. So the first blank is the dependent, what we're measuring. So in this case, we'll say our hypothesis is there is a force acting on the pen or on the object, let's say, on the rock. And if I use a bigger rock, it will fall faster. Let's say.
Identify the force. Identify the force.
Yeah.
We don't know what it. Why?
Because that is your supposed cause. That's your supposition. That's your supposition of what's causing the effect.
If you've never understood this thing before, you've just seen something fall for the first time, and you have no idea why. How could you possibly identify the force? You need to be able to
Why are you so gung ho on gravity? Exactly. Like, why are you so hardcore believing in gravity when
we haven't even made up the term gravity yet. You understand? I'm like putting myself in the mindset of someone who doesn't know anything about or any like theory, wasn't taught anything in school, whatever. We're just assuming
we're
that.
dumb? You're saying we're uneducated?
No, we're assuming we're uneducated. That's different to dumb. But yeah, we're uneducated, unknowledgeable. We are Newton level. No one's talked about gravity before. We just see things fall.
I think you're projecting a little bit, though. Like,
I think I get his effect.
I don't think you know what projection means.
Different sizes of rocks is his independent variable. He's going to vary the size of rocks.
Yes, exactly. Yeah, it's an independent variable, 100%.
So size.
It's something you're changing to see how that affects the dependent variable, and the dependent variable in this case is the speed at which they fall, let's say, or the velocity.
The independent variable is the speed?
No, the dependent variable.
Oh, so size.
So the independent variable is the size, or let's say the weight of the rock.
You should say weight. You could say weight.
Yeah. Okay, weight's a better expression. So we'll say weight of rock is independent, and then dependent variable is velocity increase or acceleration increase, I guess.
Weight causes velocity or acceleration increase.
Wow.
Well, probably acceleration increase is better rather than velocity.
Okay, so weight causes acceleration increase.
Well, an increase in weight will increase the rate at which the object accelerates.
Right, so you're going to vary the weight. You're going to vary the weight of something.
Yeah. So we'll get a light rock and a heavy rock. And to make sure they're controlled, we'll get let's not make them rocks, let's make it a ball of steel and a ball of titanium, let's say. So that they're the same size, the same volume. So that's a controlled variable. We're making sure that that's not coming into the equation. But we're just changing the weight of it. Makes sense so far?
No.
So weight causes acceleration. Right.
Okay. What does it make sense? So we've got a dependent variable, we've got an independent variable, right? And now we just need to do our test, correct? To see if our prediction is true. Our hypothesis.
Okay, what is the test? What is the test?
Okay, so we drop both an iron ball and a titanium ball from the same height, and we them at the same time. Our prediction is that because the titanium is heavier, I think titanium's heavier, maybe it's lighter. Because the iron is heavier, the iron will fall faster than the titanium. And cool. So we're changing the mass, we're measuring the speed at which they hit the ground. Which one hits first?
You've changed the weight. Are you defining
of the object we're dropping? Yeah. Yeah, we're equating them in this instance because we don't even know gravity exists yet, right? So we're just saying, I hold this in my hand, I put it on a scale, this one is more than this one, right? It pushes
weight.
down on everything. Yeah, we'll say weight.
So weight.
Sure. So we drop those two things from the same height and we measure the results of the test. Now, our prediction was that because one was heavier, it would fall faster. Interestingly, it didn't. So they both hit the ground at the same time. That's our result. And we go, interesting. Our hypothesis was wrong. That is a good observation.
You proved your null hypothesis.
It wasn't a null hypothesis. It was an actual hypothesis.
In a scientific experiment, there must be a null hypothesis.
Oh, apologies. What's the null hypothesis? That it doesn't affect it.
It's the antithesis of your prediction.
Sure. So the null hypothesis was proved to be true. That weight doesn't affect the rate at which things drop.
So weight doesn't call acceleration of a falling object.
An increase in weight doesn't increase the acceleration. Yes. So that's our conclusion from that experiment. Sound good? Yeah? No? Yes? No?
You're doing the experiment, man.
We finished the experiment. We're done. Ta-da! Conclusion. So are we happy that that was a valid scientific method and experiment that we just did?
How old are you, Jack?
I'll say yes. Let's just move on to using.
Someone say yes or no. Is that a good experiment to do? Or like a valid one that we can trust the results of?
No.
So why not? Why doesn't that experiment work?
What experiment?
The one we just meticulously described step by step. About dropping an iron and a titanium ball. I don't know why you're playing dumb. Dude, just like, you know what experiment I'm talking about.
Okay, so now let's then move on to that same.
Why are we moving on? Like, tell me yes or no. Is that
gravity? You've proved density and buoyancy. You've proved that something.
We're not proving anything. My question is that a valid scientific experiment? Yes or no?
Okay, so you've proven that weight doesn't call acceleration of
yes
metal.
Or no. That's just two options. I want to know, does that experiment sit right with you?
Concede? Is that what you're yelling about? You want us to concede?
There's no concession. I'm asking this experiment that we constructed together and just did,
yes,
that we could replicate. Yes. Okay, cool. So that experiment is fine, valid. We accept the results of it. So just then, what we've established, right, is that if there is a force that is acting on this object, any object, the weight of that object doesn't affect the rate at which it accelerates to the ground. That's a good piece of data when we're trying to investigate this natural phenomenon of things falling, right?
No. Why are you concluding that? All you've done is just said that weight doesn't.
Well, any information is good information relating to the thing, and I think it's a very innate intuition that we have as humans that heavy thing should fall faster. So it's exactly, we do, and that's interesting. So now we've got to go back, change what we said, or at least we've got to go back and use a different hypothesis that has a different independent variable in order to test different aspects of it.
No, the independent variable is testing the cause again, so it's going to be testing your hypothesis.
Well, no, it's not the cause. We understood that
the independent variable that you're varying is your hypothesis of what you believe is causing the effect. That is the most simple thing to see, read, and understand that you just don't seem to understand.
Yeah, I understand. But the cause we're talking about here is the weight of things.
Changing it and saying that you don't say you understand, because every time you say that, then you change what you're saying. And you try to tell us that it has nothing to do with the cause, but you're going to manipulate the effect. So you don't understand.
No one understand what you're saying. Well, the experiment we just did then was not manipulating any effect. We were measuring the effect. And the effect was how fast they hit the ground.
Rocks, because your hypothesis was that the weight of the rock was going to make it fall faster or quicker. Yeah. And then you manipulated the weight of that rock. You manipulated the rock, the cause, and you found that didn't occur. You proved the null. So now, when you propose your next hypothesis, We need to vary the hypothesis to see if it causes the effect. Are you
Yeah,
going to verify
cool.
the null or not?
So are we trying to figure out why things fall in general or why they accelerate?
Well, he was trying to show us gravity, but he was just starting in the beginning with his showing
What
that
he was doing was just trying to establish a scientific method. That you guys brought it up first. Donovar or whatever his name is posted the thing in with a scientific method A, B, C, D, G. I was asked to go through it, and we did. We created an experiment.
Yeah, so you understand that. You understand that things that fall, that solid objects falling through a medium is what's on the table here, because not everything goes down, not everything falls.
Great point. Very true.
Some things remain at equilibrium. Some things go up. Some things go down. Some things go in all directions. Like gas.
Well, so far
Definitely.
we've only talked about rocks. So this is where we need to move on to the next hypothesis.
Well, we're talking about metal balls or different densities, but yeah.
Balls, not rocks, metal balls. But okay, your metal ball example. Yep, no worries. So now we need to. The whole point of this conversation is for you to show us the science and how gravity, the cause, is varied.
Well, we haven't even named gravity yet, but we're assuming that there's a force acting on it, right?
Yeah, man, we understand this, man. You drag at something shocking, eh?
I have to, because otherwise you don't understand what I'm saying, and then you assume I'm like committing fallacies and frauds and stuff.
I haven't pulled you up on any fallacies. I know exactly what you're saying. Just burn through it, man.
Cool, man. Okay, cool. So anyway, the fact that we can create a scientific experiment like that, where we all accept cause, effect, independent variable, dependent variable, etc. We make a bunch of these different things. We change different independent variables. We change dependent variables. Sometimes we throw it up. Sometimes we add a bit of horizontal velocity to it.
When you're wrong and you're pulled up, you need to stop, because again, you've tried to slip in there about these independent and dependent variables. There's only one thing that we're manipulating, and that's the cause.
Which is the independent variable.
Yes, but that's not what you just actually said.
Okay. Pretty sure I did, but cool. Okay, here we go. Donato, scientific evidence. So rock falling, scientific hypothesis, more weight, more acceleration. Independent variable, weight, dependent variable, acceleration. Physical test. Yeah. Iron rock, but I know what you're getting with. Blah blah blah. Results failed. Cool. But so now we know from that experiment there is a 9.8 meters per second acceleration downwards, right?
No, we haven't agreed upon average of 9.8 meters per second, because some things go up, some things go down, some things remain buoyant, and 9.8 meters per second is not always the case in different locations and different places. It's
Sure. I don't know if we included it in the previous experiment, but we did. Well, we should have conducted it in a vacuum, right? So we should have gotten rid of any.
Okay. I let go of some gas in a vacuum. It didn't fall at 9.8 meters per second. So what now?
Good point. Very interesting. How do we measure the? Well, for one, if we did drop carbon dioxide in a vacuum, it would fall at 9.8 meters per second, right?
No. In what state? In what state of matter?
Oh, gas. True. It would expand, fill the volume, I think. Let's figure it out, actually. Carbon dioxide. But all these results are about greenhouse gases and things.
From my understanding to this point, everything you have is just a belief. You trust what you're told, and no matter what you have seen or been shown, that you are going to somehow continue to defend that belief and do the mental gymnastics required to convince yourself.
Yeah, I could say the same to you, but yeah, is what it is.
All right.
Amen.
Cigarette. Hey, Deck.
Yo. Good Siggy Mart.
How old are you?
I am 21 years old, 22 in November.
Okay. You going to college?
How old are you, Beastacles?
I'm 28.
Nice, man.
Well, I'm 43 and my son's nearly your age, so.
Represent. What is your son up to? Is he at uni?
No, he works with me. He's an apprentice.
Ooh, doing what?
We do signage.
Ooh. Like painting it and stuff? Like or like do you peel that shit off and stuff like that? Or like actually installing it?
Mainly vinyl and wrapping cars and
Ooh.
all that sort of stuff.
Is that satisfying as fuck?
Deck, are you
Nah,
okay?
it's
Like getting that layer off? Oh, true. Yeah. But if it gets good, yeah. Sorry, Beastacles. What were you saying?
No, let's do what AJ said. Let's get back to the debate, to the conversation.
I thought that's what you were saying.
Well, I was just curious about your age, but okay. So now that you know and you've accepted that what you hold in your mind is a belief, right? It's a belief.
We've already a belief by your standards is in without evidence. I still don't think it's without evidence, but sure, we have different standards of evidence.
Again, where's your evidence of gravity, of you living on a ball?
We're not going to go over this again. I've given it all. I count that as evidence. I understand that you don't. We have different levels of proof. You need to do it firsthand, be able to measure it with your own devices, etc. You cannot trust other people or institutions to combine and create scientific that thing. That's not in your mind valid enough. That's fair enough. In my mind, it is. That's where we diverge. That is what it is.
Listen, if institutions, so-called institutions, or anybody that is actually using the scientific method to take an observable phenomenon, a natural and observable phenomenon that we experience, right? Form a hypothesis about that, of why that phenomenon was caused, have an independent variable, basically control the cause, and the dependent variable to measure the effect and see if you can repeat that test. That's like fundamentals. That's you kind of have to have that in a discussion like this. And I'm just like I love all of your guys' patience, including yours too, Deck. Like, but I think
Thanks, man. You're very patient as well.
Well, I'm honestly new here. So, but new in terms of being able to have these kinds of conversations and kind of seeing how they unfold. It's pretty bewildering, or like I don't know what to say. Like I give up. But I hope you have a great rest of your night, Deck. I hope you come back to this.
Yeah, man. I've popped in a few times actually. It's good when it's not just the same people. I've come with like that one guy, Mayhem 100, whatever his name is, Miggy. He doesn't like me very much, but yeah, I do enjoy having these conversations.
You got to understand that it's not that Miggy doesn't like you. It's just that we deal in reality here, and we deal in science, and we deal in the scientific method. And when someone comes in here trying to debate on beliefs, then Miggy is someone who's definitely going to hold you to account and not let you move.
Yeah, he absolutely does that. I'm well aware of that. And he does it without a degree of understanding or letting his boot off the throat of your neck to even get something out. And when I join, he plays air horns and plays like repeats of like things I've made mistakes with in the past. I count that as like a personal kind of thing, but you know, up to you. I wouldn't say he's forgiving, at least. But anyway, I'm glad that you guys take a bit of a different temperament to other people. But I'm also glad that there's a nice wide variety of different personas in this server. But yeah, thanks for having a chat with me. Anyway.
Valve, Flying, you guys want to say something?
I guess I just have one question. I don't know. I've just been mostly listening, but I'm curious, Deck, what would it take for, maybe this is just such a nonsense question to even ask. What would it take for you to actually see the flat Earth in like a reasonable way? Like to see.
Interesting
what would it take?
question.
What would it take for you?
I mean, I can't really say what it took to get me to believe or know that the Earth is round, right? Like, I wouldn't be able to give you a step by step of like when I was 4 and I was shown this and that and blah blah blah.
You don't.
So how I would actually be able to deconstruct all that and then build that up again from a flat Earth perspective would be interesting. I mean, for me to like invalidate the idea that the Earth is a sphere would have to invalidate like all the laws of physics that I know to work and underlie the things that I see every day, right? Like it would completely disrupt my reality, right? So like even the simple idea of like things in space without any force acting on them will be attracted to each other, and that naturally forms spheres, which is why we get planets, stars, fucking black holes, etc., which are all spherical because of the way forces equally distribute equally out in all directions, right? Yeah. I know it's semantics, but what I'm saying
I'm
is
just
from my
playing devil's
perspective.
advocate. I just kind of want to hear other opinions.
Yeah. No, I'm with you.
Can you kind of see why it's frustrating when you're asked of like proof of a globe? The first things you go to are lights in the sky, and other people have done science, and those lights in the sky are planets for sure. And what we're on right now is a planet as well. You can see how that's kind of frustrating, right?
I can understand why that becomes an issue for people. All I'm trying to do is answer as truthfully as possible as to what comes first to mind, as to why in my mind I think it's a sphere, and it's because when I think of all these other things, they're all spheres, and I have reasons for understanding why they came to be spheres and blah, blah, blah. I understand that's all based off of the religious science institution and belief. Yeah, we get it, dude. Yeah, sure. But
Hold on, Deck.
yes, I understand the frustration.
Real quick, what Valve?
I
what
just wanted
Valve's
to hear your
question.
opinions.
Yeah, what Valve's question was is just like why he said, "What would it take?" Right, and what you said was, "What would it take for you to go back to when you were 4, and essentially unlearn?" Like it, you're not saying it, but it's you know what I'm talking about. Like you have to unlearn everything.
I think about it in terms of like you build like a Jenga block of ideas in like a belief system as you live throughout your life. Each idea connects and builds off the other as foundations, blah, blah, blah. In order to think that the Earth is flat and everything I've been told is a lie and all the physics I've been taught is a lie is like pulling the bottom Jenga piece out and then going, oh, fuck, right?
Well, the thing is, it's not about the physics part.
You haven't done that. If you'd done that, I'd be having a mental breakdown. But I appreciate
it. It's not even about the physics part per se. It's what you said just before the physics part that been told to you is a lie. That's the reconciliation that you need, especially if you've been here already, that you really need to focus on. It's not about why would they lie.
When I say that, I mean more everything that I've been taught in the way I think about natural phenomena and how they interact. I understand that most of the shit I hear from media and the government is complete garbage.
How they connect. You don't even know how they connect. You admitted that it's all just a faith that you have in some guy that said something.
I'm saying that because I know that's what you believe, and we don't need to go into the viscera of the conversation. We understand we disagree. We're talking about something else.
You admitted it.
I said it doesn't mean I believe it. Okay. I said it for the sake of you guys, but anyway, basically.
You said it because you didn't have a fucking answer.
Like, do you see why they're being curt though, Deck?
Yeah, because everyone they meet every single day tells them they're a fucking idiot and that they're, of course.
There was only
I understand.
6 or 7 people today. I just fucking reading through it every like 30 minutes. It was pretty funny, actually. I
For
mean,
me,
just
it's frustrating, and it's got nothing to do with people calling me an idiot because I really couldn't give two fucks what anyone thinks about me. But
Yeah, well, that's good. Yeah, that's good.
that's a good
it's
way to
very
not the reason.
frustrating when I'm reading the scientific method and I'm reading about independent variables, and you're just not accepting that, and you're just putting your own spin on it that suits your belief. That's frustrating.
That's the
Yeah, but the thing is, like, it's just as frustrating for me to hear you guys do the exact same thing. Like, to me, it seems like you read all this stuff and you put your own spin on it in the exact same way that it seems to you, I read it and put my own spin on it. That's just how stuff works.
How do we put our spin on it? How do we put a spin on it? What do we put a spin on?
Yeah, there's
don't
no
think there's a
spin. We're
spin.
reading directly from what it says it is. You're arguing with
If you
science.
guys listen, you're currently arguing with the idea that every single human being doesn't put their own spin on every single thing they do, which they absolutely do, including yourself.
What we were just speaking about, because we were talking about reading out the scientific method step by step, and you not accepting that scientific method.
I accepted it, and we created a scientific experiment that we both accepted, so we can understand that we both accept the same scientific method of inquiry.
And then we tried to move on, and you changed again the meaning of that independent and dependent variable, and we still didn't actually get to the whole point or crux of the conversation, which was you were going to show us how we could use this scientific method to prove gravity, well, to confirm gravity, yeah? And we never got there either. So that's what's very frustrating when you continually change what.
Well, that's fair enough. And I'll concede on this that the idea of creating a physical experiment where we can manipulate all the variables involved with it and have complete control over controlled, independent, dependent, etc., isn't going to work.
Well, this is my issue. What are all the variables? Because the variable is, again, your hypothesis. So
yeah, exactly. The variable is dependent on the hypothesis. Exactly. You're right.
No, you're testing the hypothesis.
And therefore the variables are dependent on what you choose to be the hypothesis, because then you have to change the variables that you're measuring.
You said
Yeah.
you've been here multiple times, right? With
3 or 4 maybe.
Okay.
Yeah.
Has there been any conversation that you've had in your 3 to 4 times, anything that made you kind of have a second look at what information you hold dear in your mind, like regardless belief, whatever the definition of belief, however you want to I'm just saying, has there been anything that you're like, maybe these guys are onto something? Anything like that?
Yeah, I mean, I'm sure like there's a few things that I see going past in the chat that are a random fucking meme with some text over it or whatever, that I'm sure have grains of truth to it. And there's obviously a lot of things that are covered up by the powers that be in order to keep the population under control, and that they keep getting the money and the power and everything, of course.
So Deck, so you understand that you're essentially in a cult, right?
Yeah, but you like if you don't understand that flat Earth is somewhat cult-like as well, you know, like we're all in kind of cults of different things, personality, ideas, etc. Like we're all going to be subject to different things. I would say this Discord in particular is a lot more culty than other places you'll go to, only because if someone speaks out with a different idea, 5 people speak up and say, no, you're wrong, here's why, blah, 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 spamming. That's somewhat culty, all right, in nature, but sure.
Hold on, man. Hold on. Okay, so
being right is being in a cult. Oh, okay.
Yeah, I mean, people in a cult would say the same thing, is my point. Like, you can't really tell the difference when you're in it.
And again, you're just assuming all this stuff. You know, I had nothing to do.
No, I'm saying I'm victim to that as well. If I'm in the cult of science, then I'm blind to why it's a cult. And if you're in the cult of flat Earth, you're blind to why that's a cult as well. I'm just saying.
Hang on. So
why is flat Earth a cult?
Yeah, why is the truth a cult? And again, I don't believe I'm in any cult because, like I said, I'm 43 years old. I've believed or known this for a very long time. And I came to that conclusion through my own observations being out on the ocean for a long time and seeing different things. I won't go into that, but
please do.
And then further looking into it and doing these things. I've been on Discord here, if you check my profile, for about 6 months, and I really had nothing to do with any flat Earth groups prior to this. So,
Same.
you know, to say that I'm hanging out in this cult of beliefs of flat earthers, I was on my own with everyone telling me I was a fucking dickhead.
Same.
There is
Well
no
said.
No, I'm sure you are. Yeah.
Well said. And Deck, the same for me. I've been a flat earther since 2014, and it had nothing to do with this room. In fact, every flat earther who comes to this room is very excited to find a place where other flat earthers hang out.
I have no doubt at all.
There is absolutely no nothing that we talk about here that isn't just repeatable and testable in nature. So we're just observing reality. How is that a cult? You need to be indoctrinated to be in a cult. There is no indoctrination here.
Yeah,
you
I was
don't
about to
necessarily
say,
need to be.
my cult
Go
my cult leader, right, is observable, objective, measurable reality.
Well said.
Okay. Yeah.
Whereas what you believe is very cultish because, like we said earlier, you have to be taught all of this stuff to build your belief system. Whereas in flat Earth, you have to strip away.
Honestly, tell me though.
What we do is we actually try and get you to get rid of this indoctrination and use your God-given senses to determine where you are. That is not a cult. That is called science. And scientific.
Yeah, sure, but you've also got to see it from the perspective and have like the understanding, that looking in from the outside, what you see is people come in and then without tell me honestly, how many of you guys have individually come up with all these scientific explanations and things that you post in the chat constantly? All of them, or a couple of them? Because there's no way each of you has individually tested every single thing that you post on here, right? So there's some ideas that get thrown around and distributed within this. I'm not saying it's a bad thing, it's an inevitable thing. And I'm sure there's plenty of people that see here with their mic muted, just listening, taking it in. They've never heard most of the explanations you guys use when describing flat Earth. They haven't heard it before. They hear it, and it is a form of them learning, right? In the same way that they could be sitting in a science class and absorbing that. They're absorbing different things. But to think that you're different and separate, it's very egotistical, is all I'm saying.
Deck, because again, let's give the example of tonight. Someone says to me, hey, AJ, this is what the meaning of science is. Or let's just say I do listen to I read one of these things in the chat, or I listen to a YouTube channel that says something, right? It might be about gravity. It might be about relativity. I even listen to Globe channels that speak about these things. Yeah. And then I go on and I'd go and research it for myself. If there's something that I can test and look at and do, I'll go and do it. If it's something about science, like tonight, I can go on and I can read the scientific method. I can read further and I can actually see what the dependent and independent variables are and what's manipulated. Yeah. So then I've learned something and I've accepted it. The difference is that when you seem to read that, you don't accept it.
Yeah, sure. The same thing says when you read and accept a Globe thing, you don't accept it either. We're doing the same thing.
We're testing that and we're looking at that. Okay, for example, is gravity scientific? No. Purely no.
Sure.
We can see that through the scientific method. So that's a belief that you've held your whole life. This is what
that I still believe. And until I stop holding it, which I don't have control over, I don't get to snap my fingers and choose when my belief changes.
You do have control over it, brother. That's my biggest thing. It's like,
I don't know. I feel like I disagree.
We want you to come to these conclusions on your own. That's the ultimate goal here, man. Is for you to open your eyes to your own reality, not trust anybody to tell you what you're observing and what you're feeling and what you're experiencing in reality.
I'm with you there. It can be an interesting, but I've certainly gone on that path myself in a different, obviously not on a flat Earth.
It's you said how you're nearly there. Do you see how your own do you understand?
Yeah, I get it, man. I get it.
This is a self journey, man.
But Deck, for example, you're saying that we, sound a bit cultish, right? But it's only because we have refined the arguments. We've been doing this for years, and when I say we, flat earthers have been arguing and discussing with Globers for years, and now the arguments are well understood by flat earthers. they're not as well understood by Globers. Questioned, but these are the questions that we've been answering since well before 2015. So all you're seeing is refined argument. For example, gas pressure. The second law of thermodynamics, which I hope you're aware of as well, states that you can't have gas pressure next to you can't have high pressure next to low pressure without some sort of containment. This is not a cultish idea. This is something that flat earthers have discussed and begun to question, because the heliocentric model goes against the laws of science.
It doesn't.
So what
We can go into that if we want,
the
but
basic
we
laws
don't
of
have to.
science. But listen.
But listen. I get what you're saying, and I understand that you've gone through all this very particularly, and you've been refining it since before 2015. Could be 1980, could be 1950. Yeah, sure, but it's definitely not longer than regular science, which has been doing it for thousands of years, right? Like, you can understand that.
Hold on.
It's not the point. It's not the point. But can you recognize the fact that yes, you've been doing it for a while, but so has the other science, right?
Deck, you got to calm down, brother.
I'm not particularly hyped up.
You're getting a little hyped up, but it's okay. This is what we call cognitive dissonance. We all had to go. We all had to go through it at one point or another when we first came across contradicting information about what we were being told our entire lives. And
the gas stuff, it's not contradictory to me at all. I understand it, and it makes sense to me.
Just hear me
There's
out.
no cognitive dissonance happening there. But yeah, sure, go for it.
Hear me out, though. What you're experiencing is the fact that if we are telling you the truth, right? Just assume for a second we are telling you the truth, right? What are the implications of that in your own life?
It's a lot.
We're telling you it's a lot, right?
Big time.
It's a lot.
That's honest.
I definitely want you to seriously consider the possibility that we are telling the truth and how that would affect everything that you experience in your life on a day-to-day basis. Who's telling you what to believe, what to eat?
Yeah, man. Yeah. I know, dude. I get it.
And it puts the burden of responsibility for your life on your shoulders rather than authoritative. And people don't like that.
Yeah, they don't. It's very
You don't like that.
I'm sure. Yeah. Right? Humans as organisms don't like the idea that the model that they've previously built up could be wrong. And that they have to change it all. Absolutely.
But just you personally, from me to you, just hear me out, man. Like, do you want to rely on other people your entire life, or do you want to have some?
Yes, I do want. Not only do I want, but I think it's inevitable that I will have to rely on other people to trust that they are doing their job correctly. It doesn't necessarily have to be the people above me or in authority places, but I think it's an inevitable that you have to trust some people.
At the end of the day, you are the only person that is responsible for you. That's it. No one's going to help you in this life. You can't trust anybody to tell you what's best for you. No, your family members, your friends, your teachers, your boss, nobody else. That is.
I think I disagree. I mean, not only you know for sure what's right, but you can accept advice from other people, and oftentimes they do have good advice.
You can have friends. You can have opposing ideas from other people and listen to that. But at the end of the day, you are responsible for you. Go ahead, Root.
Exactly. And once you sort of subscribe to the idea that, oh yeah, everybody else is smarter than me so they can figure this out, you actually give your power away. You're actually assuming that you can't figure this stuff out for yourself. We're not saying you have to go and buy all this equipment and do every experiment, but you should verify whether these experiments fall under the category of science or pseudoscience, and you need to be strict. There needs to be a scientific method adhered to. Otherwise, you're dealing in the theoretical realm. So when you get into a debate or you're trying to figure out the truth in a situation, then really, if you can't find any actual real science backing this theory, then you put a pin in it and you say, maybe, possibly, but this can't be considered truth. This can't be considered science. And I think you need to be very careful taking that step by saying, oh, this is settled science, when it doesn't have an experiment.
Right back at you, buddy. 100%. I'm with you.
So when it comes to the globe, we have there are three areas where you need scientific proof. You need proof of drop over distance. You also need proof of the Coriolis or movement of the Earth. Okay, and finally, you need to be able to prove that space can exist next to an open system. If you can find science that backs any of them three, then
Last one I can do.
Then you can start saying, right, okay, I have something tangible here, so I can go and verify it. This doesn't mean that you have to go and do every experiment yourself, but it means you need to go and find enough evidence to build what you can consider is proof. So without that evidence, you can't say you have proof. That's our argument.
Yeah, I can do the third one for sure.
No, theoretically, I can tell you why you can't, because you can't do an experiment proving where gravity, because your claim, I don't know if you realize it, your claim is that gravity is the container. Yeah, your claim is that gravity is a physical barrier. So
my claim would be that
shows this.
Listen,
that gravity
without telling me my own claim, my claim would be that any object, regardless of if it's gas, liquid, solid, is affected by the same acceleration that we can measure on any object that we drop. That would be my claim.
No, that would be against gas law.
It wouldn't necessarily, no.
Well, it would, because gas, when released at the surface of the Earth, travels in all vectors with
This
no
is true,
rhyme
yeah.
or reason. Yeah, so
But listen, gas is not an individual object. Gas is comprised of trillions of objects.
for example,
Gas
I'm
has
addressing
mass.
your own example.
Gas has mass, and if mass attracts mass, then gas should be going down. Why does gas go up?
Gas. So again, when you say gas, you're talking about like a cloud of gas. But the difference between a cloud of gas and like a bucket of water or
Where is oxygen made?
Where is oxygen made? In the sun?
On the Earth, on the surface, yeah? So
Where is elemental oxygen created from? Is that your question?
Where does it, on the Earth?
Gases are made at the surface, yeah?
Where are we getting this oxygen from? It's made at the surface of the Earth, yeah?
No, it's not made. It's been there for billions of years.
Well, yeah, whatever. We've got trees doing their thing, whatever, okay? We're picking at straws here.
Yeah. Well, I'm answering your question. I don't know where you're going through it, so I'm answering as honestly as possible.
Is it the surface of the Earth?
There is oxygen present in the air at the surface, for sure. Is that your question? Sorry?
It's produced.
It's
produced
produced,
at the surface
yes.
level.
Sorry, wrong word. Produced, thanks, T-Dub. It's produced at the surface of the Earth, yeah?
Oh, is it like an O2 gas molecule? Where's that produced from?
Yes.
Yeah, trees at the surface of the Earth, algae in the oceans, etc. Yeah, for sure.
Okay, cool. So now there's no downward bias there, where gravity's at its strongest at the Earth, and then all of a sudden this atmo.
Well, you're making a claim there. You're making a claim there that there's no downward bias. Downward bias is in like downward force vector. Is that what you're saying? Is that the same thing?
There is no downward. Yes, there is no downward bias. Gases and the atmo move in all different directions. There is no downward bias.
But there is though.
They run into each other or the walls of their container.
Yeah, but listen, if you separated an individual gas particle in a vacuum and you could track that individual gas particle.
Are we talking about here individual gas particles in a vacuum, or are we talking about where oxygen is generated at the surface of the Earth?
No, we'll live
And
in a
there is no
vacuum.
downward bias vector of what we're observing, and that's part of gas law.
Listen, scientific method means we need to isolate as many variables as possible. When you're talking about oxygen released from a tree in the middle of the atmosphere and wind and stuff, that's too many variables. You can't really do a test on that, right? So in order to do a proper test on how
You're
gas
claiming
particles...
that the gas has a downward bias due to gravity.
That is correct, yes.
Well, you're completely incorrect, and you're going against gas laws, so it doesn't matter.
Okay, I'm
If
not.
I fart, does it fall?
It does, because the sulfur dioxide gases that you produce in your fart are heavier than nitrogen and oxygen and stuff, so it kind of sinks to the ground, I think.
You think? Okay.
No.
That's my understanding. I could be wrong there, but I'm pretty
I
sure.
don't know about that, because when someone farts in my house, it just seems to waft and linger around in the air for quite
That is also true. Yeah, you're right. Obviously,
Depends
the
what you
gas
eat.
in a room is completely diffusing. You're true, but like say, like for example, the towns that like get fucking gassed from carbon dioxide expulsions from like geysers and shit, that like, or volcanoes or whatever, and like the gas kind of rolls over the town and suffocates them. That's an example of like gravity affecting different densities of gases when there's
won't
enough
stay there.
gas. No,
It
of
won't
course it
stay
will
there.
eventually disperse, but for the time that it is there, it will be at the bottom of the.
Why would it disperse? Are you saying that gravity is fickle and actually has no effect on gas?
No. I'm just saying that over time, entropy tends to lead to things not being ordered. That is obviously going to stop being one big cloud and eventually ping off and disperse amongst everything.
Oh, so gravity is very selective, right?
No, gravity's just very weak. It is a weak force, and well, if you want to call it a force, but the effect of gravity is very subtle. And when you're talking about individual gas molecules, they're barely affected by gravity if we're considering it having a very low mass. That's my understanding of it, at least.
I don't know what the fuck you're talking about, to be honest.
Oh, I do. So
when you
maybe you need to.
when you release something into our Atmo, okay, let's just say it's a car tire, a gas cylinder, like a propane cylinder. I don't know where you live, but gas or propane.
Where do you think I live, mate?
I think you live in Melbourne or Sydney.
Perth, mate. But yeah, sorry. Go on.
Which one is it, Melbourne or Sydney?
It's Perth, you dog.
Perth.
Fucking WA, mate. Up the dockers.
Yeah, you fucking dog. Sorry.
Yeah.
Jeez,
Anyway.
I got that one wrong.
Well, happens. There's only like 4 or 5 of us in Perth anyway, I think.
You just sounded a bit Melbourne-y there. It might have been Tim.
Yeah. No, if I put on my like deep Aussie accent, God knows where the fuck it's from, but my natural speaking voice isn't that deeply
So anyway,
regional.
and we release
Anyway,
these
yeah.
gases into the Atmo, yeah.
Mm-hmm.
Then they will travel in all different directions, like you just said. With someone's fart, it's going to disperse out, and some may eventually settle. Okay, but the fact is that there is no downward bias. Okay, and what the claim is that these gases travel in all these different vectors, and they're traveling higher and higher and higher away from the Earth, where gravity is becoming weaker, and then somehow gravity then contains these gases and creates a downward bias. So again, nothing to do with science.
Not what I'm claiming, but similar, I guess. If I can articulate. Yeah, how would you know what I'm claiming if I haven't even made the attempt to claim it yet? My claim. Listen.
Globe, hang on, you're claiming a globe, and that is what the globe claims.
And therefore, you know exactly what I'm going to say. You've
Well, then
thought of it
you
all
don't
in advance.
Well, then you don't actually agree with the.
It's hubris, my friend. No, the point is you just don't quite get it. If I could, let me just lay out the claim first, just so I can be completely clear. What I think is that when you consider gas as a full thing within a system of other gases, of course it's going to disperse. It's going to be very hard to track, and gravity isn't going to affect individual things. But when you're talking about individual gas molecules and their individual velocities and paths and things like that, in a vacuum, they are going to be affected by gravity. Obviously, it's very difficult to observe that very subtle change because of the very small mass. And of course, they're going to bounce into a trillion other gas particles in the atmosphere. But the point is that effect averaged over the entire circumference of the Earth and the distance of the atmosphere, which is hundreds of kilometers up, right? Well, okay, not gravity, but whatever force or thing that makes the penny drop fall, There's no reason it wouldn't affect gas, but it would affect a pen when I could
But we
like
can't
vaporize
see
a
it,
pen and
we
make
can't
it
observe
gas,
it,
right?
We can't measure it, but we
I
can't
can observe it. I can watch my pen fall. I can watch if I had a tube that extended all the way up into the atmosphere. There was a vacuum tube, and I put a single
I'm gonna go, man.
bit of
I'll see you
gas.
later.
I see it, bro.
See you, T-Dub. Thanks, man.
If I
Have a good
put
one.
if I put a gas particle in a tube that extended up into the atmosphere, you would notice that even if it was going straight up and shut up with X amount of velocity, it will decrease as it is affected by this acceleration that affects all objects. And that's true. It can be observed. Obviously, you've got to trust your instruments and the things that can detect these particles at such a small scale, because our eyes can't. If you can't, then obviously you're not going to be able to do that test. Fair enough. But if you average that effect over an entire like system of gas, which is fucking billions of cubic meters and all this kind of stuff, it does become, when you treat it like a large, massive object, like all that gas, yes, individually the masses are very small, but when you count all the gas up in the entire atmosphere, it's going to weigh billions of tons. That, as a whole object, if you want to treat it like that, is absolutely affected by gravity because of the large mass of it, and it gets sucked in. You won't trust me on...
Then why aren't clouds pulled down? Because clouds...
Because clouds are very small. Clouds are very, very small in comparison to the entire atmosphere.
Can you just check for me what the weight of a cloud would be that's full of ice
Sure.
and water?
You're
Yeah.
talking about tons of oxygen.
Clouds
It's
are fucking heavy as
not
shit.
being
Yeah.
pulled into, like,
So they're not affected by gravity, but you're saying that mass is affected by gravity and that these big masses in the sky would definitely be affected by gravity, but now we have clouds that aren't.
Well, they're absolutely being affected by gravity, but gravity, again, is very, very subtle. An individual cloud, while it is very, very heavy, like I've got here 1.1 million pounds, I don't know what that is in kilos, but if you compare that to the rest of the atmosphere, or say the rest of the air surrounding it, it's also going to be very, very heavy. And the density, of course, will line up with the fact that the density of a cloud is going to be less than the density of whatever air it's sitting on top of, because that's how it works, right? Obviously, the water that's evaporating off of the surface of the ocean is going to make the air below the clouds very, very dense, and thus the clouds are going to kind of hit this invisible, quote-unquote, wall of more dense air. But point being, when you take the entire atmosphere into consideration, which has billions of clouds, billions and billions of kilograms, etc., it's all going to be vectorized downwards towards the closest center of mass, which is the Earth. And in the same way, I know you won't trust this one, but Jupiter, Neptune, Saturn, etc., we know through spectrometry and samples and stuff like this, if you don't trust the probes, obviously the samples don't matter, but that there is gas in them. They're comprised of certain gases. Those planets are mostly gas, as opposed to our mostly rock planets and Mars and Venus, but they still stay together. They're still circular. Our sun, we know, is definitely fusion of atoms that is creating energy, heat, light that is coming out of us, and solar waves and blah, 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 blah. That is all a big ball of gas. That's definitely a sphere that's staying there. And that's much, 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 much bigger. So, and that has like what, 98% of the mass of the entire solar system.
how do you know any of those? How do you know any, like...
I gotta say,
I've
this
just-
is a fish scallop, man. This is
I'm
just.
just
What can
taking your
what
word
can I
for
say?
granted.
I'm
Like, how do you know any of this
heavily
yourself?
indoctrinated. Sue me.
Are you
I've been
medicated?
indoctrinating myself since fucking
I'm
I
trying
could
to give you
read.
the benefit of the doubt and listen to you. This is so...
I'm
You're
struggling.
lost on it.
I gotta ask you.
You're so
a question.
lost. So ask questions, man, because I can explain it for you if you want.
No, I'm
you don't
saying
have to
you're lost
believe
in
it.
I'm saying you're lost in it. How do you know any of this shit about... I have to mute.
Can I get two questions?
Can you do me a favour? Can you have a look for me?
He admitted.
Know what you fear. Can you check if that is considered as a perfect
Oh, you
gas?
call it, I was wondering why you're calling it Atmo, because it has sphere in it. Okay, fair enough. That's
Well,
funny.
first of all, I'm saying that atmosphere is an oxymoron because
Yes, flat Earth, of course.
No, atmo
No.
means air, and sphere means sphere. So we don't actually have sphere-shaped air on the Earth. So we'll say atmo.
Well, yeah, your claim is that we
Logic
don't.
again.
My claim is
It's
that.
not cult. It's not cultish. It's just logic again, Deck.
Yeah, you can. It's an empty statement because you can say that about anything. Like I understand you believe it, but I could say the same thing. I could mean it. You know. Sorry, AJ. Keep going.
Just have a look for us. Is our atmosphere, Atmo, considered a perfect gas?
I don't think anything is really considered a perfect gas, but
Just have a look under our gas laws. Let's look at gas laws for a minute here, and let's have a look.
I assume it gets pretty close, hey, because it's very large.
Oh, we're not assuming. Let's just look it up really quick, like you've done.
The atmosphere is mostly natural oxygen, both of whose behaviors are very close to ideal at the temperatures and pressures found in the atmosphere.
Ideal or perfect gas. Our Atmo is considered an ideal gas.
So a perfect gas is one in which intermolecular forces are not considered. Okay.
So how's gravity affecting this?
Gravity is not an intermolecular force. There's no gravity acting between the molecules of air. So one nitrogen sitting next to another hydrogen, the amount of gravity affecting those is basically negligible, so you can consider it a perfect gas.
So let's go and have a look at the of this ideal gas and state what the properties or what it does.
Background shit talking.
I mean, again, all these examples, I mean, Donato's picture here, 100% right. If you're talking about a cube that's what looks to be like 2 meters by 2 meters, or fucking, if there's that many gas particles, it's like a blank length. Not quite, but.
You realize the antecedent to pressure is containment.
Yeah, sure. And you understand that a containment is a wall that exhibits a force when a gas comes into contact with it, right?
So therefore not gravity, the bending and warping of space-time.
Bending and warping of space-time, while not technically considered a force, I think, or I think there's debate on it. I don't know exactly, but there's no debate. There's no debate that gravity definitely affects objects and creates an acceleration that we can measure. Would you disagree?
Where do we see
Or at least that
gas?
Dude, you have a great imagination.
Yes,
Seriously.
sorry,
You're a nice
the
dude,
question
but
is
you've got
where
a good
do you see-
imagination.
I do have a great imagination. Thank you for that. I'm going to play some Dungeons and Dragons actually next week, and I'm looking very forward to it.
Quoting Michikaku, we lied to
Honestly-
you. Gravity doesn't suck you down to the earth. Space pushes you down.
What pushes you down, sorry? Space.
Space.
Yeah, but it still
Quoting Michikaku.
exhibits a force on you.
Yeah.
Space, absence of anything.
But like, how? I don't understand how you can possibly listen. How can you quote Michio Kaku? How can you quote this guy who is definitely not a flat earther? He believes the Earth is a sphere. How can you quote anything he says if he's like a fucking globetard or whatever? Like, isn't he the malicious scientific people that don't know what they're doing?
Listen,
No, he
listen,
says a
we don't-
hostile witness. He says this, and he's one of the preachers.
We don't go around calling people globetards.
No,
Listen,
okay,
we're not.
I'm sorry,
We don't
I'm
go
sorry.
around calling people
You're right.
globetards. This isn't just a petty little game that we play. We're literally only interested in science. We're literally only interested in observable reality. This is not a cult, and this is not a game.
Yeah, I didn't say it was.
We want you to be accurate, and we really want you to focus on the curvature argument and the motion argument, because these are the only two things that you can test.
I want you to be
Prove
logical
what's
as
under
well.
your
So
feet.
I don't understand why half the time you're telling me don't trust anyone. Science is a lie. They're all lying. They don't even use science to do their thing. And then in the next moment, you link to me a very prominent professional physicist that's
hostile
backing you up.
witness.
Like,
You know what a
Yeah,
hostile
but-
witness is? So
I think so. I'm not
that
big on
side
legal.
says-
Yeah.
Yeah, but it's somebody on, let's say, the heliocentric side. One of the preachers, a scientist, he says this. How silly it is. It's called using it as a hostile witness. Now we can use different people like Michio Kaku, he preach, for example, from this side in arguments. Then we can use them again as hostile witnesses. Because not everything's agreed upon within the heliocentric model, for example, right?
Mm-hmm.
That makes sense.
Sure.
Cool.
I get it, but at the same time, why is it that I can quote, like you're trusting this physicist that what he's saying there about gravity and how it's not actually gravity, it's the force of space or whatever. Why does that have any weight at all? Or you're using it just to deconstruct my argument?
Lots of different. There's at least 2 different types of gravity, and there's lots of different scientists who prefer 1 or 2 different types of gravity. And those 2 types of gravity, they've got different opinions on as well. So
This is true, but it's also true that the basic equations, they're all going to agree on Kepler's law, say, of like radius and mass and stuff that affects the actual path that planetary bodies and stuff like take. That's very basic gravity. They're all going to agree on that because that's basically settled science. We can look at things in space. Well, obviously you're not going to consider it settled science, but in the wider scientific community, they can observe this stuff and they go, yeah, I mean, we're all looking at it with different telescopes, taking the same measurements and seeing it does the same thing. So we agree on that. But then when you get to the actual core, like why behind it, is it Einsteinian? Is it fucking all this other kind of stuff? Fair enough. There's going to be disagreements because that's on the fringes of physics. But when we go to the stuff that's actually like well established that we use every day to satellites, internet, blah, 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 all this kind of shit, that stuff is pretty fucking solid. Very solid. The point is all this pseudoscience is not science, but it's been lumped in with genuine science. Yeah, sure. I'm sure there's a lot of stuff we got wrong. And the kind of the whole point of science is to be able to explore the stuff that we think could be wrong, that could be pseudoscience, and use better scientific inquiry and better scientific tools as technology progresses to see if we were right or if we were wrong. And if we're wrong, you just put a paper out, people peer review it and go, oh, this is good science. They're using good techniques and it actually completely deconstructs what we thought of before. We'll put it in fucking Nature magazine or whatever the fuck. And that's happened hundreds of times. And I'm sure many times it's been put there because some fucking BP oil energy company has said this, that, and the other, and it looks good and people go, whoa, you know, this, that, and the other. But that's going to happen either way. Again, you don't throw the baby out with the bathwater. A lot of it is genuine scientists that actually want to improve their field and understanding, and they've made a genuine improvement.
So many fallacies.
Truly baffled by your lack of humanity when dealing with subjects that you clearly have no prior knowledge of. According to you, sure, but I think I'd... Like, if I'm going to be in this cult and belief in religious system, I might as well know it, right? Why the fuck are you here? Honestly, you're trying to learn. Are you trolling? I'm not trolling. I'm genuinely just here to talk and have a conversation and understand your point of view, and you understand more my point of view.
I don't think you've been trying to understand our point of view the whole time, man.
Well, that's your problem. I absolutely am, and you can believe me or not, but I'm definitely trying to understand you. And listen, the stuff you were saying before about how if I were to try and accept what you're telling me, then I would have to rewrite everything I think about the world, etc. I 100% get. And it is a very scary thing to think about, okay, well, if that's not true, then that's not true, then that's not true, then that's not true, blah, 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 blah. And I think it leads to a lot of people having kind of mental breakdowns to some degree within this community. I'm sure you've seen it a lot, that some people go pretty off the fucking walls with this kind of stuff. I'm not saying that's you by any means. A lot of the people here are very, very rational and down to earth, 100%. But I think you would be kidding yourself if you think all of your community is exactly to the same level that you guys are intellectually and rationally and understand all the arguments.
Right back at you.
Right back at yeah.
I think it's the same for the
100%.
science community.
Amen,
too, like the-
Amen. Yeah, I'm not saying it's not.
What are you saying, Falv? Sorry.
I was just saying it's probably the same for like y'all just agreed with. I don't need to repeat myself.
It is. Yeah, it is the same in every single thing. There's going to be people that actually know what they're talking about. There's going to be people that just agree and nod their head to the guy in the room that's speaking the loudest and then repeat parroting talking points. Yeah, 100%, without actually understanding the underlying stuff behind it. I pride myself on trying to understand as best as possible the underlying mechanics behind it.
Are you though?
Yeah,
Okay.
yeah, I am. And you need to believe what I'm telling you that I truly am trying my very, very best. Whether that's not good enough for you is your problem. But I am trying.
So earlier when we was talking about gravity and how do you scientifically, or how do you apply gravity to a scientific experiment and all this stuff, and you was bringing up your objects, right? Why is it that you was hearing relative density or a specific gravity, and why were they using that instead?
I'm sorry, I don't follow the question.
Why did I
Okay,
bring up
no,
density
hold
and
on.
buoyancy, basically?
You're trying to prove that there is a force, not a force, pulling an object to the ground, pushing an object to the ground, okay? And they're just saying it's specific gravity or relative density. Why? What's the fundamental reason why during that conversation?
Why are they trying to say it's buoyancy?
No.
Is that what you're asking me?
Yes. Why? Why would
because
they
that's what they believe to be true.
Okay. Whenever they were going on and talking about how in the scientific method you have to be able to manipulate your cause. Okay. The reason they're not saying that there's a force, not a force, pulling or pushing an object to the ground is because they can't manipulate it. They can manipulate the medium and all the other variables around the object. They cannot manipulate the gravity itself.
Okay.
That's it.
Okay.
That's why that's a.
But the reason we went sure, but the reason we went through all that was to establish where we agreed upon things, and we agreed upon that scientific experiment of dropping the balls and shit. And so the point of that was to kind of understand where our ideas diverge and where we stop understanding each other.
Do you understand Kiko's disposition? Why he said to you,
disposition?
Why do you think we are bringing up density and buoyancy as a repeatable, measurable phenomenon? Because we can manipulate the mediums around us. We can use water, we can use air, we can use any medium we choose to, because the medium is what we're manipulating.
So let's
yeah.
two objects.
But why is it that like oil floats instead of sinking?
Okay.
And
I'm going to have, and I'm going to change the medium only. I drop a 1 pound of iron and I drop 1 pound of wood in air. They both fall. I drop the same 1 pound iron and wood into water. Iron sinks, wood floats. I drop the wood and iron into liquid mercury. They both float. Why? Because the medium.
Right.
Yeah. But you understand though that that's still
simple,
applying.
bro. It's that
Yeah,
simple.
it is that simple. But you haven't asked why.
Hold on, wait. That's the point, bro. It's that simple. Do you understand? Like.
Okay. Yeah. So what you're saying is that
that's where the line comes in of gravity. It's just you don't need it.
So what you're saying is because there's like this whole atmosphere around us. When you drop a piece of wood, it's only falling because of the relative density between the air and the wood, or the air and the iron.
Just take a step back, simplify it, bro.
I'm asking a question because that's where I'm stuck.
I know. We all know.
And you refuse to answer it.
I'm trying to hear Kiko. He's breaking up. Go ahead, Kiko.
You're trying to establish that there's a downward bias. Let's change it up. I put my two objects in the bottom of a container. Right? Now I fill it up with air. Nothing happens. I fill it up with water. The wood floats. I fill it up with liquid mercury. They both begin to float.
Yeah, but I've got a question for you, a different one that I've got one that's gonna stick it to you real bad here. So we established, yeah, big time. So we established, right, that when we drop both iron and titanium in a vacuum or even in air, they both fall at the same rate, correct? Correct?
Sure, I'll agree.
In a vacuum?
But then I'll have
In a
to
vacuum
follow
or in air, they fall at the same rate.
Kiko, you're
If they're the same, so if they're the same volume, right, the exact same shape, then the air resistance isn't going to affect it like differently between them. So if we make sure it's in air, the object is the same size, and we just change the density of that.
Stream then restarts at 24 hours.
What is your profession?
Old friend, I brought more soldiers.
What it really means to live life golden. Yeah, we're golden, baby girl, we're golden. They're about to see us shine, 'cause we're golden.
Get back into full view when, according to the curvature of the Earth, it should be obscured. Part of the boat should be obscured by the curvature of the Earth, yet we're able to bring it back into full view. So I'm not I don't understand like why no one brings that up, that anomaly, but like
I think they do, but a lot of people
like it or not. You might not accept my answer, but I got an answer for you.
Sure.
Well, that's because of refraction. Of course.
Atmospheric refraction, right? But unfortunately, atmospheric refraction it can only occur with very specific atmospheric conditions.
Mate, I just saw you in there. I was just going to come in and say hello.
It's not an everyday occurring phenomenon. You have to have it.
I'll catch up with you later.
It has to be the right conditions
Take it
for
easy,
atmospheric
dude.
refraction.
One love.
I mean, okay, we can take another example of the law of perspective and, disproving the curvature of the Earth. Have you ever heard of Sawyer de Uyuni? Mayhem? The Bolivian salt flats?
Yeah, I know that place. I heard about it.
Okay. So, if you go there, if you've seen it, it's about like 100 kilometers wide, and in all directions. Let's say it rains a little bit, like 3 inches of rain per se in this Bolivian salt flats. The reason why it's popular and people know about it is because it makes it look like it's a giant mirror, perfectly flat mirror. It's not convex, not concave. It's a perfectly flat mirror for over 100 kilometers.
What's it called?
Sawyer de Uyuni. I'm not sure if I'm saying that right, but just type in Bolivian salt flats. There you go. Or Bonneville salt. Is that what it's called? There you go. Let's see here. Let's look at this video real quick. Actually, I don't know about the Bonneville salt flats, but apparently that's another salt flats place. But the one I'm thinking of is in Bolivia. There we go. Secret Asian Man posted a picture of it right there. Gorgeous, by the way. So let's take that.
Legitimately heaven.
Yeah, it's like a perfect mirror. Like there's no warping in the reflected image. It's completely flat. That's not what I'm not saying that proves it, but what I am saying is if you're able to see for over 100 kilometers perfectly like that far of a distance, where it looks like it's a perfect mirror, completely, symmetrical with the image that you're looking at. Like if you're standing 50 kilometers away, and you're looking at something another 50 kilometers away over there, it's the same mirrored image.
Yeah,
like
there's no curvature. Yeah,
there's no concaveness. Yeah.
Yeah. Well, my argue. I mean, I solely believe Earth is completely flat too. But my argue there is that Earth could be that very big. You know.
Okay, let's say that's the case, right? Let's say that that's the case, that the Earth is so big that you're not unable to see the curvature of the Earth.
For a while, yeah. For like.
Okay, well, let's go back to Eratosthenes. Let's go back, because that's important. That's basically where we got the measurement of the Earth, right?
Yeah, but I thought you said we can agree to disagree about Eratosthenes. Why are we going?
No, we are. But we're
Yeah,
going back.
that's-
We're going
I'm-
back to the measurement, though.
I'm
'Cause
doing. Yeah, I'm like I said. Yeah. Keep going.
So the important part of that measurement, right, is that it confirms, quote unquote, confirms that the Earth is about 25,000 miles in diameter, which is important. It's very important, because based on that calculation and of spherical trigonometry, by I think it was Aristotle. Let me look this up. There's actually a calculation that you can look up yourself that measures the curvature of the Earth. And it is this calculation, bear with me. And this is very important.
Wouldn't it be crazy if we don't even live in a flat or sphere? It's just a matrix.
So, let's see here.
Like, oh, guess what? It's all a simulation. That's crazy.
Let's see here. So, based on the law perspective and the measurement of the quote-unquote curvature of the Earth, that when we're looking at the horizon, that anything that we see, I believe it is 6 inches per mile squared, I believe. I can't remember the exact thing. If anyone could help me out here. Can't remember exactly what to find here. I can't remember what I'll try to find it on Google, and it keeps giving me different things. But I think it's 8 inches.
Never give him 6 inches when you can give him 8.
There you go, 8 inches. 8 inches per mile squared. Per mile of distance that you're looking at. So let's take 100 kilometers, for example. 100 kilometers to miles is about 62 miles. So if I'm in Sawyer to Uni and I'm able to see perfectly all the way to the other side of the salt flats where you can see the mountains, like for example, in that picture, which is about 100 kilometers. So if it's 8 inches per mile squared, in terms of how your perspective line, like your horizon line, starts to dip according to the curvature, then that means those mountains, for example, 100 kilometers, say, and I'm sorry I don't have the exact numbers about those mountains, but you don't even need to, because 62 miles, it's long enough to see a difference. Those mountains should not be in view. They should actually be about, 8 inches per mile squared. So 8 inches times 62 miles. Let's see, so in feet.
So you're telling me the people who made these rules are kind of like screwing themselves over because people are like proving themselves wrong.
Well, if you have,
think so. Yeah.
I mean, if you have 25,000 miles in diameter, if that's like what you're basing this entire globe measurement on, which is basically just fucking
common
two
knowledge. It should be,
dudes
right?
or a dude that basically put a stick in the ground, like. And let's take that at face value. Let's say it is 25,000 miles in diameter. Okay, so according to spherical trigonometry, it's about 8 inches per mile squared. That your horizon line, like your vision, like the way your eyes see, you can't. You would start to see that curve, based on how many miles are. If it's 25,000 miles, right? That means Earth is that's limited to that space, and it's a sphere. So you can actually have a calculation about how much curvature you're going to be seeing as you go further down your perspective line. So if I'm looking at 62 miles away at those mountains, then that should be per mile squared, 8 inches, 8 times 6, that's 48, 8 times 2, that's 16, 496. So that should be about 49 feet below your horizon. Like, you should not be able to see those mountains. It should be 49 feet below your law of perspective. I'm not sure if I'm doing this math right, but essentially it's impossible to be able to see those mountains in full view. It just doesn't make sense. Like,
Yeah, that's interesting. I've never been brought up that point from that kind of place, because you're right, it is completely flat. And I'm sure we can make this with several other flat
a lot of
places, like-
places.
yeah.
But the reason why I choose this is because it's very
The mirror. Yeah.
visual, that it's a mirror. Like, you can see that it's perfectly flat. And like your question earlier, what you said, well, the reason why we can't see the curvature is it's too big, right?
Yeah, well, that was my rebuttal.
Right. It's too big. We can't see it. Yet, we're able to see the curvature of the Earth from the beach. That makes no
Right.
sense. That's illogical. In fact, how are we not high enough in the air to see how big the Earth is and the curvature of the Earth?
but
Yet we're...
But Red Bull clearly, as they post,
Oh, you seen that? I've seen that too.
the jump, yeah.
Where you can see it totally change the fisheye lens. But
Yeah.
yeah. But to keep it like in fact-based stuff, it's like going by their logical and fallacies. It's maddening, because you can go about it for fucking hours on end and nothing will get done. But I get
Yeah,
what
for
Mayhem's doing. I get what these. You have to become correct when you're discussing this stuff. But the one
Did
thing.
you cut out just then? Mic check.
He's
Hello?
still good. He's good. It might have been just you.
Can you hear me?
I can hear you.
Mike is still here.
All I heard was, I get what Mayhem's doing. Anyway, hey, speaking of, Miggy, what's happening?
What's up, brother?
Did you cut out Beasticles?
I don't think he did.
I'm not sure if I am or not.
I think I heard him.
Oh,
I
okay,
think you were
okay.
cutting out on your own. But yeah, man, that's a very good point. And like I said, it took me a while to really fully grasp that this whole world, possibly
Let
could
me
be
let me yeah. Excuse
most
me,
likely flat.
excuse me for a second, guys. Let me talk to my the students in here, the academy. Guys, this exercise was meant for you guys to listen to and critique. We're going to go ahead and open up the panel to anything that you guys have heard within this critique. You guys go ahead and kind of help him out a little bit. Teach him how we do things here and kind of show him like what the arguments are about, what went wrong, what could have been better, and all that kind of good stuff. We can open up the floor to you guys listening to this conversation, me asking Beasticle some of those questions. So go ahead. If anybody wants to jump in, if you were hearing the conversation between me and Beasticles,
Hell yeah.
go ahead. Well, just listen to some honest critique, okay, Beasticles? So no slight to you, it's just honest critique, okay? All right. So anybody want to jump in, or we all good?
All I can say is when I first tuned into this a little while ago, I thought somebody had cloned your voice and was just BSing. I didn't realize at first that you were role-playing.
Well, it's much more than that, though, because what happens is when you actually test the metal of your argument, you start to realize where the holds are. Now, was anything that was being said? Are we all good? First of all, with between the way I was arguing, the way he was arguing, did everybody come out good? Are we all good, or nobody's got nothing to say about it, or what's up?
I'd say Beasticles needs some more practice.
Yeah,
I think honestly, I didn't know what the fuck was going on. I think Beasticles were bringing some great points. I would just probably keep the math to a minimum, because that was kind of like putting me, or my attention wasn't being as focused as as when you started saying a bunch of numbers. That could just be me.
No, I'm just asking everybody actually, so anybody can put their input. Because when we all come up to this, the point where we're actually having these discussions, arguments, or whatever, we wanted to present it in front of everyone. So this is kind of like a test run. So is everybody good with what's being said? Because I don't hear anybody else except for Wade Bixer and Big Root. Was it Big Root that said something?
Well, one thing I would say just specifically
mocking,
that
bro.
Beasticles really needs to know the times, the dates, the numbers. You know, when it comes to 8 inches per mile squared, you should know that like the back of your hand and not say 6 inches or something like that. When you get into a debate with somebody or with a discussion and you're tripping over your own words, that's not good.
Gotcha. No, and that's completely understandable critique. And that's kind of like why I'm here anyway. I definitely, because I am a flat earther for sure. I might not exactly
No, it's cool.
have it in front of me.
Yeah, it's cool. But what I'm saying is, like, when you get
I'd be
into the level
prepared.
just check this out, right? When you get into the level of the kind of discussions that we get into in here, we meet every archetype of personality, from the sophist to the weasel. Just everybody who's just trying to pull one over on you or say something, interrupt you. They'll speak louder than you or whatever the case is. But what I'm showing you, because I pretended to be the nice, calm Glober, right? So for you guys to hear me like the way I was retorting to you was the way they would normally. Because I've heard all the things that I told you was basically what I was told when I was learning how to refine. The argument. So there's a lot to learn and to glean from the people that are in this server. And so what I'd say is that I know you might be, I don't know, seniority wise, like 10 years in flat earth or something. You know, I don't know how long you spent in it, but that to me, it doesn't matter. It's not about seniority. It's about learning the arguments and understanding how to address them. So for me, it's more of like, you have to be well equipped. And this server, it sharpens your mind and your arguments get quick. You don't have to waste time with bloat. There's a lot of bloat that you actually get to, which is what I call derivative topics. Derivative topics are not needed if you can fundamentally take out the whole argument, right? And so if you've ever, I don't know, you don't know who I am, but I've curated the 3 points. The 3 points from the time that I started to where they're at today are, in a sense, well, I would say they're basically a tool that you can use to actually come at somebody to expose what kind of knowledge they have about the Earth being a globe. Now, once you have that knowledge, then you can move forward and then refine your logically consistent points to the person, and then they can understand what you're saying. Because right now, when you speak to a glober, they have their defenses up, their walls up. You haven't taken anything down, so they're gonna fight back on every point that you give them, right? So what I didn't, it was no effort on my part to just tell you that, you know, somebody else figured it out, and there was no coming to reconciliation of why I don't have that knowledge. You didn't make me understand that. So for me, it was just, I was just kicking back, listening to you say whatever you wanted to. In my head, I was playing the guy who was just like, you know what? I know it's still a globe. You haven't convinced me. You know what I mean? So I made your job difficult. So you were doing the heavy lifting. Meanwhile, I was the one listening to you tell me how the earth. You had to convince me. But see, in this specific arena, it's the other way around. We don't listen. We don't ever play defense. And if you start playing defense, then you're doing it wrong. So I always educate people here in this server about that. It's not about you playing
Defending your
defense.
point, yeah.
You're once you start defending, you're already they got you on the ropes, and so they're gonna
So make them
keep
defend
you.
their claim.
Yes,
Yeah.
exactly.
Okay.
So so this and I put it to you like this: this discussion is not a debate. It's
Right.
not up for a debate. So what it is the burden of proof rests on those who make the claim. So those who advocate for the claim, which is the Earth is a globe, they're the ones who are saying that the Earth is a globe, and they advocate for that position. Not saying that they made the claim themselves, but they advocate for it. So they're
Right.
saying, no, the Earth's a globe, and I know because the scientists told me or whatever. But so if that's the case, then the burden of proof rests on their shoulders alone. So what needs to happen is evidence needs to be put forth. So think of it like a court case, right? So
Right.
do you have a court case running, and so they are the ones that need to present the case for the Earth being a globe. So in order for them to do that, they need to sufficiently come forward with any evidence. So what you do is you're somebody to say, okay, present your evidence. Let's see what you have to present as far as evidence goes that the Earth is a globe. Now that's what you're waiting on. So if you get into like a spiel about like the Earth and the salt flats and all that stuff, you're trying to logically consistently provide evidence for the case of the Earth not being a globe but it's flat, but they're not going to see it because their walls are up. They have their side, you have your side, and then when it's their turn to speak, they're just going to retort and tell you, nope, it's a globe because you didn't factor in gravity. You didn't look at the Eratosthenes or something. So in order for you to avoid that, you have to get them to admit they don't know. So I always teach
Okay.
people when they're in here is that when you go against an opponent that thinks that the Earth is a globe, you have to listen to the knowledge that they know. So the 3 questions, have you heard
It's
of
little
them?
to nothing.
No.
Okay, so the 3 questions are this, and I'm just going to tell you so you know for future.
Yeah.
I curated these 3 questions. It goes just like this: who has ever measured the curvature of the Earth any time in history with drop over distance?
Who has
Who has
measured
ever
the curvature of the Earth
anytime
ever in history, any time in history, with drop over
with
distance?
drop over distance? So drop over distance excludes any other shenanigans from Eratosthenes, Aristotle, Al-Biruni, anybody who's ever any of the ancient guys, right? So what you're doing is you're cutting it off at the knees. So when they want to come back and say, well, Eratosthenes, you're like, no. I didn't ask for sticks and shadows. What I asked for was drop over distance. So the consequent of the geometric shape being an oblate spheroid would deem necessary that the shape would demonstrate this sagittal. Point B, there's going to be an obstruction, which is the hump of the Earth in between point A and point B. Therefore, if that is the case, we have a drop rate over a distance. So the drop over distance is necessary. It's a necessary consequence of the Earth being an oblate spheroid. So if you follow me on this, what happens is they have to demonstrate any time in history that drop over distance has been directly measured. Now, there isn't anything that has ever been done any time in history that has been taken into account. So they're going to be fumbling around trying to figure out, give you half-hearted answers about, Samuel Rowbotham and, just other things, right? And you're going to be, no, that's not what I'm asking for. What I'm specifically, what you do is at that point, you start to redirect. Okay. That's not what I'm asking for. I'm specifically asking for a drop over distance. So basically what I'm saying is this isn't a debate or left up for discussion. All it merely is for them to demonstrate their knowledge as to sufficiently answer the question, right? Has there been anyone to demonstrate that the Earth has been directly measured, that drop over distance has been measured? Now, that's up. The burden of proof is on their shoulders. It's not on yours. So at this current time, I would say turn off the answering of the questions. And they say, no, but then you prove to me the Eratosthenes. You say, we'll answer some questions after these 3 questions that I got to give you. I promise. We'll go through all whatever you need to, but first sufficiently answer my questions. And then we'll pour over ourselves into anything you want to know. but I have to know what you know first about the Earth being a globe. So first of all, you have to get them to answer those 3 questions sufficiently, or admit that the thing that you need from them, right, is the concession. It is the utmost, most important thing that you have to hear from their mouth. I don't know. If you don't listen, if you don't get that from them, the walls are going to be up and you will not penetrate their mind. So really, what you're doing is exposing their mind to everybody that's listening. So everybody's going to
Opening
be
it up, I
gathered around.
guess.
Everybody's going to be gathered around. Everybody's going to be trying to listen to how this debate is going to happen.
Right.
And when you present it to them as in like, no, this right here, what we're doing is you who have the burden of proof are going to come forward and demonstrate to us that what you're claiming is true. So that is what's necessary right now, is that they don't understand that. They don't know that they have the burden of proof. They think because you said flat earth, you got to prove it to them. And see, the magic trick, what happened was throughout the discussion, people on the flat earth side thought that we have to have the burden of proof because we have to demonstrate how the earth's... No, the earth is flat and stationary. So the burden of proof rests on those who are making a claim that is otherwise than what we know it to be.
Right.
Just like you were leading to tell me at the beginning with your questions, right? But another thing too is that this position that we have is not, and I repeat, is not an agree to disagree position. It's a right and wrong position. Either we're right or we're wrong. There's no other 2 ways about it. So with the demonstration that they're going to give you, it's either going to sufficiently answer the question that the Earth is an oblate spheroid with drop over distance, or they're going to not be able to present any to you. Which in what case?
No, right.
Yeah. Which in what case? Okay, so 3 questions, right? So the first question is: has the Earth ever been measured any time in history that it has drop over distance? They'll probably tell you. They'll run around and say, no, well, you won't like my answer, or no, Eratosthenes, or and then
There'll
you
be
have
some pushback from that for a while. Yeah.
yeah, the pushback will be a little bit, but for you, it's basically cleanup detail. You're just gonna have to like, nope, sorry, redirect back to the premise. Nope, I'm not. I'll talk to you about later on. If you want to ask me some questions, we'll do it after. Like, it's just cleanup. That's all you're doing. And so once you get to settle down, and then what do you want me to say? You're like, just answer the question. If either you know or you don't. But if you don't know, say I don't know.
Right, and then we'll move on to the next one.
Right. And so you listen. Don't give in to like, okay, you didn't have to say you don't know, but I'll just take it like no. This right here, what I'm telling you, is the most important part of the 3 questions. The concession. If you do not get the concession, do not move on to the next question. And I'm saying this specifically because what happens here, it's called an ego death.
Right.
Their ego, which is built up, which has been built up, that they think that they have, will die. And it has to. So they have to concede that they don't know. And it's a hard pill to swallow because they're going to fight.
Better, yeah.
They're going to fight, right? So once you hear that, I don't know, say, okay, that's fine. You don't know. Let's go to the second question. Like, be calm about it. Go to the second question. And then once you get to the second one is this. It's like the first, but a little bit different. They tell us, I'm gonna give it to you. Like I prefaced the second question. They tell us that the Earth is spinning at 1,000 miles per hour at the equator. So the question to you is, who has ever measured the Earth to be spinning around at 1,000 miles per hour at the equator anytime in history? By any device or any person or people? You can put a little extra to it, like the way I just did.
Next question, though. It's great.
Right.
Yeah.
So the axial rotation is the second question. Axial rotation, the spin of the Earth. Who's ever measured that anytime in history? And you could, like I said, you could preface it with saying that they tell us that the Earth is spinning around at 1,000 miles per hour at the equator and so on. So who's ever measured the axial rotation of the Earth anytime in history? So they're going to either get sufficiently answered that question. Well, Foucault's pendulum. No. Okay, so what we're asking for is a naturally observed phenomena of Earth spin. Who has witnessed the Earth spinning anytime in history? Because they have to see the natural observed phenomena if they're going to claim that they know that the Earth is spinning.
Right.
So remember, this is all about them giving you their base knowledge of how they know that. And so when it comes out to it that they don't know, they'll say, well, the moon's moving around, the sun's moving around, duh. And you'll be like, check this out. When you're outside, what do you see from east to west? The sun moves across the sky. What do you see east to west when you see the moon? The moon moves across the sky. What do you see when the stars move They move east to west across the sky. Everything moves east to west across the sky. Therefore, from our vantage point, we only see the sun, moon, and stars moving. At no time do we see the naturally observed phenomena of Earth spin. And if you appeal to Foucault's pendulum, then you're already in a fallacy, because you're using a man-made device. That's
You're not using a
naturally
natural observed phenomenon.
Exactly, it's not a naturally observed phenomenon. Correct.
Makes sense.
So you have to make sure your answers are airtight, because you'll get the sophist in there, you'll get the weasel who tries to like say things to make you put words in your mouth or something. So there's a little bit of pushback, I would say, because they already know that the collapse of their paradigm is coming, right? So, second question, you still have to wait for the you have to wait for the I don't know. Don't skip that part. I'm making a very poignant effort to tell you, do not skip on the I don't know. Like, you have to hear that before you go to the next one. But as soon as they're frustrated, like, oh, man, what do you do? I don't know. Okay, we'll go to the next question. Next question. And so the third and final question, right? Once you get to the third and final question, is simply this. They tell us that the vacuum of space is adjacent to the pressure air that we breathe, right? So on the surface of the Earth, we're breathing at about 14 psi. So that's what we breathe on the surface. Yeah, you can measure that and that. So they know that. But they tell us as we start going up in elevation, the gradient air changes and it gets thinner and thinner, and we're not able to breathe. So by the time you get to the past the Kármán line at about 64 miles up of the Earth's surface, they tell us that the Earth starts to become the vacuum of space right beyond the Kármán line. So they're telling us that the vacuum of space, right at that part right there, is 10 to the negative 6. So it's about a powerful vacuum like on Earth can produce close to that, right? But further, as you further go out into space, it's called not just space but outer space. And outer space, outer space reaches levels of like 10 to negative 17, Tor, right? So you kind of tell them all the rhetoric along with that, but here's the kicker, right? You want to go into where you start to tell them the most important part, right? So the most important part of this third question is, okay, so knowing that we have pressure on the surface and super low pressure up in the vacuum of space, how is it possible to have gas pressure without a container? That's the capstone, right? You have to say it that way. How do you know we have gas pressure without a container? You can say this: because if we have an open system and there's nothing stopping the gas from expanding, then that gas would naturally fill the volume of wherever it's in. So the gas would disperse.
Right.
It wouldn't stay in one place. It would disperse.
Something's containing it. That makes sense.
Right. So the question would then, like I said before, how can we have gas pressure without a container? So now you got 3 questions. And so their answer needs to be sufficient. If it's like, well, dude, gravity. We say, okay, now you said gravity. Please demonstrate how gravity is a container. Let's go out into the field somewhere. Can we test for this? Because you just made a claim. That claim needs to be tested. So now I need you to test gravity being a container. Please demonstrate that for us. Do you understand what that means?
Yeah, so instead of beating around the bush and saying, well, what about gravity?
Yes. You go straight for the demonstration. You go straight for the demonstration. So
Great for the jugular.
Yeah, it's important because you want to be concise. You don't want to fiddle-faddle, him and haw, or whatever it is you want to talk about, like wasting time.
I definitely didn't feel concise earlier.
Well, that's why
this is happening.
It's merely just a guide. That's all it is.
Yo, however, I didn't even know this was.
It's a pretty good guide, though, for real.
Yeah, I didn't even know this was going on.
You're definitely highlighting 3 very important key points.
Yes, these are the fundamental. Yeah, these are the fundamental pillars of the Earth being a globe. They're the most important information for someone who believes that the Earth's a globe. Okay, so I wasn't even done yet, but I'm going to show you something, right? Once you get them to this level where they're already denying the fact that they can't understand how gravity is a container, you need the concession once again. Now, either you ask them the question, right? You either know or you don't know. I need the answer, please. Well, gravity, I already told you. No, you didn't demonstrate that gravity is a container for gas pressure. Otherwise, we'd be having gravity containers everywhere and containing gas everywhere. It's not the case. Well, just go outside and look up. No, you can't appeal to the sky because I need a demonstration of how gravity is a
Because
container.
the burden of proof is
Right.
on them because
It's on
it's their claim.
Right. So it's on
Got
them.
it.
So at the end of that, when you tire them out, because eventually they're gonna be like, dude, so what do you want me to say? I don't know. Yes, thank you. You don't know, and I'll go with that. So with that, you can wrap it up. Remember, and this ending part is even better than like me telling you to tell them like if they know or they don't know. This ending part is the masterpiece of the 3 points. Okay, so the ending summarization is you demonstrating to them that they have no knowledge that the earth is a globe, and you do it this way. So you tell them this. So you're saying that the earth being a globe, number one, spinning, number two, in the vacuum of space, number three, is just a blind belief that you have. You don't know that it is. You blindly believe it right now. You didn't supply any information to give any evidence to the claims, and I gave you the floor, but you didn't sufficiently answer the question. You said you don't know to all three, and that's it. You demonstrate to them that they have a blind belief, and that is all. That is it.
Right.
You've done your
depending, and then depending on what happens after that is completely up to how they react.
Exactly.
It's
you
all
get
a
it.
big movie. Yeah.
You get it. But here's the deal though. You didn't defend one time. They were on the defense the whole time, and they lost the whole time. Not only did they lose, they admitted to you conceding that they don't know 3 times on the most fundamental aspects of the Earth's position.
So much that they're gonna join the Discord.
Well, I mean, that can be the case, but that's not the outcome. The outcome for what you did right there was not to convince them. It was not so they can say, "Oh, I want to be a flat earther." No, it was to expose their mind that they don't know. So everybody who hears will be like, "Well, let me take a shot at the title," and you're like, "Come on in, let's do the 3 points on you. Let's see how you fare." But every time, listen, since I curated these 3 points, there hasn't been a soul from an astrophysicist to the regular layman that's come in here to tell me they know. Not one.
Can you write those down? Do you have those written down somewhere? Freaking.
Actually, yeah. Somebody might put them into the in the live stream voice text for you guys.
That would be amazing.
Mickey,
Yeah,
can I expound upon this for just a moment?
Yeah, go ahead.
Remember that there is no curvature. We can't leave low Earth orbit because the Earth is flat and there is no outer space. No one has ever measured the circumference, diameter, nor the radius of the Earth. No one has ever measured the axial rotation of the Earth. The second law, thermodynamics, says that you cannot have a gas pressure next to a vacuum without a container. Mayhem has been telling you about these 3 points, and you should really be paying attention in class.
Okay, Neil deGrasse Tyson.
I love it. That's one good benefit of AI right there. Boom.
Yeah,
But
actually,
Mayhem,
that's a great thing. Yeah.
Thank you. And I
Yes, sir.
and I
Yeah, I did it
definitely
because
appreciate you sharpening my skills.
No, now I just gave
Everybody's.
I gave you a broadsword, so I'm teaching you how to use it. That's what
Right.
I'm doing. So now when you
gotta
go there,
sharpen it, yeah.
like right now, sheathe your sword because you don't need to use it on anybody in here yet. But when somebody comes in and they're feisty and they're rambunctious,
They will.
you do have the right temper for it. I gauge that you do have that right temper, that tone.
And the
I'm
head
a bit-
for it.
Yeah. So
Sorry for interrupting, bro.
these 3 points are for you because it seems like you can carry the weight of being able to navigate, and you'll be 100% on the offense, never defense. And so whether or not, listen, when they get out of those 3 points, they don't have a leg to stand on. They can't go, well, dude, now I want to talk to you about how gravity. No, you just denied the fact that you knew anything. From the point of it, Earth being a globe, to the point that Earth's moving, and now the vacuum of space. So your whole paradigm has been rocked. You don't know anything. You just admittedly said that. So now you're going to tell me that you know? How?
You can't backtrack. You can't backpedal.
You're on record saying you don't know. So now
Question for you though, real quick.
Go ahead.
So let's say we get through these 3 points flawlessly, right? And the person that's on the receiving end of after these 3 points, let's say they bring up, let's just say they ask a simple question like, so why has no one measured it?
Because there is no curvature. That's why. Because there's no curvature. If there was curvature, it would be measured. Because there is no curvature, that's why it's not measured. Well, dude, refraction. No, because see, when I took you through the 3 questions, you would have sufficiently answered it with. You didn't do that, so.
I am Mayhem.
What's up?
I'm just saying that I think a good one though is what the guy's trying to say is I have this with the questions and that. You know, you start asking for they'll bring up like Eratosthenes, like we all know the score with that, but then you're dragged into then another story about explaining how measuring a shadow. I mean, you know, what's your advice on that to the guy? You know, going into there, they'll just say, well, Eratosthenes, Al-Biruni. Then you've got to go down that.
I sufficiently answered that. And the key is when you ask them the question, remember what I told you. How's the first question go?
Has the Earth now or in ancient times ever been, or has the curvature of Earth now or in ancient times has ever been measured to show drop over distance?
Yeah, Eratosthenes, they'll say.
And then what would you say if they say Eratosthenes?
Yeah, go on, mate. What would you say?
I'm not talking about dudes with sticks and shadows.
Why?
Because we're not measuring
drop over distance.
We're trying to figure out if anyone has measured drop over distance.
Correct.
Has anyone?
No.
You know?
And so
Google it right now.
Yeah, when they appeal to that, you can easily take them to that and be like, look, he didn't do it. Show me where he measured drop over distance. If you show me sticks and shadows, I'm not going to look at it. I'm just going to quickly hand wave dismiss it immediately. Right. Until you show me drop over distance been measured, I don't want to look at it.
Question real quick though, and I'm not saying this to disprove the first one, but it's just like, did the drop over distance question, did that come from when they decided to claim that it's not a sphere, it's actually an oblate spheroid?
No.
Or drop over distance has always been a question.
Yeah. It's the consequence of a geometric shape being a sphere. The sphere, the consequence of the sphere would necessitate drop over distance. It is the antecedent.
Yeah. But it's not a sphere; it's an oblate spheroid.
It's the actual physicality of that shape, the ball itself.
Yeah,
that facilitates its drop.
Yeah, tell them.
Do you get what I mean, though? When they come back with well, it's not a sphere; it's an oblate spheroid. It's different.
Don't matter.
Yes,
matter.
There still has to be drop rate curvature. There still has to be a drop rate curvature.
The other thing you get as well off the Al-Biruni hips is depression angles. They'll say, you know, because you can do a depression angle at a height, and you'll see the apparent horizon at a lower level than your eye level. That they'll say that's drop over a distance.
Yeah, but let's keep it concise to like the point where they have to specifically talk about, they have to directly measure it. So when they go off into other things, you can redirect back to the point, to the premise. See, here's the thing that
I like. No matter what, you're still the point of the 3 questions and this argument in general is to highlight the fact that it's them making claims.
Yes. And they have to answer the question that you're.
I got it.
Listen. So when they veer off, they give you a red herring, or they.
No. Go back. Has there anyone that's been measured? Right. You keep on that. Got it.
And not only that, is they no. Well, you tell me how the Earth's flat. I want to hear you tell me how it's flat. Be like, dude, I need you to answer my question. Like, they're gonna try to use their tricks because their mind wants to escape out of being pinned down. And it gets harder because if you have other flat earthers when those guys go, yeah, but tell me about gravity. And another flat earther goes, I'll talk about gravity right now. In the middle of your 3 questions, they're gonna bamboozle
Derails.
you.
Yeah, derails the
Derail
conversation.
and bamboozle, and it's gonna be a shit show. And you're gonna try to get it back, and the other flat earther, dude, I just want to answer this gravity question. Like, you know what I mean? Like, it's not gonna be. So that's what I'm saying. You have to kind of, at least at that moment for the 3 questions, say, guys, please let me just run them through the 3 questions. Afterwards, you guys can jump in and say whatever. You have to, because if not,
was that what was going on right there? Because I didn't know.
No, I'm
telling you,
brand new to the server, and Mayhem sounds like an OG, and I
Yeah, I know. Me too. I kind of just been here for months, but I have never talked to him before. This is crazy.
This is exactly what I was looking for.
Welcome.
Is how to deal with
trolls,
logical and fallacies, though. Like super, like
Yeah, well,
I get caught up in my words, but like the thing that you really taught me is the fact that the burden of proof
rest on their shoulders.
That's key, man. That's
You're always on the offense. You're never on the defense. When you're on the defense, you're
Exactly.
What is your profession?
Old friend, I brought more soldiers.
In case you don't know by now, the whole system's a dead thing. Free your mind, free the man in the cell, because to live in reverse is EVIL. I give this shit to you for free, I ain't got nothing to sell. Every word that I'm spitting's REAL, the real DEAL. I ain't trying to talk about how we play well, I'm trying to wake your ass up off beat as well. So if it all kicks off, we don't end up in hell. Listen, you better watch the clock. No time for ignorance and those who mock. We used to have trust when the doctors knocked. Now we all feel terror when they're on the block. And the cops, they're a captured lot. WHO, that's a captured block. The BBC, that's a captured flock. Everything on TV, captured. Still nobody's raptured. Families are fractured. So much fears manufactured. So much fake news that it's chaptered and overacted. The devil's overactive, and those who lack spirit are attracted. Don't make me laugh, kid. It's more than just lyrics over chords. Cause if you put an S in front of words, you get swords. The MPs and the bankers are all frauds, and our scientists are so specialized they get bored. It's not that I wanna be relevant, but the current crisis has a criminal element. Depending who you are, that could sound negative, but the truth is only a matter of evidence to be foolproof. Let me add some more juice. You can't be sitting on the fence no more, you must choose. Atheists, Christians, Muslims and Jews. Good must conquer, evil must lose. Tell me whose history is still intact, when the lost tribes of Israel are still in fact being born into bondage all over the gaff. And the only slaves I ever read about were black. I'ma tell it how it is, I ain't taking it back. I'm taking you back to King James, remember that king's name. This is a big plane, and it's a big shame how the truth gets hidden with a bad name. It's a sad game, stuck up in the rap race, trying to live your best life. This ain't fucking Westlife, but me and you ain't enemies. I'm trying to wake you up and hook you up with some herbal remedies. Everybody wants to go back to before, but before caused the problems we chose to ignore. So from here forth, there's no more ear talk. We're kicking down your door hardcore with sincere and clear thought. You are what you eat, they ain't keeping it quiet. Seems they forgot about this in science. I ain't trying to cause a borderline riot, but the cure to disease is an alkaline diet. Try it, better yet, grow it, don't buy it. Can't get a drug if the government don't supply it. Quiet, you can see the harm in harmony. We need the farm, not the pharmacy.
That's fine, but that's not a citation. A reference is not a citation. Okay, so if you want to use these words, go find a reference for what they mean, and then bring us back the citation of what they mean. Thank you.
So, can you tell me why relativity says that it would be equal if the sky was moving or the Earth was moving? Sure. So the definition of citation, a quotation from a reference to a book, paper, or author. And the definition of reference, number 2, is the use of a source of information in order to ascertain something. So I'd say those are synonyms. You disagree?
No, not even close.
Awesome.
Dude, have you taken any collegiate or university level courses?
Yeah, I have, but why does that matter? Are we in college?
Have you done references and citations? Well, have you done references and citations?
I'm sorry, I didn't know that I was currently doing a college course on flat Earth in this Discord server. So can I not use synonyms? Is this like whoever said, what was it before? Someone said the
A reference isn't a synonym for a citation, dude.
What was the colloquial term for space? Someone used a colloquial term for space instead of using the actual physics term of space, right? So am I not?
Why should they use the physics terms?
Well, we're at a collegiate level to debate right now, aren't we?
There's no debate. You're just flailing.
So we're not. So I can just sort of like give the references a wiki article that has a list of the actual copies of the scientific paper. I can do that, can't I?
Right. That's not a citation, though, friend. That's the difference. You're offering references while asking for citations.
To reference something is to point at some source of information, like a.
Right. That's not the same as citing it. That's not the same as citing it.
I can cite a reference and I can reference a citation. Are those two sentences equal?
No, they're not.
So if I cite a reference, if I say, oh, my reference for this is my friend Jason X, who this is his phone number. And if I reference a citation, I say, oh, my citation is the one written by Jason something, here's his phone number. Is that not equal? This is just...
No, because now you're mixing categories.
Do you guys have any reason why Michelson-Pierce scale didn't show the Earth was in motion?
Oh, yeah, because they had to apply a mathematical transform to fit their bias in order to get the conclusion that they wanted.
My boy just realized he goofed up and tried to run away from his own little example.
No, I'm just tired of the semantics. It's pathetic.
It's not about semantics, dude. It's about earlier you were asked to cite something that you offered as a reference, and you just told people to just read it. And I was just pointing that out, that you're a hypocrite.
How? I read out the result.
Okay, look, fair enough. Okay, maybe you're not a hypocrite. Maybe you just are ignorantly think that references and citations are the same thing. We'll forgive you.
You haven't given an argument why they're different. You've just said, are you doing a course? And I said no. Do you want me to read out dictionary definitions again?
Dude. Okay, for example, if he asks you for a specific piece of information about something, right? And you say, I'll give you the wiki in total.
Yes.
You're referencing the wiki. Now, if he says, I want this specific piece of information, you go to the wiki, pull out the citation, give him the citation from the reference that has a specific piece of information. Those are entirely two different things. They're not synonyms.
You think that citation has some different meaning.
Dude, I just explained it to you. Very simply.
From or reference to a book, paper, or author. That's for citation. For reference, the use of a source or information in order to ascertain something. Provide a book or article with citations of sources.
Oh my goodness, dude. Dude, you're wrong. You're stupid. You forgot the word specific.
To specific. No, it says or a specific reference.
Oh, a specific reference.
Yeah.
Not a general reference.
Citation, definition.
Holy fuck, bro.
Quotation from or reference to a book. So that's the noun definition for citation.
Yes, and where's that in?
This is used in the definition of citation. You understand that, right?
Dude,
quotation from.
If you're asked for a citation, a citation is a specific.
You have argument for flat Earth.
Yeah, you already conceded down is down, and water's flat and level. Therefore, the Earth is flat. Welcome.
Tower bridges show that Earth is not flat and level.
How?
Quarry tanks show Earth is not flat and level.
No, wrong. You failed to provide the citation that you were asked for about the tow tanks, how they specifically measured curvature.
No, string line.
You failed to provide the citation, friend.
No, you just didn't like the citation.
No, you didn't have a citation. You just generally said the term string line, just as you did again now.
And?
Watch. Ask me how, just ask me in the reverse. I want to play role play so you can see how stupid it is.
Yeah, sure.
Ask me how to prove, or what proof I have that the earth is flat. Ask me that.
What proof do you have the earth is flat?
Lasers.
Cool. Do you have a reference for someone claiming that lasers show the earth is flat?
I do.
Awesome.
I have an 120-page PDF and an accompanying documentary of the methodologies and the practical tests that they did. And I also have a citation from their document that says the WGS-84 model is not found in the field.
Great. Link that and I will read it. See how that works?
Okay, perfect. Now, let me, actually my friends are going to link it because I'm going to speak. So, links, FE Core, for my friends who are using the bot, and then exclamation point videos laser short, exclamation point videos laser long. The short version is a condensed version that you can watch, and then the long version is the long version, obviously, that you can watch when you have more time. Now, I'm going to give you the practical methodology because I'm capable of... Hold on, friend.
I wanted to... Oh, no, it's a PDF. Okay, we're all good.
Oh, my fuck, dude. Did I not tell you what was coming down the pike? I said a PDF.
But then you spoke about long and short videos, and I wanted the PDF.
Yeah.
I don't know if that was being linked as well. But someone linked the PDF.
Yeah, fair.
I do.
No, all right, good.
Where?
Oh, yeah, it's my turn to calm down, bro. Were you not on calm when you began? The answer is yes, so fair is fair.
Yeah,
anyway, let's move on. When you were asked for a citation of the methodology that they used with the string to prove curvature over the distance, you weren't able to provide it. You didn't cite from the text, and you didn't articulate the methodology. You didn't cite it from the text, nor did you articulate the methodology. But I'll tell you the methodology from this laser test, right? If you want to listen, I'll tell it to you. But you can also validate it from the document. So this is actually multiple tests, culminating in the final biggest test of 25-mile sample size over water, right? So there's 14 or 17, I can't remember correctly. But the longest one they shot was 25 miles. So what they did is they set up what's generally known as a laser transit, right, methodology, which is you have a laser, you level the laser, you shoot the laser across, and then you use what's called a storyboard or a receiver that's at the same relative height, and then when it hits, you see where the laser hits, and then you can tell how off it is. We use this in construction all the time to level foundations, excavate, all kinds of stuff. Very practical methodology, very simple. So if you have the laser set up on one side, right, about 2 meters, 6 feet off the ground, and on the other side you have the story or the target about the same, 2 meters, 6 feet, right? The globe Earth predicts a differential between the off angle that the laser should continue into the sky if it's perfectly level and the target at that distance to be 90 meters, right? So in other words, the big hump of Earth curve water and the level laser, right, can't shoot through the hump of Earth curve water, so it shouldn't hit the target. It should go over the target by 90 meters. Now, when they set this up, right, they took into account the ambient conditions. They took into account the millirad divergence of their laser. They created, which is in the documentary, a very accurate aiming device and leveling system. And if you watch it, you'll see how precise it was, very precise.
Type of laser was it?
Well, you'll have to look into there. It's a big old laser. A laser sufficient to shoot 25 miles with a very limited millirad divergence.
Yep, I read that.
So sufficient to the task. And they might talk about the type of laser, because they actually had two. I think the first one failed or they destroyed it. But anyway, they talk about that in the thing. and they give the specs for it. So they did the test.
So it doesn't matter. Refraction wasn't accounted for.
Says who?
Them. As light travels in a straight line through a homogeneous medium, light angles due to different refraction indexes in a non-homogeneous atmosphere. We calculate direction and amount of refraction to show how much laser beam deviation affects the measurement outcome. In a non-homogeneous atmosphere where the index of refraction increases with height, rays of sufficient small initial elevation angle of refraction.
Holy crap, dude.
Is proportional to the rate of increase of the bi-directional index of refraction.
Yeah, you just said they didn't account for refraction, and then they went on to say we accounted for refraction in the very text you just quoted from.
Yeah, but they accounted for it wrong. And well, actually, they didn't. So they're saying that it's a homogeneous through a homogeneous medium. We calculate direction amount of refraction in a non-homogeneous atmosphere with the index of refraction. Blah blah blah. This curvature is proportional to the rate of increase of the bidirectional index of refraction.
Yeah. Anyway, so they set it up. They set it up, and the laser hit the target. Okay. Now, you may claim they didn't account for this, they didn't account for that. That's fine. But at least they have a practical example of their methodology.
Here we go. This is because I've read through this before, actually. Here's the problem. So the lake is partially frozen, therefore walking along the beam on the ice or using a boat was not possible. There's no data on the ambient conditions along the laser beam were available. We measured the conditions at the measuring.
Yeah, which site, which shot is this? Which shot are they talking about?
I don't know. I'm just reading out of the text document for refraction conditions, the PDF.
Which test? Which test was it? What location?
Point of laser beam.
I told you there was about 14 or 17 different ones, dude. You can't just pick one at random.
Well, this is their heading for refraction conditions.
Oh my goodness, dude.
So they said when they measured refraction between the
which location? Which location?
Why does that matter?
Maybe because, listen, friend, maybe because over time and at each location they learned things and improved their methodology.
Then why wouldn't they add that in under the refraction category or subheading?
Dude, how many different shots were there? How many different conclusions?
Right now.
I don't know, dude. How about you read the whole entire thing? How about that?
Yeah, I thought so. You'd run away from this discussion because you don't actually...
I'm not running away from it. I'm asking you specifics about the thing, and you're not giving them.
Bruh.
Now, by the way, in the final 25-mile shot...
Temperature was 2 degrees, the air at night was 3 degrees. Humidity is always higher the closer you are to the lake surface, which indicates a lower refractive index. They just assumed a low refractive index. They didn't actually measure one. The ambient conditions showed that the refractive index
which location?
Was the two sides of the lake. So they didn't measure the difference across the lake. They just measured one side of the lake, the other side of the lake, and said, yeah, good enough. Am I wrong?
Yeah, maybe at that site that's what they did. But which site are you talking about?
The refractive, measurement number 1.
Measurement number 1.
Find the actual spots where like,
oh my god, dude.
Balance on Vallegos observation points. And
is it observation
laser position?
Yeah, is location number 1 the one where they state that the WGS84 model hasn't been sort of upheld?
No, that's just their first one they did, dude.
Well, that
anyway. He won't even make it onto the rest, dude. He's just going to look at number 1, say they didn't account for refraction. Refraction curves light.
It was still at 0 degrees in the air. The night was down to minus 11 above the air. Air temperature at the time of the measurement was minus 6. The ambient conditions showed refractive index were about the same at the two sides of the lake. So they're just on the same thing, two sides of the lake.
Yeah, so the point I was trying to make is that if it's the first measurement that doesn't state that the WGS84 model is invalid, then what they did there isn't relevant to this argument. Cricket.
My argument was their methodology was incorrect. because they didn't
Right. So
measure the refraction
which
across the
location-
lake. They measured it from 2 points, the start and the finish. And if
Yeah,
the
a
beam was to
location one,
curve,
yeah?
it would curve between the start and the finish, not starting at the start and ending
Fantastic.
at the
So
finish.
is that location 1?
Yeah, and location 2, they use
so
the
in
exact same
location
methodology.
Is location 1 the let's just call it
Okay, stop for a second and listen to what I'm
Yeah,
saying.
no, I'm
I
not
just
gonna
read
stop
location 2, and they use the exact same methodology.
I'm not going to stop talking, right? So the issue is that if they are not using location 1 as the quote-unquote evidence for the WGS84 model being invalid, then it's a waste of time to analyse the methodology there.
The second one did the same thing. All of their measurements, they just measured the temperature at the start and at the finish. They didn't measure the refraction between them. Do you understand that, Crypto? Do you understand what I just said to you?
Is location 2 being used to invalidate the WGS84 model?
It doesn't matter because they use the same.
Fantastic.
They
So the answer is
use
no.
the same. They use
So
the same way of calculating refraction in all of their experiments.
The conversation. You're just wasting everyone's time.
What did I just say to you, mate?
AI, yeah, I heard what you said, bro. It's irrelevant. AI, can you tell me which location was actually used in this argument in terms of the WGS84 model, and then maybe we can read that.
Oh man, the only one I was talking about was IDSIL, the biggest one.
Fantastic.
Calculation of third measure.
So we're going to look at the methodology there, or we're just going to ignore that?
Condition shows the refractive indexes were about the same at the two sides of the lake. The same methodology. It's a failure because of that methodology.
Which location was that?
No, I mean not really, dude. You can interpolate the lake, bro.
Lake Isle or whatever that.
I mean, unless you think that there's going to be a dramatic change in the middle.
Yeah, of course there will.
Okay, let's say that's true.
The middle is over water. Do you not understand that? The start and the finish are both land, and the middle is water.
No, they're not just like in the middle of land, dude. They're on the coast.
You idiot. They're both on land, and the beam goes across water. Those are two completely different, sets of air they're going to be going through. One's going to have
a frozen
constant.
Lake?
Sorry?
Isn't that frozen lake?
Partially frozen lake, but you understand that,
right, so frozen water,
exothermic and endothermic effects.
Dude, do you really think that you're just going to use 4-syllable words and that's going to frighten anyone here?
Do you know what exothermic and endothermic means?
The frozen nature. So the frozen nature of the lake obviously changes the refractive properties of the air above the lake, doesn't it?
It does, and they should have measured that, but they didn't.
Wonderful. Yeah, but obviously you're saying it's water, which is being dishonest because it's partially frozen.
I'm sorry.
Also, we don't have the burden of proof.
And wrong. I'm sorry.
Also, we don't really have the burden of proof there because your side has never proven that the light is bending around the globe to make it appear flat.
That's true, brother.
That would happen.
What the? Yeah, you do.
We say refraction would change it so that any observation we can have a certain deviation. If you take refraction into account, it will always fit the globe.
Yes, dude. Did you not just hear the words that were coming out of your mouth? Hold on, friends. What did he just say? He said, no matter what observation you make, it will always fit the globe. Wow, very scientific. You just ceded that any observation that supersedes the globe geometry, you just add the word refraction and it magically cures it.
Yeah, sure. It's like when will water boil? If you add pressure, suddenly it'll change, won't it?
Yeah, sure. Yeah, sure. We have an unfalsifiable tautology that begs the question and inputs values up into 60 billion mile radius to account for refraction.
What question am I begging?
Listen instead of talk. Maybe you would know.
What question am I begging?
The globe in the first instance, brother.
No, we've measured it.
How?
I just told you there's tow tanks, there's tower bridges.
No, stop right there, friend. Stop right there. The tow tanks, you didn't give us the methodology of measurement. The towers, you didn't give us the methodology of measurement. You just claimed them as a positive assertion. And then when I asked you what's the methodology, you simply said the word line. Fishing line, I think, was the actual word.
You're choosing to ignore all the times I read it out and just focus on the one time where I said string line.
No, I listened to you read it out, and that wasn't a sufficient methodology to see that the entire bar was curved, dude. It was segmented. You didn't even explain to the person who asked you. You didn't even explain to the person who asked you how they did it.
As you guys like to make Globers do, you're willing to concede that I didn't just say line in all instances. Can you concede that?
No, I'm saying when I asked you.
So you're not going to concede something that you just admitted to?
Dude, when I asked you, it was correct. You just said line. Previously, you read something out about a line. Listen. Previously, which I already had just said, you read out something about a line. You were asked to clarify how it was done over the entire thing. You were asked to point to it, and you didn't.
I didn't what? What was I meant to point to?
How they applied the fishing line to prove that the entire structure was curved.
I read it out a couple of times. They put it at 2 points with a microscope pointing at the fishing line. Yeah.
Right.
Yeah.
And what did they do then?
A reference that they would then move the beam so that it had the correct amount of curvature according to that reference.
Okay, hold on, friend. Pay attention now. If you pull a line taut, without the catenary curve in existence, you'd have a straight line.
Yes.
Right? So unless you have a benchmark, all you have a straight line. So if you then...
You can have a calculation of the amount of curvature that you want in that thing according to the reference.
Bingo. I want everyone to stop right there and notice how if you take a straight line and just calculate how much curve should be there, you can then make the claim that curve exists and that you've measured it. Slow clap. Slow clap, friend.
What? Correctly.
No, friend, stop. You're assuming the water's curved, bro. You have flat water.
And then you
hold on.
The thing that you're making.
Right, so my friend, hold on. The previous guy who you asked 30 minutes ago, he critiqued you that you just assumed the water's curved, put the line parallel to the water, and then put the beam parallel to the line that's parallel to the water and assume that all three are curved, and then call that a measurement. That's what you did, brother.
No, I never said the line was curved. Remember catenary effect? I said specifically it wasn't curved. I read that out to you multiple times.
Okay, so let's be clear. If the line isn't curved and you parallel the metal to it and it's parallel to the water, then that means the water's not curved, and that means that the rail is not curved.
A reference didn't parallel it. You ever used a straight line before?
I build things, brother.
Great. So I built a fence not long ago, okay? And my fence, it was a picket fence, and that picket fence went up and down, up and down.
Correct.
Fences do. Right. So
Absolutely.
Line, and then I referenced the amount that the middle picket would be up off this straight line. And from there, I could reference out the curve.
Perfect. So where did they do that in your example?
I just read it to you. They had a microscope that pointed at the string line and at the beam thing, and then they calculated how much they'd have to have of curve on that beam to match the water on an earth of a given radius. And they referenced the distance between the string line and the beam on the road.
What was the length of the string line?
I don't know.
Well, that done fucks it up, doesn't it, brother?
No, a gap in knowledge doesn't mean that the whole thing can be thrown out.
No, I'm saying if the string line isn't known, right,
God, what's the name?
and it's not sufficient to the task, and then you give us the answer that's not sufficient, that's going to screw up your argument. So how about you go get us that information?
Well, he also just justified all of the laser measurements he just got shown because like a gap in knowledge does not disqualify the argument. So apparently he just justified all of the laser measurement. Thank you very much.
What did I justify?
You said there was if you have a gap in your knowledge that doesn't disqualify it, and you said that we don't know the exact temperature over the water in between the measurements of the lasers, and so according to your logic, that still stands.
That is almost a smart argument. It's close, but not quite there. So the problem is that I have a gap in my knowledge. That doesn't mean that they have a gap in their knowledge. So the people that actually built the tow tank didn't have the gap in knowledge. I just have a gap in my knowledge.
So you haven't provided the methodology.
The experiment had a gap in their knowledge. The people doing the experiment, the laser test, had a gap in their knowledge, which does invalidate their experiment because they didn't account.
Not really. It doesn't really. You're assuming that if there's a massive temperature differential, then the light's going to be able to travel around the ball and hit the target.
Yeah, it is. When we account refraction in...
Yeah, no, we don't have the conditions required when you measure the temperature on both ends.
Sorry, sir.
Dude, I don't know why it's so hard to get, like...
We can get the conditions in the middle? Is that what you think?
I think you should get us the knowledge that you're gapping on, because that would be the thing that would validate your entire claim.
Yeah,
No,
like the length.
I don't need this to be 100% fundamental.
No, it's not, dude. Right now, it's an assertion.
A reference to a piece of evidence.
Look, listen, friend. Guys calculating the curve they should expect and then forcing that expected calculation into a piece of metal doesn't prove the Earth is curved.
Of course it does. The tow tank works. So that's
holy frick, dude. No, let's be clear. Let's be clear, dude.
That's a logical fallacy, dude.
No, it's not. What logical fallacy is it?
It's called appeal to pragmatism. It works, therefore it's true.
I haven't heard that. Appeal to pragmatism.
Right. It also assumes...
You haven't even heard what your own argument is.
Correct. It also assumes that the variable in difference that they needed to account for would have made the object in question unusable had they not accounted for it. But when you look at the tolerances necessary in those machines, and you look at what the alleged curvature is over that distance, it's negligible, inconsequential, irrelevant.
So it doesn't seem to be that it's a pragmatic fallacy.
It is. You said it works, therefore the reasoning is correct. That was your claim that you just said to try to rebut me.
Well, no, it works because it physically exists. So a pragmatic fallacy would be something...
My truck... Oh, dude, my truck works. My truck works.
Right?
My truck works.
I believe X is true. Believing in X results in practical benefit... results in practical...
No, dude.
Therefore X is true.
Dude, no, that's not how it works. Here, let's put it properly. Hold on.
Consult my horoscope, things always go wrong. So it seems like when there's actual, like a physical thing, then the appeal to pragmatism is...
Dude, you're trying to say the tow tank works, therefore the Earth is curved. You're not trying to say the tow tank works.
Let me give an appropriate analogy. Epicycles work, therefore they're true. Epicycles work, therefore they're true. That's the actual physical situation. Epicycles, yeah.
What are they?
It's a Ptolemaic model of orbits.
Do they work?
Yeah, they work. Yeah, they work great. They work better than frickin' Newton's model or Kepler's model. Yeah.
Can you reference that?
Oh, sure can.
How do you spell it?
You've never heard of epicycles? Jesus Christ, man.
No, I haven't.
Some elementary shit.
Do you speak any English?
Epicycle model.
Yeah, they use them in a planetarium when you go there. When you go to a planetarium, they project the planets and the stars on the ceiling, on the dome ceiling. They use epicycles. They don't use the heliocentric model to model. Just because you have a model that works doesn't make the model physically real or have some ultimate reality there. This shit is well known. It's not even an issue.
What do you mean by works? Do you mean as if we model something out, we get a result? Or do you mean as
and you got a result. Yeah.
Build things based on it or measure things based
on it? Yeah. That's called engineering. Yeah. It's awesome.
Yeah. What it's called is predictive evidence.
Okay. So
what they did is they predicted that the water would curve. They predicted in order to get their rail to match the water, they would have to make their rail curve. They then predicted that a string line would have to deviate at certain points by X amount in order to fit that curve prediction, and then it was all true. That's called science, buddy.
No. First of all, that's not called
So
science.
I'm not seeing anywhere that this thing is
that all would be
more
like
accurate.
post-dictions. Those are all like post-dictions. Because they had to alter the string. I'm reading it right now.
No.
They had to adjust the string until it so-called aligned.
What part? Where's that?
I'm going to read it. A 0.33 millimeter dynamine fishing line was attached to one bespoke winch at each tail end. The line has a breaking point of about, that sounds precise, about 25 kilograms, and very little stretching. Oh, that's scientific too, man. Very little stretching. It's not even like they have two things here that they didn't even
I'm
quantify.
sorry, you haven't validated your claim, mate. Go back to your claim.
Listen, I'm going to keep going. I'm going to keep going. Don't worry, man. There's more here. So, but I'm just saying, this does not sound like precision. Okay. Anyway, which allowed it to be pulled very tight and reduce the catenary effectively. A microscope was mounted on the rail to look down at the line and perform the adjustment with high precision. Right. So they adjusted the string until they got it to match
really
where they wanted.
That's really sad.
So this is your repeated thing I've been listening to over and over again. When you get cornered in this box, you start talking about us and how our argument is and how sad our argument is, and you start talking about us. The way we're talking, the way we're arguing with you. Shut the fuck up.
You're
here for round 3 to get knocked out, dude. This is like, Hearns versus Haggard. There was never fight 2 and 3. Anyway, this is not a precision measurement. This is garbage, dude. Garbage.
Yeah, I'm referencing some experts that built something according to the curvature of the Earth and it worked. What's wrong with that?
Yeah.
Are they lying? Do you think they're lying?
I think it's confirmation bias. That's what I think.
Okay, so they specifically machined and came up with a system to make the rail curve to fit what they thought the water would do, and it was correct. And you think that's confirmation bias? How does that work?
Yes, I do.
So if I was to think something like no, like if you just use like a base iron to make a camshaft, that'll be fine. Like it's great. I believe that. Someone told me it had worked before because I used it in an old steam engine once. And then you do it and it fails because it's not the correct metal to use.
Yeah, and how is that analogous to this?
So confirmation bias failed in the practical, didn't it?
Yeah, because that's why engineering, you do things by trial and error.
No, you
right. So things are manufactured all the time that fail, break.
Engineering is doing things by trial.
It is.
Dumbest thing I've heard. Honestly.
Well, then you've never actually made anything. Have you ever made anything in a manufacturing process? Have you ever worked in any manufacturing environment?
Yeah, I've worked in a couple of factories. They're shitty jobs, but yeah.
No, an actual manufacturing environment where they actually engineer, design, and make the product, and then have samples, and then the samples are gone through tests, and then you have the production line, and you start making it in production, and then you have to have quality control because not even that is a perfect process. It's called trial and error.
Yeah.
So you start with an idea, right? You maybe apply some models. And then you engineer some prototypes. Some of those prototypes will work. Some of them won't. Right? So if they could just do it by equations, then they should just be able to fill out the equations, do the math, start pumping out the products without ever testing them.
The one I worked in made fire-resistant suits for firemen. Right? Mm-hmm. And it was for firemen working with the army, so it was like armed personnel fire-resistant suits. And what they did is they got the known tolerances for the fire-retarding capabilities of certain fabrics, and then they got their heat sink capabilities of other fabrics, okay?
Yeah.
They added all that in with the dimensions of a human being, and then they modeled that out so that any stitching would be covered, and then everything was cut, everything was manufactured, and they tested it at the end to make sure that everything they'd done was correct. But everything they'd done was correct. They then updated it depending on user needs, but that fabric had known properties, and they
how did they know the properties?
That they
did they use equations or did they test the fabric? So they got the fabric secondhand from somebody.
Someone else did.
Exactly. So they got it from somewhere in that
When you buy
place
steel,
that
you don't
manufactured the
test the
fabric.
steel, do you? The manufacturer tests the steel to make
Oh,
sure the
shit.
grade is correct and then sends it to you.
Yeah, they have test samples. They test samples, right? So they manufacture fabric samples.
Engineers buy things of known properties. They don't test everything.
Yeah, it's known because they tested it to trial and error and figured that stuff out.
Yeah, a long time ago, and now they're known properties. So engineers can make things using those known properties, like the engineers.
Yeah, so they're just using trial and error.
They knew the known properties of that fishing line before they started.
Not within any certainty, obviously.
Yep.
About 25 kilograms with quote unquote very little stretching. Not the stretching was not quantified. The break point wasn't actually quantified.
And
it could listen.
And
the catenary curve that they calculated existed might not have existed.
How do you know that? You're just coming up with that. If they've had some monumental failure.
Because you think this is a precision, some sort of precision. Listen, because you think this is a precision measurement of curvature.
The precision in that document. How do you know they didn't have the precise properties of that string line and just vaguely referenced it because they couldn't be bothered going and looking it up again?
How do you know these people weren't fucking aliens from Mars and didn't just fucking throw a bunch of random words on the paper? I mean, come on, dude.
We've never seen aliens in existence, but we've seen people in existence. We've seen engineers in existence. We've seen the properties of certain string lines in existence.
We don't see curved bodies of water in existence.
We've seen that when engineers calculate as much stuff as possible and it all works, then it's reasonable to assume these engineers are competent, aren't they?
We don't see curved bodies of water in existence. So no, that's stupid.
Where, heretic, where? Is that all you got?
You're just assuming shit, right? You're just assuming shit, which is par for the course.
Yeah,
it doesn't shock me.
Induction. I know it's scary to you guys.
Yeah. Inference and induction. Yeah, great. Affirming the consequence.
Oh my God. Can you say it again? Inference and induction?
Yeah, inference and induction. Yeah.
What's inference?
Inductive logic is hinged on making inferences from observations. Is that not true? Is that not a true statement? Is that not a true statement? Yes or no?
You get, sorry, did you say inferences?
Yeah, dude, how come every time, see, the problem, one of your problems is you talk too much.
You said properly.
You talk too much. Do you know how many times you have to say, I didn't hear you? Because you're fucking flapping your gums?
People. We're on Discord, mate.
Yeah, because you can't listen and talk at the same time. That's why you can't hear people.
Induction also doesn't lead to concrete conclusions. It only leads to strong or weak, potentials.
Well, he didn't even do that. He just assumed his conclusion in the first place.
Well, no, I didn't. I gave.
Yeah, you did.
So what I had
no,
was
you didn't.
And
you already admitted
my
it.
My hypothesis is either
you assumed a curved water level. You matched some railings to the curved water level that you assumed, and then went, "Good, it's all curved." That's all you fucking did.
No, I didn't. What they did was they made the railing.
You're right. I misspoke. You didn't do that. That's what you think someone else did.
So we're at the point now of just muting me all the time? We're finally done? Do you want me to just go now? Are we done?
You can do whatever you want.
I can leave if you want. If you're just going to mute me anytime I'm halfway through a sentence.
Well, you can sit here and cry or you can leave. I don't care.
We just told you that, basically that you're over talking. I tried to tell you what the problem was, why it's not a good thing. Because it means you're not listening, right? And we're just wasting our fucking time, which I'd rather not do. Right. So
no, I was listening. I just think you're wrong. The reason I couldn't hear some people is because some people are low. So I'm trying to figure out who is talking, whose sound is low, so that I can turn them up so I can hear them better next time. Make sense?
Anyways, Linda, feel free to be a beta and leave if you want, but that wasn't what we were trying to do here.
Why would I be a beta if I left?
And you still haven't proven curvature or anything else. All the stuff you said is crap.
Why do you use the word prove?
I can't even read
evidence, which can never prove anything. It's called the problem of induction.
Trying to figure out why they need to compensate for curvature for this design.
Why
the rails must be aligned vertically to follow the curvature of the Earth. Vertically?
Vertically?
Yeah, the rails must be aligned vertically to follow the curvature of the Earth, horizontally and enroll in Southampton, Saginaw, oriented tank of 138 meters.
Yes, that's talking about the
is about
the rail.
0.6 millimeters.
That's talking about the rail in this case has little like jacks under it to move it up and down before they set it. So they have to be aligned vertically. Those jacks have to be aligned vertically so that the horizontal lines up with the horizontal curve of the water. What's wrong with that?
Doesn't seem necessary for what they're doing.
Why? They're trying to do
I'm reading it, though.
measurements of different hull shapes.
Well, do you know what uncertainty and precision is?
Yes.
Okay.
Uncertainty is an unknown, and precision is to the highest degree of measured known. So for this tow tank, they need to know if there's a deviation in the railing, because that deviation in the railing would cause the hull of whatever thing they're testing to push further down onto the water, causing more drag and changing the results, or to go higher up over the water, which would reduce drag and ruin the results.
Okay, and if they didn't do it right, what would happen? Let's say they did all this process and they did something wrong and they didn't know about it and it's not in this document. What would happen?
What would happen would be that the boat, when they move it along the railing, would experience more drag in some spots than other spots, which would mean they would.
You mean so they're trying to model drag? So this is a tank that's trying to model drag,
amongst other things. Yeah.
I'm trying to figure out what the even purpose is. It just seems like just some nonsense.
I can answer the question. It's very simple.
And you get a hull design of that boat.
You're saying
hull design will go faster than others.
Brother, you're saying the same thing, so we're going to break it down to simplicity. All you're saying is that the rails must be parallel to the water surface. So this entire procedure is to make the rail parallel to the water.
Yep.
Yeah.
That's only the of Earth curvature is in calculations. Thank you.
That's my case. Again, because you were too upset and you cut out.
Well,
or they measured the curvature of the water level that they assumed.
All right, I'll say it
talking again while he was talking. So let me translate in normal speak.
Oh, I wasn't normal speak talking, but I'm talking while you were talking because it's kind of sad to start off like that. So, Arden, do you want to just say what you said again? Because I couldn't hear you because you got too upset.
Yes.
See, once again, talking about how we're talking, you're being exposed. You're a chump, dude. You're just a chump. If you're going to talk about us, I'm going to talk about you. You're a chump.
Anyway, I'll validate my position, which is this. I'm driving a truck, which has axles, which make noise. And I have auditory feedback in my ears to my voice, where I increase the amplitude of my voice based on how much roid noise. Right? It's not that I'm upset. So again, you failed. But anyway, I'll say it very calmly. Yeah, perfect. Yeah, so here we go, friend. The entire methodology of the rails, the only thing that must be accomplished for the principle in question is the rails must be parallel to the water. It's all that has to be done.
I agree.
And all you need is a methodology that makes the rails parallel to the water, and all that is a distance from the top of the rail to the water's surface, and that's all they have to do. All that other methodology and including calculations for Earth curvature is superfluous.
Sure, if you look at the document, they didn't actually measure it off the water surface. If you were to look at Figure 4, you can see that tank isn't full. They're not measuring off it. And Figure 7 shows that they're using the microscope and the string line and the rail to check the deviation.
Yeah, so I'm not sure about this particular setup, but the other setup, which we already critiqued the last time a guy came in here with tow tanks, is they have a water channel next to the rail, and they use that water channel as the leveling channel. It's not the water in the channel.
Well, I'd love to hear about that. So which tow tank was that?
They're assuming the equipotential would be equivalent in both instances. So what they're doing is really, truly, they're just making the rail parallel with the water. That's it.
Yes.
You said so yourself. That's the ultimate goal, is that the rail is intended to keep the same drag line on the boat, continuous over its entire journey on the rail. Now, in order for that to be true, it must be what? Parallel with the water's surface. That's all they're attempting to do. No, which is assumed to be curved in your worldview.
No. Well, yeah, they assumed it to be curved. We gave them the prediction that if they set the rail at a certain curve, it would match the water, which came true. And predictive evidence is the only good evidence.
How do that? Listen, how are they making the curve on the rail, friend?
They get the string line and they
listen, the only way to curve the entire rail
based on their model.
What's the length
They
of the
didn't
line?
adjust the rail, though. They adjusted the line.
Wait, no, they adjusted the rail. They didn't adjust the line. You were wrong about that. Remember, you
So what I read was wrong.
They adjusted.
So what I read was wrong. That wasn't me freestyling. I was reading.
What you read didn't say they adjusted the line. If you look at figure 7, you can see that on the rail where they have 2 pins and they have a microscope pointing at the string. Okay. So that means at any given point, they can look at their model and they can see how far should the pins be from the string at this point.
So they didn't measure it in between the 2 points, right? Just like the laser test?
Say again?
So they didn't measure between the 2 pins, right? Just like the laser test?
They did, yeah. They measured between 2 things.
Right, but I still haven't gotten the answer to 2 questions.
In between the 2 points, because if you have a curve, then you need that, like the hump in the middle of the curve. So you're supposed to have
That's what the string's for.
The strings to measure the hump.
Yeah. The string is a reference. It's completely horizontal reference, right? So from 2 points, it will be.
Yeah, he also claimed. Yeah, before you continue, we got a caveat before you continue that the allegation is that they. Go ahead.
Excuse me, Indio. I'm trying to listen to Arden right now.
Yeah, well, no. So they presupposed
I yielded the floor, brother.
Just wait, Indio. Arden.
Yeah, great. Stop moderating our fucking chat, douche. Okay?
Yes, if you were paying attention.
They took the rail.
I yielded the floor to Indio.
I know, I don't know why you have to say it again. Stop humoring this clown, okay?
All right, my apologies.
So, listen, I'm not bawling for the distractions, man. So they have this beam, right? This rail, and they can adjust the rail, and they pull the string. And so, what are they adjusting both at the same time until they're within
Why do you think they're adjusting the string?
Because they think the string has to be within a certain distance of the rail, right?
No, the string just has to be a reference, a horizontal reference.
But they don't know if the string's horizontal.
Yes, they do. If you get
how do they know that?
You pull it taut between 2 points with very little catenary effect. It is a horizontal. It is a straight line.
How do you know there's very little catenary effect? That's what I'm asking you.
Because that's what they say.
Yeah, but very little is also some, and they're only seeing a small deviation, which is very little. So they're seeing the very little catenary curve. What are you talking about?
How do you know? You're assuming that because you're biased.
You just said so.
You just assumed that there's very little catenary curve. Your answer was because they said so.
Yeah.
Yeah, let me ask a question.
What is the value for the catenary curve? And then, how did they measure this? Because you're going to have 2 inverted curves, right? You have the curved rail, and then you have the curved string. And the curves are opposite to each other. So one's curving down and one's curving up.
And it's a very...
Yeah, but I also want to know how long...
It's so hard they can't even measure the amount of catenary curve in the string.
That's not my problem. That's your problem.
Right, but also I just want to quick qualify.
Some catenary effect doesn't mean that catenary effect is enough to screw up their model.
They have to measure it, brother. Otherwise, they wouldn't know. By the way, also, you were asked, hold on, it doesn't matter, dude. I just said they would have to. I'm trying to get to a different point.
The entire problem is that there's a catenary effect. Isn't that your entire problem at the moment?
Listen, the catenary effect is a constant in physics, bro. It can't be negated.
Yeah, but there are all sorts of problems that anything that you physically do, like there's some form of like tiny 0.000000001 problem in every single thing you do. But if it's not enough to screw up that thing, then who cares? It's like saying
right. So, friend, for goodness sake, stop talking.
That thing can still work.
We all know that. Okay, what I want is the brass tacks. How long was the string?
Doesn't know.
How was the? Shut the fuck up, kid.
Why?
Thanks.
All you're going to do is you're going to ask.
Because I'm trying to complete it, dude.
When the.
All right, I'm just, dude. These things matter. So stop frickin' sidelining. For goodness sakes. You were asked how they know it was horizontal. You just said they affixed it to 2 points. Being randomly affixed to 2 random points in free space doesn't prove that anything's horizontal. You then said they got rid of the catenary. That's how they knew it was horizontal. But you didn't prove how they knew it was horizontal.
Didn't have a great
Dude, I'm speaking. Thank you. You then said that they got rid of the catenary problem somehow for whatever methodology they used, which you didn't quantify. You didn't give us the length of the string, so we can't even calculate any of these problems to even begin to say. So far, all this is a fanciful assertion with no data and no quantification to it.
Yeah, the engineers made it. It worked. They referenced they reference the methodology they used. You just don't have the actual numbers in front of you, so therefore it's wrong. That makes no sense.
Dude, you haven't presented them. And your appeal again is just to the pragmatic at work. Dude, listen, the methodology they used got, let's just say for lack of a better term, it got the rail parallel with the water. Great.
Right.
What does that prove? Nothing. It just proves that the rail is pretty parallel to the water. That's it.
Pretty parallel?
Yes, because of the sentences that you just talked through, everybody, about error bars and all this other nonsense. You know it's not perfectly parallel. Good grief, dude.
So, Heretic, you said it's a pragmatic appeal again, but it isn't actually a pragmatic appeal.
It is. You said it works.
No, a pragmatic appeal would be for something unknown and unmeasurable.
What?
Where's the measurement?
It's for something unknown and unmeasurable, something abstract, like astrology work.
It is unknown. You already told us it was a gap in your knowledge, dude. You already told us the measurements that we needed were a gap in your knowledge, so they are unknown. And you don't have the measurements. Yeah, okay. How do you know if you don't know what they know?
You also admitted it was a gap in their knowledge because they didn't add it in there and have it nowhere presented. So.
Yeah, so let's link their engineering specs for this whole thing. Do you not understand that?
Right, but the other one that we did, bro.
Find a flaw that you can exploit in this when you guys don't have a single measurement of straight. Like, I gave a glaring flaw in your laser test. A glaring
you didn't. Actually, you just showed your ignorance. You actually just showed your ignorance.
Did I, Indio? Do you want to talk about that? Do you want to? If I get 2 points across a bay and I just measure what point A and point B's temperature are, does that tell me the refractive index across the bay? 1, 2, 3.
No, it does not.
I'm thinking about it. I'm thinking about
it across the bay.
It could,
because
possibility.
Could you explain how it could?
You could apply modeling, and you could assume it.
They didn't apply modeling, though.
Yeah, why would you?
So they didn't calculate a value?
There is refraction. You establish that those models are correct.
But you can't establish if there's refraction unless you measure a difference across the bay, can you?
They did. They did have 2 meteorological stations at each end.
Yes, of course there'd be something different, Drace, you fucking idiot.
So you do know that 2 meteorological stations, right?
Yes. And they said meteorological station 1 and meteorological station 2 show X. But all that distance in between, they didn't measure any points on that and then map out the refractive index. Refraction doesn't happen between point A and point B. It happens the entire way in between. There's any sort of change.
No, that's not how refraction works. That's not how refraction works.
Of course it does.
No.
Light goes from one dense medium to another dense medium. All that has to be is a change in temperature, pressure, or humidity. of that air.
No,
Any
it's
change
not.
at all,
It's
any
it's called
deviation at all will
optical
cause the beam of
density.
light to
It's
move.
not just the density
Yeah,
of the
we
medium.
covered this with him before. Yeah, we've been over this
Yeah.
optical density. He
What
was
about it?
furiously Googling or something.
Yes, you guys say it's optical density. Optical density can be changed by factors like temperature, the density.
Yeah, it can, but you also require the correct boundary conditions to those temperature gradients to be able to refract things, and you don't have those conditions all the time. And it also it depends on those angles and the optical gradients.
So
which
you know what,
direction the
like
light goes. The
ISO,
light can go up and down.
so you know what, like ISO, not only did they horizontally pan it, they vertically panned the laser, and on top of that, they did it twice. They did it twice 3 weeks apart, and they got the same result. So what they just have like,
what does that mean?
So they have to have the same magical refraction conditions, the same 2-3 weeks apart.
And in different directions at different ranges. They didn't just horizontally pan the laser. They panned the laser horizontally.
Seems like they had different outcomes.
See, here you go again.
I'm speaking, brother. Okay.
AI, please.
Yes. They panned the laser to targets at different ranges. So, for example, in the 25-mile shot, the 25 miles was the final target, but they panned it through like a 4-mile target, a 14-mile target, etc.
And this was done 3 weeks
it seems
apart.
like they've got different. It
The
seems like
firing line is hot.
It
seems like they have different what?
They have different measurements for every single laser test that they did.
What does that mean?
Well, considering
different measurements of what?
They say refraction exists. Yeah. And they say that the laser is hitting different points, but it's just within the tolerance that they set based on the refraction that they think, to fit a flat Earth model, right?
No, they're tested. They tested the WGS-84, and it's outside those values by 2 orders of magnitude.
Because they didn't look at the refractive index between the 2 points. So the 2-week change would cause a small change in refraction in the refractive index, right? It wouldn't be
okay. So how much refraction does there have to be to get the result they got?
Well, we could look at that if you'd like.
Yeah, let's look at that. Give us the model that can make that prediction.
Let me know when you're done with
the Bislin Advanced Earth Curve Calculator.
That doesn't. First of all, there's no predictions in that. I said a model that makes predictions, not post-diction.
Yeah, so the Walter Bislin Advanced Earth.
Yeah, those are post-dictions. I want predictions.
Observation data, and then you just change the refractive index.
Yeah, that's a post-diction. That's not a prediction.
I just.
Yeah, hold on.
For a second. Let me know when you're done with this point so I can jump in because I wanted to ask him a question, but I won't mute him.
Yeah, but I want to. No, don't unmute him.
Amount of time, Miggy. I'll just yield for you.
Yeah, I will let AI because I don't know. You guys were in the point right now, but I don't know. AI.
Yeah, we can wrap it up very quick. So what he did there is he has an ex post hoc solution because he's going to go to this calculator and just change the dial until the dial fits the observation, which he already said he will do, which is no observation can debunk the globe because you can always input refraction to be sufficient ex post hoc, which is not proper reasoning or proper anything. All right,
and basically the calculator doesn't simulate anything. If you look at the Black Swan so-called simulation, okay, if you look at the rays, they invert. So the image that you should be shown should be half inverted. But he doesn't show that, right? So all he's doing is adjusting pixels up or down, but never adjust the orientation. So that calculator doesn't simulate anything.
Well, it does simulate one thing, so let me finish up with this, is that it simulates an increase in the radius of the Earth to lower the Sagittar via the circle segment formula. In other words, it models a lower hump between point A and point B, which means it's effectively flattening out the Earth to account for observations that debunk the globe, conceding that the Earth looks flat. I yield.
Okay. I'm going to unmute him. Dogs, if you can hear me, I just need to ask you a question before you go on. Or maybe you just want to respond real quick so I can ask you?
Yeah, it'll only take me 2 seconds to respond.
Yeah, go ahead.
The problem is what you said about Walter Bislin's Earth curve calculator flattening out the Earth is that it flattens out the apparent geometric horizon, not the actual one. You get that? And there's no problem with a post hoc falsification of an experiment. The problem is if you have a positive claim and you want evidence for that positive claim, you then need to make it predictive. So I'm not saying the Earth is a curve because I can post hoc use refraction to account for a flat Earth like experiment.
Man, I want to respond, but go ahead, Miggy. I'll bite my tongue till later.
Yeah, we'll just, I guess you can respond. I just wanted to ask you maybe 2 questions. Can we know 100% sure that the Earth is a globe in any way?
No.
Okay, second question. Has anyone directly measured surface curvature?
Yes.
Okay, can you tell me who?
Transcontinental arc, the parallel.
Who? No, that's not what I'm asking. I'm saying who directly measured it? Was there, what persons were there, or people? Was there a group of people?
I could find the people that did it, but
I know that, but I'm saying, do you know?
That's called a genetic fallacy, so it doesn't really matter.
No, I'm asking you a question though. Either you know or you don't, right?
Not off the top of my head, no.
Okay, so you don't know. Yes, it's a problem. It's definitely a problem because the whole topic and the debate surrounds the information of a baseline of knowledge that you do not have, which right now currently seems to be stemming
How
from
does the knowledge of who made the...
So I'm trying to tell you, unless you want to interrupt me and then form your own conclusion. It's up to you. So the knowledge base of what you have right now...
You lagged there, so I interrupted while you were lagging.
Oh, all right. So can you hear me now? Hello? Can you guys hear me?
Yes.
Okay, so basically...
Go ahead.
Okay, so the knowledge base that you have right now is built on derivative topics that's surrounding like a giant puzzle piece that you're trying to put together. They're like all these little clues are going to equal to like curvature. That's what I've been listening to for the past, I don't know, hour and a half that you've been in here. And that's what it sounds like to me. You have a lot of evidences that are going to equal to your answer. Is that correct?
That is correct. What's wrong with that?
Because it's not one single direct measurement of the thing in question. So let's put it this way. I'm just going to give you an analogy, right? Like the ones you've been using. So basically, if I have a basketball and I tell you it's a cube, you would be telling me that it's incorrect. And I would be saying, how? You said, because we can directly measure this thing, which it turns out it's going to be a sphere with a radius, diameter, and circumference. And you can show me how in math, also in principle, how this actually operates in reality. So if I was to tell you to do the same with the geometric shape that you're actually standing on, it would not be the same, and I would ask you why. Because it's the same thing in reality, something tangible, something you can actually look at, and you can actually apply maths and then directly measure the thing that you're in question, right? So in this instance, it feels like it's a bit more obscure, and all these little clues that you're talking about don't seem to add to the single direct understanding that we know that the Earth is curving with the set rate that they're telling us with the diameter and radius. So what we're doing right now is we're going round and round and arguing about derivative topics, never getting to the underlying premise that the Earth is indeed measured curvature, because we have all the metrics, as you may or may not know. They're made public to everybody, so we can pull those up and we know what they are. So what I'm saying is that it's a fruitless endeavor that you're on right now, this quest to actually try to prove the thing that you're actually trying to prove, but without proving it directly, but indirectly. And so maybe to you that makes sense, but to everybody here, I know, but I'm saying, but to everybody here, it makes more sense to directly measure the thing in question, and that hasn't been done.
Can you directly measure something that is as large as the Earth?
Yes, absolutely. With the variable. Listen, because I'm going to tell you.
Can you do it the same as a basketball in your hand?
Yes, absolutely.
No, you can't. You can't, because you're big, and you can have bigger things to use as measuring tools for that Earth, right? For that basketball, sorry. But for the Earth, you can only measure a small patch of the Earth at a time.
So that's the thing, though. How did we do it in the first place? Because we have these metrics.
Transcontinental arc, the parallel.
Okay, so is that how we derive the metrics of the Earth? Yes or no?
Well, no. What we did is we have tested it many different ways. Some haven't been exclusive to globe Earth. Some could be experienced on a flat Earth, but we have then done some that are conclusively for a globe Earth over a flat. Did you hear what I just said, or did you start talking after you'd rambled for like 4 minutes?
We have the metrics. You don't want to look at the metrics.
Do you hear what I just said? Do you hear what I just said, buddy?
No, because it's not the actual direct measurement of the Earth's curvature by which we have.
Did you have a direct measurement of flat Earth? Yes or no?
I don't need to directly measure something.
Exactly. You're a fucking hypocrite.
Okay, so now you're resulting to insults because you're losing. You don't know how to provide evidence for the direct measurement of the Earth's curvature, so you want to spiral.
Transcontinental arc of the parallel. What's wrong with that?
Is this your out? Because it's not directly measuring the surface curvature. That's why. And I asked you, is it? You said no. You conceded. That's great.
No, it is. Transcontinental arc of the parallel directly measures the curvature of the Earth.
No, it doesn't.
It does.
Does it derive? Do we derive the metrics of the Earth's size from that?
Yes.
Show me where.
Great. I will link you the document.
It's a document that you didn't read.
Yeah, the one I did read that you didn't understand. You thought that
dude, you can listen.
That they listed as direct measurements. You thought they'd already applied some form of transformation.
They did.
Page 47 this time.
They did.
No, they didn't, Indio. Remember, you linked it to me and you read it, and it said that they had put the data in and then they put the calculation.
Sorry,
it's called a horizontal reduction.
So,
right?
like, listen, I asked him for direct measurement. He said no. Now he's saying yes. He's going back and contradicting himself. But what he's going to pose, because we've all seen this document, right? This PDF. I think is it page 19? Is it on the 4th paragraph? He's going to be astounded to know that it's not. They didn't directly measure anything. They actually pulled it out the Clark spheroid model. That's what they're using. So they didn't measure the curvature of the Earth.
He's denying that that's what they did.
Right, but that's what it directly says on the PDF that he's probably going to post if he hasn't posted it already.
He's denying it means that.
This dude is infamous, though.
His own meaning.
He's infamous for denying his own references. That's all he does here.
So the thing that I asked him were 2 questions. Can we know if the Earth is measured to have curvature? He's for 100%. Like, can we know that? He said no. Second one was that has it ever been directly measured? And the answer was still no. It was because he's trying to use all these derivative topics to ruffle feathers and try to make it seem like he has a point when he does not. And he starts to get angry and starts to put out insults because he doesn't have an answer. But that's all I wanted to say, just to expose him that he doesn't have an answer, and he wants to dance around it. That's all he knows. And that's all I have to say. I yield the floor.
I did notice he had a lot of direct, pointed personal insults. Now, I did swear at him to say shut up because he was constantly over-talking and through-talking.
Okay, can I talk about Mickey for a second? And how he started off with a genetic fallacy?
We'll talk about him, or do you want to talk about the arguments?
No, his argument. His argument was a genetic fallacy. His argument was, I didn't know who did the measurement, so therefore the measurement is wrong.
That's not a genetic fallacy.
No, he was talking about you. He wasn't talking about the argument.
I don't know who measured the transcontinental.
No, he's pointing out that you have a belief. That's what he was pointing out.
Yeah, you just have a belief.
That's exactly how he started his argument. Is that how you started your argument? Because I wrote it down.
Yeah, that's okay. If you think about his first question,
I said no because we can't be sure of anything. If you had epistemology, if you knew anything about knowledge, you'd know that.
Oh my goodness, dude!
You said that because I don't know who did it, I'm lacking some knowledge that makes that an actual like a good argument. When that's
that was your interpretation, but he never said any of those words.
He specifically said I was lacking some fundamental.
Yeah, that's right, but he didn't
sources that would make my sources incorrect.
No, you're adding that yourself. The incorrect part, you're adding that. He never said that part.
Okay, so for everything I've argued so far, what have I done that have made my arguments incorrect?
Okay. He wasn't arguing against your arguments. He was illustrating the fact that you have a belief.
He was using a genetic fallacy, yeah.
No, dude, what don't you understand? He was just illustrating the fact that your claims about whatever measurements exist out there, the results of which that you don't actually know are just a belief. Oh my God, dude.
Anyway,
it's about you, dude. This isn't about the measurements. It's about you. Are you like some weird narcissist?
Page 19 of the Arc of the Parallel. Isn't that great?
Dude, listen, before you read that, you need to specifically rebut the claim that they pulled that stuff off of that model.
Well, how about this? I can get right to the heart of this. Why do they use a reference ellipsoid? Why do they use a reference ellipsoid in the first place? Why is this even used? They're just measuring curvature.
We have previous information that tells us the Earth is a sphere. So based on that previous information, people now assume it because it makes sense to do so.
But why is it used in anywhere in any calculation ever? Why do they need it? Why is it necessary?
We have previous evidence that the Earth is a globe.
Okay, that's awesome. But why do they need it? You're not answering the question. Why do they need it in the equations? Why does it exist?
For the
why not just use the raw measurements, right, and then just come up with it like that? Why use the measurements and reduce them to an ellipsoid? Why are they doing that?
They have the raw measurements and they have the ellipsoid measurements.
Okay, so why are they reducing their raw measurements to the ellipsoid surface, the sea level? Why are they doing that?
Because they want to fit the measurements that they've made onto one larger, grander set of maps or measurements.
Okay, that are based upon old measurements. Were they reduced to another ellipsoid?
No idea what you're talking about.
So you just said the ellipsoid is based upon measurement. Dude, don't overtalk me. Don't overtalk me because you know you're fucked now. You're fucked and you know it, dude. Yep, that's right. You're fucked and you know it. You're fucked and you know it, dude. Sorry. You know you're fucked. That's why you're trying to fucking rabble-rouse right now. Listen, you said the ellipsoid's based upon some previous measurements. So these new measurements, arc of the triangulation, they reduce the measurements to the horizontal directions to the surface of this Clark ellipsoid. Where'd they get the Clark ellipsoid from? And when they took those measurements, did they reduce it to some other ellipsoid? How far back does it go?
Assumption upon assumption upon assumption.
To the first measurement of the radius of the Earth, you fucking moron.
When was that?
When was that? How stupid you are?
When was that?
I don't know. Maybe I don't.
Oh, you don't know.
That's probably prior to Eratosthenes, but Eratosthenes did the first one, and then we worked out
sorry, I missed that. I missed that.
Actually correct using different styles of
He's going to talk about Al-Biruni?
We've done it dozens of different ways. How do you guys not understand?
When was this measurement, dude?
Okay, the radius of the Earth's never been measured and can't even be measured in your paradigm.
His whole argument is based on he doesn't know. That's it. I've been saying I don't know this whole time, dogs.
You blow your father with
That's
that?
embarrassing, bro.
Look, you know what the answer is.
Look. Should we just
It's embarrassing. It's embarrassing. You're embarrassing yourself, dogs.
Yeah, you're so emotional, man. What you talking about? AI's emotions?
Go back and learn some more.
Let's have a good cry.
Yeah, I got a shoulder you can cry. Go on. Go back to McToon and go get some more information from him because you're not up to date, bro. This is weak sauce, bro.
You guys haven't given a single argument for flat Earth.
Bro. You don't know. I don't know. I don't know. Are you 100% sure? No, can never be. Well, you don't know anything, bro.
Dude, it's not.
Anyone that knows about epistemology knows you can't be 100% sure about anything except.
Well, then you don't know the Earth. Thank you for admitting that.
Yeah,
that's nonsense.
It's provisional knowledge. It's knowledge that isn't 100% complete, but is still knowledge. You have two competing hypotheses, and one has over 50% probability of being correct based on predictive evidence, then you should go with the hypothesis that has a greater predictive evidence. This is epistemology 101. It's fallibilism.
Dude, you just don't know.
Your lack of fundamental knowledge about knowledge is the problem. That's why you're all fucking flat earthers, because you're too dumb to understand.
You don't know anything, dude. I love it. I love that you don't know. Please.
What he basically said is that
tell me why fallibilism is incorrect.
If something has a greater than 50% probability and you have no other alternatives, you should accept it as true until something new comes along. Then it becomes false. Hooray.
Great. That's great. So give me something new that comes along that disproves the globe.
You don't know. That's all.
Nothing's come along that proves the globe.
That's all, folks.
I just gave you like 4 different things, didn't I?
Yeah, 4 different things that don't prove.
Yeah, 4 different things that you don't understand.
From towers is one. Yeah.
No, it isn't. No, it isn't, dude. Towers are not evidence of curvature. You're a clown, dude.
Go try to
need to find some way to disprove these things instead of just saying.
You haven't proved it in the first instance, you weirdo.
I didn't add in this specific number.
You haven't proved it in the first instance, dogs. So don't even be saying that you got all this evidence. You got shit, bro. You didn't prove nothing.
Can you
You're saying that I don't know. I don't know. That's what you said, bro.
Okay.
We got to do that.
If you read that document, there's not enough information in that document to make an evaluation. And
But
you
that
claim
doesn't
that.
make it wrong, does it? The experts, the
Listen.
people that built it, say
The experts, exactly.
You've been measured.
Exactly. You just said it all. Your actual true epistemology, the experts.
Oh, by the way,
Fuck all highfalutin.
by the way, that's a genetic fallacy. The experts, it comes from the experts, therefore it's true. It's a genetic fallacy.
a genetic fallacy would be because they are the people that did it. It must be correct. But the problem is that they did it correctly using the methodology that they chose.
Are you keep saying I don't know, dogs? We're used to you saying that already in here, so just keep saying I don't know. That'll win an argument anytime.
What's the correct methodology? How do you know the methodology is correct? Give us the methodology then.
I don't have to. The toe tank.
Okay, so you don't know the methodology, but you know it's the correct methodology. How does that work?
The same fallacy. It's great.
And because the experts worked on it, and it works.
Because the rail and the...
So nothing to do with their methodology, just the experts, exactly like these guys just said. Cool.
No, the thing itself, the toe tank works. That's evidence
we do not care.
The engineering works.
Yes.
The thing works. That's how engineers work, you idiots. Do you not understand this?
Yeah. So I got a PDF from an engineer from Australia that says just because it... Oh, do you want me to... Okay. Hold on.
Read your last PDF. Do you remember what happened there?
No, I don't. Well, you read what PDF?
Big failure in them not calculating refraction across a body of water?
Yeah, they don't. They don't need to because it's an unproven quantity. Gee, that's why I asked you. Let's actually go back to that.
Wait, is this a YouTube video?
Let's go back to that.
Video? This is the calculus they won't teach.
Listen, don't mute him anymore. Let him talk. Right? Don't interrupt me. We're gonna have a real interchange. Fucking interrupt me, I'm just gonna kick you the fuck out of here. Okay? It's gonna be like that. So check this out. I asked you, what model for refraction should we use to make predictions? You are aware that there are probably a dozen to maybe 24 models of refraction going back 150 years. Which model should we use that makes predictions? Which one?
Snell's law.
Snell's law doesn't work.
Why?
Because it doesn't preserve the angles.
It doesn't preserve the angles. That's the whole point of refraction. Refraction is the angles changing.
Okay, so in a gradient index medium, you can't use Snell's law because the angles are not preserved. Okay, so hold on, I'm describing.
The angles are not preserved. Can you explain what that means? Because the angles aren't meant to be preserved. The angle is meant to go from A medium to B medium. The angle is to change. The inference angle.
Yes, that's right.
C medium is meant to change again. Then from C to D, it's meant to change again. Then from D to E, it's meant to change again. So at what point?
Sine theta is a conserved quantity in Snell's law.
Say again.
Right.
I didn't hear
Sine theta, the angle is a conserved quantity. Okay. So the angle of incidence and the angle of refraction have to sum to 180 degrees. Right? Because they have to be normal.
Sine theta has to be 180 degrees.
The sum of the angles. The sum of the angle of incidence to the medium's interface, right?
Yeah.
And the angle of refraction have to sum to 180 degrees.
Okay, and?
Okay, so in a gradient index medium, that's not the case. If you apply Fermat's principle, I just posted a PDF that runs through the mathematics. I don't expect you to go through it now.
Live stream text?
Yes, right? I even posted the PDF, right? So it says sine theta conserved along the light path. And it goes on. Snell's law states that the quantity sine theta is not changed in the refraction of light passing from one medium to the other. We inquire whether this is true in a general case where the speed of light varies continuously within a medium. That is a gradient index medium, right? So you have to apply Fermat's principle, right? The principle of least time. So you understand that. Final result of these exercises is that, contrary to initial expectations, the answer to the question in the title is negative. So there's problems with using Snell's law and a freaking on like some gradient index medium, because you would end up having weird ducting, weird reflections, right? So if you modeled, right, so a medium with n number of, indexes of refraction mediums, how many freaking layers are you going to use, right? So what you could end up happening is the light being trapped within one of these layers and never exiting, especially if the light ever ends up going horizontal. So if it ever ends up going horizontal, it's never going to transition some barrier, right? Some interface. So if you look at Andrew Thomas Young's website, he admits this, that it results in a singularity if you use Snell's law, right? If you use Snell's law and the Earth is flat, right, and you have a medium at that level, so 6 feet, right, and you even have a gradient, right? You can even have a temperature gradient. That light, if it's horizontal, will never transition into any other refractive index medium, because it's horizontal over a flat plane. So if you model out mathematically, yeah, it'll just go on forever, right? The only reason you all say there's bending light, right, is because you have a curving gradient. I'm not gish galloping. Just because you can't comprehend what's being said, because this is above your pay grade, ain't my problem. That's your problem.
Well, I'm reading through this, and I'm not seeing the part where they conclude. So, what page is it where they conclude?
The conclusion? Scroll down.
Yeah.
The conclusion is literally in the abstract. You don't even have to read the conclusion. You can scroll down to it.
So, in the introduction.
So, you've never read actually any scientific material, so this is just like fucking Chinese to you.
Well, the conclusion is usually...
I've been reading this shit for 20 years.
It's in the abstract.
The conclusion is in the abstract. The answer to the question in the title is negative. Is sine theta conserved along the light path? That means, says, Snell's law states that the quantity and sine theta is unchanged in the refraction of light. Is sine theta conserved along the light path? The answer to the title is negative. The answer is in the abstract. They don't use Snell's law to model in physics, gradient index medium. Abstract, I posted it literally in the chat.
It also provides...
Look.
The final results of the exercise is that, contrary to an initial expectation...
Let me ask you this. Does Walter Bisgund's simulator use Snell's law?
Yeah.
No, it doesn't. It uses Fermat's principle.
Okay, if he uses Fermat's principle, who cares?
Okay, so does Mick West.
What's the difference? What's the applicable difference between the two?
Is that there's no boundary.
In Fermat's principle?
Yeah, there's no boundary. You integrate over the light path, basically.
No. Yeah.
If you use the calculus of variations of integrate over the light path. Whereas one is just simply algebraic or trigonometric, if you want.
And?
That they're not mathematically equivalent, dude.
They are mathematically equivalent. The outcomes are still generally the same.
No, Snell's law is a special case of Fermat's principle.
They're still...
Where you have a well-defined medium. No, they're not.
Yes.
Snell's law is a special case, right? Snell's law is a special case where you have two well-defined mediums with a well-defined boundary.
Based on Snell's law and Fermat's principle, would they be roughly equivalent?
In one case, where you have two homogeneous, a medium where you have two mediums with different refractive index that are homogeneous, isotropic, and have a well-defined boundary. That special case, that's what it models. Which is great for designing lenses. Right? You can use the thin lens equation, no problem. Easy peasy. Then you
Snell's law
still
can be
get to the
derived from
engineering.
Fermat's principle, which states the light travels the path which takes the least time. By taking the derivative of the optical path length, the stationary point is found, giving the path taken by the light. And there are situations of light violating Fermat's principle by not taking the least time path, as in reflection or a spherical mirror. In a classic analogy, the area of lower refractive index is replaced by a beach, the area of higher refractive index by the sea. And the fastest way for a rescuer on the beach to get to the drowning person in the sea is to run along the path that follows Snell's law.
Yeah, because you have a well-defined boundary. Sand in the water. You go one speed over the sand and another speed over the water. So you want to find the path which is the most efficient to reach the person. Well, the principle of least time. Which one takes you the least time? Should you run through the sand more? Should you freaking swim more? Which one should you do?
Great, so they both use the principle of least time.
Fermat's principle, or Snell's law,
no
is a special case
defined
of
boundary
Fermat's principle.
does, right? Okay, great. So why doesn't Snell's law work?
I told you, because it's a gradient. So now you have the sand, right? So the sand is continuously varying. In the water, your speed through the water is also continuously varying. Actually, there is no sand in no water because there's no well-defined boundary. It's just all sand. And your velocity through any given point in the sand, like at point, there's 0.0, 0.1, 0.2, 0.3, 0.4, 0.5, but there's a continuum. It's a continuous change. It's a continuous change, right? It's not a discrete change, like at a boundary, which is Snell's law.
Why is that a problem? So think about it like this time. You have X speed on sand, X and Y speed on water, and then you replace that water, and you have the speed across just sand being equivalent to the average speed between X and Y. And all it is just...
I don't know how to explain this to you. If you don't understand basic mathematics, I just don't know how to explain it to you.
Well, I just explained to you what Snell and Fermat's law, the difference in the principles. One says you go from X to Y, and the other one says there is a gradual change between X and Y. But if they both end up with very, very similar end results based on, the different optical...
Do they end up with similar results?
Of the mediums. Yeah.
Yeah, where's your evidence for that, dude? Like, seriously.
The paper you cited. They only found very, very small deviations using different calculations. In your paper that you cited.
Well,
every Flurf paper disagrees with them.
What did you say?
Every Flurf citation disagrees with
Dude,
them.
okay, you just said that there's a difference. Previously, you said they were the same. Okay, it doesn't disagree with me. It disagrees with you. That's a crazy projection. Now it's close enough. Before you were saying it was the same.
I'm waiting for evidence that it isn't. Can you tell me why Snell's law wouldn't work across a lake?
Because it's not a well-defined boundary. It's a single medium, so they have to...
You can take all the different mediums, and it's not a single medium because optical density changes depending on the temperature and the amount of the amount of water in the air, and the density of the air, and the pressure in the air. So you can.
So tell me, in reality, how would you model this out? How would you model this out? This gradient, right? This air gradient. How would you model this out?
I don't know. I don't have enough knowledge in maths for that, but I understand the concepts.
Yeah. So you would have to use an infinite amount of
to B density, or X density to Y density.
How many layers
do you need? Is that there is a gradual change between A density and B density. That's all it is.
How many layers until you approximate Fermat's law?
I don't know. I don't care. But that doesn't matter.
I know you don't care.
And this is amazing. This is amazing. You're doing a reification.
Yeah, now you're going to talk about me again. How predictable.
You're doing a reification fallacy.
No one is reifying it.
You know
I'm asking you. You say refraction exists. I'm looking for the evidence that it exists. I'm looking for the model that makes
a mathematical
so that we can.
Is it something that exists in reality?
Refraction as a general phenomenon exists. Refraction bending light around the curve of the Earth. Does that exist? That's what we want to determine. Does that exist? What is the evidence for it?
Indio, the boundary in Snell's law, does that reference something actual? Like an actual boundary, or does it reference a mathematical?
Yes, it's an actual fucking boundary. Yes.
No,
it's where one medium becomes another medium. The atoms on one side is.
I've ever heard. It doesn't.
Oh, so water. No, Elijah, please don't. Please. I'm asking you, please. I want to finish this. He's going to try and get off it. I'm not letting him get off of it.
Snell's law calculates the optical density of A and the optical density of B, and then it arbitrarily pops in a boundary between them.
Where do you think they would pop in that boundary?
What?
At the end of A, at the spatial end of A, and at the spatial beginning of B? Do you think that's where the boundary is? So if you have two substances, one's water and one's glass, the water's not the glass, and the glass is not the water, and where they meet is what we call the boundary.
They can both be water with two different optical densities.
So water can be water, and glass can be water and glass at the same time?
No. Indio, listen to me, okay? You can have air, just air, but if the optical density of air is different at 2 points, in Snell's law, you'll take those 2 points of measured optical density, so the different temperature and pressure, and you will put a boundary in the middle of that calculation. And that boundary calculates the deviation, the refraction.
That's why I asked you how many layers,
going from A to B. Whereas in Fermat's, it will be a gradual change. It won't be a defined boundary they put into the calculation. It will be between A and B, there is this amount of change, not it changes at a defined boundary, okay? It's all abstract, it's all mathematical, and it's called a reification fallacy when you say that there's an actual boundary in spatial reality.
No, what I said was there is a continuous change in Fermat's principle, and you just made my argument. Thanks you very much. Snell's law. Snell's law has a boundary. Snell's law has a boundary. Dude, Snell's law. Oh my God, the fucking spiral. Snell's law has a boundary. You said that you can make an arbitrary boundary. Where do we make that boundary? How many boundaries? That's why I asked you how many layers. You didn't even understand what that was talking about. Like, how would you model this? How many layers do you have to do? If I take six feet of freaking air, right? How many layers of Snell's law of different refraction index to model this gradient do I use? Do I use 10,000? Do I use 1,000,000? Do I use 1,000,000,000,000? Do I use an infinite amount? Right? When we use an infinite amount, well, oh my God, that's fucking calculus. And we use a continuum. And look, the continuum's more accurate than the so-called simulation of boundaries. I don't know why you don't understand this. Oh, because you don't know anything about mathematics. But your whole idea of refraction is based upon mathematical models, which don't work in reality, which make no predictions in reality. That's why I'm going to ask you again. I know someone muted you. Give me the model of refraction that makes accurate predictions that we can test, so that we know which one to use, so that when we make our post hoc claim, we can be using a model which has some predictive power. You even said we need predictive power to tell us what's likely true. Give us the model with predictive power.
Both.
Give me the exact model with predictive power.
Both.
Okay, so those are models. How are they tested?
I can find some journal articles if you'd like me to.
Yeah, I'm sure I've read them all.
Awesome. But are you willing to admit that the boundary is just what they put in? Like it's the maths that they add in to say that there is a defined...
They don't use Snell's law for a gradient, you clown.
A defined point between the refractive index of A and the refractive index of B, right? So all they've done is they've said there has to be a boundary here instead of it being a gradual change.
Okay.
No. So you're saying that exists in reality is bullshit.
No, when they model it, listen, when they model it in reality, right? Like if they model it between glass and water, they'll use Snell's law. But if they have a gradient, they're not going to use Snell's law. So when I say the Snell's law is an actual boundary, that's what they're modeling. They're modeling an actual boundary. They're not going to use it in a situation you're talking about. They're not going to use it for a gradient index medium. They're just not going to use it. So it's like,
why not use it? If it's easier, because Snell's law is
because it's inaccurate.
Principle, isn't it?
Because it's inaccurate.
To what percentage? To what percentage?
It probably depends on the application.
Oh, okay. So we can use Snell's law if we want, say, a couple of percentage points of accuracy. And then Fermat's if we want, say, a couple more points of accuracy. It's the same with Newton's and Einstein's, isn't it?
Well, it depends on the distance, right? So it depends on how long the light is within the medium, right? So that's the defining factor. How long the light is inside the gradient versus, or how many layers you model. So there's all different, depends on your model, right? So that you could probably make a situational Snell's law model and use Fermat's principle and get them fairly correct, probably for good enough for practical purposes, and make it quote unquote work, right? But it's not what's used in the common practice. They just use Fermat's principle because it's more accurate. That's just what they do.
So they both would work. One's just more accurate.
But the fact of the matter is, you can use Snell's law. You can use whatever the fuck you want.
You thought that this boundary was a physical boundary, you fucking goose.
No, listen, in the use that they model it, it is. Yeah, in the use that they model it, it is. Where they actually use Snell's law to model something,
it's real. When they model it, it's an actual boundary.
No, listen, they don't model gradients using Snell's law. Only dumbass fucking anti-flat earthers use it for that. That's what I'm trying to tell you. Only you fuck clowns use it for that. Nobody uses this. If you go read all the literature, no one uses Snell's law for this shit. Nobody. Not a fucking person. Only Dunning-Kruger.
Does it still work?
Does
it still work?
No.
Why? What's the percentage difference? How many decimal points are different?
I just told you. I already answered that question. Depends on the application.
You don't know verification fallacy, and you don't know, and you're trying to lecture me about the maths. At least I was big enough.
No. Listen, I told you the situation. It depends. It depends on the situation. It depends on what you're modeling. The error depends on what you're modeling. If you're modeling how long light's in fucking 1 millimeter of a gradient, dude. Yeah, they're going to be almost identical. But if you're modeling how far, like if it's going through fucking 1 trillion miles of air, that's something else. You're going to it depends. It depends on the application.
I think we're done with this now.
No, you're going to give me the predictive model. Dude. You're just going to give it to me because we want to know when we do our post hoc, ad hoc bullshit at the end, right? So we can't falsify the globe. I want to know what model we have to apply.
You're obviously too
I want to know what model, dude. I want the evidence. No, I want the evidence for your foregone conclusion. I just want the evidence. That's all I'm asking for. What's the evidence, dude? What's the evidence? What's the evidence any of these models work? What's the evidence that that light is bending around the curve? What model predicts that? And then that model has been validated by observation.
Great. I'm looking up
really simple.
Theoretical and experimental study of refractive indices of water, acids, and nitrile and salt systems.
Yeah, so I'm talking about terrestrial refraction.
They calculated the refraction.
I'm talking about terrestrial refraction. This thing that's supposed to be like bending around the curve, making everything look flat.
If you apply it to the surface of the Earth. No, these are physical constants, buddy. Do you know what a physical constant is?
Dude. Okay.
Dude.
That's a cool story. Physical constant. Yada, yada, yada. Cool story, bro. I'm asking for the model that makes predictions that we can apply in real life.
I propose a simple theoretical formula for describing the refractive indices in binary liquid mixtures containing salt ions. Our theory is based on the Clausius-Massotti equation. It gives the refraction index of the mixture in terms of the refractive indices of the pure liquid and the polarizability of the ionic species by properly accounting for the volume change upon mixing. The theoretical predictions are tested by extensive experimental measurements of the refractive indices of water, acid, nitrile salt systems for several liquid compositions, different salt species, and a range of salt concentrations. Excellent agreement is obtained in all cases, especially in low salt concentrations with no.
Are you almost done? Like doing nothing?
Expression of the refractive index for low salt concentration is also given, which can be a theoretical basis for determination of salt concentration using refractive index measurements. So it seems like they've come up with a very, very simple equation for refraction based on this one specific liquid, and it's been correct. They tested it, and it was correct.
Yeah, awesome.
Okay.
Yeah.
So now we're going to apply that to the air. What model is used for the air?
Just a second.
It doesn't matter. There's not a big deviation.
It doesn't matter.
What I love is they're using a tank and a solution and allowing it to set so it becomes homogeneous and isotropic.
Are they?
Yeah.
Are they? Because what I just read out.
Because when you stir the solution, I've seen many demonstrations of this.
Okay.
When you stir the solution, you see no deviation.
Look, I'm just looking for the justification for claiming that there's terrestrial refraction fucking up all our measurements with a laser. I want the justification for that. And you can't seem to come up with one. Other than because I said so.
Experimental determination of the refractive index of Snell's law. This experiment uses a narrow beam of light passing from air into glass and then into air. The experiment is practically easier using a hemi-cylindrical prism of glass with a beam entering the curve.
These are inapplicable to what we're talking about.
Why?
You're just Googling random shit on refraction, dude. Terrestrial refraction. Google that, brother.
There's
Dude,
literally
you think I don't know you didn't look for this?
An experiment showing refraction works, but you don't like it because you don't seem to understand that Snell's law, being a model, means that there has to exist things in real life.
You can claim it works in different applications that have nothing to do with. We want to see it works in this application.
In what application? Through air?
The application of a laser or a ray of light through air, dude.
Great. Refraction over water experiment. Have you never typed these things in?
Look, dude.
No, you haven't, have you?
What are you talking about?
It's much easier to just sit here and go around in circles about things that you don't understand. Other than
Snell's law. Yeah. Talking about me again. The old standby.
Hey, so anyway.
No. We're gonna finish this point. I don't care how long it fucking takes, dude. I don't. So we're gonna finish this. I want the predictive model for refraction so we know that there's a justification for saying that it exists. We need a justification. We can't just say, hey, willy-nilly, we're just going to throw in this phenomenon that we say exists. We need a justification for saying it exists, right? And one justification would be a model that's been tested and makes predictions. But that model doesn't exist, and you know it doesn't exist. That's why you're bringing up all this ancillary bullshit. And you know what? By bringing up ancillary bullshit and
predicting atmospheric refraction with weather modeling and machine learning.
Yeah. Okay. I've read that.
Would you like to read this?
I've already read it.
Have you?
Yes, I have. I read it about 2 years ago.
Oh, okay. What do they do in it?
I think they're looking at the side of a mountain, if I remember right. It's in Arizona. It's like in the desert.
White Sands, New Mexico.
Yeah, I got a pretty good memory. Seeing I only freaking skimmed it freaking goddamn 3 years ago maybe. Yeah, but even if listen, so check this out. I'm pretty sure the AI successfully made predictions, but AIs are black boxes, so we don't know how they actually make predictions.
So you've read something that confirms that.
No, it doesn't confirm anything. They just.
Weather model data results were computed for 10-minute intervals and ray tracing procedure was applied. The data is interpolated in time to align with the time-lapse image frames. Shows results of the experiment as a function of time of day, blah, 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 blah. Where is it? Measurements are only available for daytime. General downward drift through daytime hours is an effect we commonly observe in clear weather, and this corresponds to a reduction in the average refractive index gradient of the atmosphere along our line of sight.
Yeah, claiming something and showing the actual mathematics to support it are two different things.
Well, they've got the mathematics in this.
Not for that specifically. That specific claim you just made, they do not have.
I'm looking at it right now.
So what model do they use?
They have a machine learning model.
Well, you said it just matches the gradient of listen, you just said it matches the gradient of the refractive index. What is it matching? What is the machine learning matching? What model is that?
So the machine learning takes the image and then the ray tracing, whatever it is, and adds that into the known distances, and then takes all of the weather data and then calculates a refractive index based off that.
Okay, so What model is it comparing it against?
I mean, I can just link the paper. It's got all the maths for it here.
Yeah. What model does it compare it against? So what you have is you have a model, and the machine learning looks at the images, right? And then the machine learning goes, if this model existed, how would this image match that model? And now I'm going to make predictions. When I take an image, how does this image fit this model?
It doesn't matter. It works.
What's the model, dude?
Refraction exists, and it's between Fermat's, Snell's, and this model. They would have similar outcomes, right?
No.
And the deviation doesn't matter because the deviation can be changed by any of the variables changing. So the refractive index should actually just be like a range, okay? So if you have like the black swan image and then you apply refraction to that, you don't just add a set refractive index. You can make that a range of refractive indexes based off the measurements you have and the variables that could change. That's how science and data works. And then from that, you can see whether that image can fit the predictions based off refraction, which would be the range of refraction.
What predictions? That's what I'm asking you. How do we make the predictions? What model do we use to make the predictions?
It doesn't matter. Fermat, this machine learning. I'm going to use chicken bones. Be fairly similar, right?
No, not really.
Not really. Okay, so what's
depends on what model you use. They actually. They've tested models, in the literature, they've tested these models against each other, Well, then so you actually don't know anything about this topic. I'm asking you this for a very specific...
Any literature, champ?
Because they're so... Dude, you want me to link hundreds of PDFs that say, dude, we don't know.
I want you to link one.
Hold on.
Here, look, I'll add this in showing that machine learning can predict refraction.
So what? Machine learning is black boxes. We don't even know how it's doing the prediction. If you knew anything about machine learning, no,
that's genetic.
The machine learning is at modeling anything. You don't understand how machine learning works. So let's not talk about it until you know how machine learning works. Then, but there's nothing to talk about.
It's a genetic, fellas.
No,
isn't machine learning where the machine takes in multiple sources of data and then it comes up with an algorithm based off that data that would predict any two sets of data outcomes further on?
Okay.
Let's look. Machine learning, subfield of artificial intelligence that deals with systems that are able to acquire their own knowledge by extracting patterns. There we go. Extracting patterns to get new data. Great. So, have you found that study yet?
Yeah, I'll just read you a whole bunch. How about that?
No, just link one.
Where should I pick?
Have you linked one? Have you dropped one in voice chat yet?
Yeah, I'm going to link like 10.
Well, I just want one, so link your best one. I'm going to just look at the top one anyway. Top one better be your best one.
So what? Just so I get the right thing, and I give you the right thing. What exactly do you want?
Show the difference that an observation using Snell's law refractive index versus Fermat's law refractive index.
I already did that.
Deviation.
I'm not doing it again. They don't use Snell's law, and they don't use Snell's law in any type of surveying, anything to do with.
They use Fermat's law.
They don't use it.
Why'd you ask which one's best?
No, oh my God, dude!
So why would you ask?
This is what you don't understand. There's models for terrestrial refraction. They involve temperature, humidity, CO2, yada yada yada.
I explained all this to you, fucking idiot.
Listen, no, dude.
Yes,
there's
I did.
multiple models.
10 minutes ago, I went through all the things that can impact refraction.
That's right. That's awesome. Yeah. That's awesome.
Explain it to you already. So every single image you guys have of a flat Earth can be explained using refraction we know to exist.
Okay, cool.
Is that true? Yes or no?
Yeah, cool. No, it's not true. Okay.
Great. Give me one image that shows that the Earth is flat that can't be explained using refraction.
Using assumption, you mean?
No, listen.
Refraction. Okay. I just went through machine learning.
You just have assumption. You have no evidence that there is refraction happening on those days.
Hold
machine learning was able to calculate a refractive index.
They're not calculating anything.
Yes, it did.
No, they're not.
You're
Dude.
just
You don't
assuming
understand how it
things.
works.
You
dude.
have no values, so you're
You
just
just
assuming
don't
things.
understand
There's
how it
more
works.
values in the
I'm
laser
taking
test.
your time.
Data goes in, it calculates, it comes up with an equation
It
based off
doesn't
that data.
calculate. It does. It doesn't come up with a
It
fucking
does.
equation. You don't know what you're talking
Yes,
about.
when you get data and you run data
Dude,
through
machine
something,
learning
it's
is
a
basically a
calculation.
lookup table, dude. That's basically what it is. It's a lookup table.
It isn't.
You have no idea what you're talking about.
If
Dude, I got a
X
degree in
equals
computer
Y,
science. You don't know what the fuck you're
X
talking
equals
about.
B,
You don't.
if X equals C, depending on some variable,
It's
it can
not.
come
They
up
use
with an
gradient
equation
descent,
where that
dude. In this
variable will change
machine learning
X to
model, they use
whatever.
something called gradient descent. You have no idea what the fuck you're talking about. Stay like you don't know what you're talking about with reflection.
Verification
You
fails
really
to
don't know what
verify
you're
me I
talking
don't know
about
what
with
I'm talking
machine
about.
learning.
Even if I don't know what I'm talking about, I
I'm
have
not
some
going to
basic
explain it to you.
logic. I can understand
Look, I
things
want to go
faster
back
and
to
better
these
than you.
variables.
Someone
Dude.
who's been doing this for years.
I want to go back to these variables, right? So these variables that you say exist, it's cause refraction, right? You think they exist because there's models that exist that use these variables to make predictions about refraction. Well, none of these models actually makes accurate predictions.
They do.
No, okay, where is that?
The Fermat's law. You just explained yourself that surveyors use it. Surveyors
even
get
know what we're talking
accurate data over land masses, don't
I'm
they?
not talking about. So listen. Okay, so to
Do
apply
surveyors use
Fermat,
optical instruments, yes or no?
to apply Fermat's principle, you have to know the refractive index at any given point. How do you calculate that?
No,
use
you can
variables.
average it. That's the
Temperature,
whole point of
humidity,
it. Snell's law assumes that there's some set boundary, but Fermat's law can say that given like the known variables, you can average it out over a distance.
Well, they don't do averaging, but whatever. That's
what Fermat's law is. It may not be an average, but what it is it's going from A to B using a function rather than going from A to B
right.
with
And
some
so there's
defined
different
boundary.
variables that they use in these different models to model terrestrial refraction.
So if you go from 10 to 1,
none are
across a
accurate.
distance of
That's what I'm
10
trying to tell
centimeters,
you.
And
None are accurate.
As a
None make
function, it would
predictions.
be centimeter 1 is 9 from 1, centimeter 8 is bloody 2, centimeter 2 is 8 from 1, centimeter 3 is 7 from 1. That's how the function would work.
Yeah. Great. Fantastic. How do they figure out what the refractive index is at any given?
Maths. I don't know much advanced maths, and I was able to explain to you how that would be.
You don't have to explain it to me. You're just you're trying to convince yourself of something, dude. You're not understanding what I'm saying, or you're deliberately being obtuse.
This is getting sadder, right?
There's a model. There's a model that uses these variables. So you're still going to talk over me again. There's a model that uses these variables, and none of those models make accurate predictions. These variables that you say exist, which cause refraction, to validate whether these models cause refraction, you need a model that makes predictions which are tested and known to be accurate. You don't have that. You're putting the cart before the horse. Where's the fucking horse? Where's the model of refraction that makes predictions so that we know these are the variables that matter? These are the variables that cause uncertainty or observation. These are the variables that we need to account for so that we can come up with a refractive index or a change in the refractive index from which we can make predictions with. That doesn't exist. And do you know what? It's been tested. So there was an experiment, this laser experiment across the Hawaiian Islands. And they took 3 lasers. And they went from one Hawaiian island to the other. And they did this experiment. They were measuring turbulence in the air. They picked up all 3 of these laser frequencies through their telescope. Then what did they do? So there was other research students there. So for his master's degree, he tried to model it. And when he applied the model of refraction, right? Gradient, standard US temperature. When he modeled it across this same distance using the same laser frequencies, he found out the experiment should not have worked at all. Because the divergence, because refractive index is wave dependent, right? You have, what the hell do they call it? Can't remember the name of it. Dispersion of light. That's where the wavelengths separate.
Why are you still talking? Have you linked the PDF about it?
Oh, I will if you want.
Yeah, of course I
will.
will. I've asked for
spiral into oblivion, but whatever. So, So what happens is the spread of the wavelengths of the laser are greater than the width of the telescope. So when you model it, right, when you model it in this refractive index error, the spread, so you have 3 frequencies of lasers all starting at the same point. They spread out because not all of them refract the same. They refract differently. It's wavelength dependent. So they're spread out by some spatial distance. That spatial distance is greater than the width of the telescope. But somehow they picked up all 3 beams in the telescope at the same time. The only way that can happen is if there's no refraction.
How do I find this? How do I find this?
Hold on, I'm gonna post.
How do I
you want
find
the
that?
underlying experiment? Yeah, hold on. So I'll find the underlying experiment. So this was there's experiments based upon, it's done by the Air Force. So the person that wrote this master's thesis, he tried to model what the results were. And when he modeled the standard, terrestrial refraction, using the same shit Bisgin uses, using the same shit Mick West uses, found out that, like it says, I'll read it to you. For the 150 kilometer path simulated, the rays are misaligned by about 4 meters.
Okay.
With respect to the point, the telescope's 3.4 meters wide.
And?
That means they should not have, if the refraction model was correct, they could not have picked up all 3 lasers simultaneously in the telescope. But they did.
What did they say about it?
I mean, what did they say
What
about
was their conclusion? What was their conclusion?
Well, see, they did the test first, and then after the fact, they applied the model, and then realized our test should not have worked. If they would have applied the model before the test, they probably would have never did it. They would have probably designed a different test.
Okay, so they came up with there is some variable or phenomena that we cannot explain. Is that what they came up with?
What they were testing was, okay, so was
But
the test
was their answer? The presented experimental results on intensity scintillation characteristics reveal complexity of the observed phenomena that cannot be fully explained based on the existing atmospheric turbulent models.
Yeah, so there's turbulence models, there's refractive index models, and he tried to use a mixed turbulence refraction model. None of those models worked, but the turbulence model, called a non-Kolmosov model or some shit. Can't remember the name of it because there's actually 2 of them. There's the non one and there's just a regular one. Anyway, so the turbulence model fit more closely than the so-called terrestrial refraction model. The terrestrial refraction model says that the experiment should not even have been completed. Because you can look at the simulation. He simulates it the same way Walter Bisgin simulates it, using the same methodology. So the fact that, and I have more stuff, right? So I have more. They've done terrestrial laser measurements using 2-frequency LiDAR. I can post that. And what they measured was the deviation.
What's that going to prove? What's that going to show? What's that going to show?
It shows that when they so-called measured the refractive index, right? They measured the angle of arrival of a beam of light of 2 different frequencies of light, and then they measure the angle, like how much deflection they are measuring, right?
Yes, but the argument.
And they're measuring 5 m. They're measuring a max 4 mgon deflection, which is equivalent to 0.009 degrees. So if you extrapolate out to 29 miles, 25 miles, that's 8 feet.
And?
That's an 8 feet deflection at the max.
And?
The laser, like ISO laser test, would have to be a 420 foot deflection. A 440 foot deflection.
And?
You don't understand that the observation at Lake ISO is 2 orders of magnitude off the prediction, right? Even if you, say you use 7.6R, it's 2 orders of magnitude off that prediction.
What was their conclusion?
Dude, for FD core? Yeah, that does not fit the WGS84 model.
Oh, you're talking about FE core again. They didn't add in any refraction, you fucking idiot.
And I'm trying to justify adding it in. So don't you get it? We're trying to justify adding it in. We're not just saying, yeah, it exists.
The surveys use refraction.
Let's say we use 7.6R.
Surveys use refraction.
Surveys use refraction. How much refraction
do they
use?
accurately measure the surface of the Earth in distances?
For practical purposes, yes.
Great. Do they use optical measurements?
Yes.
Great. So why didn't FE Core do the fucking same?
We can do the same. We can use 7.6R.
Then do it.
We can use. So if you look, so I'll give you an example. We in the United States, different states build roads. If you look at the surveying manuals for their for the transportation departments in different states, they all use different refractive index ratios. They use different values for terrestrial fraction. So, for instance, in Massachusetts, they use 0.17. In Washington State, they use 0.13. In Europe, they use 0.13. So different places use different values. Listen, the point is, the value, the largest value anyone uses is 7.6R, which is 0.166, right? So you take this 0.16 that they use in surveying, right? It only takes 5 meters off. You have to, and the value is 137 meters off. The measured value is 137 meters off, dude. So, okay, we'll give you refraction. We'll give you terrestrial refraction model. We'll go 7.6R. Yeah, now you have to make up another 132 meters.
I didn't say this FE.
Now we can go, okay, there's even double extra special refraction. We'll multiply it times 10.
Drop in the FE laser measurement link again. I'll look at it again using the highest and lowest refractive indexes.
What does that even mean? First of all, you just quoted surveying.
If I'm right,
they use a 7.6R value.
Stupid rambling way. If we were to add in the standard refractive indexes into the FE Core measurement, it still would.
Yeah, the ones you just appealed to, surveying. Those are the ones you just appealed to. You said surveying, they use refraction. That's what they use. They use 7.6R.
Big fella, if you add those into the FE Core data, it still won't explain the data. Is that what you're trying to say?
I'm saying, if you add that value into the, listen, I'm explaining it to you. If you add that value into the data, it only moves the laser down 5 meters.
Okay, great.
You have to move it down 137 meters.
The FE Core thing again. I'm gonna download it. I'm gonna go away. I'm gonna do the maths. I'm gonna come back. Okay.
Yeah. Okay. Fine with me. I want you to keep in mind that they didn't just. This isn't a one-off. They did it 3 weeks apart. So make sure that you read the dates.
Don't care if they didn't add refraction. I don't give a fuck.
You don't even know why they should be adding it, other than somebody told you they should add it.
No, I know why they have to add it. They have to add it because as light moves through a medium, if there's any change to that medium, then the angle of incidence changes.
And that means what?
And that means that the light can make things look further up or further down.
Okay. Yeah, you're claiming that. But you're claiming that. But what's the evidence? Dude, that's what you don't understand. You don't understand there's a difference between claims and evidence.
Open the fridge, mate. Have you ever opened the fucking fridge and looked at it? You cold air when it hits the warm air and things get all goofy behind it.
Well, that would be evidence.
There's experiments, but there's one where some dude pours cold water over, or I think it's liquid natural gas, over a propane tank, and you can see some, I don't know, colours that you couldn't see before, some bands of colour.
Thank you for proving. You just proved flat Earth. Thank you very much.
Affecting what you see.
Yeah, that's great, dude. Do you know what that proves? Because you have to use this butane. Listen to me. Because that proves that you're applying refraction. Listen, you don't get it, dude. Butane has a refraction. Okay, can I finish? Can I finish? Can I finish? Can I finish? Okay, so the refractive index is butane, by the way. And the refractive index of butane is 1.33, right?
I don't care. I don't care.
So check it out. The fact that you have to use, listen, the fact that you have to use an extreme, non-physical, unequivalent demonstration to simulate what you say is happening all the time demonstrates that it's not happening all the time. The fact you have to use butane to show it to happen
happens with cold air.
demonstrates that it's not happening all the time.
It happens with cold air. It happens
How
with cold
cold?
air.
Yeah, with cold air, but that has a temperature gradient of something like 70 degrees per centimeter. Is that physical? Do we experience that in the real world? Do you ever have your feet get frostbite while your knees were burning off? I didn't think so. The fact you have to use extreme examples of demonstrations, non-physical to what we experience in everyday life, proves that it's not happening.
Oh my God, that's because the demonstrations are done in people's houses, you fucking moron. You fucking idiot. If you're going to demonstrate something in your house, a very small area, then you have to use extreme refractive conditions because you can't have the massive change over a long area. It's numbers, you dumb cunt. It's numbers.
Oh,
what numbers?
The language on you. You blow your father with that mouth?
Oh my God. So
what numbers?
Have, say, I want to test something in a very small area. Okay, and I want to test some variable that usually happens over a very long area. I have to make that variable much bigger in the small area to make sure that I can observe that variable in action. Because over the very, very, very long area, that variable can have very insignificant changes, but because it's such a long area, those insignificant changes can cause a massive change over that long area. I'm explaining this to you like a child because so far you've shown that you may be a child.
This is actually pretty humorous. So what you're saying is,
look, here's a video.
We have to scale down the experiment to demonstrate that the phenomenon, which should be happening all the time in the air, is actually possible. And to do this, we need extreme conditions. But the underlying phenomenon, you can't actually demonstrate is happening.
Extreme conditions, just people show that it's possible using extreme conditions because they're doing it in their little house.
But they're not equivalent.
Of course they're equivalent. It's just scale, mate.
Okay.
If I want to make a square, I can make a square 1 centimeter by 1 centimeter or 1 mile by 1 mile, but those fucking squares will still be square.
Okay. It's not equivalent, and the scale's not equivalent, okay? Because the refractive index of air, I'm going to explain to you why. I'm trying to explain to you why the emotional child. Irony of you calling me a child with your spasming, dude. That's hilarious. Anyway, so the refractive index of butane is nowhere near equivalent to air. Air's refractive index changes. Yeah, you don't give a. I thought it was math, dude. I thought it was numbers, but now you don't give a fuck.
Past butane onto air, but you're stuck on butane.
No, I'm going to cover them both.
No, see, anything that goes against your biases.
So I'm going to cover them both. See, don't presuppose what I'm going to say, dude.
Well,
I'm going to cover them both.
Don't talk about butane because I don't give a fuck.
No, you don't give a fuck. Okay, so let's talk about the air. The temperature, the extreme temperature gradient, right, that you're demonstrating. So I've seen the dry ice demonstration. The refractive index of CO2 is not the same as air. And then I've seen I think they use a cold plate or something like that, or ice. I think it was Mick West used ice. Was it Weiss? What did he use to make everything cold? Was it turbulent air?
No, he didn't use Barry Weiss.
What was used to make the temperature gradient?
I don't know, because I'm not obsessed with people that do these experiments like you retards are.
So you cited an experiment that you don't even know what happened. Great. Let's go with that.
I've watched. I cited an experiment that I've watched, but I don't remember the people that did it because I don't give a fuck. Look, I found.
So what if they use dry ice? Let's look at the Mick West. What if they use dry ice?
I found the one you wanted. You wanted me to talk about Mick West, didn't you? Because you have pre-prepared.
No, I don't care about Mick West. He already got smashed in here. You can fucking listen to the video on the YouTube channel.
Yay, there's Mick West. I finally found the thing you were talking about that I wasn't.
I don't care about Mick West. I'm asking you, if you don't know the details of the experiment, you don't know if they use CO2, if they use some equivalent. You claim they're equivalent, they're just different scale, but you don't actually even know that. I'm asking you, if they use CO2, why did they change the air? I'm trying to figure out the iron. See, you make claims that there's no evidence for. That's the hilarious part. You just keep
What claim?
You claimed that these demonstrations are equivalent and they're just a change in scale. So I'm asking you details about them and you don't know the details. So you're just talking out your ass.
What detail do you want? The guy put up an iron,
to cool the air. What did they use to cool?
It changed it.
What did they use to cool the air? What substance? How did they create this temperature gradient?
Nothing. They warmed up the air using an iron.
They warmed up the air using an iron? What?
Are you just going to repeat back with a dumbfounded?
I don't understand what you're. I don't understand what you mean by they warmed up the air using an iron, like an iron for ironing clothes. Iron, like
you
what?
Don't seem to understand anything. I linked the video.
Because you suck at explaining yourself.
You know, an iron, like you iron your clothes. Yeah, it heats up the air. Look, here's one of nice wavy air patterns in front of a heater. Why would that happen?
Turbulence. It's called sensible heat flux.
Amazing.
Yeah, it's called sensible heat flux. Yeah. So, like when air gets hot, it goes up, right? Right? It tries to equilibrate and it moves around. It's like why you don't survey in the wind. So there's something called the Fresnel effect, where a medium that's in motion will deflect light in the direction of the motion.
Oh, okay. So there is refraction, deflection.
That's not refraction. It's a completely different thing.
So did they look at what the wind speed was over the water in the FE core experiment?
Yeah, I'm pretty sure they did. I mean, it's on like they took pictures of the meteorological.
Anyway, I'm out of here. My earbuds are about to die, and you seem to be thicker than a brick, my son.
Yeah,
Hypothesis in science, buddy.
Does that qualify as a wig, bro? I'm sorry to everyone that I cut up, but I do not want to let him out of that. Otherwise, we're going to be looping on that shit forever. I'm sick of this guy. I'm sick of looping with this guy.
That counts as a wig with the earbud still attached.
Ew. How about the ear still attached? How much glue did you use on that wig? Listen, this is, to me, these refraction claims, like, I'm so sick of it just being like a foregone conclusion. You didn't include refraction. You didn't account for refraction. Why should we? Give us a reason why we should. Oh, because everybody else is doing it. That's not an argument. Surveyors do it. Yeah, so what? And? They're measuring 50 meters at a time. The uncertainty is like 2 millimeters. Do you think that like if they don't use refraction, it's like, oh my God, now the fucking road's all fucked up. It's a 1,000-mile road and now it's messed up because we didn't account for refraction. I mean, come on, man.
Dude.
Get serious.
Did they account for refraction when they used the microscope on that fishing line?
Dude, that's somebody that's like, have you ever done asphalt AI?
Not really, no.
I
Cement, though.
When I was a kid, so I've done asphalt. I wish Mike was here. Like, you're precise, but you're not that precise. It's fucking asphalt, dude. It's like,
yeah, exactly.
Fucking not measuring to like, oh my God, we didn't account for refraction of the road, man. Oh my God, like, no, the road doesn't work. I mean, get real.
I've done sidewalks and stuff and foundations, but yeah, same principle.
So they only use the geodetic surveying so-called techniques for practical purposes in road work. They don't use them. And it depends. It depends on whether it's an interstate highway versus, state road versus a city road, right? Depends on whether they're going to use a state plane system versus like the geodetic system. And the geodetic system is going to has to be long. And like any error of not using refraction is going to be so negligible, it isn't going to matter. They never like built roads and were like, fuck, we built this whole road and didn't account for refraction. No wonder why it's messed up. No one has ever done that. That's never happened.
Yeah, you were trying to tell me. I thought that the point that I wanted to jump in that was annoying was that he was trying to say boundary wasn't like the part he was missing was that to spell law it's two mediums.
Yeah, well, I went over that.
That's the boundary.
He denied it.
And I posted. It's like because I would have pointed into the screenshots of Snell's law. I'm like, what's that?
Look, I really didn't want to go into these rabbit holes with him. I just wanted to point out that there was like I was laser focused on one thing. Point out that he has no justification for including refraction in any calculation of anything ever. That there's no actual justification for it. There's no like, there's like, oh, we have a model, and this model requires refraction to make it unfalsifiable, but other than that, there's no reason to have it.
Yeah. Well, there you go. That's the rationale.
Oh, you got him so hard, AI, dude. You got him to admit we're making our model all falsifiable. Like, that's pretty much what he admitted. That is just perfect.
It's like that day when me and Kiwi were going through, and I was teaching him how to use the Bislins, and the refraction slider. I thought it went up to 60 million radius, but it actually goes up to 60 billion radius.
Oh shit!
He's like, "Oh, dude, what's these extra 3 zeros here?" And I'm like, "Hold on a second." I resized my screen, because sometimes it cuts it off if you have like 20%, 70%, whatever.
Yeah.
And I saw the rest of the numbers, the rest of the zeros. I'm like, "Damn!" I'm like, damn.
Oh my God, Earth's the size of the solar system. Actually,
well, one of our
galaxy, right?
Yeah, so one of our friends asked a question, which is, how does he explain the Canigou shot? Well, lo and behold, this is what me and Kiwi were looking at. So we went and we did the slider, right? And we did this calculation for how much we would need to get to the Canigou shot. Now, check this out. The number of that value was only like 0.003 different than the category that you can click that just pre-calculates what's called extreme refraction. So let that sink in. And Walter Bislin's calculator, when we did it, and by the way, it's recorded, so if it was changed, there's proof still there. He literally labeled extreme refraction the exact amount of refraction needed to defeat the Canigou shot, proving the point that it's just an unfalsifiable ex post hoc excuse.
Yeah, that's the same thing he did with the Black Swan. That's why I brought it up, right? So he created this piece of software, and then he manipulates the variables until the piece of software looks similar to the image, and it doesn't matter what the values say. The values can be non-physical. It doesn't matter. So in the Black Swan, unlike all the other simulations, he tilts the camera up a tenth of a degree. I don't know why. If you put it at regular degrees, it doesn't match. So he takes the camera. So he's got all, he's got the tabs of different observations.
You mean level?
Yeah. So he tilts it up 1 degree from level, or
right? Yeah,
from level.
Makes perfect sense.
Yeah, but he doesn't do that for any other observation in his little tabs of Soundly's Bridge, Pontchartrain, he's got all these little tabs, right? So This is the only one where he does this, the Black Swan. He tilts it up. And then when you look at the ray trace, the rays flipped it over. That should make an inverted image. When you have ray tracing paths, right, and then the rays cross over, like the top rays become the bottom rays, and then the bottom rays become the top rays, that's an inverted image. But when you look at it, it doesn't invert the image. I don't know if he did this intentionally, or it's an error in the software, or a combination of both. It's not a bug, it's a feature. You know what I'm saying?
Well, if there's a point of inversion, your lens would have to be there in order for it to be an upright image.
At least he has a little graph where it shows it has the variables, and then it shows this crazy it has a graph of the variables for the temperature, altitude, that, right? So that is just insanely all over the place. So if he had to fiddle around with the variables until he got something close enough, right, to what the Black Swan looks like, but didn't think past oh shit, these rays are inverted. He doesn't care about that. As long as the software comes out the way the image is, that's all he cares about. That is some bullshit, dude. You couldn't get away with that in 9th grade.
It works. It works.
It fools people like this guy. You know what I'm saying?
So it does work.
Yeah, it does work.
Dude, once you're told that there's like he said, a greater than 50% probability, right? When you apply the Snell's law or whatever, that the horizontal rays will remain horizontal, right? That would be an impetus for you to maneuver the thing like at an up angle, right? Because if you just have the rays going straight and they're not passing any variability, they're just going to stay straight, and there's going to be very minor variability. But in their worldview, they have infinite variability of paths probability, so they can just pick and choose any paths they want. And then draw lines like as if they're heat-seeking missiles shooting you straight in the eyeball. And again, that just makes their claims unfalsifiable in principle.
So I'm going to take a screenshot of this shit.
But by the way, all his claims also backfire on all optical observations that the globe makes, because the scrutiny that he demanded of the flat Earth side was not applied to any of the globe Earth observations.
Yeah, like, did you measure in the middle? Remember that? We got to measure in the middle. He don't. But
Yeah,
the middle is where you're going to actually have to measure it, right? You're not going to measure it at the edges.
Yeah, all the models, all the refraction models are based on measurements that were taken at some point, not current measurements of the current conditions, anything like that. And then it's like you can stretch those boundaries, so it's just used to fill in the gaps to make things match.
Yeah. Well, the Itchel test, they did measure in the middle by hitting the panned targets. And they demonstrated the variableness of whatever alleged refraction would have been there. Well, it really just all about the bias that we already know the Earth is a globe. This observation doesn't fit geometric wise. Therefore, the light must have curved. Oh, well, what model did you apply to know how the light curved? Well, simple. We just plotted out the geometric points and then applied a circle, and then we said this light had to follow this trajectory to get to you. Therefore, it did. It's the most ex post hoc bologna sandwich of rationale.
Doesn't the infrared observations just throw the refraction argument out the window anyway?
Yeah.
Not having a globe radius to refract does that pretty well too.
Yeah, it's just they make the claim that all the light is bending around the globe, so it appears flat, and so we can see 10 times further than the geometry in the Black Swan, and they just bend everything to make it match. But if that were true, then we would be able to just use infrared and be able to see that the horizon is always closer in infrared. Do we see that in real life? I don't think so. All long-distance photographs in infrared that I've seen taken close or with short duration between a visible light picture show the infrared actually seeing further. So I don't see how they can get away from that.
Dude.
Well, that was.
Yeah, hold on, I gotta show you all something. How far is the Black Swan? How far is 10 kilometers? Or 10 miles in kilometers? That's
16.
Okay, 16. Yeah, I should have known that. 1.6. Should have been able to do that in my head. I'm sad. That's just sad.
Well, that's just the next greatest whole number after the demarcation point of the rig. It could be much further than that.
how interesting would it have been to see that black swan taken, one with infrared and one with visible light? Like, how far would we have seen the beach of the island that's back there? I don't know. It's hard to see because it's the light is so diffused near the horizon.
Look how insane this is. This is Bislin's ray trace. These are the path of the rays. Look how just insane this is. This is what it takes, right? These extreme situations as evidence for the globe, right? That there has to be an extreme, and that's the only way that they can even approach what they're claiming is happening all the time. That's the thing, is you're claiming that this is the general condition, right? That we see too far, and we have to apply this refractive index, this standard refraction all the time. And occasionally it's a little bit worse. But how come it's never a little bit better? Oh, that's when ships go over the horizon. Well, how come refraction doesn't make it look even closer still? How come the refraction doesn't make it look like an extra curvy ball?
Exactly. Or make the horizon appear like at 30% in the top of your viewpoint.
Yeah, why doesn't it make the horizon appear like a mile away when it should be 1.2 miles away, or 500 feet away, or right in front of your face?
How come they can't even show a picture that even matches their claim standard?
Yep.
Good question.
Dude, why does this picture you post have a big yellow block for obvious contrast, like it's flashing at me and it says custom refraction?
That's I don't know why you're there bragging about that.
I know.
So, the way I figured out that this was tilted, right? These rays are tilted up. Was I'm like, man, look at all those rays that are all really close together up top. I mean, that's kind of weird. I'm thinking, and I'm like, he must have did something. So I start clicking through the tabs, and these rays are tilted up, right? So they tilted the camera up, so the rays that are entering, so what you're taking is, so what they're doing is, right, they're taking the image, right, and they're taking one pixel in the image, and they're moving it across the grid, right, and moving it up and down based upon, the angle of change of the refractive index, and then they're projecting it onto the image that is going to be presented on your screen, the one that quote unquote matches the observation, right? So there's just moving this pixel up or down relative to that. But apparently that must be clamped because they're not moving it into their correct actual location. But in order to do this, they had to tilt the projection plane. This is being projected on. He had to tilt it back to get the geometry, the shifting to match the so-called black swan, and it still isn't even a match. You know what I mean?
Yeah.
It's A for effort, but not quite.
It's also, if you look at your image at 2 minutes after the hour, if you follow those rays, why on the globe you'd be seeing the ground up in the air, really high up in the air.
Yeah, it's all messed up. This is I just use this as an example of post hoc, right? It's just completely post hoc. We're going to sit here and fiddle with the dials until we get it to match, right? And we're going to make refractive indexes that are absurd and not seen in nature, dogs are gods was citing, right? We're going to do tests that aren't seen in nature to prove that these phenomena exist in nature. No, dude, that's not how it works. If you have to do an absurd test, then that phenomenon does not exist in nature because you're going outside the natural order to demonstrate that it can happen at all.
Yes, a roided, jacked up, serum-induced, Neanderthal can lift, 2,000 pounds. Therefore, I can lift 2,000 pounds. Therefore,
yeah, everyone can do 2,000 pounds. 2,000 pounds is happening all the time. People are just like picking up 2,000 pounds. And here's I didn't want to point it out because I didn't want to go down this rabbit hole. Kept saying you're using a genetic fallacy. Literally, he was doing the exact same thing he was complaining about. Remember when he started talking about epistemology? Right? And he what he said was a genetic fallacy was because I don't know how somebody did something, that means it's not true, and that he used it for epistemology. So some people had to come up with the epistemology, right? So they said that this epistemology is correct, and that we don't know about it, therefore it's not true, right? He did the exact same thing, the exact analogous thing, 5 seconds after he complained about you doing it. Or he complained about Miggy doing it, quite honestly. Yeah, it was Miggy. So, I mean, it is what it is. I just want to illustrate that, like, that was my only laser focus. I want to illustrate there's no rational basis for applying refraction just because. Right? We can say other phenomena exist, and we're not just going to willy-nilly just apply them to, like, observations. So you could think about it like this, right? So we have diffraction, right? So we can model the path of light as if going through a shitload of holes, right? There's an infinite amount of holes, and we can use this diffraction model. There's an infinite amount of holes between point A and point B. And then we can just say, well, the light's just all over the place because, it's actually, that's not even a real image. That's just like a hologram of an image because you have all these little, you can model the air as like a hole because the light's going between the freaking atoms, right?
All
so that's
the little
just
balls, yeah.
Exactly. Yeah, so it's all scattering and diffracting, and so when you actually see it, it's just a hologram of the image because of wave interference. It all just comes together and coalesces in your eye, and and we have a model for this, so we're going to apply this all the time on why, the Earth, ships over the horizon is bullshit because we have this diffraction model. Okay, so we have a model. It doesn't make predictions, but we're just going to apply it post hoc to every single observation. Nobody would accept that, and they should not accept it because it's bullshit. And this is what these guys want us to accept. This nonsense.
Wait a minute. Did you just say that every space between a particulate is an aperture and therefore compounds diffraction? So you have an infinite diffractive path model, which essentially would become the same thing as their infinite refractive path model.
Yeah.
So you could just pick any path you want, and as long as you can trace that path from the source to the observer, then you can validate your claim.
Yeah, I mean, we could all play the same game, right? We can say refraction makes the Earth look, the Earth look like a globe, right? Like, I mean, we could say anything. That's the whole point of unfalsifiability, is that the underlying claim can prove both propositions. Well, not prove it, right? Or you can be used as evidence for both propositions, right? We can claim
either one.
Yeah. So we can claim refraction makes the Earth is actually flat, and when it doesn't look flat, that's refraction, and and they can claim the Earth's a globe, and when it doesn't look like a globe, that's refraction. It makes it unfalsifiable. Well, how about there is no refraction, and that we're just misapplying it, like the optical phenomenon that we're seeing is not refraction, it's turbulence, or internal reflection, or any number of things. The point is, because the refractive model can't make accurate predictions, that's actually wrong, and it has to be because they've been trying to figure it out for 150 years, and they still aren't any farther, right? And to the point, man, I wish he was on here. I should have asked him, if they have a predictive model, why are they using AI? What's the purpose of that? They have a predictive model. That's redundant. Why even use AI to do anything? right? We have a predictive model. We can just take a picture and we know what the refractive index is. You understand what I'm saying, right?
Yeah, if I was gonna feed my AI, right, what I would do is I'd take a bunch of pictures that have supersedery information according to globe geometry, feed them with that presupposition that the bottoms of things are cut off because of globe geometry, and then you have the squashing effects, right? And then I would tell the AI, create me a model that traces the path of light that assumes globe geometry from these images. And then it would give me all this, spaghetti string nonsense, right? So now they just have an even better Earth curve calculator. So you say, oh, look at this image of a mountain 500 miles away. Oh, yeah, well, look at this spaghetti string.
Well, see, this is, I didn't think of it at the time. I should have did this. So you could have took this AI, right, and fed it a model of gravity, right? So little g, not big G, right? So that when the mountain is displaced down, that means there's a greater acceleration, and you could put in the equations for it, like you put the mass of the mountain and the acceleration of gravity at that particular spot, and you would just say, okay, what's the acceleration of gravity if the mountain's in this location? What's the acceleration of gravity if it's displaced this much, right? And then you could feed the AI a bunch of data, and the AI would say, yes, it matches. When the mountain's here, the acceleration's this. The mountain's here, the acceleration's that, right? And you could just come up with, because you're making correlations between one model in the AI, in the image, right? So you have a model, right, the equations of gravity, and then you have the images, and the AI is making a correlation between a particular image and a particular value in the model, right? But it has to start with some reference location. And as long as it has that initial spatial reference, right, then it can measure the displacement of the pixels relative to that. And so you have a reference like, okay, the image is here, the acceleration of gravity is this. Now, we're going to show you all these images. How does the acceleration of gravity change based upon the images? And you apply the vertical displacement is because acceleration increases. And the AI just figures out what's the correlation between those two. That's what I was trying to tell them. You don't understand what machine learning is doing. It's just making correlations between two pieces of data. But you have to start at some reference, right? You have to start at some reference location so it knows how to make the correlation. And you could have literally stuck in any mathematical model of any phenomenon and told it programmed the AI so it said, oh, if any causal mechanism for the displacement of the pixels, right, up or down in the image.
Yep.
You literally could just said anything.
I choose women's feelings about the color blue presently.
You could actually do that, which is kind of scary.
So the more women who are happy with blue, the more refraction is present.
You could have correlated to the menstrual cycle, how many times freaking someone watches clown porn on Pornhub, like you could have done anything. The people don't understand like an AI, they're caught up in the hype, like this thing's thinking. It's not thinking. It's not doing anything. It's just like making a correlation and giving a probability on how two particular data points are correlated within their data set, right? Within the data set that it was fed. Because when you start increasing the size of the data set, values change, right? Or if you decrease the size of the data set. So it reaches different quote unquote conclusions. It's not reaching a conclusion. It's just, It's just a giant fucking lookup table.
So long story short, how this all works is you have a distance between point A and point B. You have the assumption of straight line rays, right?
Yeah.
You can't see the bottom of something, so you shift the rays down. You then assume a curved Earth horizon is blocking it. Then after that, when you see any observation in the real world that supersedes that, you then say, oh, well, maybe these straight line rays aren't straight, they're curved. And then you just draw curved lines. And you notice how all of this just occurred on a piece of paper and not actually out in the real world.
Yeah, amazing, man. It's amazing what you can make up in fiction. I mean, there's no difference between writing down a bunch of refraction equations and saying that's terrestrial refraction and that's evidence of it, than me like writing a book of fiction about wizards and elves. There's no difference. It has no relation in the real world.
What always got me is this idea of curvilinear graduations, right? And how they would apply these apparent straight line redirections of the light, because it seems like they would just be driven off rather quickly if you assume any kind of curved boundary. So you almost have to go into this infinite boundary. Do you remember that refraction model where it was vertical gradations from the target point to the observation point? And that's how you could get it to the light to go with, I think with Snell's law, maybe.
Yeah, well, yeah, what they use, like, yeah, it's like, I'll pick graphics. I mean, there's the best really way to just show it in images. Wherever the hell it is. Yeah, so I got, refraction. So we got this. So this image, right? So each one of these, this is how you would model Snell's law, right? You'd have a bunch of layers like this. If you look in live stream voice text, you have a bunch of layers. So it's like the how many layers do you want to use? Basically, you're like, how cheap is my computer? That's what you're asking, right? How long do I want the simulation to run? How cheap is my computer? And as you start adding layers, right? Like, it deflects more because it has like this set value. It's not like a smooth curve. And like, it'll approximate a curve, but that curve isn't going to look like the curve of the Fermat's principle. And like, I don't know what he didn't understand. Like, it's a divergent value, right? So say you compare them at like 110 kilometers distance, the divergence is going to be small. But if you have a longer and longer and longer optical path, the divergence becomes larger and larger and larger, obviously. It's not like a ratio. It's not like they stay like in this ratio. It's only 10% different forever. No, it's like the difference like increases over time. The divergence becomes greater.
Right, but
because the error accumulates, right? So the error, like if you were going to like, okay, this ray would hit at 10 feet versus 15 feet. Well, as you move down, right, because that angle is continuously changing, right, and they're not continuously changing the same, that difference compounds over time. Right, so now one ray is like shooting up at a 45-degree angle, and the other one's only going up at a 10-degree angle after some distance. Well, now when it starts like curving some more, it's going fucking straight up, and the other one's going up at 45 degrees. That's a huge difference. That difference went from 30 degrees to freaking 45 degrees. Right, so like I don't like he just didn't. I don't know if he don't understand or what the issue is. I don't think he wanted to understand quite honestly. Probably how I should have characterized it. He didn't want to know.
Yeah, well, he did call you a cunt, so...
Yeah, well, he could be right about that.
Right, but those are still horizontal gradations, not curvilinear gradations.
Yeah, yes, exactly. So what they're saying, like, with calculus, like, if you take an infinitesimally small straight line, it'll approximate a curve and yada, yada, yada.
For what?
You're hot, Wave Mixer, you're hot, dude. Your mic's hot.
Also note that, like, there's a specific angle here. They would require all these specific angles and boundaries to get things around the ball.
See, in Snell's law, you have to calculate where the light intersects, the angle that intersects the boundary, and then it bends towards the normal. So you need to know 90 degrees from that. That's what the normal is. The normal is in mathematics is called it's 90 degrees from a boundary, right? So that's the intersection point. So that normal in a gradient keeps shifting, right? So you have to keep calculating that over and over and over again, and then like to get to the angle of incidence at the boundary, and right, like one location isn't going to be the same as some other location, which is why they just use Fermat's principle, because it's just simpler. It's simpler, more accurate. It's just like, why would you use? They just don't use it. So like saying it's this whole shit about like whether the boundary is physically real, not in the application you're using it for.
Well, look at my picture there, man. Look at that picture. You see what I'm saying?
Yeah, man.
See where I'm going with this?
Yeah.
If you got curvilinear gradients, bro, your little 180 degree summation is going to take all that light and just drive it into the ground.
Yeah, man. It just ends up a mess. That's why they don't use, like I said, it doesn't sound redundant, why they don't use it. Like, they don't even think about using it. They know it doesn't work. They know it, like, you know,
right,
but for a long time.
And does nobody remember that vertical gradient thing where it says this is the way it would have to be, and it shows like it's black and white, and then it's got vertical columns, but they're splayed out in radials, and then it shows the path of the light going through. Yes,
Oh,
right
that,
there.
yes, yeah, Trace, you're the man.
Yeah, like that's what you need to chart it out nicely and spicely. Otherwise, you get
Cobra
my
say this is
picture.
wrong. Cobra say this is wrong because the gradient is radial, right? It goes up from the center.
Right, but if you have a radial, like curvilinear gradient parallel to the alleged curved surface of the Earth, then in my opinion, you get the nonsense that I drew.
Yeah, but your nonsense supports the globe, so it's obviously correct. Actually, it doesn't support the globe. I don't know what that supports. That supports insanity, I guess.
Concave Earth, welcome.
Oh, fuck, dude. banning you right now, man.
This was an elaborate troll to get you all set to the concave side.
Gandalf has entered the chat.
Wait, what's concave Earth?
Exactly.
It's a mental illness, man.
It's a joke.
Concave Earth is very simple. So go to your house or go to a store and look at a globe, and you're seeing a ball with everything on the outside of the ball. Now just imagine all of that is exactly the same, but on the inside.
Yeah, all the math works too. Yeah, the math works perfectly. You just add a negative sign to all the values.
I was imagining like a bowl.
It is a ball, but you're inside the ball on the inner surface.
A bowl, like we
A bowl? Oh, no. Oh, I mean, it's two balls upside down touching each other, and you're inside each bowl.
Well, there is a model of like that. It's what is it called? It's what the Brazilians did.
Oh,
what's the difference between hollow Earth and concave Earth?
Hollow Earth is Earth's the globe, but it's hollow on the inside, right? So there's like lizard people or whatever's in there, and then like concave Earth is where you're like, I don't know, held to the inner surface of a hollow sphere.
Yeah, it's basically concave Earth is you're on the inside of the sphere right now. Hollow Earth is like there's like a concave Earth on the inside of the sphere. Although there's also hollow Earth conceptions under like many different other conceptions. It's just
there's a bunch of hollow Earth ideas. Like they're pretty varied. Some think there's subterranean, right? So that there's subterranean stuff. Some think there's like there's a whole land, like a different, complete ecosystem. You know, so like
the concave also has different conceptions. Some of them are just like our ball wrapped on the inside, so we're just the same sphere, but just we're on the inside of that sphere. Others are just like it's a flat spot on a gigantic sphere, and there's a ton of them.
Yeah. So concave Earth versus globe Earth is globe Earth thinks your feet. Someone is antipode to you. Your feet are pointing at them, and in hollow or concave Earth, if you're antipode to somebody, your head is pointing at them. Your heads are pointing at each other. They're at the top of the inner sphere, and you're at the bottom. And what's in the center, the thing called the stars, right? The night sky, is also a giant sphere that is too big. That it's so big that you can't see that it's a sphere, right? So it goes all the way to the horizon. And that, like, when you travel, right? So if I, quote unquote, fly, do they even have a word for it? I can't say fly around because you're not going around anything. So what happens when you go, quote unquote, around the world in a concave, or what do you call it? Is there a word for that? Like, is there like a mathematical term? Okay, so so you can't, like, you go around a ball, but if you're inside the ball and you go, like, you're on the inner surface and you, like, trace a path on the inside, that can't be going around.
Yeah. It's called centrifugal navigation.
Going within?
Just like skimming the crust.
We call it in round. We call it in round. You go in round or
in round.
I don't know, man. I'm grasping at straws here, man.
So the Brazilians called theirs convex Earth.
Yes, that was it, convex Earth. Yeah.
I'll show you the picture. Since you're since you're gonna love it.
So also about the concave Earthers, they're led by someone. Did he pass away, Lord Stephen Christ?
Well, if he did, he certainly didn't rise again.
Well, I mean, he's like a paranoid schizophrenic perennial jail inhabitant that kind of like it's like cell Earth, concave Earth. So what they think is that the sky is a big giant ball that you can't see the edges of, but like when you walk around the Earth, you are basically walking around this ball thing. But the sky is projected from the Great Pyramids in Egypt. It's called the Black Sun, right? So the sky is the Black Sun, and the sun and the stars and everything are within it. So when you look at the stars, you're not looking out, you're looking in. Everything is backwards. Like I said, all the math is the same, just add a negative sign to all the values.
Yeah, but there's a big problem with negative curvature.
What's that?
I'll show you. 1 second.
Oh my god, that image is so cringe, man.
Dude.
That really is, man. That image is mad.
Dude, it's mashed potato Earth with blue gravy and a little parsley.
I know, man. There's some chives in there. Is that chives or parsley?
So a sphere with negative curvature. What is it going to look like? You guys ready? Hold on. I got to get the photo. Download. Now this is actually very relevant to what we were talking about earlier, which is the catenary curve problem. Because a sphere with negative curvature forms a catenary curve. If you take the two ends and flip them around, so you inverse the negative, and then you end up with a catenary. Here it is.
That whole debate was a train wreck, man. 100%. That's where I live, man. Ouch.
That, my friends, is a sphere with a constant negative curvature.
In 2 dimensions? How many dimensions is that?
3.
You sure there isn't a 4th dimension I can't see?
I don't know, maybe.
That's a black hole.
Yeah, that catenary curve thing, that was a train wreck, man. That was an absolute train wreck. Like okay, they pulled the string taut. Well, there's a catenary curve. Well, it was negligible. How do you know? Did they measure the string? No. Like, what?
How long was the string?
He said it was very slight, so there was curvature of the string.
Right, so he couldn't answer how long the string was, which means you don't know how much of a sample size it was of the overall structure, and he couldn't tell you how they affixed the string in free space, meaning did they just put two sticks in the ground and attach the string to two sticks? How did they make sure those sticks were level to each other? Because the whole point was, he claimed, is that they were referencing the curve of the Earth based on calculations that they were applying to the string, and then they were using a string as a reference. That literally makes no sense, unless you can tell me all the parameters of how the string is oriented compared to the size of the overall structure and at the 2 points, the two ends.
Well, let me talk about how much of a useless exercise that whole thing is, what they did. Now, let's say they did everything they said. They're going to make two tanks. They're going to make a tank where they think there's curvature and a tank where they don't think there's curvature. And then they're going to stick a toy model boat in there and simulate the boat's action through water on the ocean. Right? And then they're going to build a boat. And then they're going to stick the boat in the water. Right? They made one with the tank designed one way and one with the tank designed the other way. Do you think there's going to be a fuck bit of difference between those boats and the ocean that you can tell? Oh my God, this one's going 13.0001 knots faster. You wouldn't be able to tell the difference. It would be so infinitesimal because when you actually model fluid dynamics, the functions are nonlinear, so they normalize them. So there's errors that are greater. There's uncertainties within the mathematics that are greater than fucking their tolerance of their measurements by probably 100 orders of magnitude or thousands.
Yeah.
So the Navier-Stokes equation, which is about fluid dynamics, is a Millennium Prize problem. And if you can figure it out, if you can prove it, then you can have $1 million. It's considered the hardest one out of all of them, other than the Riemann. I mean, the Riemann one is thought maybe provable. The Navier-Stokes equation, because of the nonlinearities, is probably not provable, whether it's valid or not. But they use it to model shit within a range, right? They just basically clamp the infinities, right? Normalize the infinities, and that's it. But what I'm saying is that they didn't need to do that. They didn't need to do that. They didn't need to do that like engineering adjustment, because for practical purposes, he kept saying it worked. It worked to do what? Yeah, they made a tank, right? And they stuck a fake boat in it. Yeah, it worked. They didn't have to account for curvature to make a tank full of water and stick a boat in it. It makes no difference, right? Because what were they designing? A yacht or something, right? A racing yacht? Okay.
Well,
I don't understand what even the purpose of this was, because it seems like just doing it to do it. We got to publish a paper. Let's do this bullshit.
Assuming a curved water level and lining stuff up to it worked. Would it not have worked if they hadn't assumed the curve that they never measured or verified? What's his point?
Yeah, that's what I'm saying, man. That's exactly what I'm saying.
Yeah, they used
like when they built the boat, when the boat sank because they didn't curve the fucking tank 0.06 of a millimeter.
Yeah, that step is key. Yeah, you first have to imagine that there's 0.6 millimeter of a bulge, and then everything will work.
Yeah, and then everything will work, or your ship sinks to the bottom of the ocean.
No, but you got a good point, which is, I believe he read they used a bubble level.
Yeah, it said they used a master level, whatever the hell that is.
Yeah, it's probably the brand of level that they used. Which, by the way, you can only level with the precision of your ability to hold it level, and your ability to judge the bubble between the lines.
Okay.
So they're just using local water techniques or liquid leveling techniques, and then they're just trying to make it parallel to the water surface. That's pretty much all they're doing.
Yeah, well,
what else could they do?
They think that parallel. They think that they're trying to quote unquote level it to the water surface, but in their model, level is curved. So they have to curve the rail so that the rail is one height above the water, and that it has to be, for some reason, 0.6 millimeters different in the center than at the edges, right? So it has to have a 0.6 millimeter curve over this distance, whatever the distance was.
Right.
I can actually, and that somehow if they didn't do this, it would work.
If you intentionally put a curve that's higher than the base with the water, it'd be arced in the center.
Hey, what's up, fellas? Just trying to figure out why they would even do this. Like, what was the purpose? I really don't get it.
Like, if you have a 170 foot long piece of metal and you just go to the middle and jack the middle up, dude.
The tank is, so just to tell you, AI, the tank is 138 meters long and 3.5 meters deep, which corresponds to 3,000 cubic meters of fresh water. Despite appearances, the bottom of the tank is flat. And the maximum carriage speed was fixed at 12 meters per second, which is high for a facility of this size, but gives the ability to run a wide range of experiments. The dimensions were selected based upon the experience of university staff, past recommendations, and the site's physical limitations.
Yo, what are you talking about?
Yeah, we're talking about some corny ass dude that came in here earlier saying,
yeah.
So there's a tow tank, like it's a tank to model boats. It's like I was just describing its dimensions. And they claimed that they measured that they had to account for curvature to make this tank because there was 0.6 millimeters of curvature higher in the center than at the edges on some rail. And the rail had to be exactly the same height above the water. So they took a string and then they measured, they pulled the string tight, and then they measured and adjusted this railing to make sure that it was curved exactly with the water. Just, it's a bunch of horse shit. Anyway, we had someone come in, we were just like laughing at it, basically, at this point.
Yeah. Well, it is
that,
a joke.
Well, it is a joke because his argument was it works, right? So their design of their tank to test boats, it worked. Like, yeah, what if you didn't account for 0.6 millimeters of curvature and 153 meter rail? What would the result have been? Like, you wouldn't be able to design boats anymore, and like your boat would sink to the bottom of the ocean now because you didn't like account for curvature in your little tow tank. Like, you're being dumb. Just shut up. You're embarrassing.
You know what's weird is the last guy who came in and argued that, which by the way we have recorded, and you guys could go watch that if you want. It was much more technical, but his argument, I believe, was that the sled or whatever that pulls the boat wouldn't be able to ride correctly on the rails if they weren't perfectly, in tune with the curve of the Earth, to the degree of like what, a 0.6 millimeter or 0.06 millimeter or some nonsense, less than a credit card thickness, supposedly.
I'm reading like what was the justification for doing this. Like, I can't like find anything. Like,
I just can't believe that people still in 2023 people still think we live on a spinning ball. It's just crazy to me.
Dude, it's worse than that, man. The last week, man, we had 3 people coming in. I think it's a ball because of the authorities. After what just happened with that Mexican beer germ, why you're trusting the authorities is beyond me.
And they call us, conspiracy theorists and nut jobs. And no, they're the nut jobs for, they're just brainwashed. Like zombies. like the Night of the Living Dead.
Safety, man. They think there's safety in numbers, right?
Yeah.
So you ever seen the penguins in Australia? They like all huddle together, and like birds do the same thing when they flock. They all flock together because if they flock together, there's a probability you won't be the bird that gets eaten. It'll be some other bird. Because I've seen it, right? And, like where I live, there's pigeons that fly around in flocks. But when there's a hawk around, they go mad, but they stay in the flock. And you know, you're the bird in the flock. You're hoping I'm not the pigeon that gets like snatched by the hawk. Some other bird that's right next to me. So that's kind of like a defense mechanism that they have, right? Stay in the herd, right? And they do it with antelope, elks, bulls, you know, you name it. Go ahead, Trace. Sorry.
It's all
good.
good.
Say, I've been listening on YouTube all morning. I couldn't get in here, but I tell you what, it'd be more productive to shit in your hands and clap than listen to dogs all day.
Yeah,
that's how I feel. I mean, thank you.
Yeah,
that's
I like listening to India though.
Man.
But the thing is, they're the conspiracy theorists. They're the ones saying like, you shouldn't believe your eyes. Like you see the sun moving, it's not moving. It's trying to fool you. It's actually you that's moving. Like the Earth looks flat. It's just the light is all trying to fool you. The world is all just out there, out to get you. It's actually a globe.
I really don't understand this tow tank argument because all that rail is doing is towing a model boat. What is that boat going to, not float on top of the water? Is it, what's going to be the
I don't under... Yeah, that's what I'm trying to figure out by reading the document is why did they do this? Why did they go to all this effort? Because one way or another, it doesn't make any difference in what they're doing.
Dude, right now, brother, check this out, friend. I specifically told him because I said they parallel this with the water. Did I not say that multiple times? He said the tank is empty when they do this. I told him they have a leveling trough that runs along the sidewall, and they use that to level against the rail. Okay? He said, oh no, I said, I know that we did that in the other one that we did, right? He said, well, I don't know about this one. Now keep in mind, this is something he posted as proof. So let's read from it right here. The tanks are fitted with a small trough in the concrete. This trough was filled with water. 2 steel pins were precisely machined. A datum bracket was installed at one end of the tank to adjust the length of the pins, so their pointy end just broke the surface tension of the water. Another bracket was then moved along the tank to the desired alignment location. Each pin was checked and readjusted.
Was the curve, did I get it wrong, but was it like 0.6 of a millimeter?
No, let me pay attention. Pay attention. You ready? I'll read it for you. The rails must be aligned vertically to follow the curvature of the Earth, horizontally and in roll. In Southampton, the Sagataw for an east to west oriented tank of 138 meters is about 0.06 millimeters. That's an assertion based on the model. It's not a measurement that they did.
It gets better, AI. Read farther. Dude, this is hilarious. Listen to this, though. Sorry. The towing tank only has a walkway on its south side, so the north rail alignment had to be performed from a floating pontoon, which was complicated. Dude, I can't believe this.
I don't know. Anybody who works with steel would probably be able to tell you that, 0.06 of a millimeter was
over 153 meters, right?
Over
that's the span, right?
Meters. That's like their tolerances are higher than that.
Dude, that is a higher tolerance than CERN, probably.
Dude, look at this photograph of the pin system at the brackets. Look what they're doing there, bro. If you're looking, it's the brackets with the red thing and the 2 pin system. So the 2 brackets are at the joints of the thing, right? And so when those pins touch the water, they break the surface tension of the water. That means that the distance from that bracket down is correct. So they are just paralleling it to the water. Exactly like I said. What else could they do? How else could they have 100 and plus meter continuous level unless it was a trough of water? They also said in here that they couldn't use lasers to do it.
Yeah, I'm going to read that citation too. I'm going to find that. They cited something about them making a different tank in Australia. I want to know why they think they can't use lasers to do it. And now there could be reasons, right? Legitimate reasons, like inside. Sometimes you have differential heating inside of a building and stuff that will throw it off. Yeah. If you're trying to do a long span, I mean, you guys could do it incrementally, like you do in regular construction, right? You do, right? Like, I don't know. I have to read it. My God, dude. This is what passed us for a Glober citation. I swear to God, that dude was just Googling furiously. The most frustrating part is that he didn't understand what, like, when I was like predictive model, I'm talking about not Snell's law, not Fermat's principle, an actual model for terrestrial refraction as a phenomena, right? Not like the general role of refraction, right? That model, generalized refraction model versus a model applied to a specific phenomena. Like, that shit was going over his head, man.
They just try to talk big so that they sound important and they know what they're talking about. And then, as Miggy would say, they get their wig snatched. They like to compete. But not
That must have been frustrating to listen to, like, from your point of view, right? Like, when you're in it, it's a different thing. Like, dude.
I just want to get in there and tell him what a fool he is. That's all. I've had some experiences with this guy before, as well as heard a fair few debates that he's had, and I just can't stand him, to be honest.
Yeah, his debate techniques are like transparent, dude. Whenever he gets cornered, he starts talking about you or talking about flat earthers or start calling you dumb, right? So he just does this all the time. Or he postures and pretends like you don't know something and he did, or you're freaking like, but it's a pretend, it's a freaking ruse, right? It's a diversion, right? To take eyes off the topic. Look over here. No, look over here. Look over here. Just don't, like, how long did I talk to him? I never got an admission that there's no predictive model. I had to go through every goddamn iteration, right? Of just, like, you know, I call it like.
When it comes to where you are, where you're standing, what you're standing on, do you have any ideas around that? Like, what do you think? What do you perceive? What do you experience?
I think it's quite spherical.
What you're standing on is quite spherical. What leads you to believe that in your kind of everyday life, your experiences?
Probably from what people who know more than this have told me. Well, know more than me have told me.
Okay, so it's not anything that you as a thinking human being experience per se. It's just a story you've been told and you believe the story. Your everyday experience doesn't necessarily match that. Maybe it does, maybe it doesn't. I don't know. You could give me maybe an example of how your everyday experience would lead you to trust that story.
Well, it's just I'm taking somebody who knows more than me and has spent more time on this subject than me, his advice, like I do with everything in life.
Yeah, well, one of the things I do that earns me money is I'm an accountant, right?
Mm-hmm.
So you might trust me to be your accountant, but being an accountant, if I was not being a professional and not living up to the standards of the profession, I could probably figure out a way to swindle some money off you without you knowing, right?
Yeah, probably, but I'd say it's quite different than making up scientific proof.
Oh, so you're under the impression there's some scientific proof of what exactly? Because a shape claim isn't really science, that's more measurement, right?
Well, I guess more everything kind of fits and works together, which is what a theory is, isn't it? System of belief.
So when you say everything fits and works together, are you under the impression that there's some sort of scientific model or some working model of what may be portrayed to you as the Earth and the universe?
Talking model, isn't that called the heliocentric model?
Yeah, but we got to stop right there real quick before we continue. A scientific theory is not a systemized belief. A systemized belief is a religion. So if you're claiming that the globe is a system of beliefs, then you're basically saying it's a religion or a philosophy at best.
Well,
Continue.
kind of, but the definition of theory is a system of ideas intended to explain something.
Could religions be theories, right? Could we take any religion you want to pick, and could we say that religion is a theory as to God, a creator, a prophet, certain theological beliefs?
Yeah, I guess that makes sense if it's a system of ideas. Yeah.
Fair point. The problem is we're now all confused. Because you're starting by talking about science. And then you use the word theory, and then you give a definition that it doesn't have to do with science. A scientific theory is a specific thing, which is not the definition you gave or the explanation you gave.
Isn't science like, I don't know how to explain it. It's like proof, isn't it? Do you get me? It's facts based on observation.
No.
What is science?
Okay. Science in the way in which we're using science in this arena, right? When people say there's scientific evidence of the globe, okay? Scientifically validated evidence is about cause and effect relationships that are validated by experimentation. Okay, so a theory in a scientific theory comes after an observation of the natural world, a phenomena that occurs within it, a hypothesis about if this occurs, then maybe it causes that phenomena, the effect. You then have a rigorous, you then have a rigorous experimental phase of validation that will either validate your hypothesis or nullify your hypothesis. Once all that is complete, then you can start having a scientific theory. So that being said, since you use the word science, where is any of that for the idea that the Earth is a globe?
Okay, so first of all, I apologize for saying science is. Yeah, I mean, sorry, as far as a religion is a theory, I'd say it's more of a hypothesis, then, isn't it?
No.
Because if it's so with that, why is I'm a bit confused with that? Because like, wouldn't it be a hypothesis because it's what you think is happen, like what you think, but you haven't observed it yet. It hasn't been tested.
Not in a scientific sense.
Same thing you're talking about.
It's just an idea.
Yeah, exactly. Hypothesis.
Right, but you see, a hypothesis in regards to science is a specific thing. Just because it's the same word doesn't mean it's the same thing. You know, in
Oh,
general
it's an
common
idea.
language, yes. So in general common language, a hypothesis is just the underlying belief, right? Of why you hold a proposition to be true. That is not what a hypothesis is in the scientific method.
What is the hypothesis?
It's a specific if-then statement that's validatable. For example, if 180 degrees Fahrenheit applied to water, then water boils at sea level, right? And then you can validate that by demonstrating it. So, for example, let me give you an example of something that doesn't apply. Okay, there is a blue knife on my table, right? Not a scientific proposition. It simply is the case that there's a blue knife on my table.
Yeah, because you observed it.
Yes, directly. The object in question is directly observed. There's no causal relationships required, right? Now, I want you to ask me questions about my knife.
Okay.
So ask
There's
me
your knife.
questions about it.
What questions do you want about your knife? Is it sharp?
You think of the questions. You think of the questions that you would need to ask to divine what it is, because it is a knife of a certain type. So start asking questions like maybe the size of it.
Okay. How big is the knife?
7 inches long. Okay, stop. Don't continue. Did I need to do any science to get that answer?
You need to measure it.
Oh, there you go. All right. I pass it to my friend who was talking to you earlier.
Okay.
Is that my cue?
I think
You
so.
can take a napalm.
Sure. So, yeah, the measurement isn't science, right? Is that what we were just talking about?
Yeah.
I thought it was a part of science.
It's not. Measurement is just measuring something.
Yeah, it can be a tool used in science, but it wouldn't be science itself, right?
So it's to measure. I'm a bit confused. So it's part of science, but it's not scientific.
Yeah, so like AI was saying, in this realm, right, in this arena, we talk about science, natural science, which is the study of the natural world through experimentation, right? So we observed something in nature. We observe an effect, right? So let's go back to when he was talking about water and heat. So you and I are walking along and we come upon a boiling pool of water. We've never seen this before. We look at it and we're like, oh, wow, this water's boiling. And then we come up upon it and we realize there's steam, and we kind of touch it briefly and we realize, oh man, this is hot. This feels exactly like the fire back where we came from. I'm wondering what's going on here, right? I feel heat within the water and I see it boil. So maybe we could form some sort of hypothesis as to why the water is boiling. Maybe it's because of the heat. So we go back to our campsite and we try this. We take some water, we put it over the fire, and it hits a certain temperature over time, and it starts to boil. So we can do this over and over again, and it's repeatable. So we have a variable that we're manipulating, which is the heat. We're putting the water on top of the heat, taking the water off the heat, stops boiling. So we're manipulating a variable that we think is the cause of the effect that we're seeing, which is the water boiling. So then we come to the scientific theory that heat causes water to boil. And we've demonstrated this through experimentation, right? So the key to all of this. Now, if we saw from a distance, really far off in the distance, a pool of water that seemed to be boiling, but we had no interaction with that pool of water, and we just started coming up with ideas as to what may cause that water to boil. If we don't touch that water, or we don't look at that water, or we don't try to take water ourselves and figure out what can cause this boiling, do any of our stories that we may come up with as to what is causing the water to boil, do you think any of those would be relevant?
It would be a hypothesis.
So let's say you have a hypothesis. So we're viewing this water that's boiling in a distance. We've never seen anything like this take place before. We're familiar with regular water. We've got some around us. What is your hypothesis as to why that water we see in the distance is boiling?
Because it's warm.
Let's come up with another hypothesis as to why water is boiling. We have no idea. We've never seen this take place. We would have no inkling or indication as to what may be the cause. Throw out an idea.
I have absolutely no idea why water would be boiling.
Well, we could maybe we could say that we think that there's some sort of entity or being that lives within this water that is somehow below the surface, which is causing this thing to take place, right?
Yeah.
Well, we'll make up a name for it. You pick the name.
It's unicorns.
Okay, so unicorns.
Read that in the chat, you copper. You want to cheat.
So our hypothesis is that we've got these unicorns, whatever these may be, that are underneath the water that are causing this agitation that we see that looks like little bubbles. Now, what would be the first thing we would do to test this hypothesis?
I would try and see if we can find these by ourselves. I'd try and observe one of these little unicorns.
Right. So we never experience these unicorns. We don't see them. We have no viable reason whatsoever to believe that, one, these unicorns even exist, and two, that we would have the ability to find them, and three, that maybe if they got in the water that they would cause this effect.
Rule that hypothesis out. It's not true. We cannot observe it.
Right. We haven't observed it. But if we have no other viable hypothesis, can we just claim that since that's our best hypothesis, that it must be true? Nobody else has come up with another one. You can't think of another one. Nobody has done any experiment with water to figure out what may cause it to do the thing that we're seeing off in the distance. But we have this postulation that it's unicorns. And then everybody starts to catch on to our story. We start talking around town. Yeah, you know, that water off in the distance that we can't get to, but we see it and it boils. Yeah, it's these unicorns. Really? No, yeah. And then we start coming up with more stories about the unicorns, the color of their fur, how they can breathe underwater, all kinds of different things, right? Now, if we tell these stories, tell these stories long enough and nobody ever actually touches the water, goes to the water, tries to do any experimentation whatsoever regarding the water, does that make our theory, because it's the only one that we have, a viable theory?
It's the right hypothesis. Well, I mean, it's the wrong opinion, but
well, we haven't proven
it's the wrong hypothesis,
right? because we haven't done an experiment. That's the whole point. We need to do an experiment in order to come up with a viable hypothesis, right?
Or you could observe these unicorns.
So let me ask you a question. When it comes to what you believe in, the heliocentric model, globe Earth, all of this stuff, has any of it been scienced? Is any of it
been
even a
observed.
question of science? So it's been observed.
It's been observed.
Right. So
Yes.
what in particular has been observed?
Curvature.
Curvature's been observed. Where is this taking place?
What do you mean? I don't understand.
Where and who has seen curvature?
Every person that's, I can't remember the exact place. You know, every person that's ever seen an image or a video from above.
Every person that's watched TV.
Okay. So we got an
every
image.
person that's seen an image or a video. Well, if you photograph one of these unicorns, you would have proven to see the unicorns there, and you know.
Right. So
You've
you're
observed
under the impression. So you're under the impression that we have a photograph of Earth from space.
Seems quite likely to me.
Seems quite likely, but the funny thing is, it's 2022, and we still don't have one. Why is that?
I'm back.
Did you hear me? It's 2022, and we still don't have a photograph of the Earth from space. Why is that?
I don't believe you.
Where
Can you provide one to me, or have you seen one? Could you give me an idea of an image?
Blue marble.
All right. Blue marble 2.0. That's a picture of Earth from space. I'm sorry. What was that?
I believe so.
You believe so? Do you know so, or do you believe so?
Doesn't seem very. It seems quite credible.
Seems quite credible. Okay. Well, what if I told you if you go to the NASA website, you can find a data visualizer named Robert Simmons, who has also been interviewed on a radio show talking about how he created the blue marble image. So what he did is he took strips of high altitude pictures and took that flat map, wrapped it around a ball in Photoshop, and then started coloring it in. He put in the clouds. He talks about how he made the colorations within the oceans, how he made it a little bit more green in areas that they had sensors that sensed more phytoplankton in the sea. He decided to use that data to color those parts a little more green, right? So the interviewer even asks him, so there's artistry to making the Earth. And one quote that Robert Simmons has is that he says, it's Photoshop because it has to be.
I'm reading this.
Did you find Robert Simmons on the NASA website? You can read it all.
Yeah.
I'm not reading.
Yeah, while you're reading that, so you might say, oh, okay, that's not a photo. But the Himawari 8, that's a photo. And that came after the Blue Marble. And it's a satellite. Right? So in the modern day, they put up a satellite called Himawari 8, so they say, with the intention of taking photographs, right? Because they realize nobody's buying their other fake nonsense that's not a real photograph. So lo and behold, people believe that the Himawari 8 is taking a photograph of the Earth every 10 minutes. Come to find out, the Himawari 8 is just overlaying the blue marble data set that Simmons created with NOAA data, which is weather data. So it's a simulation. It's not a photograph. So again, like my friend said, where is this alleged photograph that everyone has seen?
It says here that in 1972, during Apollo 17, that was the last time someone took a photograph from above low Earth orbit.
1972. That's the only alleged photograph.
From what this is saying, from whenever this interview was out, 2004.
So it's 2022, and the only photograph that's ever been taken of the Earth from space is from 1972. Do you believe that?
From low Earth orbit. According, so it shows the entire hemisphere.
It's from they were going to the moon, they claim, and that's when they claim to have taken the picture. But NASA admits today that they cannot cross through the Van Allen radiation belt. They would kill anyone who would try. So they cannot send people beyond low Earth orbit or to the moon.
What? So apparently,
so that's why they couldn't have taken that picture. And even if you watch the documentary, a funny thing happened on the way to the moon. The tapes from when they were faking that actually showed more and were leaked and found and were shown in that documentary. So you can see exactly how they faked that picture as well.
Right. So what we're telling you here, my friend, is that the only photograph that everybody's seen is scandalous at best, unvalidatable at worst. So again, where's this supposed photograph that everyone has seen?
According to what you said, there isn't one.
Oh, there you go. That's the answer.
Well, I find it hard to believe, which I'm sure is quite normal. Wait.
So you think it's rational to believe that the only legitimate photograph happened at the beginning of space exploration, and since then, not one has been duplicated by an advanced system? You think that's easier to believe than just to believe that they can't take a picture because they can't get far enough away to take a picture? Just like our other friend just told you, they admit that they're planning missions to go past low Earth orbit, past the Van Allen belts. It makes it sound like, wait a minute, didn't you already go past the Van Allen belts? I mean, if you're a wise person, my friend, and you think self-reflectively, all that sounds pretty scandalous, don't you think?
Well, I don't think we've really have people really been past low Earth orbit since the end of Apollo. No, not really.
No, they never went past it. They never went past it, my friend. That's the point.
Yes.
Allegedly.
What he's trying to say is in the Orion project, that's NASA. They admit themselves, just like he said, that until they fix this problem of going past the Van Allen belts, they cannot go past low Earth orbit. We're using the globe experts, NASA. They're telling you the truth. They can't go past. That means they never went in 1969 to 72, ever. They never went.
What? So they said they went, but then they said, for some reason, I don't think they do that.
Yeah, they said they went a long time ago, and then they realized, oh, the radiation would actually be completely lethal and can kill anyone who actually tries. So that's why anyone now cannot go. And for the last few decades, no one has been allowed to go because it's deadly. You can't go. It'll kill you. We don't have any shielding that'll protect us, so we can't go. That's their excuse right now.
All right, fair. However, the pace is getting too frenetic. Okay?
Right.
People are interrupting each other, and that's causing people to create a fog of war in their mind that they have to talk faster, and it's just going to escalate. So I'll take a moment and breathe, and then continue.
So, Laundry,
Yes.
Is this new information to you that the Blue Marble 2.0 is not an actual picture, right? The only claimed pictures from 72. And there's certainly some issues around whether any of those missions did or did not take place, certainly because NASA's excuse of not going back is they're trying to figure out a way to get the proper shielding and protection against the radiation so people don't die going past low Earth orbit, right? So you said something not too long ago where you said something along the lines of this information was hard to believe, right? It's hard to believe that maybe what you thought were real pictures actually aren't. Are you just kind of trying to process that? Are you coming into the realization that maybe what you thought you believed before was proof is not actually?
It says here that the last photo taken from above low Earth orbit was the pale blue dot, right? Taken in 1990, which would make more sense. Yeah.
So Voyager,
which isn't a manned spacecraft. So that makes a lot of sense.
No, it's an alleged space probe, which, if you believe it or not, is still up until, I don't know, when was the last transmission we allegedly got from Voyager? Within the past 5 years, I think. We're still allegedly receiving photographs from this alleged space probe that was sent into orbit.
I don't think we're receiving photographs. I don't think we have since the ones. But
maybe it's Voyager 2 that's still providing images.
The last photo from Voyager was 1990, pale blue dot.
Okay. So take a look at the pale blue dot. What does that tell you? That
what's there?
Does that give you any indication as to what you're even looking at in that picture? Have you seen the pale blue dot?
I don't think the quality of the image is very, I don't think it's like why does the quality of the image matter? You know what I mean?
No, like if I handed you a photo that looks similar to that, right? If not the exact same photo, and I drew a little arrow on it to one of the more lit places within that image, and I said, this is Alpha Centauri. Would you just automatically believe that? If I drew the same arrow to the same pale blue dot and I said, this is Alpha Centauri, how would you know or verify, or what would give you any indication, even looking at that photograph, that that's Earth?
Well, I wouldn't see a reason for you to say that it's Alpha Centauri. And surely if you did, you would try and make it a bit more believable by maybe putting some sparkles or something around it. Yeah?
I don't know if sparkles would make it more believable. It actually would make it look more fake. But either way, man, looking at this pale blue dot image, does that make you think that that's where you live? That that's a picture of where you live?
Yeah, I don't see why they wouldn't.
So what on Earth itself, aside from you believing pictures that are shown to you, which we've already proven, the main one you thought was proof of where you live and the shape of where you live, was a utter fabrication. So what on Earth here, the ground that you and I are both currently standing on, indicates that you live on a globe?
Because that has no reason. Like what? So, wait a minute. Say that again. Sorry, really, I'm tired.
Yeah. So what here on Earth gives you any indication, you personally, any feeling, any observation, or anything that you see in your daily life looking around you would give you any indication that you live on a ball
Well,
that's spinning?
nothing, but it's the same for the other way around. There's nothing that gives me an indication that it's flat as well, because it's quite hard to observe that.
Sure. I mean, I observe it all the time. I live near water, right? So I see very far. Looks very flat. When I go over, across this very large bridge in my area that's tall enough for cruise ships to get underneath it, and I look around, everything that I see around me indicates flatness. No indication of curvature at all whatsoever.
But can you see those ships forever? Like, can you see them go forever?
Forever? Do you think you can see forever?
Well, I'm sure the higher up you are, the further you can see.
Okay, so if I had a penny in my hand and I was standing on that ship, would you be able to see the penny?
Ships are quite large, and you can.
How far away do you be able to? How far away do you think you'd be able to see a penny?
Oh, I don't know. About.
According to you, forever, right? Forever.
What?
If I just went straight up in the air, would you be able to see a penny that I was holding in my hand as I continued to increase in elevation forever?
If I had a telescope large that could magnify it a significant amount.
Okay, so let's even say that the moon is as far away as they claim. Could you see a penny on the moon?
If I had a significant enough telescope, probably.
There's not a telescope good enough in the world to be able to see that.
What? Well, yeah, obviously.
So when the ships go off in the horizon, you don't have a telescope. You have your human eyes. With your human eyes, would you be able to see a penny on the moon?
Well, no.
Right, because you can't see forever.
It's different,
right?
Perspective.
You
things
understand that
things shrink.
Things get smaller with things shrink as they get further away.
There's a difference between a ship dipping under the horizon and something shrinking.
Yeah, can you explain to me the difference?
You can see the ship get lower, and if you go up, you see the ship again. If the penny was at the same distance, if the penny, that it doesn't matter how high in elevation you are, you'd still not be able to see the penny.
So as the ship moves away on the sea, wouldn't you expect it to get lower because it's getting smaller as it moves further away? Or would why wouldn't that be your expectation?
What? Sorry.
Why wouldn't
the
that
ship
be
is
your
getting smaller, but not a significant enough distance. It's not a significant enough distance for it to be any. I don't get what you're asking here. Sorry, it's quite late.
Okay.
Well, you say these ships go over the horizon, right?
Yes.
So ships get further away, they get smaller and harder to see. But there's also a ton of different things that take place in the atmosphere.
Yeah, so I have a question. Because he's saying if things get lower in your field of view, I guess the insinuation is that they're going over a curve. So I'm in my house and my ceiling is getting lower. Is it going over a curve?
What do you mean?
Well, I'm looking at my house, and for some strange reason I just can't understand, rather than my ceiling being straight, it seems to be angled down in my field of view, as if it's going downwards. So I can't fathom it. I guess my house is built on a curve.
It could be. I don't understand the question. Like, is the
Yes, that's the point, my friend. My friend, the statement's incoherent. I know that my ceiling is straight and flat because I can measure the entire thing. So I know that the effect of it going down is not because of anything physical. It's all to do with optics. So why would you just jump to the assumption that if I can't see something or if something is appearing to go down, that it must be because of a curved Earth.
But don't you? I mean, I've never seen my ceiling curve, so I don't like.
Right, but you have seen your ceiling recede in your field of view on the y-axis. Yes or no?
Can you word that a bit more?
Let me give you a
understand.
visual here that
yeah, visual
yeah,
aid.
let me give you a visual you might comprehend. So let's say you ever been to a hotel.
Mm-hmm.
Okay. So imagine a hotel with a very long hallway, right? We know it's flat, straight, because they don't build buildings that aren't straight, right? So we're looking down this long hallway and there's lights on the ceiling.
Yep.
When you look down that hallway, does the floor appear to ramp up towards your eye level? And does the ceiling appear to ramp downwards towards your eye level as it gets further away?
Yeah, to a point.
Yeah. So in reality, is that ceiling that's above you physically going downward? Or is it just a matter of your perception due to perspective?
No, but I don't think that's a large enough scale to see. Like the hallway would have to be quite long, wouldn't it?
Wouldn't even have to be that long. I mean, that's what you
to
see.
be able to see it. Well, yeah,
Have you ever been in a hallway where you don't see the ceiling appear to come towards your center of view and the floor appear to go up towards your center of view? That's how you view everything. Always. It's perspective.
Well, I don't think there'd be the hallway long enough to show it not. You know what I mean? Like, unless the hallway is like, you know, so if you had a hallway that was from where you are standing to the ship that could be really far. I don't know how far ships are bend across the horizon. I'm not sure about that.
Dude, if you had a hallway, so let's talk about that. If you had a hallway, if you look at the live stream voice text, you'll see an image of a hallway that's running as a GIF, and you'll see the effect in question. Okay, so if you had a hallway, the length all the way out to a ship where a ship starts to disappear, you know, which is roughly 3 miles, 3 to 4 for a 6 foot tall observer if he was on the shoreline. If you were looking down that hallway, right, after a short while, the rest of the hallway would be unresolvable. And all you just see is that everything converging to a point, and you'd be impossible to see the rest of the hallway.
I agree with that. But
right. So if you then remove the hallway, does the same angles of light not apply anymore?
The ship isn't the same as a hallway because
why not?
The ship is a point, if you know what I mean.
Right. So remember what I just said.
You know what I mean.
Remember what I just said. The angles of propagation within the hallway, and the angles that they enter your eye or the optic, right, are at too small of an angle to be resolvable on the hallway, which is approximately the same height as a person, right? And all of the information from the end of the hallway recedes into a point. So if you then remove the hallway, would not the same thing be happening to the portion of the ship that occupies the same space as the hallway, being approximately 7 to 8 feet tall, standard hallway? So at
isn't a ship bigger?
3 miles. I'm talking about the portion that represents the same scale as the hallway, like I just said. 6 to 8 feet.
But how am I supposed to see that point from a ship that's far away? I wouldn't be able to see that.
You got it. So what you would see by what you just admitted is you wouldn't see the portion of the ship that represents the same scale as the hallway, but you would see the portion of the ship that is much bigger, being the top. So by your own admission, you generally conceded that the bottom of the ship would disappear due to the laws of perspective alone.
The point of the ship that faces. You know what I mean? Like the point of the ship that is level with me.
Right. That
Because
part's going to disappear.
obviously,
first.
obviously,
just think-
the whole length of the ship isn't the same size as
Yeah, no, but
the
think,
whole.
think about this. Think
Stop
about this.
there
The
for a second.
ground.
Hold on. Stop there. Stop there real quick. Because he's saying something that most climbers don't get, and that it's worth noting. Okay, the whole ship represents a certain angular size, but each portion of the ship represents a different angular size. And the smaller portion at the bottom of the ship subtends a different angle than the whole ship. And due to the law of triangles, that angle is going to be smaller. And since we see in angles, once the angle gets too small, we won't be able to resolve the bottom of the ship while still being able to resolve the top. Thank you for being one of the first people to get that without having to go for 2 hours. All right, I yield the floor.
Yeah, that was a really good point. Just think about it for a minute. If the floor all the way up to the vanishing point, and at the vanishing point, that's where you can't discern the floor anymore. Of course, his feet or the bottom of the ship at that point cannot also be discerned when it's connected to that point on the floor. Do you get that?
Oh, wait, so you're trying to say that it's like a plane? Like, I don't know if, like, so every part, so, right, so every part is the, sorry, I'm a bit, you know, like, I understand what you mean, but every part of the ship. Sorry about this. Can you just
Yeah, so
say it?
think of it this way. If you had a smaller ship, like a dinghy, just a little boat, that was tied to the side of that ship as it goes away so that you can see it. And you see this little ship. Now, if you removed the big ship, you understand that that smaller ship is going to visually disappear at a shorter distance than that large ship because it's a smaller object, right?
Got less height.
Yes, less height. So you would expect the little dinghy to disappear before the large ship, solely just based off of its height, right? Because you understand perspective works. The angle is going to be too small for you to resolve that small ship first. Now imagine tying that dinghy to the large ship and sending it out. It would stand to reason that that small ship is still going to be unresolvable at the same distance, regardless of whether it's tied to the ship or not tied to the ship, right?
Agreed.
So as that little dinghy disappears because we can no longer see it due to angular resolution limits of our eye, it's tied to the ship. Wouldn't it stand to reason that the whole entire portion of the ship that is that height would also be unresolvable?
Yes, because in my opinion, it's gone under the horizon, but I understand what you said.
Okay, perfect. So your claim would then be that the only reason that things disappear from view is because they're being physically obstructed by Earth curve. Would you agree with that?
Yes, on long enough distances.
Okay, perfect. So now I do this on the regular. I go to my little lake, 333 meters across from the observation point to the observation, which is a yellow floaty boaty on the other side. Okay. Now you put that into the mass of the alleged curvature of the Earth, and you will find that the heights that I observed at, there is no way that the Earth curve, if it existed at all, could be precluding that boat in totality. Okay. So this means that it's not geometrically possible for the curve of the Earth to obstruct that boat. Yet, okay, 9 out of 10 times I go, pretty much consistently, the entire yellow boat disappears. So, my friend, what is causing that to happen?
Sorry, so look. So it's 333 meters. Right.
Mm-hmm.
How big is the boat?
About
How
half a
tall
meter,
is the boat?
1.5 feet. About 1.5 feet tall.
Okay, well, let me do some maths. So how many? Sorry about this.
Just doing the math off the
Sorry
top
about
of my
this.
head. No portion of that boat should be hidden. And if it is a portion, it's such a small portion that you wouldn't be able to notice based on the Earth curve calculator. Because that's what, about a quarter mile?
Right.
It's 1.2 miles. No, sorry, 0.2 miles.
Quarter of a mile.
Yeah, 0.2 miles. Sorry. All right, so
So
then
do
that
you know
would
what
be
do you know what the alleged
inches
drop
per mile.
over 8 inches per mile squared, right?
Yeah.
Right. So
Yeah,
that would be
so-
at the surface.
So then it would be like 1.6.
1.6 what inches? Would be
probably,
the
yeah.
alleged hidden height due to the curvature of the Earth, allegedly.
Mhm.
So when AI said he goes out, and 9 times out of 10, the whole entire boat disappears. Why? Is that Earth curvature? Do we have a tiny Earth, smaller Earth?
That'd be funny. Probably not.
I'm so glad
Yeah,
you said
there's no reason.
Right. So
There's
then
no
what
reason.
must be the reason? Okay. So it looks like it's happening. So what must be the reason?
The only other hypothesis you've given is that whole stuff about vanishing points.
Well, let's just be more broad, just for fairness sake. Okay. It's not because of geometry. It's because of an optical effect of some kind, whatever that might be. It's no longer in the category of geometry. It's in the category of optics, correct?
Yes.
Exactly. So now that we've agreed that the bottom of things can be missing, or an entire object itself can be obstructed without the necessity of Earth curvature in the way, we can now make progress.
Oh, sorry, I'm sorry, it's really late here.
Now,
I'm
I
sorry,
want you to realize that that's a necessary concession that you made because it's obvious, because it's observable, that it is not true that the only way for things to disappear from the bottom is because of Earth curvature. So that's a false statement.
You've proven that to me.
Yeah, I just did, and you conceded. So if you retract now, it just means, right, yeah, you're fair, exactly. Now, you might argue that those effects are this or those effects are that, but we know for certain that it falls in the category of optical effects. So now, since we can't do this for real right now, we're going to do this in our minds, right? And mental experiment, okay? So, well, first let's preface this. Do you know that the optical device, whether it be biological or synthetic, has a limit to it, known as the angular resolution limit? Everything that has an angular field of view has this limit. It's just that simple. It's a hard physical limit, known as the Rayleigh criterion.
Heard of it.
Yep, it's known as the Rayleigh criterion. So for the human eye, it's approximately 0.02 degrees. Okay, what that means is that any light from the source that enters below that limit will be interfered with by any other light that enters within that angle. and therefore there will be no resolvable information, and it can at best be only rendered as essentially, for lack of a better term, 1 pixel value.
Isn't
So
that
you imagine,
resolution?
yeah, 1 pixel value meaning 1 element, right? 1 element of the total picture that you're seeing.
But
so in that area,
everything have different
in that angular
resolution?
area,
Sorry.
no. This is angular resolution, not pixel density. So for example, if you only had 4 pixels in your sensor, right? If you literally had only 4 pixels in your sensor, you could never render something that requires 10 pixels to render, correct? It would look like blurry nonsense, would it not?
Yeah.
Exactly. So now you fully understand the principle. So if you imagine a man standing on a line looking out, right? And these radials, right, of angles emanating from his eyeball, you can imagine the 0.02 degree triangle coming out from his eye and going out along the horizontal line in front of him until it intersects the horizontal line. So you have a triangle, right? And I want you in your mind to color that triangle red. Now, everything that enters that triangle must, of a necessity, render as 1 color value in the final image, which we've already agreed. It just so happens that if you take the time right now to map this out, it pretty much coincides with where the alleged horizon is for a 6-foot-tall observer. The triangle hits the horizontal line approximately at the same distance. Very coincidental, don't you think? So principally, we know this to be true. So, for example, let's say that you're standing over water, and then you have a brick, but it's not a solid brick, it's a floaty brick. And let's just make it red, because red is very bright, easy to tell apart from blue. So if you take said brick, and we've already established that this water is horizontal, okay, it's not curving in any way, it's perfectly horizontal. That's the premise. You might even imagine that it's a floor, painted blue rather than water, make it easier. So you take said red brick, put it on the floor, and you have your friend start to walk away from you. Now, as he keeps walking away from you, something interesting is going to happen. Eventually, you will not be able to see the color red anymore, because the red and the blue simultaneously will occupy less than 0.02 degrees. And as they approach that towards 0 degrees, the blue and the red will meld together into purple. And then it will meld together to where you only see the air and the blue floor, and you can't even tell the purple anymore. Now,
That makes sense.
let's just say, for example, that you call your friend, you say, okay, I can't really see the red thing anymore, so you can stop pulling. And your friend goes, okay, and he stops pulling. Now what your friend does is he calls his other friend, who brings over a truck full of red bricks, and he starts stacking the bricks on top of the previous brick that you can't see. He stacks 1. You start to see a very faint purple. He stacks 2. The purple intensifies. He stacks 3. You start to scratch your head and say, I'm starting to see red. He stacks 4. Now you see some more red. He stacks 5, 6, 7, 8, 9, 10. And now you see a line of red. But when your eyes trace down this line, as they get closer and closer to the floor, eventually you cannot see the bottom of the stack. It has become unresolvable. It has disappeared. Rest assured it is there, and it is the bottom portion of the stack. But the stack in total has disappeared from the bottom, has it not?
I like that. I do like that, you know. I
Now,
really do
this
like
is a
that.
necessary, yeah, you're right. And this is a necessary consequence of the way our eyes work. And and all optics with an angular field of view, by the way. In order to see without perspective, truly, you need to have a lens the exact size with all available propagation angles to a parallel rate to the target source from the object. So if you wanted to observe a 100-meter building, you need a 100-meter lens, not an angular lens, but a straight lens that only allows the light to pass collimated, parallel, and horizontal to the sensor. So you need a 100-story tall sensor and a 100-story tall collimated lens. Okay, these types of optics don't exist. So every observation that we make is through an angular field of view with these limitations, in which we already have said that because of optical phenomenon, the bottoms of things can disappear. And that's just the facts. All right, so with that, I rest my case on that, unless you have any questions specifically.
Why would you need a 100-meter lens to see a 100-meter thing?
You need a 100-meter lens to see a 100-meter tall building without the effective perspective, and it needs to be a collimated lens where the sensor exists parallel to the light coming from the object.
Like a mirror.
So if you don't have such a lens and you use normal lenses like your eyes, you'd be standing on the ground, right? And the angles of propagation from the top of the building would be at a downward angle towards you, forcing all of the light from the propagation angles to enter at essentially inverse angles after they pass the lens, and that's what creates the effect of perspective. Is that you see
imagine like a mirror. Oh, this is right. I imagine like a mirror, right? Okay, and this mirror is the same height as something. Yeah, right. So it's like a mirror, if you know what I mean. It would work like a mirror.
Yeah, well, the problem is that mirrors suffer from a perspective as well. If you stand in front of a mirror and start to walk away from it, does the image that appears to be you not shrink in size? Of course it does.
Yeah, because that's your eyes. It's not the mirror.
Right, because your eyes are getting the angled light, not the straight light, not the direct one-for-one parallel reflection that's going back in on itself. Now you get it.
There's also another way to show it. The ancient Greeks, of course, didn't have any fantastic telescopes or anything. They just looked at the horizon with their eyes, and they drew on a piece of paper and used orthographic view to assume that the horizon was Earth curve. So in orthographic view, things don't get smaller with distance. So the mountain is just as tall angularly in their idea, in their math, but that's not how it is in reality. It's actually tiny in reality, and so when they compare these pictures from reality to their math or orthographic side view, which they got from the Greeks, they're actually just taking perspective and turning it into Earth curve and assuming that the horizon is this start of this Earth curve. But there's no evidence to actually substantiate that.
So with telescopes, you have a more resolute lens, not lens. You know what I mean?
Yeah, with a bigger aperture, you can see further, like in the Black Swan images and other such things. That's why we use telescopes, to see further. And then if you use a very small aperture, like we did with the pond tests and other stuff, such things, we can see that the horizon appears much closer and things disappear over what should be a flat surface. According to the globe mechanics, these bodies of water should not have enough convexity to hide these objects, but it does happen on the smaller aperture cameras. But on the bigger cameras, you can actually see the boat still. So it is optical. There's no Earth curve here.
What's Black Swan? I know what a Black Swan is, but what is Black Swan experiment?
black swan is not an experiment. It's a reference to the Karl Popper's falsification, and he has a story that goes with it. You can say that all swans are white, and people can just accept that. But if you find a black swan, you know that all swans are white is just wrong. There are black swans. So that's what we find. We find black swans that show that all swans are not white. And so the black swan image is just what this image was called. It's two oil rigs taken. A snapshot taken from a video where he lowers the camera 1 foot off the surface of the water. So the horizon should be only 1.22 miles away on the globe, but we can see the horizon way past the second oil rig. So that's over 10 miles. The size of that globe is completely unsustainable, so it just doesn't work.
Black Swan.
Excellent.
Yeah, well said, Grace. Go ahead.
So it's basically just a proof, a contradiction.
Yeah, we're comparing the claimed globe geometry to reality, and it doesn't hold up. But you can go check it yourself. You don't have to just believe anybody here. You really should go out and see if you can test some of this stuff on your own. If you have a body of water nearby that's like 5 miles big, maybe bigger, that's a good start. Next time you go on vacation to the beach or something, take an Earth curve calculator with you. See if you can do some long distance observations. This is the kind of stuff you don't want to just leave this Discord and be like, well, these guys on Discord told me it was flat. Like, you want to go out and check for yourself. So, there's plenty of resources for you to be able to go out and do that. And if you need help, we're here.
Okay, so let's establish where we've come from so far. We've conceded that the concept that the Earth curve is the only reason why things disappear from the bottom up is false. Right? Now we've been presented with the black swan, which is a premise, right? In a sense. That premise is that if you can disprove a certain proposition by providing one counterexample, that negates the proposition, and the proposition isn't true. So the proposition in the idea that we already agreed to isn't true is that the horizon is a hump of Earth curvature between point A and B that's blocking the bottoms of things. Now, we've already agreed together that that's not the case. Now, let's talk about the black swan. In the black swan photo, the horizon, as you can clearly see by looking at the photo, is beyond the oil rigs. Right? The oil rigs are at 9 miles, respectively, between the other one and the other one. There's approximately 9 to 10 miles from the shore. This means that the horizon is greater than 10 miles. We only know this because we see the boats. Sorry, not the boats, the oil rigs. So we know the horizon is beyond 10 miles. And as he said before, it must be, if the Earth is a globe and if the horizon is a geometric hump of Earth water, right, that's curving and getting in the way. From the observation height that the man observed this, it should have been at 1.225 miles. It's not at 1.225 miles. So the necessary conclusion is that the horizon that you see is an optical phenomenon, not a geometric edge of Earth hump curved water. Now, in summation of all of this that we've already discussed and you conceded to, okay, is that there is no hump of Earth curved water blocking the bottoms of things. Now you might say, okay, that's compelling. How would I know for sure? Well, the correct answer is to directly measure the water. So far, we've been talking about optical defects, right? So let's measure the water. How are we going to do it? We can't use a string because of the catenary curve problem, right? Which is a physics problem. Just take my word for it. Can't use a string.
Okay.
Can't use a solid piece of steel for similar reasons. So the most efficient means to get something at that range, that we need a sufficient sample size, right? So what's a sufficient sample size? Let's say 25 miles. That sounds pretty good, don't you think?
25 miles, you'd see. Doing the maths. 25 times 8. 200 inches, which is what? I don't know what that is in feet.
25 miles, it would not be 200 inches.
Wait, what? So wouldn't it be 25, then 8 inches per mile, times it by 8?
It's squared.
Oh, there we go. So would it be
If
5?
you're doing it your way, it'd be a
5
slope,
times.
not a curve.
Oh, yeah, that makes sense. Sorry. Right, so 5 times. What is it again? What is it? 5 times 8.
It's 20.
40.
No, 25. 25 times 25 times 8 inches.
Right, so
that'll give you inches.
Sure.
5,000.
That's going to give you. Right, that's going to give you the drop.
16 feet.
Right, so that's 416 feet drop. Right.
That doesn't seem very believable to me. I'm gonna be honest.
Really?
Yeah.
Why not?
I don't think you can see 400 feet of drop between 25 miles. That's like.
I mean, that's the math of the ball.
Significant. That's very significant.
Yeah, it's very significant. So we have something that's 400 feet, right? 400 feet.
I can live with like 400 inches, but I can't live with 400 feet.
Well, too bad, because that's the measurements of the ball that they told you exists.
Yeah.
So I'm going to walk you through it. So this is how it goes. You got 400 feet. It's actually worse than that, but we'll just use 400 for sake of argument. It's easy to divide. So what they did is they set up what's known as a laser transit measurement. Laser transit is basically a really long level, right? Because obviously you don't have a 25-mile long level. So you level the laser on the one side of the land, you shoot it over 25 miles of water, and you have a target, right? You set up the laser at 6 feet off the ground. You set up the target at 6 feet off the ground. Right?
It's can't a laser be refracted and stuff though.
Ding, ding, ding. He said it. He said the word.
Oh, what? Hey. Calm down.
Oh, no.
We're not getting frenetic here. Yes. The correct answer is lasers can deviate due to refraction. Okay. So I want to ask you this before we start. You already have heard this is a 400-foot differential, right, between the drop.
Mm-hmm.
Now,
yeah,
we're going to measure this. We're going to measure this to see if that drop is there by setting up a laser transit level. Now, I'm going to continue with how this works, okay? So we'll set a baseline for how this thing's supposed to function. So in construction, let's say you have a foundation, so you have a piece of land. You set up the laser on one side, you set up the storyboard on the other, which is what the laser hits, and it tells you the differential between a level laser and the ground. So for example, if I set up my laser at 4 feet tall and the storyboard says 6 feet, right? Then that means I have to add some dirt to level the ground, right? And transversely, if it says in the other direction, I have to take some dirt away. So what this tells me is over my foundation that I'm trying to lay, whether or not I'm laying it flat. Because I can go with that storyboard and get 4 feet here, 4 feet here, 4 feet here, 4.5. I got to change something. Right?
Yep.
Now, of course, there's tolerances, right? So when, for a client, I want to make a level floor or a level foundation or a level piece of land, there's tolerances that they're willing to accept. Now, dirt has a different tolerance that someone's willing to accept in concrete, has a different tolerance that someone's willing to accept for their tile in their kitchen floor, right? They want that floor flat. They don't want it curved, they want it flat. So I want to ask you this question. If they hired me to make a flat floor, and I got my measurements so off that I was 2 orders of magnitude off level, is that acceptable?
No,
it isn't, is it? In fact, 1 order of magnitude is not acceptable. So, for example, if the differential is supposed to be 0.4, and I have
Russ,
0.40,
mute the bot and then talk.
Those are the same, are they not?
I can't mute the bot, but you have to
Okay, but what if I have
mute it in
4?
your Discord.
I'm off by 4.
Like we just kind of got to talk over it with it muted on our
That is not a flat floor anymore, is it?
What's up?
No.
What up, dude? So tell me how you got into flat Earth.
Sloped.
Right. I've done screwed up.
Let's see.
Now, what if it's off by 40?
I guess just general distrust in narratives that I was given.
Whoa.
Yeah, you wouldn't even be able to walk.
Authoritative sources, and then
it'd be so steep.
What are some, like, if you had to give some, like, other examples?
So not
like,
acceptable.
This is one, but I'm guessing, like, if it's a built-up thing to you be like, no, I'm flat Earth, there's probably some, like, other
see, I don't want to go off the reservation too much in the live chat, but I will tell you that I spent many years reading books from people considered
and it's off
elites,
by 2
like
orders
Bertrand
of magnitude.
Russell,
We've already agreed that that's not
the
acceptable.
Huxleys,
So
Henry Kissinger,
if the laser is at 6 feet,
Zbigniew Brzezinski on politics, right? These people kind of shaped our
is in the single
world
digits.
into this technocratic society,
and the double digits,
they pretty much hate humans.
Tens is not acceptable.
They're all members of
And the
secret
hundreds
societies,
is
and I don't
definitely
say
not
that like in a
acceptable,
conspiracy way. I say that because it's all
So lo and
confirmed in the
behold-
books if you read them.
Lo and behold,
I
this
spent
test
many years
was
reading
conducted.
shit like that, and then I realized they're
ambient
part of the
conditions
same
were
group
measured.
that crafted the
Refraction was
heliocentric
taken into
narrative.
account.
So I
The
looked
Millerad
into
beam
it. I mean,
divergence for the
my
laser in
first
question that was used on this
impression,
day
I
was
came
taken
across a
into account.
YouTube video when YouTube
The laser
wasn't
hit the target.
censoring everything.
Give me 1 second.
Yeah.
With a maximum differential of approximately 3
said
feet,
that the heliocentric
still within the single digits. And they're supposed to be 400 feet. So if the Earth was a globe,
the heliocentric model was made by those rich guys,
over the
right?
target by
The
hundreds.
same, so you can connect them for
upon
sure. So
hundreds
the
of
education system,
Yet the laser hit the
the
target.
people that, so if you
By the
go all the
principle
way
of laser
back,
transit within the
I
margins
can't
of error.
confirm that any,
surface
Copernicus or
is
Galileo
flat.
or any of those people, A, even existed, or B, were in secret societies, or
Oh,
any-
okay. Hey, wait a
Now,
minute.
what say you
Wait,
is?
so you're saying that you don't
should
even
be,
think
oh,
that
I'd like to see that
Galileo or
evidence.
like,
Lo
those
and
famous
behold, we have
scientists
it
were
for
even
you.
real?
We
I
have
have
a
no way of
documentary.
confirming that. I didn't say I don't think it's real.
We have a short
I'm
version
saying
of
I'm
it
not
if you don't wanna
making
watch the long version,
making
just to get your,
claims about them, but I'm
appetite
talking about
satiated.
basically the introduction
We
of
have
the
a document,
education system, right? The
120
Rockefeller
pages,
education
with all the
system that we could
information,
all
the
agree
sites, the equipment, everything.
within the last century and a half has kind of
One of my
changed the
good
way
friends-
they educate
one of my
people.
good friends
it's
will
more of
post
a
that for you.
memorize and regurgitate instead of actually actively
Friends?
I agree with that
learn.
100%. But
What's that?
I said I agree with that statement 100%. Like the
So
Yeah,
what's
I
gonna
think most
happen
people do
is
at
you're
this
gonna say,
point in,
oh,
in
okay.
time.
But I don't think that necessarily
Right, and then
means
you're
that
gonna be like, well,
the
is
things
this the
that
only
they're
test
telling
that's
us
been done? The
aren't
answer is
true.
no. Many have
It
been
just
done.
means that the way that they have us learn it isn't
Many,
really
hundreds.
effective.
Yeah, I'm not trying
All
to commit an
different kinds of
all or
methodology.
nothing fallacy by any means.
All
I mean,
demonstrating
obviously,
no big hump of earth
some
appears
things
in the
they
way.
teach us are true, but again, based on what I've seen, the way that
Observations as well.
from how
In
government
excess of
operates and what
255
really
miles,
the purpose of
which
government
the
is
target object
to
should not only
medicine.
be 400 feet below the
Everything they've
curve,
taught us
but should be a mile below the curve.
every narrative they've given us in
Yet
regards
the
to
object
those
in
things.
question is clearly visible.
I
So we've
as
already
far as
established
my standard of proof
within tolerances that the Earth doesn't measure to be a
kind
ball.
of
That the
disproven a
horizon
lot
that's
of
been
what
claimed to be a
they've said,
horizon
and kind of seen
doesn't
the
exist,
methods that they've
and that
used
it's
to
not true
deceive
that the
us.
bottoms
And
of
again,
things
it's
can
all
only
about,
be
if you go
obstructed
back
or
and
cut
read
off by Earth
Bertrand
curvature.
Russell, Impact of
So
Science
we've
on
basically
Society,
shown
it's
that
all
there's
about
just no
trusting
evidence or
experts.
need for this
The new
Earth
world
curvature.
in decades from now, it's going to be about reliance on experts, basically scientism as a religion
I'm
in
looking at
place
this
of
thing.
God.
What is this
And,
thing about a blue
that's what
laser
they've been
and a
doing.
green
Everything
laser?
is, just blind belief based off
Blue
of
and
what
green
an
lasers
authority
refract at different
figure or
rates.
institution has
Colors
told you.
refract differently comparative
It
to the
led to
refractive
Flat Earth
index of the medium.
because
By using
YouTube
different
used to
colored lasers,
recommend
you can
videos. I
determine
guess when
the
you
refraction that's present in the ambient
watching one
conditions.
conspiracy video, it would recommend another. So,
Okay.
Which, by
I
the way, the
can't lie to you
military.
and say that when it hit
Hey,
me,
by the way,
or when the video
military
started
recently
coming
did that.
in
The
front of
military
my,
recently did that at 120
in front of me,
kilometers,
I was like, oh, this is retarded.
shooting two lasers to see how
I
it
genuinely was
does,
curious.
and they
I was
found
like,
out that it doesn't match the globe
why,
model.
why would this be ridiculous? Even though,
Space
We also
Force is
have
going to be
Flat
angry about
Earthers
that.
definitely perceived that way. I
Space
can't
Force
lie
is going to
in
be
and
angry
say
with that.
I thought it was
Well,
retarded
I
when I
mean,
first
yes and
heard
no,
about it too,
because
because I was just interested in learning more about
most
it.
people, when presented
And
with this
then
evidence, just hand-wave dismiss
the
it
way to get here is you just got to really learn the globe arguments. And
because
then
they're
once you
under the
realize
impression,
it's all in the imagination. I mean, it's
right,
just a
that
story
the Earth is a
attached
ball.
to
Therefore, what
observations
must be happening
that
is
we
that
all
light is
see, we could
curving.
all agree on. And instead
Do they have
of
any
being able to
demonstrable
say, I
evidence of
don't know
such a
what
thing? No, it's
causes
just an affirming
the
the
sun to
consequent
move across the
phenomenological
sky, they
fallacy.
have to attach a story that
So
somebody
now we've
made up.
established that the
And
rebuttal for all this evidence you've been presented with is a
again,
logical fallacy,
regurgitated
not
without
actual measurements
any
or
proof of
demonstration.
causation whatsoever. And it's
So
unfalsifiable.
again, we just have no need or demonstration of this
Okay.
Earth curve
So,
on the ground level.
I get that there definitely could be things that the government would probably want to deceive us on. Why the shape of the Earth? Like, it's like you seem to bring up like religion.
So,
at least a
Well, not
little.
religion. So I want to
have
just
direct
I want to
evidence
establish
of
something.
Earth
I'm not
curve
religious.
measurements.
Okay, well,
That is what is
either way,
my
you
whole belief.
necessary to rebut.
believe in like a
Yeah,
higher.
I got you. Yeah, so basically just stripping the
Unless you
existence
have
of
that,
God. So I don't
the
know what God
proposition
is.
stands.
I think man-made
And the reason
religions
why it stands is because we all
power
experience the Earth as flat
control
stationary.
mechanisms
That's agreed upon
created by evil
by
people
both
to
camps,
basically control the
by
minds
flat earthers and globe
So
earthers
then,
people like
what
alike.
do you mean
That
by
our
they were
present
trying to
day
get rid of
experience of
God?
the Earth
If
is
they're
a
if the
flat
why wouldn't they
stationary
just
plane.
keep religion? It's also
That's
a
how we
control method.
experience it. That's the
Right,
base
because they
axiom
want
of
the
our human
scientists to be God.
interaction
They
we
want
can
the experts
experience.
to be God. They want you to go to the experts to
Based on
ask
everything I
questions
just
about
said,
our origins. I mean, if you
What
look at
about
every
the
ancient
coincides with that
theologists
experience.
and like that are like wouldn't
The
they just couldn't
globe
they just be experts as
curvature
well?
is an extraordinary claim that requires
Yeah, so
extraordinary
that's how it
evidence.
used to
But
be
most
back
people
in
are fooled
back in
by
the
the
medieval
claim
times
that
and
a fuzzy dot
early
on a piece of
first,
paper
early
is a
second
picture of the
century.
Earth from space.
Yeah, the
That's
early
bad
what is
though,
it?
right? You don't.
What?
That's bad though, right? You
Given to you by a government,
So
then
at some point the church
we
got
know
taken over,
lies
and
on
you
the
realize,
regular.
Georges Lemaitre came up with the idea of the Big Bang Theory, right? I mean, the whole
I'm just interested, right?
heliocentrism comes from the Roman Catholic Church.
Why would they like? So now you're gonna have a really good answer.
no,
Why
wait,
would they
whoa,
lie?
whoa,
Why would they lie?
dude,
There it
Yeah,
is.
yeah, yeah.
There's the
Okay,
that's
hold on. So
$1 million question.
Georges
isn't it? Who cares why they lie?
Lemaitre. You ever hear that
Don't
name?
matter.
George. Let's hang it. Let me look it
Right,
up.
but you're an
George is
intellect person,
what?
right? You'd lied
Yeah,
before, and you've been lied to before. So you know why people lie. So you already know the answer.
Lemaitre.
You don't know the exact specific
So
answer, but you know
George.
the general answers.
Yeah, I'm gonna
To
post it
gain
on that
power,
type.
to gain
I don't know if we're
resources,
getting in
to
trouble
gain
for talking
fame,
about this.
to gain women. All
Hopefully the bot's drowning me out.
George's Lemay.
So he
Belgian
created the Big.
physicist.
I mean, you could type in Georges Lemaitre Big Bang.
Okay,
He
yeah.
proposed the Big Bang.
Oh, it says, "What is George Lemaire's discovery?" Appealing to the new quantum theory of matter, Lemire argued that the physical universe was initially a single particle, the primeval.
The Big Bang.
Yes.
He's trying to say it started as a single atom, right? A single particle, and
Yeah.
and it formed itself. Basically, nature created itself. So it That's the Big Bang.
Yeah, and so what about it?
Okay, so do you understand how the Big Bang ties into heliocentrism, or is that kind of like a little fuzzy right now?
Wait, I sorry. Like, are you saying like, do I think if I think that the Earth is round, then I have to accept the Big Bang? Like, is that what you're saying? 'Cause I do.
So
I definitely do. I 100% do. But I'm just
yeah,
asking.
if you think about it, right? So heliocentrism and like religion slash a creator are kind of mutually exclusive, because if you're if this Earth, if you're in the heliocentric paradigm, the creation story, the ontological primitive here is nature creating itself. I mean, crazy like Bible, some crazy religious fanatics will try to like warp their heliocentrism into what the Bible says. And again, I don't have any belief in the Bible. Frankly, I think it's all an allegory. But the Big Bang and heliocentric, that's where the ball came from. It came from a Big Bang explosion. Matter appearing out of nowhere and forming from gravity into these spheres. So that's the Big Bang. That's the heliocentric creation story, the Big Bang. There's really no other alternative. So it's either
more complex. Like, it wasn't like matter didn't like. I'm pretty sure people think that Big Bang is just like something that constantly reoccurs. So like we keep expanding and expanding, and then it collapses on itself, and then it explodes again, and goes over and over.
right. But as you're saying saying this out loud, like it's just a story. I mean, right? It's
but they have like actual
story.
physics to back it up though.
Well, you can't see, that's the problem. See, this is actually highlighting exactly what I was talking about when I said trusting the experts and having these experts take over our education system. So we just appeal to them to basically know anything. So they've lied to us about what science is and what physics is. They just basically slap the word science or scientist onto anything that they want you to think is empirical. But science,
hang on,
physics.
Well, you're getting kind of crazy because like think about it like this. Like
no,
they didn't lie about. Well, let me tell you this. They definitely didn't lie to me in my physics class, because we would do like real life examples where we would measure the mass of the ball and like the slope that it's going down, and then you could calculate where exactly it would land.
Yeah, but they told you that was science?
That is science.
No, it isn't. It's measuring. You're measuring something. That's a what is. You're trying to get a measurement. Science answers how and why questions. It examines cause and effect.
You have to do like the calculations, but like the way that like the process it would have taken to figure out like how those things correlate would be like science. It would be the scientific method.
Okay, so what's the first step of this scientific method?
Make observations.
So we're talking about natural science since we're talking about the Earth, right? The physics, nature. So it would be observe a natural phenomenon.
Yeah,
okay,
but
so you observe something happening in nature, and you want to try to figure out what is causing that to happen.
Like crazy extents, just like the same way you can take math. Like you probably
what?
don't believe everything a math person tells you, but it doesn't mean that they don't know what they're talking about.
But I'm trying to point out a category error here. Measuring things is not science. Science is you're making an observation. Okay, so science. Would you agree that you need to experiment in the scientific method? Is that an important part of it?
It's like the physics part of it that like makes it science in my eyes is that like you have the slope of like a ramp and you have a ball, and all you get to know is like how steep the slope is. Like you assume that gravity accelerates the ball at 9.8 meters per second squared.
So science shouldn't have any assumptions in it. You should just be observing things.
What do you mean?
And looking at cause and effect relationships.
Where do you think I made the assumption for gravity? Like you can technically like do a camera video of you dropping something, and then you can like take.
Yeah. Okay. So okay. Let's see. So gravity. When you say drop, so I just want to establish science is the investigation into cause and effect relationships. So you have an independent variable and a dependent variable when you form your hypothesis. I think the independent variable is causing this effect to happen. So taking, for example, water boiling, right? You have water boiling, that's the observed phenomenon. That's a dependent variable. Then you have heat. So you go out into nature, you see a hot spring and water starts boiling. So you try to form an educated guess to see what is causing that to happen. So you say, water seems to boil in the presence of heat. I mean, you could say there's a bunch of birds on the water. Maybe it's the presence of birds, but you'd have to test that in experimentation, and you'd have to rule out one hypothesis. So you're looking for cause.
There's no independent variable there. How is heat the independent variable? What are you testing?
Heat. Okay, so you want to see if heat causes the water to boil. So you apply heat.
You'd have to also have a control, because if you just
Of course. I'm giving you a hypothesis. Controls are introduced in the experiment stage. So yes, you're right, but the hypothesis doesn't contain controlled variables. You enter controls in once you start testing the hypothesis. So you control for pressure, you control for...
Let me just real quick. I just have a really quick question. I'm going to give you an example, and I just want you to tell me your honest thoughts. All right, you ready?
Yeah, yeah.
Okay, so I have a garden, and I am like, my friend told me that fertilizer makes my plants grow more, but I'd have no idea. Maybe like I do it naturally and it works just fine, but I wonder if he's right, but I don't know. Like I'm not saying that it would make my plants grow more, or it won't make it grow less, okay? You get that?
Okay.
So then
I have a problem with it right off the bat.
I set up the two pots with the plants. And one of them I use fertilizer, and one of them I don't. And then I repeat it over time and time again, and I find out through my data that I take while doing the experiment that fertilizer does make the plants grow more. I never really had a hypothesis there, right? I never made a prediction on what I thought was going to happen, but I can still set up the experiment and get results.
Right. So no, you need to form a hypothesis. You need to put something through a scientific method. You're basically saying he's telling you fertilizer causes, which by the way, fertilizer. I'm no.
But if I think about it like this, like if I go through, like I set up the experiment and I do it 100 times, and every single time
you need to have something to test. You need to have something to test. What are you testing? Why are you experimenting if you don't have a hypothesis? You have to test your hypothesis.
My friend told me, but a hypothesis is a prediction. Like, what do I think is going to happen? But if I'm unbiased, like I don't think anything, I don't know.
That's the point of the hypothesis. That's the point of the experimentation, to take away your bias. That's why you experiment, because it's going to either prove the hypothesis.
But if you stand unbiased, then it doesn't matter what like the ended up bias is. Like if it sides with the fertilized plant or the natural plant, it doesn't matter.
Right.
Like if I make a decision.
This isn't, first of all, so fertilizer, I think it's synthetic, it's man-made, right? It's chemicals and shit. Is fertilizer?
No. Like you can like cow shit. Like that's fertilizer.
Okay, yeah, so right. So what you would do is, right? So you're saying your friend told you, but at some point before your friend got this idea, somebody had to have observed the presence of cow shit, right? And the correlation of the cow shit and plants being fertile and growing. So they said, holy shit, why are these plants growing at such a nice rate? They're, beautiful plants. And so what could be causing that? There's a ton of cow, or the soil has cow. I don't know the technique. I'm not into planting or anything, gardening, but before your friend found out about it, somebody would have had to make a scientific inquiry into it. So yeah, there are things that science, and I don't want to commit a reification of the word, but there are things a scientific method allows you to know, and then you operate basically moving forward as kind of base axioms. So like, yeah, we know that like it's kind of like scientifically validated, I guess, at this point, if what you're saying is true. I don't know anything about gardening. That manure causes plants to grow faster or better or whatever. But there had to have been some scientific inquiry to determine that in the first place. Your friend's knowledge didn't just come from, making it up. If it did,
really hypothetical. My friend was an idiot, and he was like, "Dude, I swear to God, my plant just grew more when I put cow shit on it." And I'm like, "What, dude? You're an idiot." I was like, I'm gonna test it by growing a natural plant and a fertilizer plant.
Right, okay, great. So your friend is presuming that the reason his plant grew better was because of the presence of the fertilizer, right? Just generally speaking, right? So you're going to say, let me test that, right? So science is systematic experimentation and validation. So it's not just your friend doing the experiment. It's many, many, many people conducting this. And that's how you arrive at a scientific theory. Some people use the word theory all the time, like, oh, I have a theory of this. But a scientific theory is the result of systematic experimentation and validation. So if you want to form a theory that fertilizer enhances plant growth, you would have to go and test. So your hypothesis would be, if I add this fertilizer...
I think I'm getting it now. Because I guess in the end of the day, if it doesn't matter if I don't make a prediction, it doesn't matter. But the ultimate test of it, the hypothesis would be that you're testing to see whether or not a plant grows more or less because of fertilizer.
Yeah. If I add fertilizer to the plant, and again, control everything else, control the soil, control the temperature, control the climate, control whatever, there's a ton of control variables you'll have to factor for. So if all other conditions are the same and controlled, and fertilizer is the only the independent variable, so the only one that's being manipulated, basically you're adding more or less fertilizer or taking it away or whatever, and you're going to see how the plant reacts to just introducing that one independent variable, while all others are controlled. Now, if there's no difference, and there are other things in the presence of your friend's plant growing, you could effectively rule out the hypothesis that states, if I add fertilizer to this plant, it will grow better. And you could add the fertilizer as a control, and you could form a new hypothesis. If now we'll test out the amount of time, the amount of water it gets, let's say, or we'll test out the temperature that it grows in. We'll test out the manure, shit, or whatever. You understand? So you could change the controls, but in any given experiment, you have a hypothesis with one independent variable and one dependent variable. You could either prove the alternative hypothesis, which is if I add this fertilizer to the plant, it will grow better, for the lack of a better term. Or you're proving the null hypothesis, which is the inverse of that. So if I add fertilizer to this plant, it will not show any signs of, significant growth or whatever. So there is a hypothesis because there has to be, because the experiment is a hypothesis test.
Yeah.
So I mean, there's really nothing controversial there.
Okay,
That's
sorry.
Yeah, no worries.
So what was the original point you were going about?
The original point was science and what we've been led and fooled into thinking it is. So you notice that example we just went through. You're observing a natural phenomenon, plant growth, right? You're observing plant growing and blossoming, and you're trying to figure out what caused that. Then you're making educated guesses and forming hypotheses. And, one hypothesis at a time you're going to test, but you could form multiple. You could have a hypothesis with the independent variable as the amount as water. You could have it with an independent variable as fertilizer, etc. And then you could arrive at the conclusion that at a theory rather. So you could either definitely say that fertilizer affects plant growth or it doesn't. So the main point there is you're manipulating the amount of fertilizer. Either you're putting fertilizer in or you're not, or maybe you're adding more. You're adding increments of it, right? You're adding every experiment. You're adding a different amount and seeing how that reacts. So the point is you're manipulating directly. The researcher is manipulating the independent variable directly. Problem in astrophysics and astronomy and cosmology, you could observe the Big Bang. You couldn't even observe the natural phenomenon, so it's not science. You can't go back 4 billion years and observe the Big Bang taking place. So it's just all philosophy. It's just a philosophical viewpoint. But as far as like planets and stuff like that, you're just looking at a planet and you're making up a story. You're not testing anything. You're not doing any science. My point here isn't to say that they're wrong. I do think they're wrong, but that's not the point I'm trying to prove. The point I'm trying to prove is it is not natural science. It's not physics. There's no experimentation. Experiment is the key to the scientific method. You can't put astrophysics through the scientific method. You can't manipulate the variables. You can't.
What do you mean you can't?
So okay, let's try to do one of these examples with astrophysics. So I don't know. I look at the moon, right?
What about time dilation?
What about it more specifically? So, go ahead.
Time dilation. You know, like Einstein's theory of relativity.
Yeah, which it's just a reification of a mathematical equation, right? There's nothing.
but
There's
it's
nothing
been
concrete
tested.
in it. It's just.
But it's been tested.
Yeah,
been
but he's basically just forming a mathematical equation and seeing if he can get an observation to fit within that equation. You could write an equation to prove or to assert that Superman can fly. They could 100% do it. But
How?
Superman,
How would you do that?
how?
Or, like where would he? Because you'd have to be getting like a thrust force. But if he's not getting,
You calculate the equations it would take for a person of that weight to leave the ground, and you factor all that in. I'm not a mathematician, but you can do it.
well,
You
you
can
could
do
figure out
anything.
like the thrust. Yeah, you could figure out the thrust he needs. But like we can, like if you try to do it in real life.
Okay, good point. So let's go to gravity, right? So theory of relativity, because the heliocentric paradigm doesn't operate on Newton's, or it's not even Newton, on Cavendish gravity anymore. Einstein came along and superseded him, toppled him from the throne. So now in
Not
that paradigm,
necessarily. I mean, it's not like Newton's. It's not like Newton's like idea of gravity is like that wrong. It's just like he was doing it based on what he observed, like with pens dropping and shit like that. Like that would be natural science, wouldn't it?
yeah, no, because again, so let's go to that because that's simpler because the bending of
If we're talking
space.
about natural science, Newton's is like the most natural it gets, but I feel like and
Hey,
Einstein
well, wait.
leveled up because he's
You can
throwing in
assert that it's more relevant to science than Einstein because Einstein states like I said, it's a reification of a formula. Einstein states that gravity is a bending and warping of space-time. Space and time are both concepts. How do you bend and warp concepts? So you can't even perform an experiment. But let's go.
Well,
Let's
hang
go
on.
to
You can like there have been experiments for like let's talk about this. One, you
okay.
can
Give me a
mathematically.
hypothesis.
Well, hang on, Russ. You can mathematically prove time dilation, and then you can go test it. So like time dilation, and I can give you the hypothesis. It's if you are moving, then time will run slower for you because you are because the speed of light is constant. So if it is constant, then time has to dilate like that. Then unless you'd be able to, because then you'd be able to differentiate from inertial frames of reference.
Right. So what this looks like is basically trying to fit something.
Hang on. So, but then if I got into a jet, like a really fast jet, and I had a really good clock, like an atomic clock, then I fly around the Earth. I land, and my clock is slower than the atomic, or like has less time has passed for my clock than the clock that's been on the Earth. Wouldn't that be like a sign that might be true, time dilation?
Yeah. So ready. So here's the problem. You have the model is coming before the experimentation here. So they're basically making up something and then making up equations, then testing it to see if it fits the model. In reality, scientific models come after experimentation, and they're the result. So you get models and theories after putting the observation through the scientific method. So if you want to use that one you just said, give me the hypothesis with the naturally observed phenomenon, with the time dilation. Because it's just trying to fit something to your model that you already created, but the model needed to be created after the experimentation.
Think about it. So like Einstein comes up with the theory of like with the idea of time dilation. So they could think about this, and I'm guessing they.
Hold on. No. Where did he come up with that from? What made him come up with that? What did he observe that made him conclude all
because
that?
here I'll tell you, it was
Who's the
like,
observation?
hang on here. Let me tell you. Like recently, like in his life, in terms of Albert Einstein's life, like recently in the world of science, someone like figured out that electromagnetic waves all move at a constant speed, and he was thinking that if that was true, then you could tell the difference between inertial frames of reference. But you couldn't do it if time dilated in accordance to it. So like you can look up the equation for time
Right, but
dilation.
how do you directly manipulate time?
Relative to the speed of light. And so, what did you say?
I said, how do you directly manipulate anything? How do you manipulate a concept? Time is a concept. It's not concrete.
Well,
It's
see, that's what
abstract.
like
You
that's
can't
like an
manipulate
assumption. How could you prove that time is just like Newton would agree with you? Like Isaac Newton
I
would
don't know.
agree.
Can I take?
Here, hang on,
What
give
do
me
you
a
mean?
second.
How can
Isaac
you prove
Newton,
that?
like that statement you just said, Isaac Newton would agree with you. But
Yeah.
the thing is
I don't know.
Albert Einstein challenged that theory by saying, like, by kind of figuring out that clocks have to move at different times, in order to, keep the principle that inertial frames of reference can't be, you can't.
So what's the observed phenomenon? A clock moving? Like what? Clock,
No, so
clock is man-made. Clock is a man-made
like
thing.
let's say it's a stopwatch. So like clocks gain time, right, over time.
But it's synthetic. Man made the clock, and man made the concept of time.
But that might not be true. Like Newton would agree with you on that. Isaac Newton would agree with you.
It's not agree or disagree. How could you prove that time is an actual tangible thing? It's just a concept in a math equation. I mean, people, Globers admit to this. I mean, I'll try to find like.
I mean, like I know it's hard, dude. Trust me. I know it's hard to like to kind of crunch in your mind, but that's what like the big thing that Albert Einstein figured out is that we might not be on just one like universal clock. Like it's not just a man-made idea. Like it is actually a factor.
Okay, I'll give you that. And so, so what? Okay.
Because think about like what you're saying, like that idea, like I 100% would, like when I was like growing up, and it's still to this day, like it's still hard to like really like visualize the fact that might actually not be the case. But either way, Isaac Newton, when he was making up like the basic like groundwork of physics, he thought in the way that you did, that it's just a construct of like of how we, it's like if somebody runs and I count it for 5 seconds, like that's that's me. And not only that, but I could say I counted it for 5 like armadillos, but an armadillo, let's say, is like 2.378 seconds, But at the end of the day, think about, like, because you can like, I know that might sound crazy, but I'm saying like
an armadillo is 2.7. Come on, man. Like what? Okay, so like I said,
I'm just saying, like,
whatever
without
you're
finding like a
trying to.
random thing, like okay, not armadillo. Like what's like, I'm trying to think of like
Whatever you could say, replace it with anything. And basketball is 3.4 seconds. Whatever.
like you could
It's
like
nonsense.
you could do like man, you could do Russ forearm. So like you measure your forearm, and then you could replace it with Russ forearms as like distance. You could do like so like. And
Yeah,
we
you
can
could
measure it out
construct your own units of measurement. Yeah.
like a foot or so, or
but-
something like that.
But my point is, so, and by the way, Newton's concept of gravity was also math. So there was he observed something falling, right? You observed something falling.
Yeah.
What is the cause of it fall? And you observe it falling at a certain rate, right? Like 9.81 meters per
What is
second
the
squared.
cause of it falling? He never answered that. He just observed it falling, and he was like,
No, well, he tried. I mean, he didn't, but people after he died, people tried to attach gravity to that. If you think about it, gravity isn't the cause; it's the effect, if anything, and the effect is just something falling at 9.81 meters per second squared. How do you prove that's gravity? You're just labeling an effect that we all observe.
Like Newton made up the fact that he noticed that things that are moving or being applied a force accelerate. So anything that accelerates, there must be a force, like to Newton.
Okay, so let me ask you
and like here's the thing, like the weird, like there people are getting kind of crazy with some theoretical physics, no doubt, but like the whole idea that gravity isn't a force, like I've heard that, and like they probably have a good assumption for it, but like I don't know, I could never wrap my head around it. And so for me, Newtonian gravity can work, like it still applies because it's still observable. Like it's not 100% accurate, but it's pretty damn close.
I mean, so Einstein and Newton's gravities couldn't be further apart. Newton's was claimed to be a force. Einstein is not a force. Newton's was instantaneous action at a distance. Einstein was limited to the speed of light. Newton's took place in 3D Euclidean 3 space. Einstein in pseudo-Riemannian 4 space. So they're not even in the same geometry. And I will post all these citations of people saying, not people, physicists stating that gravity is force. So what the hell is this? I don't know what that was. Yeah, it works. So to summarize, general relativity says that matter bends space-time, and the effect of the bending of space-time. Oh, why is this getting cut off?
I feel like it's almost impossible for Newtonian gravity to be that far off of like you're saying that they can't be the same thing because they're in completely different concepts of how the universe works. And yes, that is true, but that doesn't mean that they're both not based off of what we observe.
You feel like it can't.
They both have to be rooted in what we observe.
Okay,
so Newton what he observed, and we can take what Newton observes and then apply it to the Einstein model.
Right. I'm saying you can't, and I don't know why this didn't post the way I wanted it to. All of these physicists are saying that you can't, and they're not the same either. I think I just tried posting.
I'm sure there must be an example in there. So could you give me one?
Yeah. Einstein created his general theory of relativity, which provides our modern understanding of gravity, with the express purpose of expunging non-locality, Newton, from physics. Isaac Newton's gravity acted at a distance as if by magic, and general relativity snapped the wand in two by showing that the curvature of space-time, and not an invisible force, gives rise to gravitational attraction. George Musser, the Scientific American, article titled
Think about that.
Einstein.
Hang on. You just there you go, like that. What were those two words? Gravitational attraction.
Yeah, no. These are people within the heliocentric paradigm that are saying basically.
Well, you can't use their source, and then once I give you a point that still shows that they have to be connected, then you're like, well, they're in the
The point is
they're all against
he's
us.
saying that you're not understanding or intentionally strawmanning me. The first sentence says that Einstein created his general theory of relativity, which provides our modern understanding of gravity. My only argument here is that the modern understanding of gravity is no longer Newton's. That's about 105 years out of date.
100%.
It is now general relativity.
That's a true statement. No
so
doubt.
they're not the same thing.
They are very
that's what he's
similar.
saying.
They are very similar.
Okay.
Maybe not in maybe not in concept, but in practice, like when we observe them, they're the same thing. Because what we observed never changed.
Yeah, because it's not gravity. We're all observing the same effect.
How we understand what it is. But at the same time, there's always that gravitational. I can't even say it. Gravitational attraction, and that is both observed in the way Newton did, and it's both observed in the way that we do it today. They're just measured differently and they're looked at differently.
So George Musser's wrong.
What'd you say?
So George Musser's wrong in this quote, right? So expunging non-locality from physics, meaning you know what expunging means, right? So if they were so similar,
here's the thing: is I think you're thinking that here's the thing that Newton probably got wrong. masses, like it's not just like a mass on mass thing. It's how much your mass can, like the new thing is that it's how much your mass can warp space-time. But it doesn't take away from the attraction. Like something that people figured out is that it doesn't matter if like, and this would probably be hard for Newton to have like come up with, but it doesn't matter how like heavy something is, like a hammer or a feather. If you dropped it in a vacuum, they both hit the ground at the same time because it's Earth that's just pulling it in through the curvature of space-time.
Okay, right there. So you're saying Earth is pulling it in through the curvature of space-time. How can we prove that it's the curvature of space-time that is pulling things down? Especially when it's, as I've displayed here.
Dude, I could never prove that to you. I could never.
You ought to be able to Google a scientific hypothesis for the general theory of relativity.
The things I know is that when I drop a pen, it drops at 9.8 meters per second, as if a force,
Yeah,
almost as if a hand. It's almost as if a hand was like pushing it down.
Hey, you are pushing it down. You're dropping it. You're causing it to fall. The question is, what's causing it to accelerate at the rate?
I picked it up, so I gave it like potential energy.
Right. Yeah, energy. Yes. So, but the cause is right. We don't need to look into the cause because you picked the pen up and you released it. And if you did that with the helium balloon and you release it, it would go up. So really, the question is, what is causing things to fall at the same rate or to accelerate at the same rate? It's not what's causing things to fall because it's almost always humans. If you leave a pen on a table, it's just going to stay there.
Yeah, exactly.
But you have to pick it up and give it energy, and then drop it. So that's the cause. You're causing it. You're letting go of it. When it goes down and when it goes up, you're also letting go of it. So
what's making it go down? Why would it be attracted to the ground?
I mean, it could. I wouldn't say it's attracted to the ground. I would look at the medium that it's going through, right?
Think about it. If I picked up the pen and I put it equal distance to the wall and the ground, what's stopping it from going to the wall equally? Because it would be the same amount of energy.
What?
Like you're saying
that bias?
Well, hang on. Maybe I'm misunderstanding because it sounds like you're trying to say that if I pick up a pen and I hold it over the desk, I'm putting the potential energy in. So when I let go of it, it's just using the potential energy I put into it.
And you're asking why wouldn't it get stuck to the side wall, right?
I'm saying, I'm saying why is it directed towards the ground? Because if you technically set it up where you drop the pen equal distance to the ground versus the wall, then there should be no reason it goes to the ground versus the wall because it'd be the same energy.
Right. So I think we can.
Or if I did it closer to the wall versus farther to the ground, it should technically go to the whatchamacallit.
Yeah, again, we could all agree that there's a downward bias and an acceleration rate that everybody agrees on for the most part, that things fall roughly at 9.8 meters per second squared. Now, the thing we need to look into here is what is the cause of that, and take away, my example.
Dude, I can never tell you why gravity happens. I just observe
gravity. That's the point. You're just calling it gravity. So I mean, take a look at this. You can't.
The term we use for it. The force
it's a term you use to describe the effect.
The force that pulls things towards the ground, towards the earth.
But we've already explained that it's not a force. It's not pulling anything. It's just things are going
at a Newtonian example, you can apply that. It's not like no. You're right. Fucking.
And our current modern understanding of gravity is general relativity.
What do you say?
You said at a Newtonian, but
I disagree with you on the fact that, here's the thing. I get what you're saying, that those people are this gravity is throws Newton's gravity out of the boat.
That's what they're operating under. Nobody considers Newton gravity anymore because it got expunged from physics.
Because Einstein's version of it was just so much better. It worked so much better. It doesn't take away that there's an attraction, that the Earth's mass is attracting things.
Right. So, okay. So again, I would like to get down to the main issue here. How can we prove that Earth's mass is attracting things? So again, let me give you an example because I've been trying to get this out. if you drop something that's more dense than the air, right, it's going to fall. But if I take that same object and drop it in water, is it going to go up or is it going to go down or up? If I take a lead ball and drop it in a tub of liquid mercury, is that going to go down compared to if I dropped it in water, compared to if I dropped it in air? So, I mean, we're talking about a few different factors that go into this. Density of the medium seeming to be the most important of them all. I could validate this scientifically. You can't validate the bending and warping of space-time scientifically. I could do this by, let's say I was at the beach and I saw an object floating on the water. Let's say, I don't know, an egg from a bird that fell out. We'll try to make it as natural as possible. It's just floating on the water. I say to myself, wow, that's weird. Why didn't it sink? Why didn't it go to the ground? I decide I'm going to do an experiment. My hypothesis, I look at the water, right? I go over to it. It's the ocean, right? So I know that there's salt in the ocean. I taste it. Okay, this is salt water. Maybe the salt has something to do with the density of the medium. So that's going to be my hypothesis. That's where we're going to start. So let me form a hypothesis. If I add salt to water, it will change the density of the medium and it will cause an egg to float, let's say. So I set up an experiment. I add controls, so I control for all of the other variables: temperature, water temperature, ambient temperature, water temperature, wind, any type of atmospheric conditions or anything else. And I just add salt to the water. And I decide, I determine that when I add salt to the water, I can make or add or remove salt.
Is this like what are you trying to say that it's because of density?
I'm trying to say the density of the medium can be the manipulation of the density in the medium can be scientifically validated to show you that the density of the medium does have an effect on whether things go up or down. That's all I'm saying. That could be a possible explanation, because you could do this experiment and you could observe the natural phenomena in nature without having to concoct something in a lab or do a mathematical equation. So how can we do that for gravity, right? How can we do that for gravity, the bending and warping of space-time?
So, are you trying to say that the reason things fall up and down is because of density? Is that
I
what you're
didn't
trying
say
to
that.
say?
I said that could be an explanation. You and I are we're trying to figure out what is causing things to go down, right? That's the root. It's the crux of the issue right now.
I'm not even saying that like I know what exactly causes it. I'm just saying I see things fall.
But you're saying that what you're seeing
not
is
only that,
gravity.
but I see things fall in a way that a force would act on it.
But gravity is not a force in general theory of
It doesn't change
relativity.
the fact that it
Yes, it
accelerates
does.
the pen.
What?
I said it doesn't change the fact that the pen accelerates. Like that's like you can still. It's like anytime I apply a force on something, it'll accelerate. And so if I just do nothing to the pen and it accelerates, why is it so wrong
Right,
to
so,
assume that
okay,
it's
that's fine. So if anytime you apply a force on something and gravity isn't a force, maybe it's another force being applied that isn't gravity that's causing this thing to go down. Because I have 5 citations right here. Strictly
So
speaking,
do you
gravity
think
is not a
when
force.
scientists decided that like they're like
I don't know.
Einstein version of relativity or has made gravity like we don't even need the Newton things, like it's completely like useless to us now. They
Yeah,
didn't
they don't. They could in physics. They still do use Newton's equations. Again, they're his math equations to for some purposes, but the physics community is currently operating under general relativity. And again, it's all just equations. It's all just equations. I mean, you even said it yourself.
and so they're the people that were like yeah, it's a force. But then they're like, wait a minute. After Einstein did this, it's like, wait a minute, maybe it's not a force. But that doesn't change the like they know that when you observe it, they know that when you observe it, it's like a force. So why would they? That would be the dumbest move ever to go back on it, unless they had some reason to. That made it more accurate.
Right. See, the thing is, you keep saying they know that it's doing, they know that the effect that what we're seeing is happening. And I agree too. We all are observing the same effect. Why should we believe that it's gravity when you can't manipulate the gravity to change or to show the effect that we're seeing? So if we were able to scientifically validate, we'd be able to manipulate the gravity to stop things from falling or to make things fall slower. We would have to manipulate that directly, and we can't manipulate gravity because it's a reified math equation.
Wait a minute. So what if I dropped a hammer in a vacuum so there's no air? Why does it still go towards the Earth?
Okay, A, humans create vacuum chambers. B, you drop the hammer. So this is a synthetic example. It's not a natural experiment. And C, vacuum
How's it
chambers
not natural?
because where can you find a vacuum chamber in nature? Where can you observe a phenomenon of a vacuum
Can't you just
chamber?
build one? Can you
Yeah,
build
so
can't
there
you
you go.
build a vacuum?
Yeah, it's synthetic. It's man-made. It's not natural science. Man's the cause. Man made the vacuum chamber. Man dropped the hammer. I mean, that's just a hypothetical thought experiment.
Well, any like technology man-made to get results is not is well, are you saying that makes it invalid?
I'm saying you need to observe something happening in nature, right? Because if you're not observing something happening in nature, you know that man is the cause.
I could never prove to you then, because then anytime I remove air from something, like, do you think that if we could, let's say it somehow in nature we could remove air and drop a hammer, do you think it would go down towards the Earth? What do you think it would do then?
See, that's the thing. It's a silly hypothetical, and there's no vacuum chambers in nature. So if there was, we're basically establishing it's unfalsifiable. If you can't show it happening in nature, it's not even worth considering, because we know that the man that made the vacuum chamber is the cause of whatever we're seeing happening. The vacuum chamber doesn't occur naturally on Earth. Unlike when you see an apple fall from a tree naturally, that's happening in Earth. We can look at that and try to formulate a hypothesis. We still can't figure out the cause. We still don't know what that is. We could label the effect and do some equations, and then reify those equations into calling it gravity. But that's all it really is. Science is all about finding the cause of effects that we see, and we can't do that for gravity. And before, I wasn't asserting as a positive claim that it's relative density disequilibrium, but that is one explanation that could be scientifically validated for sure. I've done it myself. You can go through the entire scientific method.
Because, well, think about it. Because what about the I drop it in the vacuum? I'll never be able to, that's an experiment that you could do. Like, you make a vacuum chamber, you suck all the air out, and then you drop things in it, and it shouldn't really move, or it should move to the closest thing to it, because it shouldn't be biased towards the Earth.
Okay, so right. What if you drop the gas in vacuum chamber? Gas is a phase of matter, right? There's 3 phases of matter. Gravity is supposed to be a downward force acting on all forms of matter. What would gases do? Gases move freely and randomly
fill up
in
the
all
vacuum.
directions.
It would kind of fill it up.
Exactly. There you go.
Why is the hammer biased though? Why is the hammer biased? What makes the hammer different? Well, and not only that, but what makes water different as well?
And I'm
So 2 out of the 3.
I don't know.
2 out of the 3 are biased towards the Earth. What makes those things biased?
Wait, what do you mean they're biased towards the Earth?
You drop it from so you suck in a vacuum, you suck all the air out, so it's a vacuum. You drop the hammer and it goes towards the Earth. Why does it go towards the Earth? And you could do it with liquid too. You could do it with any solid object and any liquid object. Liquid matter.
In a vacuum?
In a vacuum.
Right. But again, vacuums don't occur in nature. So it's a fun little experiment to do to see why things do what they do in a vacuum.
Well, then
but it doesn't report to reality.
I feel like that's dumb. You definitely can create a vacuum in nature. Like, one doesn't happen in nature. Maybe, in my eyes, it would be...
How do you create something in nature? Nature creates itself, in a sense. I mean, I don't think nature creates itself, so I shouldn't say it like that. But nature is just part of our physical and natural world without any man-made intervention. So yeah, we can make a vacuum chamber, of course. That's synthetic, and that's not natural science. That's my only point here. So you can't really do physics experiments in places that don't exist on our Earth.
What do you mean places that don't exist on our Earth? It does
Vacuum
exist.
chambers.
Yeah,
Vacuum
but we
chambers
can
don't
make
exist.
one. Well, why can't we just make a vacuum chamber?
Because that wouldn't help us investigate the cause of the effect that we observe in nature, which is something falling, right?
Yeah,
So
falling
so
towards
if
the
you do
Earth.
it in a
So
vacuum,
well, hang on. It
I mean,
it
doesn't
does help because well, hang on. It does help. It does help. It does help. Let me explain why. It helps because you might assume that density could explain it, but if we remove the air, there should be no reason why hammers or liquid has this bias.
we don't we have air here. That's the thing. It's so again, it's non sequitur. We have air on our Earth. We can't
I need
remove it.
J.E. Jedi. He would be able to argue me a little bit better. No offense to you, man.
Frank, I don't think he would. I don't think anyone in here would entertain you as much as I have been. They'd continue to ask.
J.E.
Continue to
Jedi
ask for scientific.
would actually be able to
No, they
give me some.
continue to ask for scientific
Dude, I have.
validation of gravity.
What'd you say? It's not a
They would just
validation of gravity.
continue. They would continue to press you for your scientific validation of gravity. That's what they would continue to do. I don't even think they wouldn't entertain these vacuum hypotheticals.
What do you mean? It's not like there's a YouTube video about it. You know Brian Cox? He did a YouTube video.
Yeah, John. Yeah, of course. I quoted Brian Cox up here saying gravity is not a force.
Yeah, most PhD physicists don't think it's a force. they think it's
Johannes Midgard said if you remove the air, you change the medium. Right. So when you do your experiment in a vacuum chamber, you're changing the medium, and you're by removing the air. Okay. So yeah, I mean, again, I don't really get into those types of thought experiments because
you remove the hang on. Why don't we?
If you remove the air from the atmos.
Please explain.
Johannes, maybe a little. It's the density of the medium. So if you change the density of the medium by removing the air, that's what you're manipulating. So the cause would be right. The density of a medium. So that still supports relative density.
Wait, how? I'm so confused. So hang on.
And
well, you say that like I don't know why you're so you are going to entertain the vacuum chamber, right? We're entertaining it.
I really can't entertain it much further than this, but I mean, I won't stop the conversation. There's nothing really more to entertain because, like I said, there's no vacuum chambers.
We have a big vacuum chamber. Big vacuum chamber. There is one out there. There's a YouTube video about it. You can look at the Brian Cox YouTube video. What it demonstrates is in a vacuum, you can drop a bowling ball and it will still fall. There is no density acting on that.
That's because of gravity?
It probably yes, like yes, I am.
Okay. Now manipulate the gravity to see if the thing doesn't fall.
Manipulate gravity? What do you mean manipulate gravity?
Gravity
How could I ever make
what?
That makes no sense. How could I ever make gravity not pull it? Dude, what do you mean?
You can't manipulate it. So it's just an equation. You need to be able to manipulate it to cause the effect that you're observing. So even if you go into a vacuum chamber, you're still going to have to manipulate the variables. Like I said, you manipulate the density of the medium. You can do that. You can't to cause the effect that you're seeing, right? To change. You can't manipulate gravity. You just said it. Everybody said it. If you type into Google, can you manipulate gravity?
Can you manipulate gravity? Of course not. I'm not God.
So it's not scientific. That's my whole point.
What do you mean?
And again, see, you're not God. So gravity is your religion.
You don't observe the ball falling. You still observe the ball falling.
Yeah, that's fine. So you're observing an effect.
Falling at 9.8 meters per second, just as you thought it would.
Yeah, that's fine. You're observing an effect at a rate that's pretty consistent with most objects. Now what? What does gravity have to do with it?
What does gravity have to do with it? Because then we can assume that there has to be something that's attracting the pen or the hammer to the ground.
And why does it have to be gravity? if you can't scientifically validate it.
You want me to?
It might have to be something,
You want
but
me to
it
call it
can't be
like my
gravity.
asshole? Do you want me to? But either way, you can call it whatever the fuck you want. It's the
Right,
you
man, thank
observing
you,
it, being
thank you.
attracted to the Earth.
Agreed. You can call gravity whatever you want because you're just labeling an effect that we all see. So thank you. Yes, I agree. You can call
So
it.
what
You
does
can
that
call
mean?
it
So if you
invisible
observe an
uniform.
effect, if you observe an effect, that doesn't mean it's a thing.
You can label it whatever. That's exactly what you do. You're observing an effect and you're just labeling it gravity.
But
Gravity
you
has
agree
it's
that
no
it is
not a
there.
causal
So
mechanism
you're agreeing
force.
that it's there.
No, you're choosing to call it gravity. That's fine
And
with
what
me.
would
But
you call it? Well, you can't call it density because density wouldn't apply in this. Density is the amount of mass
I
something
didn't
has.
call it anything. I'm just observing an effect of something falling at a certain rate. That's it.
And say that again.
I said
Yeah, and
all
so
I'm
and so
doing is observing
if you
an
had to give
effect
that a name, what would
falling.
you call it? If you had to give that a name, what would you call it?
I probably have to look into I don't know,
I'd probably just go with
electrostatics
the one
more.
we had.
I heard
Like,
something the other day. I don't have a name to label onto it. There
what
are
about
other
gravity?
explanations for it. But
This is
again,
crazy.
you're
This
trying
is
to assert it's
crazy.
gravity, and when you admit that you can't scientifically validate it. So
You mean
again, you're just labeling a
I
cause
can
an
I can
effect.
scientifically validate that when I have something, it will be attracted to the Earth. If I pick something up, I
Not
can
attracting to
scientifically
the earth.
validate that
Not attracting to
I can
the earth. How
scientifically
can you
validate that it
prove
will.
that it's attracting to the earth? It's just going down when
What'd
it's
you
more
say?
dense than the medium.
Say that again.
You're adding the part where you're saying it's attracting to the earth. That's begging the question. You're assuming that the earth, I'm guessing, is a sphere, right? Which hasn't been proven. We haven't gotten to that yet. And you're
Okay.
attempting that there's a center of mass in
We
the
can
earth
get
that
we
is
can get to the
attracting.
curvature of the
You
Earth in a
can't
second, but
validate that.
let's stay on this for a second. Keep going.
I'm just saying you can't scientifically validate that. You can call it whatever you want, but
So
you
what do
can't
you mean?
assert that
I
it
can't
causes
scientifically.
gravity.
What do you mean I can't scientifically validate that the Earth attracts? How would I not be able to scientifically
Because
validate?
you can't manipulate the earth to not attract something and cause the effect. You
Well,
need to be
think
able
about
to
it.
cause
Well, think about it. Think about it. If we remove the density, so you can't a density wouldn't apply in the vacuum. If I have the hammer closer to the wall, why is it still biased towards the ground?
See, this is doing nothing for physics or natural science because you're doing it in an unnatural synthetic location. I know that a man made a vacuum chamber, but like it sounds, a man made a vacuum chamber. It's not observed in Earth, so you'd have to do this on Earth and show that you could
And
prove
obviously,
that
I
it's
would
getting
never be able to prove. Like, here's the thing. Like,
Hey, thank you. It's
you
unfalsifiable.
say that. Hang on. You say that when things fall, it could easily just be density at work. And I would say, well, how about this?
Relative to the medium.
Take some bricks and let's build a building. And then we build a chamber, and then we suck all the air out of it. Like we get a big old like a vacuum.
It's not natural science.
Suck it all out. What? Well, it doesn't change. What do you mean? How is it not natural? It's the same thing as natural, except we just build the scenario that we want.
So it's the same thing as natural, except the man has to build something, a place that doesn't get naturally found in nature. So physics is a study of our physical and natural world. If you found a vacuum chamber in nature naturally occurring without a man creating it, then we could do that experiment. Until then, it's not natural science.
Okay, well, I guess I could never argue that. I'm just
I appreciate
gonna quickly look up natural science. I feel like that still doesn't. Sorry, it may not naturally prove it's science, but it's still scientific.
It's kind of well, we're talking about natural science here, so that would fall under the classification of pseudoscience because you can't put it through the scientific method.
Why can't you? How can you
Because
not?
you can't manipulate the independent variable, and you can't perform a valid experiment.
Gravity isn't an independent variable.
whatever it is, the center of mass of the
Gravity
Earth. You can't.
Gravity is what we assume is what like the dependent variable, like that math equation we come up that we see the thing being attracted to the Earth, even if there's no air and it's in a vacuum, even though you don't think that's like even though you don't accept that. Shit, I lost my train of thought. Like we label that dependent variable as gravity. Like we notice the independent variable is dropping things and like different things and from different heights and with like closer to the wall and not closer to the wall. That would be the independent variable.
Okay, so you want to know the cause of? You want to know what the cause is? I figured it out. Right? You're dropping things, so you're causing them to fall. Dropping them. Man's the cause. It's not a natural cause and effect relationship.
Why can't I drop it on a wall then? Why doesn't it drop onto the wall?
What?
You are now just assigning that things drop downwards, but why is it biased towards the down, like towards?
I didn't say things drop downwards. Things go up. No, things don't go side to side.
Okay, so then why don't things go left and right? Things only really go up or down.
Downward acceleration.
Not only that, but things like
1.8 meters per second square. We all agree on that. We already established this.
What could possibly make like things like hammers and liquids biased towards the Earth? It doesn't matter. Like sure, gases are a little special. They're a little special.
So why isn't gravity acting on gases?
Even if they don't matter.
Why aren't gases being pulled towards the center of the Earth? Gases are matter. Why are they freely moving?
They technically are.
They what?
They are technically like the sun. Like
so, gases are being pulled towards the center of the Earth.
The sun, like the sun would be, like the sun is just gas, and it's just all bottled up.
Again, that's just a story that you heard, and now you're repeating. You can't scientifically validate anything up there because you can't manipulate anything having to do with the sun. So that's just a story that you heard that sounded good to you.
You can observe the sun. Like
okay, you can observe it and make up a story, right?
Really quickly, what about satellites? Like, you don't think that we've ever been like sent a satellite to space, right?
I think that there are probably things above us in low Earth orbit. Nothing wrong with that.
Orbit.
Yeah, low Earth. That's what they call it. I'm not saying they're orbiting the Earth.
How could you orbit around a flat Earth? Like I know it's not. I know you guys don't think it's like exactly flat, but you don't think the Earth is curved.
And you got me. Okay, I was using the term colloquially. I got caught slipping in that. Okay, so
wait. Then back to the satellites. How do you think that we have satellites?
I mean, there's plenty of evidence that everybody knows of that there are satellites, quote unquote, attached to balloons. NASA's the biggest purchaser of helium in the world. They have videos of putting these things up there. So I don't want to get into that, but I will talk about satellites and why they can't be in the place that you're asserting that they are. Right?
You can literally see satellites in space, like on certain nights. Like you can look into the night sky and see them like fly over.
Again, just seeing a light in the sky and attaching a story because you were told it. And
okay,
it
so hang on.
sounds
Let
good.
me say this. What if somebody told you, like, dude, there's going to be a satellite that crosses over this line in the sky, and you're like, no, it won't. What? Like, I don't believe you. Like, you prove it. And so the time comes, and the thing flies across the sky as it says, and like, what do you say to that? Like, you're just like, oh shit, what is that? And you'd be like, it's the satellite. I told you.
Let's try to construct your argument, right? So you see a light in the sky, it's predicted to be there, and then it shows up there. Therefore, it's in a vacuum of space. That's what you're saying? It can't just be above me. It can't just be a light in the sky above me. It can't just be a satellite on a balloon above me. It can't just be some sort of aircraft above me I don't know.
Well, the thing is, the reason it's not an aircraft, the reason you know it's not an aircraft is because, dude, you can tell what aircrafts are in the sky, but with the light, it's so tiny that
there's more than one type of aircraft. First of all, but again, this is speculation. These are stories that you were told that sounded good to you, so now you're just you're just parroting them back to me. What I want to get to is how can they be in space when space is a second law of thermodynamics violation, and you cannot ever prove that you could violate that law. How do you violate the law of entropy and show that you could have gas pressure like we do here on Earth without a container? Why are there gas pressure gradients here? Why is there gas pressure?
It's
So
probably
how
this
is our
weird
Earth
thing
not
called
contained? How are we
gravity.
leaving it?
I would assume that it's gravity, and I get that it wants to, like, some things want to go to like a vacuum, but like we can look at planets called like Jupiter. Like, do you think that we don't observe Jupiter?
That's a straw man. I don't know if it was intentional, but no, I don't think that we don't observe the light in the sky that we call Jupiter, and
Like,
I
with,
can
like
happily
my
call
dad,
Jupiter. I
my
believe
dad,
there are things in the sky, lights.
my
Yes.
dad has like a giant telescope, and he knows where to put the telescope on certain nights to like look at stars really well, and you can see Jupiter. Like you can, and it's like
Yeah,
you can like
you
see
know what? I
lines.
don't have a telescope. I don't really. I'm not like a space fanatic, but I've looked at plenty of videos from live telescope feeds that show the planets, quote unquote, and they look like pulsating lights. That's it. They don't look like spheres. To say that they do is it's a lot. I mean, we got him to concede that gravity is just a term that they made up to label an effect that we all observe and agree upon. So that's good. We'll talk about the second law in a second.
Yo, I'm back. I'm sorry, my sister called me.
Yeah, no worries.
Hey, I will say, hey, I gotta say, you are 100% correct that you're not being combative. You've been very calm, 100%.
Oh yeah, you too. Which makes this like I don't hop on the mic a lot. I listen, and I don't know how these people do it because you know, when you're not being combative, it's tough to hold you to a point and be a dick. But I don't remember to do it. They do it pretty easily. So no, it's been a good chat. Where were we? You were talking about satellites, right?
Yeah.
All right. So here's my thought. Satellites. I'm not denying the existence of lights in the sky, planets, whatever you want to call them, or even.
Well, hang on, like, dude,
or even satellites.
how?
Okay.
Hang on, I'm gonna look up live telescope because you got to be joking if you don't think that there can be some good live telescope footage that like shows you like not wait, I'm not gonna do live. Would just like a YouTube video of someone doing it work, or would you think that that's fabricated?
Again, see, there's too much. Let's see. There's not enough. There's not a good enough standard of proof for this evidence here. So you
Well,
send
here's the
me a.
thing. I'll say just believe me on this. Like my dad has a telescope, and like it's so good that like sometimes like if you set it up right, you can see like the individual rings of Saturn. Like it's insane.
Yeah, no, I've seen that too. So like, I believe your dad has a telescope. I believe you see what you see. Like I said, I don't really look at the planets too much. I have seen, but again, if you were to link me a video, and I didn't see what I wanted to see, there's a chance that I could just be like, they were edited. And if I send you a video that you don't see what you want to see, you could say the same. But what I will say is,
I imagine there wouldn't be very many astronomy videos that you could send me that I wouldn't.
But either way, I want to make this point. Even if they are balls up in the sky, and they're spheres, and they're places that look like you could go on, which I don't think they are, that would have no effect on the shape of the or the reality of the Earth. And I'll tell you why, right? And I'll tell you why you can't have satellites in space. And I know you know because you've been here since February 2023, and it says you're a flat earther in denial. So I know you know about the second law of thermodynamics. So I want to know how we could violate that when we're told we have an open system.
Hey man, I will say, I know what you're getting at, and it's because it's like
yeah, I know you do. That's why I don't want to bring up what happened.
Hang on, if space is a vacuum, then why can like our air like it should act in the same way as the bulb?
How are we breathing?
It disperses.
Right. Why isn't the high pressure on Earth flowing instantly to the low pressure environment that's right next to us with no containment? So
I would say it's because of gravity.
Okay, but gravity has no effect on entropy, and gravity doesn't act on gases. And if it is gravity acting on gases in a downward vector,
well, it's not that gravity doesn't act on gases. It's just that gases are really easy to like pull around. They're really light. So it doesn't take a whole lot of force to.
So sometimes they overpower gravity, and sometimes they don't. Like, oh, it's just like leaking out, and gravity is kind of just sort of keeping the gases down. I mean, gravity has no effect on entropy. That's I'll find a citation for that. But gases are always they're in constant motion, moving freely and randomly, colliding with each other in the walls of the container. That's the definition of gas pressure. We have gas pressure here, so there must be a container of some sort. It has to be a closed system. There's really, unless you could show a demonstration of gas pressure without a container, and I know that's rhetorical because it can't be done. I don't see why we have to consider any conversation about objects existing in a place that is a second law of thermodynamics violation. And if you want to go down the gravity road, I'd be happy to. I have a few thoughts on that, but gravity doesn't have an effect on entropy. Gravity was acting on gases in a downward.
Yeah, send me the site for that. But I actually have. I'm gonna look this up again. I have a video. I'll send in.
So on my work computer, I have all my other stuff on my computer at home. But let me try to find.
It's definitely biased because he is targeting flat earthers, but he tries to explain how you don't necessarily need a container something to have gas pressure.
Yeah, I mean, I don't need an explanation. I don't need a anti-flat earther to explain to me why. I just want to see a demonstration of it existing, and then my stance will change, and then we could write. He could write a white paper to physics departments all over the world and tell them to strike the second law of thermodynamics. I mean, so whatever he has to say, really, it's irrelevant. It's just another story, another explanation, ad hoc explanation to explain
I don't know. I feel
why.
like it's hard. Like, do you think the guy, like, if we're doing this, like, do you think the guy that made the laws of thermodynamics thought that the Earth was like what you say it is? Like, because I would guess that he probably thought it was round or
Yeah, so
spherical.
see, this is the thing. The beauty of natural laws is it doesn't take any presuppositions or preconceived beliefs or non-beliefs, whatever you want to call them. You're just observing what happens all the time on Earth. So I don't even think they thought about how it could relate to the Earth, because they're just observing something that happens without fail all the time in nature. So that's what a natural law is. So you would need an experiment, right? So natural laws aren't theories; they're not scientific. They just are what they are. In order to violate one, you need to provide a scientific demonstration experiment showing that law can be violated. So I don't think they had any baked in beliefs when the whole when this law was discovered, because it doesn't matter. It doesn't matter. Frankly, if he was thinking about globe versus flat Earth back when they discovered this law, I think they would have figured out a better explanation how to overcome the violation of it. Because nobody has an answer for this.
Well, I would say, my answer was always going to be gravity, and I guess part of why it's so like, hang on, and part of why I think like it's so for sure to me is that like when I see Jupiter, I can assume that that's probably like mass, and part of it's probably gas. That's what they
You
think
can
it is.
assume it's a story you're making up in your head. You're looking
Then
at something and you're assuming.
you could also apply like logic, like what color it is, right?
Okay, form a logical syllogism.
A logical syllogism.
Logic. So logical syllogisms are the staple of logic. So what's the logical syllogism you can construct to support your claim that it's gravity by looking at Jupiter? Right, you establish premises. It could be a base axiom.
Tell me if this is logical.
Then a conclusion.
Hang on, I'm getting another call. I'll be right back. Nope. Good. You won't. The Milky Way. Still stop by. I guess it couldn't be like that far off. Um, I'll do a Harry Nixon all day. I mean, I don't want to. Let's do the New York strip. Probably New York strip. I guess I don't even know which one to go. If I go medium rare, I feel like I'm gonna get it raw. If I go medium, I'm gonna get it overcooked. I guess just give me medium rare. I'll do both. Love you. Hey, what up, dude?
Hey, so I just watched the video. So I don't know if you noticed, but he has a syringe and he's trying to make the demonstration about the air molecules in the syringe, and when he releases the pressure from it, right? The syringe is a container.
Yeah.
The syringe is the container.
Yeah, but it has a hole.
Yeah, but it's still a container. It's still containing particles. Particles will leak out.
Why wouldn't it? Why
It's
wouldn't
still
it
a
just
container.
like flow out through the?
Yeah, that's not gas
wouldn't it-
pressure without a container. The syringe is a container because gas pressure is the gas molecules pushing against each other and the walls of the container. Like he said, there may be a few molecules left in it when it's done, but they're only in
It's
there
open,
because of the
so shouldn't
container.
it just
If you break open the
shouldn't
container,
technically like hang on by that like definition shouldn't like the outside pressure of the world like suck all the air out?
yeah, I mean, it was just a
It's
thought
like still a
experiment. He
hole.
didn't
It's still a hole. Like, it's not
prove
like
or demonstrate
yeah,
anything. He just made a diagram and
it
just
isn't
attached the
completely
story to it. But he also had a container in his story, so that's all I'm pointing out. It's a container. That's
Well, but I like actually. I'm glad you brought up the syringe because that actually makes a lot of sense. Why wouldn't the air in the syringe just all flow out through the nozzle?
yeah, that's not the point. I don't know. I don't know the specifics of the syringe. I don't know the. I
I
don't
mean the
know. All I
specifics of
know
the
is
syringe.
it's a
Like
container. It's a
it's
container.
just like a water just like one of those like water syringes, but you fill it up with air. Like it doesn't just
First of all,
all the
it
air
was a
doesn't
video
shoot
grab.
out
It was a video.
shoot out.
Yeah. Like I said, I'm not budging on the fact that the syringe was a container. I just wanted to tell you I watched it, and again, it wasn't even a syringe. It was a graphic of a syringe and a
Yeah, but like
diagram,
if you've
a
got like
CGI
a
diagram. So,
okay, so all I need
no,
to so
if you
I
want
get a
if you want
video
to
of me
demonstrate it,
making.
but it's still a container. So you need that container to
No,
get the
it's not.
pressure in the first
A
place.
container would completely contain something, right? But it's
Well,
not
that's a closed
completely contained.
container. That's a closed container.
How it's not? Well, how could
Gas pressure pushing on the walls. You could have walls in a
but if gas
syringe.
moves out freely and everywhere without reason, why would it stay in the syringe?
Who said it stayed in the syringe? He did by leaving a couple of little blue dots on a CGI screen.
Well, you could go out
So
and
then
test it and
he
just see
didn't
like
measure the pressure in there, dude.
eventually it would, but like for the time being, it can still hold pressure.
Syringe
It
is a
doesn't need to be
container.
completely
You
something
got the
doesn't need to be
pressure from the
completely
walls of
sealed.
the container.
Something doesn't need to be completely sealed for there to be pressured.
Yeah, no kidding.
But that would mean
It's
that
still
like
being
then it doesn't
contained.
matter
It's
that there's a
contained.
complete container.
The pressure is generated from the walls of the container. It's the gas molecules pushing up against the walls. If you take away that container of the syringe, it has nothing to press up against, so it releases back into the atmosphere, and reaches equilibrium. So it doesn't prove
Yeah,
anything.
but the thing is that air never flows off away. That's the thing. There's
the thing.
gravity.
All right, right, yeah, that's what we were getting back. I shouldn't have even brought up the video. I didn't think it would
Well, hang on.
really
Let's change topic. I think we're gonna go in loops on this. We've gone in a couple loops. Let's move it. I got another one. When I watch boats go off over the shore, they sink bottom up. Like they disappear bottom up.
They sink bottom. They disappear. Okay, I agree. Most of the time, right? Most of the time. Sometimes they just disappear into
There
like a
can be
little.
weird things, and people assimilate to that to light refraction. But at the like,
Yeah, so
if we
are
did
you
it,
saying,
like, if we did it, let's say we did a science experiment and we had like a boat.
Not science. Remember, you're not manipulating anything. That's not a science. It's just an observation. So you can't form a hypothesis, and you can't
What do you mean
experiment.
I can form a hypothesis? If I put a flag on a boat that is labeled in red, green, blue, and I go out to sea, the person on the shore will see the red part of the flag disappear first because the Earth
Okay,
is.
and what are you going to do? Are you going to manipulate the Earth?
That's my hypothesis.
Are you going to manipulate the Earth curve to show that it's causing the flag to disappear? Are you going to manipulate
How could you manipulate the Earth curve? That's the same
You
thing with
keep
gravity, but that
agreeing
still
with
makes no
me.
sense.
Right, you keep agreeing with me. It's not science. It's not an experiment.
What do you
You're
mean? I
agreeing with
am
me.
experimenting.
Every time
Why
you
wouldn't
say,
why wouldn't the flag disappear all together at the same
listen.
time? Why would it
We'll get to that
disappear
in a
bottom
second.
up?
We'll get to that in a second. But whenever you come back to me and say, how would I manipulate that? You are agreeing and conceding that you cannot manipulate.
You're
the
right, but I'm saying that
independent
doesn't
variable
mean
that you're
anything
claiming.
in terms of that. That means nothing. That literally
Yeah,
means
it's not a
nothing.
science
Dude,
experiment. It's an observation.
you're saying that you're trying to say that the dependent, like if I can't manipulate the dependent variable, and then
Independent, yeah.
No, I
Yeah,
can
it's not an
manipulate.
experiment.
I can manipulate the independent variable. I can make the flag, and I can go off to different shorelines. I can change how I do it in a
okay,
bajillion
but-
ways. But the thing I will
so
always
then-
see is that the flag will
So the
disappear.
cause,
bottom
the
up.
cause of it, right? So the cause of it disappearing then isn't the Earth curve. It's you moving locations, and again, that's not not a natural cause of something. I mean, again, and the boat isn't a natural phenomenon. So it's right on its face. It's just not a natural science experiment. And again, we're talking about natural science here. I don't want
This
to
is
get caught up
100%
on that.
natural. This is so natural. It can't get more
Right.
natural.
So you putting a flag on a boat. Did the boat just appear randomly, and you just said, "Oh, look at that boat"?
Dude. Okay,
We're
this
trying
is
to
absurd.
establish what
This is
natural
absurd.
science
You
is.
cannot lie that this is absurd.
We're talking about natural science. The first step of the scientific method is to observe a natural phenomenon. You're trying to say,
Okay, it's
putting a
not
flag on a
natural.
boat.
Okay, fine. It's not
It's
natural.
not an experiment because you can't manipulate the cause of it anyway. You're saying the cause is Earth curve. You can't manipulate the Earth curve, so it's not an experiment anyway.
No,
and that
dude,
doesn't mean
how?
it
Dude,
doesn't
the
mean
cause is the
it's flag.
independent is the dependent variable. The cause is the dependent, or the effect is the dependent variable. You're saying it's the cause, it's the effect. The effect is that the flag disappears bottom up.
Right, that's the dependent variable. The cause. What is the cause of the flag disappearing bottom up? Going over Earth curve, right?
That's what I assume it is.
Right. Okay, fair. So how are you going to manipulate Earth curve to show that it's causing it to disappear?
Why would I have
It's
to
not even-
manipulate it to show that?
Because you need to prove that that's the cause of it. So if you change the Earth curve,
tell me this. Why
and-
do
and
they
it's-
disappear bottom up? Why does it disappear bottom up?
that we can move on to that. So you're saying, which I agree for the most part, right? When boats move further away from you towards the horizontal slope of 0, when they go towards the horizon, right? What's the slope
Oh my
intercept
goodness.
formula? The slope of a horizontal line is 0,
Okay,
but
that's funny, but go on.
I'll digress, right? So when you see a boat move away or an object in the distance move further away from you, it appears that it is disappearing from the bottom up most of the time.
Yeah.
Now, you're asserting that the reason that we're seeing that,
99% of the time. Like,
okay, yeah, no, the argument isn't that. Sometimes it just gets smaller and smaller and smaller and turns into a little pin.
definitely
Either way,
sometimes there can be some weird finicky shit, but life's crazy,
Wait,
bro.
you-
I'm never denying that life isn't pretty unexplainable. But
yeah, I mean, if I could just get to the end of a thought, you keep your nip. I mean, nothing I'm saying is false, but you keep jumping down my throat every time I I specify something because it's not true that things always disappear from the bottom up. There are conditions that cause, and again, conditions that cause
Yeah,
it.
but and I agree with that. I would say not, but like,
right. That's why I said for the most part, I'm being careful with my words, right?
But I would say like
Semantics.
99%. Like it's not that often that something like it's pretty rare.
Okay, 100% of the time, for the sake of argument, things seem to disappear from the bottom up as they move further away from you, over water, right? As they move towards the horizon. Okay, great. I agree. I agree. Now you're asserting that the cause of that is because there's Earth curve obstructing the bottom of the boat, correct?
Yeah, like it's dipping over the horizon, and because of the curvature of the Earth, it will slowly like look like it will sink into the air, like into the water, but it's not.
Right. Okay. So that means that
and I'll say this, like, yes, I am definitely, from this perspective, I'm definitely assuming that it's because of the Earth curve.
Right. So it's begging the question. You're assuming the Earth's a ball in the first place. You're seeing an effect again, which I agree on. Right. We both agree on the effect. You're just attaching this story to it that it's the Earth obstructing it. Correct. So that means that the Earth is geometrical.
That's a reasonable explanation, though. That's 100% a reasonable explanation.
Yeah, but it's only reasonable because you were introduced to the idea of the Earth being a ball. If nobody ever told you that the Earth was a ball, it would be ridiculous to think. You would never think.
That's what, like, a lot of like ancient civilizations, especially the Greeks, were like, boats sink like into the sea as they go off in the distance, but they don't actually sink. So it's like, I wonder if the Earth is round and it's curved.
Right. Okay. Well, I think the base axiom here is the Earth appears flat and motionless. I think most people would agree with that. So again, we're agreeing on this effect that we observe.
I 100% agree with you. When I like walk out in my suburb, like, this shit's pretty fucking flat. Like, no, like 100%.
Right. So we have the logical axiom, right? That's basically the baseline belief, or the baseline knowledge that we all could agree on. So we observe this effect. You're saying, and like you said, like you admitted, you're assuming it's Earth curve. You're presupposing a ball, which is fine for this purpose.
That's my hypothesis. That's the because statement.
It's not a hypothesis. Like we established, this isn't science, right? So we can test it though. It's not science.
If as long as I can apply the scientific method to that experiment, but you don't think so. Because it's not natural. It's because it's not natural, because I have to put a flag on a boat, and that is too much. That is too unnatural for you.
Man. And the most important part, which you missed conveniently, you can't manipulate the independent variable, which you're assuming is Earth.
It's not the independent variable. The curvature.
So then, what's the cause of the boat disappearing?
It's how I explain what happens. It's how I explain the dependent variable, what I observed.
So, what is the cause of your observation? What do you think is causing the boat to disappear bottom up?
I don't know, but I would assume that it's the curvature of the Earth.
Okay, so that's the cause.
It's not. So it's what I'm assuming is the cause. But regardless of what I think is causing it,
that's what a hypothesis is.
I think is causing it.
Right. Okay. So yeah, again, I don't want to let you off this, because a hypothesis is a suppositional statement in regards to the nature of a cause and effect relationship, again, of a phenomena observed in nature, but we'll let that one go. So for this one, you're supposing that the Earth curve is causing the bottom of the boat to disappear. And all I'm saying is you can't manipulate the Earth curve, so we can't do a scientific experiment. We can test it, though, and we're going to get to that.
Dude, okay. Listen, think about it like this. Do you and when I was taught science, a hypothesis was an if, then, because statement.
Right.
Like, do you agree with that? Because I feel like that makes sense. Because ultimately I'm going to look up the.
Look, this is we're way into the weeds. I want to get to like the actual argument here. I hate to hear blasphemous speak of the scientific
or proposed explanation. So I'm proposing an explanation.
Right, you're proposing the cause of the phenomenon that you're observing. You're saying that the Earth curve is causing the bottom of the boat to disappear. Right, so you can't manipulate the Earth curve, so it can't be an independent variable.
My Dude, my proposed hang on, let me go back to the definition. My proposed explanation is not the independent variable. Let's get to that point of the argument. It is not the independent variable.
So your proposed cause is an Earth curve.
That's my proposed explanation, but it is not my
What do you
independent.
think your explanation is? You're explaining why you're seeing why. The
I think it's
explanation is
happening.
why you
That
think
doesn't.
you're seeing what you're
But an
seeing.
independent variable has nothing to do that. Like in the fertilizer example, like I
What?
think my proposed explanation for the plant growing more is the fertilizer, but I can.
That's the independent
fertilizer
variable, so you
varies
can
naturally.
manipulate the fertilizer. You can add more fertilizer or take away fertilizer, or you can manipulate it.
That's if I was trying to see which fertilizer was better, and then I'd have to make a proposed. But like, here's the thing: my proposed explanation would be I would think that shark blood would make the plants grow better, but that would be my proposed explanation. It doesn't matter how I manipulate shark blood; it's how I test it against fucking other fucking fertilizers.
All right. I mean, I'm on my work computer now. I'm not like I don't have citations on hand, but like this is just blasphemous right now. Anyway, again, fine. Let's do an experiment on your hypothesis that boats are disappearing bottom up because of the curvature of the Earth. Okay, can we just move to that?
Yeah. Let's go with
Okay,
it.
so since they're disappearing over a geometric Earth curve, which would be the horizon, right?
Mm-hmm.
And when we're assuming that we're on a ball, that ball would need to have dimensions, right? So you would have had to have measured the radius. I'm not going to ask you who measured the radius. We won't go down that road. I don't even think anybody has, but let's just go with the commonly agreed. Satellites we have. So, right. So what's the radius? What's the radius of this ball?
You can do it with geometry. Like people back in the day did it with geometry, and they got pretty close.
Okay, cool. What's the radius?
Oh, I don't.
We need to figure out how much.
I can't rattle that off the top of my head.
Okay, well, I mean, it's your belief, it's your claim. I don't know why.
Here, I'll look up radius of.
This is it's 3959 miles, right? So it's interesting. Like you often have to teach Globers what they're supposed to believe before we deconstruct their arguments.
Just because I don't, dude. You are dude.
It's the size of the bowl that you're living on.
Dude, think about this for 1 second. Just think about this for 1 second. You are a valued member of a 24/7 flat Earth Discord. You are 100% going to know more about the little details about the globe and your argument way more than I am. This is my second time on this Discord.
You've been in here months more than me. But anyway, I have no problem giving you the measurements. It helps me understand how much we're going to need to go over here. So you have 3959. Now from the globe maths, you have an Earth curve calculator. You're on a computer, right? So we're going to want to see if the Earth curve is the reason that this boat is disappearing. Bottom up, right? So let's Google Earth curve calculator. You can go to anyone that comes up.
Are you? Yeah. What are you trying to get to? What are you trying to?
We're gonna give a demonstration. You're giving a hypothetical now, but we're gonna put something. We're gonna put an actual real world example to this hypothetical, so we can go through it and we can see if it's Earth curve that's obstructing things from bottom. Because we just said generally, right? Earth curve is blocking the bottom of boats. So I want to at least find a specific.
Especially when like you're going out to like sea. Because like regardless of like this guy's like regardless of like how like things can get manipulated with like light, whether you think it is or isn't, you could like technically go out to a certain distance and then like let's say to the boat and flag experiment, but it doesn't have to be an experiment. Let's just say I do it. I go out with the boat and flag.
It's not an experiment.
I can sit in the water at a point where you would only see the top part of the flag, and I can just stay there, and you'll only ever see the top part. Maybe sometimes some weird shit would go on with the temperature, and then you'd start to see little pieces of like my.
Yeah. So what distance are we? How far away is that flag?
You would never go all the way down to the bottom of the flag. You would never get to see that part.
Okay, I want to test that. I understand what you're saying. I want to test that, right? So, do you have an Earth curve calculator up, just so you don't have to take my word for the numbers that we're going to be spitting out here?
Yeah. Earth curve Earth curve.
Actually, you know what? Do a Earth horizon calculator. All right.
I'm
Because we're
going
going
to
to be
do
the
curvature
horizon.
calculator.
Grab a horizon one, right? As long as it has an observer height, that's fine. Right? Because you understand that.
Horizon. What was
you're
it?
claiming horizon curve calculator or Earth horizon calculator.
Earth horizon calculator. Fuck.
Doing this right because is that there's a geometric Earth curve horizon descending
Oh,
away.
dude, you're cutting out really rough. Right?
Sorry, every time this computer stuff. Can you hear me?
Yeah.
Okay, so you understand we're getting the dimensions of the Earth, and we're pulling up this calculator because the claim on the table right now is that when boats go off into the distance and they disappear bottom up, they're going over the geometric Earth curve horizon. So it's basically the horizon, which is a geometric distance, right? So it's at a certain distance, they're going to start going over the curve of the Earth, right? That's why we're looking up these numbers.
Yep.
Right? So we want to see in a real world or in a demonstration that we can kind of link to this claim. We want to see what that horizon distance would have to be and how far we should be seeing. And so we want to know, is it 5 miles the boat starts disappearing? Is it 10? Is it 8?
Hey, so yeah, you could 100% do that. Yeah, you could 100% do that.
Well, that's what we're doing.
So then do it. you can actually
you
like
got the calculator?
Dude, I've actually seen videos about it, but the funny thing is
you have the calculator pulled up?
Yeah, I got the calculator pulled up.
Okay, so go to live stream voice chat, and Quetzalcoatl posted an image, and I've attached a link. I've attached a link to a YouTube playlist.
Dude. I'm not getting into single images. I'm talking about let's do another thought experiment. All right.
A single image. That's why I posted the link with multiple days of observations, the whole setup, times a day, and we have these which are better than a boat because you could tell. We have these windmills. It's his setup. It's showing how he set up the camera, the height that he was at. He was showing, so you don't have to just take my word for the screenshot from the video. This is a screenshot. How are we going to watch a video and tell the distance of something? We need a screenshot to be able to do this.
Well, here's actually, I'm going to challenge you guys for this, and whether you can believe it. Let me just give a
You're in a 2015 argument. I'm just trying to have fun, but I do want to go.
Hang on, I'm gonna give this a challenge, and I'm gonna wonder. I'm gonna ask you if you think that this would work or not, or like, yeah. Just I'm gonna ramble, and you just tell me your thoughts on it. All right. So let's imagine we had that boat experiment, the boat with the flag, and it goes out to a certain distance and it sinks. Well, then we could use this calculator, the calculator that you sent me to figure out which parts of the flag will disappear and when according to that distance. If you were sitting on the shore, and you watched it and it did exactly how you calculated, and not only that, but then you repeated it thousands of times, and 99.9% of the time you got the exact calculations. What are you supposed to think?
That's false. So I'm trying to show you that you don't ever get the exact calculations. The horizon is never where it's supposed to be.
Yeah, there will always be like a level of discrepancy, but like
now it's not a geometric horizon, right? Now there's atmospheric conditions. Right? So I'm trying to show you with a specific example. You're just giving me another story attached to your observation. You see boats going over a curve. So I want to try to check that with demarcation pointed windmills, right? So you know the distance of them. And I want to go through them and see how far behind the Earth curve each one of those windmills should be. That's what I want to do right now because that's the way to get to the bottom of the claim.
How tall are those windmills?
What does it matter how tall? They're demarcation points. They're hundreds of feet high, but what does that matter?
that would affect.
But we're
like,
looking at
the
we're looking
observer.
at where they're supposed to be disappearing over the Earth curve, not the height of them. What? You're looking at them right now.
Oh yeah.
Okay, so we have 6 different windmills at 6 different distances. The nearest one is 8.4 miles.
Is
The
8.4 and the farthest one's 11.
furthest is 11.2, right? Okay, so and this is why I sent the video, because you have the coordinates, right? So it's the Rampion wind farm. You have the coordinates of his exact location. You have the camera height above sea level. It's 3.5 feet. So if you go to the Earth curve calculator and you type in eye height 3.5 feet, and you do target distance, right? You don't even need to do target distance, because it's going to spit out a horizon distance. So it calculates that based off of the eye height of 3.5 feet, which is the camera height. You get a horizon distance of 3.87 miles. So that should be where the horizon is, because the horizon is the geometric edge of a sphere. Things when they go over it, right? So you see these windmills, and they're clearly beyond 0.8 miles, but that's not even my argument, okay? You there?
Hello?
Hey.
Okay. So I need to send me a link for a calculator that has the whatchamacallit, that has that.
Yeah, I got you.
Right.
So again, I attached the video so you can go to it and you can see his location's verified. You can see the camera height is verified. You can see his setup. You can see him zoom in. Obviously, it's a high magnification zoom camera. I sent one. So when you do that, when you pull that up, the camera height is 3.5 feet. So we're gonna plug that into
Follow the windmills. You know.
The windmills, again, they're just look at them as demarcation points to know the distance that you're looking. The windmills are probably a couple
target height. Target distance. I thought target height mattered.
Target distance. So it's just the max target distance. So at the last one's 11.2. But again, the windmills are just there to demarcate, so you know how far he's seeing. So the height of them doesn't matter. It's a couple hundred feet high, but we're focusing on the bottoms of them. And you'll realize we're not even going to be focusing on the bottom of them. We're just simply going to be acknowledging them as distance points.
Wait. So that's the distance to the horizon, but then there's also the layer of that how far you have to get to finally sink in.
Okay, so you have the distance to the horizon. Now on that top photo, can you tell me where
and then
the
you're saying okay, and then you're saying the horizon's in the background.
It's at least 11.2 miles. I'm glad you picked that up right away, because a lot of people lie and say, oh, I can't see it. It is at least 11.2 miles. So that would mean the Earth would have to have a radius of, I don't know, 240,000 miles?
I'm just going to say this.
How is that?
Like,
I just want to know, where's the Earth curve plant? Why isn't it blocking?
Where's the continued flatness when we do my boat experiment? Because you and me agreed that what we would observe on is that the flag would disappear bottom up, and then I could sit there for hours and hours, and it would stay there.
Are you looking at the photos? I don't see a flag.
No, I know the photos, but I'm saying you could do this in real life.
Yeah, I do it in real life. I live on Long Island. I have 4 friends with boats. I do this all the time. I have them go out on their boat while I stay at shore just so I can make these observations. But it's irrelevant.
Hang on. So then you could hang on. Theoretically, then you could calculate how far they are for the flag to be entirely disappeared with using the curve calculator, how far it would be at half the flag, and then how far it would be at like 1/3 or 2/3 flag. And then you could go out
so
those
I did this
distances and
exact
test
thing
that.
now with the flag. Right now with the flag, I did this exact thing. With a like a neon what are those, like little, you do your projects on them, one of those neon like cardboard things that you do school projects on when you're a kid. I did that. right? And the thing basically disappeared. But the funny thing was the horizon was still beyond that green piece of thing. So if it's the horizon that's supposed to be blocking it, if it's going behind the horizon, there has to be, and the horizon's beyond the boat and beyond the green thing, there has to be another explanation, like waves.
So, and where did it go? Okay.
I don't know, but it's not being blocked by the horizon because the horizon's beyond it, just like the horizon's beyond the bottom of these windmills. By the way, the bottom of these windmills are all.
But it still goes away bottom up, though, right?
Okay, maybe it's a wave. Maybe I don't know if it goes bottom. The bottom gets blocked first, yeah.
And then as they keep going further away from you, it keeps going, like it keeps disappearing from the bottom to the top.
You hear what you're saying? So, Plant, you just made the claim that the horizon is the physical Earth curve that is blocking things bottom up. So if something's blocked, but the horizon is past that, how can you still say that it's the horizon that is blocking things? Because the horizon is beyond
then
that.
you'd have to say that it's like sinking into the Earth. Like, what are you talking about?
What do you
mean? If it's going down, and you're like half the boat appears to be sinking into water, but it isn't in water.
Yeah, for sure. It's anything but Earth curve. It's not Earth curve. So it doesn't matter what it is.
Well, you can't even. So you don't even have
Sorry, guys. Guys, Plant, look at the GIF I just posted. It's a flat table, and look how the light goes away. Looks like it's sinking. Yeah, look at that GIF. Maybe that's your explanation with the flag as well. How about that?
It's a perspective issue. Thank you.
Yeah, it's just perspective, man.
Especially when you're seeing the horizon clearly beyond.
I need some a little bit more.
But you don't have any explanation for your.
That is literally, bro. That is literally a camera going through a panel. That is a camera going through like a specific panel. Like, dude, you can get like a panel that when you like sit behind it, it makes you look like you're not there.
Yeah, but you're talking about stuff sinking behind the horizon. You don't have that in your claim with the flag, do you? It's behind you. So
well, no, the claim is that the flag like sinks into the water. That's what I'm observing.
Yeah, and look at this flat table. Look where it sinks.
Well, dude, that's also going through a fucking panel. Like, dude, that's so biased because that panel of like glass is definitely refracting the light in weird ways.
Refracting?
Like I said, you can get a plexi thing that you can like stand behind.
What do you think you observe?
I disappear once I'm.
What do you think? What do you think? Okay, cool, cool. What do you think? What you observe in the Atmos? Like it's completely like we don't have any Atmos, like anything distorting in the air, magnifying. The air is magnifying as well. Certain days, certain conditions can magnify things. Yeah.
Give me a second.
I just want to know how the horizon's beyond 11 miles. It's never where it's supposed to be, and according to this Earth curve calculator, the horizon should be no more than 3.8 miles. I mean, the only thing you really could do is lie and say it's 3.8 miles after looking at the distance of the windmills.
And I'm trying to get this picture, and give me a second.
Atmospheric, I was trying to say the atmo lensing. That's what it's called. Not magnifying. That was a wrong wording of it. Lensing, it's called.
Yeah, you would say that's during how am I supposed to look at that giant? Why have the? Hang on, take away that glass and then show me.
Yeah, but you have that in nature as well, man. The phenomena happens as well there. Certain conditions during certain days.
Not to that
extent. Lensing will change.
Though. Not nearly to that extent.
Okay, so you have a better explanation than this? What I just gave you?
Okay,
what do you have?
No, I'm done. I've
so if he's denying
Russ,
atmosphere,
Russ, it was a good talk, man.
All right.
Yeah, you too. You too.
Thank you for the from conceding.
Yeah, I mean he's basically conceding that there are no Atmos conditions. So
he didn't have anything.
He's not even claiming refraction of the horizon.
Yeah, I'm surprised he didn't claim refraction with the horizon when his flag was just being obstructed, like at the bottom.
He was claiming that's the first time I've ever heard a glober not forgot refraction. That's wild.
Well, you see, I shut him down with this example, and in nature you have those conditions. Certain days the lensing will be changing, like everything. You know how it looks like, how things are closer, how things are further, how things seems to just dip away like this in this GIF. Anyone can go and observe that.
Right.
And
the
record
point
those.
is there's many explanations, one of them not being Earth curved.
Yeah, no, obviously not. But
Right.
I just gave him one plausible explanation. There's plenty of others, of course. So it's just this is just one of many.
Right. He did the same thing with gravity before. He conceded that he was just labeling an effect that we all observe. He was just slapping the word gravity onto it. I said, that's fine. That's all you guys do. And he's, what would you call it then? What would you, he's constantly asking for replacements, but at the same time conceding his original claim. So that was kind of his style. It was refreshing because I did want to go into refraction, but I don't even think he knew what it was.
No. He said there's a fraction going on in that plexiglass. I don't think he understands the refraction, to be honest.
What is that? What's that mainstream publication that did the boat with the flag with this 3 stripes?
National Geographic's that one. I think he was using that one. Yeah, National Geographic's. They want to prove the curvature
the
or
horizon
something.
was beyond the boat there too.
Yeah, I've seen that. Yeah. It's the same argument he was using, basically. I think he was lying about himself doing that flag thing by himself. He was using that, or National Geographic's part. Unless he showed you if he did it by himself by any recordings or
he didn't
images.
show anything. He was
of course
full
not.
on in storytelling mode.
Yeah.
He was just telling stories and asking me to tell him stories. I wish I had the RC boat.
Oh yeah, that one is a good one as well.
Yeah, the Indio RC boat thing.
Yeah, Indio used to post that. Let's see if I can find it. That one he has no explanation for that. He's gonna say I guess he will say refraction, but who knows? Whatever. But yeah. Let's see. Maybe I will try to find that RC boat. It should be somewhere. Maybe on Indio's YouTube channel, possibly. Let's see. Let's check his channel. Might have it there. What's his YouTube channel? Let's see. Indio, probably the same, yeah. Indio. Yeah, there is. RC boat. You should have it here. Let's see. I hope so.
Yeah, I found it. It's there.
Yeah, cool.
I
All
posted it.
He's
got a lot of short little videos like this.
Optical phenomena, yeah.
Yeah, optical phenomena. Right, exactly.
I think the guy needs to educate himself with this video, Optics Explain on Flat Earth.
Yeah, that one's a good one too.
Yeah, that would be a good one, yeah, because they don't teach you that in school at all. Like this kind of topics. They have no idea what they're talking about. You see perspective, they're like, oh, okay, so what? It means a lot.
Yeah, it is a shame that I had to stumble upon a flat Earth server to learn all these very important, subjects of our reality.
Yeah. And also in that National Geographic's, the bottom being obscured is by the wave, actually. You can actually see that when you look closer. It's the waves. Like, it was not even a calm water a day, even. To be honest, it was some waves here and there. Yeah.
Yeah, because I mean the horizon was beyond it, so it had to be an optical effect, or it had to be waves, and that's what I was telling him. I said, whatever it is, it's not the horizon blocking it. So
Yeah, and he
waves,
also
it could be-
and he also wanted us to explain what is it obscuring the bottom of the flag. Why should we explain that? It's your claim. You tell us what's obscuring your bottom. Is it refraction? Give us your your claim, whatever.
Right.
Then I don't know. He wants us to give him the answer for his own claim. It's kind of ridiculous, man. Yeah, you got to hold them down to these observations we have, because usually when you just talk about it, they just waffle on and just say whatever they feel like is true to themselves, I guess. So whatever suits their
I
story.
had difficulty holding him down to anything from gravity to we didn't get to rotation, but he was just hopping around to looking at the rings of Saturn, and I couldn't tie him down successfully. But agreed.
Yeah, about the gravity part, it doesn't even follow the. It's not it doesn't have any hypothesis, even the actual so-called experiment of gravity. They don't have any hypothesis even. Yeah, it's not even there in the paper.
We kept going through that, and then he kept going. Okay, well, I'm like, how do you manipulate gravity? Okay, well, let's get a vacuum chamber. I'm like, you can't get a vacuum chamber. Where do you find a vacuum chamber in nature? You can't observe a natural phenomenon. That's the first step in the science. He just kept going to, well, just like indulge me for a second. Let's just do this in a vacuum chamber. And he just kept. It was nonstop. It was a little frustrating, but it wasn't being like belligerent. I'm not like Huey. I can't just like turn on a switch and just steamroll him when he was he was being kind of reasonable, but a little dopey. That's for sure. Yeah, he just kept galloping around and making up. He just wanted to be told stories, and he just wanted to tell stories. And I kept telling him, "You're just observing something, and then parroting a story that you were told to explain that phenomena that you're looking at, or whatever's happening. You can't prove it, especially not scientifically." So yeah, we went through the whole. Vacuum chamber isn't found in nature. We went through the whole. If I drop a hammer, okay, don't drop the hammer. Don't pick up the hammer. What does it do? If you drop it, the cause is you letting go of it. You drop a helium balloon, the cause of it going up is you letting go of it. So again, you don't need to investigate the cause and effect relationship because man's causing it. So everything that he was proposing was synthetic, not following the scientific method.
Yeah, no, natural observed phenomena happening in nature.
Yeah. It is tricky though, because most institutions have like really butchered the scientific method, and that's why you hear QE scientific method so much.
Mm-hmm.
But they can go to a website like I don't know, any given college, and they'll say, yeah, just looking at things and making up theories, and they'll call them theories, even though a scientific theory comes after experimentation and validation. But there's a lot of garbage, bad information out there that kind of frustrates me. Luckily, he wasn't really doing too much research to support his kind of just yapping. So.
Yeah, there was a lack of it. I noticed when I was listening to him. But yeah, perfect example of a global believer, I would say. Demonstrating that.
With 2015 arguments, really, he's like caught in a time machine. I thought he was joking when he said boats go over the horizon.
Yeah, I think he Googled that, and that's the search result that came up, the National Geographic's one. Most likely. So he was looking at that and making his own claim about it. Yeah. Mm. Oh, we got a new guy in VC Chicken. I will hop up there and check him out. Right back.
Hey there. I'm new here. I just got verified in voice, and I think that the Earth is a globe, and I just wanted to do some chatting. I've never like talked to flat earthers before, but I just wanted to come in and see what's going on.
Welcome.
Yeah, thank
Yeah.
you. I heard you just finished talking with somebody else, and I heard it went pretty well for you. So that's pretty nice to hear.
Were you listening? Do you have any feedback on the topics we discussed?
No, I was telling him Glober came in and he left without saying anything as he conceded, but without saying, holding up his end of the bargain, I guess. But I just gave him a heads up. What we do here usually, we don't just talk about what we believe in, because the things we claim, I mean, I don't say claim, but flat Earth is what we observe, what we can measure. Also, we have a lot of data and observations to give as well, citations and sources to back it up as well. We don't just, say things when he
Absolutely.
Yeah.
I was just talking to Quetzalcoatl about my background, and I have a bachelor's degree in physics, and I work in kind of a space simulation related field. So if you have any questions for me about that kind of stuff, I in particular am super interested in what flat earthers think like gravity is. That was just always very interesting to me, and just kind of that kind of stuff.
So first, I think it's important to point out that and everybody on Earth can agree on this, that flat Earth has the base logical axiom, meaning we observe our Earth to be flat and motionless.
Mm-hmm.
Everybody, except the exception of maybe 500 people who have claimed to have gone to space, have experienced that their whole lives, right? So we have, right? So we have the base axiom. People came along and said that we're living on a giant ball that's spinning and shooting through a near perfect vacuum of space that's infinitely expanding. This outrageous, not outrageous, but this extraordinary story. So here, we look at it like the burden of proof would be on the extraordinary claim, since we could all agree that we experience a flat and motionless Earth. So a lot of what goes on here is we like to know why people who believe in the globe, and most of them admit that it's just a belief. We understand that we were all taught this from the moment we were conscious, basically, right? We've had globes in front of us our whole lives. Everything's about space, and so we want to know, what's the average person's base knowledge or base understanding of what they believe in, and that is the Earth being a spinning ball. Why they believe that, and if they have any evidence for it. You said you have some background in science.
I just have a bachelor's degree in physics. That's about it, and engineering, I guess, the minor in engineering.
That's pretty cool. Yeah, I was at the gym yesterday with the kid who was studying physics, and being that I'm in this conversation a lot, mostly listening, I had a lot of questions for him, and I'm realizing physics has kind of turned into, physics is supposed to be the study of our natural world, correct?
That's what they told us on day one, yeah.
Right. And it seems like to me now it's a lot of kind of assumptions and then calculations to kind of model those assumptions to see if they fit.
Right. I like the word that you used is model. That's a good word.
Right. So from what I understand, and I have a very elementary understanding, but this is very elementary stuff of the scientific method in science. But scientific models come after, and scientific theories would come after systematic experimentation and validation. So it seems like they're doing this in reverse, where they're forming these models and then trying to make calculations to fit these presuppositions that they have. And I was always taught that natural science, and that's what we're talking about here, right? Our natural world is basically the investigation into cause and effect relationships that we see happening in our natural world, right? And what are the key components? The main components are observe a natural phenomenon, form a hypothesis, so a suppositional statement that is presuming something to cause the effect that you're seeing, so cause and effect relationship, and then experimentation, where you introduce control variables and try to determine if what you're supposing is causing that effect is actually causing that effect, and and then